Hello everyone. So friend, in this section of course, we will be discussing about various sorting algorithms. And in this lecture, we will discuss what is bubble sort algorithm. So we will be looking into the demonstration of bubble sort algorithm and later we will look into its implementation. So here what is bubble sort? So if you see, bubble sort is also called as sinking sort. Now what do we mean by sinking sort? So here let's say we are given an unsorted array which has some random numbers, and if we apply the algorithm on those random numbers, so usually the algorithm works in various iterations, and with each iteration the largest element tends to sink at the end of the array, and when they sink to the end of the array they are usually placed at the correct position, and after every element is placed at its particular position, at the end we get a sorted array. So how does this algorithm work is, as we are given few numbers which are unsorted, so usually this algorithm, it repeatedly compares the pair of adjacent elements and swap them if they are in wrong order. So when the few numbers are given which are unsorted, we start with the first two numbers and we compare them to check whether they are in correct or wrong order, and if they are in wrong order we simply swap them and then we move to the next two numbers. So let's look into an example where we are given an unsorted array. So here inside this array there are 6 numbers which are unsorted, and now let's say we want to sort them in ascending order. So now what do is, we compare the adjacent elements repeatedly. So in the first pass we compare the first two numbers, and as we want to sort this array in ascending order, we simply compare that the number on the left is greater than the number on the right or not. So if the number on the left is greater than the number on the right, then we know that they are in wrong order. So here 3 is greater than 1, so we know that they are in wrong order. So what do is, we perform a swap. So after performing the swap between these two numbers, 1 comes to the left and 3 goes to the right, and after performing the swap we simply move to the next adjacent elements. We compare 3 with 5 and 3 is less than 5, so therefore they are in correct order, so we perform no swap, and then we simply move ahead with the next two numbers. Now here you can see 5 is greater than 2, so therefore they are in wrong order, so we perform a swap, and after we perform swap, 2 goes to the left and 5 goes to the right, and then we move to compare the next two adjacent elements. Here we see 5 is less than 6, so therefore they are in correct order, so we do no swap, and at the last 6 is greater than 4, so therefore we perform a swap because they are in wrong order. So 4 goes to the left and 6 goes to the right. So after the first pass completes, you can see that 6, which is the largest element among the array, tends to sink at the end of the array. And here you can see, being the largest element, 6 is actually at its correct position. So now with the first pass, the first number got its correct position. Now we again perform the steps with the second pass. But this time, as 6 is at its correct position, we don't include 6 in our comparison. So now our new array is from index 0 to 4. So initially it was from 0 to 5. As we got one of the number correctly sorted, for the second pass our array becomes from 0 to 4. So we start comparing the first two elements. Now 1 is less than 3. Therefore we perform no swap. Now 3 is greater than 2. So it means they are in wrong order. So we simply perform a swap here. So 2 goes to the left and 3 goes to the right. Moving ahead, we compare 3 with 5. 3 is less than 5. Therefore no swapping is done. And then we compare 5 with 4. So 5 is greater than 4. Therefore we perform a swap because they are in wrong order. So 4 goes to the left and 5 goes to the right. And as we don't include this element, after completion of the second pass, you can see the second largest element among this list, which is 5, is correctly placed at the second last position, just before the 6. So friend, here you can see that this algorithm tends to make the largest element sync at the end of the array. So similarly this algorithm continues, but here you can see the numbers are now in 1, 2, 3, 4. So by looking at the array, the numbers are already sorted. But there is no way for the algorithm to know that the numbers are sorted, because the algorithm has to make the comparisons. So in order to make the algorithm know that the array is sorted, what we do is we simply keep the track of the swapping. So let's see how we can do it in the third pass. So we compare the first two elements. 1 is less than 2, so therefore they are in correct order. So no swapping is done. So here we perform no swap. 2 is less than 3. So therefore there is no swap. 3 is less than 4. So therefore there is no swap. So friends, here you can see in the third pass we didn't perform any swap. So at the end of the third pass, we simply check that whether we had performed any swap or not. So if we haven't performed any swap, we can come to know that array is already sorted. So friend, usually with each iteration or with each pass, we simply keep the track of swapping, and if in any particular pass no swapping is done, then we can directly come to know that the array is already sorted, and we simply break from the algorithm. So friends, this is the demonstration of the bubble sort algorithm. In our next lecture, we'll see the demonstration of the code through animation, and then we'll write the implementation of it in Eclipse and see it's working. I hope you like this video. Thanks, have a nice day. Hello everyone. So in our previous lecture we discussed about what is bubble sort, and we saw its demonstration with an example. So in this lecture we'll see the demonstration of the code using an animation. So here let's say we are given an unsorted array having 5 elements as 5, 1, 9, 2, 10. Now we want to sort this array in ascending order by applying the bubble sort algorithm. So here you can see that this is the bubble sort algorithm. So friends, in our previous lecture we saw the demonstration of the algorithm, where we discussed that we start comparing the adjacent elements, and if they are in wrong order, we simply swap them. And usually when we complete one particular iteration, the largest element tend to sync at the bottom of the array or at the end of the array. And we also discussed that with each iteration we keep the track of the swapping, and if no swap is done in any particular iteration, we simply come to know that the array is already sorted. So let's see the demonstration of this algorithm step by step. So here the number of elements are 5 with an index from 0 to 4. So at the first step what we do is we simply create a boolean variable. We give it a name as isSwapped. Now this boolean variable will keep the track of the swapping in each iteration, that whether the swap is done or not. So here you can see at the last step what we simply check, that if the swap is not done, then we come to know that the array is already sorted. So we simply break from this algorithm. So we'll see its usage inside this algorithm. So here we have created the boolean variable isSwapped. So friend, here you can see there are two for loops. One is the outer for loop and other is the inner for loop. So usually the outer for loop basically keep the track of each and every iteration, and the inner for loop will simply help us in performing the comparison with the adjacent elements. So let's see the usage of these two for loops. So with the outer for loop we start with I equal to 0, and this for loop will loop till I is less than n minus 1. So here you can see 5 minus 1, which gives 4. So this for loop will travel 4 times. As it is starting from 0, it will go from 0, 1, 2, 3. So with total 4 iterations. So usually this outer for loop what it tracks is, here you can see there are 5 numbers. And we also discussed that with each iteration, the largest element tend to go to its correct position by syncing at the end of the array. And once it syncs to the end of the array, we simply don't include that element in the next iteration. So here as the outer for loop will traverse 4 times, with each time we get a number sorted at its correct place. So here there are 5 numbers. So with 4 iterations we will get the 4 numbers sorted correctly at their position. And as the 5th number is only number left, it will be already sorted to its correct position. So therefore we iterate this for loop from 0 to less than n minus 1. So currently value of I is 0 and it is less than 4, which is n minus 1. So the condition in for loop comes out to be true. And as we want to track that whether any swap has been performed with each and every iteration, with this iteration we start with is swapped as false. And moving ahead, now we encounter the inner for loop, which simply compares the adjacent elements and perform the swap. So here you can see the inner for loop starts from j equal to 0, and here it goes till j is less than n minus 1 minus I. Now here you can see that the outer for loop is controlling the inner for loop. Now why we are doing it is because with each iteration the largest element will sync to the end of the array, and once those elements are syncing to the end of the array, we don't have to include those elements. So as the outer for loop is incrementing one by one, the j will traverse only to those positions which are still unsorted. So let's see it via a demonstration. So currently j is less than 5 minus 1 minus 0 because I is 0. So the condition in for loop comes out to be true and for loop executes. And here inside this for loop we are simply providing an if block where we are simply comparing the adjacent elements j and j plus 1, and as we are sorting this in ascending order, we are simply checking that the value at jth index is greater than value at j plus 1th index or not. So it means we are simply comparing these two elements. Now here you can see 5 is greater than 1. So therefore they are in wrong order. So we simply perform a swap. So here the condition in if block comes out to be true, and here inside the if block we are performing the swap. So usually how we perform a swap is, we create a temporary variable and we store one of the values inside the temporary variable. So here we are storing the value at jth index to the temporary variable, because in the next step we'll overwrite this value and we actually need this value in the later computation. So as we want to swap these two elements, now we are taking the value at j plus 1th index and we are assigning it to the jth index. So it becomes 1, and at the last step, as we have stored this value into the temporary variable 5, we simply assign the temp to the array at the j plus 1th index. So here you can see we have swapped both the numbers using the temporary variable, and then we mark is swapped variable with a value true because we have performed one swap in this iteration. So it becomes true. Moving ahead, now we'll increment j by 1, so j becomes 1 and 1 is less than 5 minus 1 minus 0, which is 4. So the condition in for loop comes out to be true. And here as j is 1, so it will simply point to the first index and j plus will point to the second index, because now we want to compare these two elements. And here as 5 is less than 9, therefore they are in correct order. So we perform no swap. As the condition in if block comes out to be false, there is no swapping. We'll increment j by 1, so j becomes 2 and 2 is less than 4. So the for loop executes. Now the value of j is 2, therefore now we'll compare 9 with 2. So here you can see as 9 is greater than 2, therefore they are in wrong order. So here we need a swap. So the condition in if block comes out to be true because 9 is greater than 2. So now we'll simply swap using the temporary variable which we saw in our previous steps. So we store 9 in the temporary variable. Then we store 2 at the place of 9. And then we store the value stored in a temporary variable at the third index on the place of 2. So here we have simply performed a swap between these two elements. And we assign value true to its swapped variable, which is already true. We'll increment j by 1, so j becomes 3 and 3 is less than 4. Now we are simply comparing the jth index with j plus 1th index, which is the third index with fourth index. Comparing 9 with 10. So here you can see 9 is less than 10. So therefore no swapping is done and the condition in if block comes out to be false. So we simply skip this part. We'll increment j by 1, so j becomes 4. So now here you can see value of j is 4 and 4 is not less than 4. Therefore the condition in for loop comes out to be false and this for loop exits. and just after the for loop, we have completed our one iteration completely. So we simply check that whether in this iteration we performed any swap or not. Because if we haven't performed any swap in this iteration, then the algorithm comes to know that the array is already sorted. But here you can see the value of is swapped is true. So therefore this if condition comes out to be false. So friends, here you can see the outer for loop has performed its one iteration completely with a value of I equal to 0. So after the first iteration of the for loop, you can see the largest element, which is the 10, has basically synced to the end of the array. And here now you can see 10 being the largest element is at its correct position. So now we'll increment I by 1, and 1 is less than 4. Therefore the condition in for loop comes out to be true. So friend, now next pass starts. So we simply assign the value false to the swapped variable. And now the second pass starts. So we start comparing it from the first two elements with j equal to 0. So friend, here you can see the value of I is 1, and value of I is basically controlling the inner for loop. And why it is controlling? Because with the first iteration we have found our one element which is sorted and it is at its correct position. So therefore when we are starting our next pass, we don't want to include this element. So our array has now become from 0 to the third index. So therefore we are subtracting 1 from this condition because value of I is 1. So it means the inner for loop will simply compare these elements from 0, 1, 2, 3, and it will not touch the fourth element using this condition. So currently you can see j is 0 and j is less than 5 minus 1, which is 4, minus 1, which is 3. So 0 is less than 3. And we simply perform the comparison what we did in our previous steps. We compare the value at jth and j plus 1th index. So here as 1 is less than 5, therefore they are in correct order. So no swap is done, and the condition in if block comes out to be false. Now we'll increment j by 1. So j becomes 1. 1 is less than 3. Now we simply compare the elements at index 1 and 2 because value of j is 1. Here 5 is greater than 2, so therefore they are in wrong order. So we simply perform a swap because condition in if block comes out to be true. So we simply store 5 into the temporary variable, and then we migrate this value which is stored at the j plus 1th index. We simply assign it to the jth index. So it becomes 2 using this step. And at the last we simply assign the value stored to the temporary variable to array at j plus 1th index. So it becomes 5. So we have performed a swap here. So as we have performed the swap, we simply assign the value true to its swapped variable. We'll increment j by 1. So j becomes 2. 2 is less than 3. Now we compare the second index with the third index using array of j an array of j plus 1. So 5 is less than 9, therefore they are in correct order. So no swap is done. We'll increment j by 1. So j becomes 3. Now here you can see 3 is not less than 3. Therefore the condition in for loop comes out to be false and for loop exits. And here we simply check whether is swapped is equal to false or not. But here s swapped is true because we had performed one swap here. So therefore the condition in if block comes out to be false. And friends, here you can see with the completion of the second iteration of the outer for loop, the second largest element, which is 9, is at its correct position, which is the second last position. So here bubble sort makes the largest element tend to sink at the end of the array, the second largest element tend to sink at the second last position, and similarly it goes on like this. So now we'll again execute for loop with I equal to 2 by incrementing the value of I. So I becomes 2. 2 is less than 4. We assign false to its swapped variable. Because with this inner for loop we are starting our new iteration. So here you can see as these two elements are basically sorted. So we are using the value of I, which is 2, to control the inner for loop in this condition here. So j is starting from 0 and it will go till which is 5 minus 1, which gives 4, minus 2, which gives 2. So 0 is less than 2. So now we'll again start comparing these two elements. And as 1 is less than 2, therefore they are at correct order. So no swapping is done. And also friend, here you can see the importance of this boolean variable, because if you see, the array is already sorted, but the algorithm doesn't know this. So here when the j was equal to 0, we didn't perform any swap and its swapped value remained false. Now we'll increment j by 1. So j becomes 1. 1 is less than 2. So we simply compare the elements at the index 1 and 2. So 2 is less than 5. Therefore they are in correct order. So no swapping is done. So this boolean variable still remains false. We'll increment j by 1. So j becomes 2. And here you can see 2 is not less than 2. So therefore this for loop will terminate because the condition in for loop comes out to be false. And friends, here you can see at the last step we are simply comparing that whether is swapped is false or not. So here is swapped value is false, which tells us that array is already sorted and we don't want to continue this algorithm further because we were keeping the track of the swapping. So in this step, the condition in if block comes out to be true and we simply break this for loop. So friends, here we saw the demonstration of the bubble sort algorithm. So in our next lecture we'll see the demonstration of this algorithm in Eclipse. I hope you like this video. Thanks, have a nice day. Hello everyone. So friend, in this lecture we'll code the bubble sort algorithm and we'll simply test its working. So in Eclipse, I have created one class as bubble sort and inside that I have created one method print array. So this method will simply take the array and will simply print its content on the console. So we have already discussed this algorithm in our previous lectures when we discussed about the arrays. So I'll be using this print array method to simply demonstrate that whether our array is sorted or not. So inside this class, I have provided a main method where I have created an unsorted array, which we already discussed in our previous slide. And at the first step, what we are doing is we are simply calling the print array method and providing this array to simply see the contents of this array before performing the sort. So here you can see the array is not sorted. So let's write an algorithm to sort this array. So in this lecture we'll see about the bubble sort algorithm. So we'll create a method as public void. We'll give it a name as sort. And to this sort method, we'll pass the integer array, which is the unsorted array. So from inside this method, the first step we do is we simply calculate the value of n, which is the number of elements inside this array. So we simply do array.length. And as per the algorithm which we discussed in our previous lecture, we'll first create a boolean variable is swapped. So we have created this variable to keep the track that in any particular iteration we performed any swap or not. So if we have performed any swap, then we are unsure that array is sorted or not. Also in any of the iteration, if we haven't performed any swap, then we can come to know that the array is already sorted. Moving ahead, we first provide a for loop which starts from 0 and goes till n-1. And also friend, we discussed that value of I will basically control the inner for loop, because as we are comparing the adjacent elements, we need to stop at a point where we don't want to compare further. So here with the start of any iteration, we simply provide a value false to its swapped variable. And now we'll provide the inner for loop where j will start from 0 and j will traverse till n minus 1 minus I j plus plus. So friends, we already discussed that why we are providing this condition here is because we need to control the inner for loop by the outer for loop value, which is the I. So we are simply providing I here. Now inside this inner for loop, our basic comparison will start. So we simply start with comparing the adjacent elements, that if the value at index j, if it is greater than value at index j plus 1, then we know that they are in wrong order. So we simply perform a swap. So inside this if block, in order to perform swap, we create a temporary variable and we simply store the value at the jth index so that we can use this value to perform the proper swap. So after we take out the value at the jth index, what we do is now we can simply store the value at j plus 1th index to the jth index, because we need to perform a swap. And the final step, we simply store the value present in the temporary variable to the array at j plus 1th index. So in these 3 steps, we are simply performing the swap of the values present in the jth and the j plus 1th index because they are in wrong order, as value at the jth index is greater than value at j plus 1th index. So after we perform swap, we simply assign a value true to a swapped variable to keep the track that inside this for loop, when we compare the adjacent elements, we did perform a swap. So after every iteration, here what we do is we simply check that whether we performed any swap or not. So if we didn't perform the swap, we know that array is already sorted because all the adjacent elements are at its correct position. So we simply break from this algorithm. And if we had performed any swap, then the value would have been true. So we are unsure till this point that whether array is sorted or not. But if the value it holds is false, then we are sure that array is already sorted. So friends, this is the bubble sort algorithm which we already discussed in our previous lecture. And in this lecture we have simply provided the code for it. So now let's test its working. So here what we do is we simply call the sort method. We provide the array. And after we have performed the sorting, we simply print the array again. So if I run the code now, so friends, here you can see initially the array was 5, 1, 2, 9, 10, which is the content of array before sorting. And then we performed the sort on this array. And after performing the sort, we simply printed the array again. And we found that array is sorted with all elements to its correct position. 1, 2, 5, 9, 10. So the array is sorted in ascending order. In this tutorial we saw the demonstration of the bubble sort algorithm. We tested its working in the main method. So friends, I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in our previous lecture we discussed about the bubble sort algorithm. So in this lecture we will discuss about the insertion sort algorithm. So let's discuss this algorithm in detail. So here if you see, insertion sort is a simple sorting algorithm that works the way we sort playing cards in our hands. So when we play with the deck of cards, usually most of the games are involved where we keep few cards in our hand, and what we generally do is we keep them in proper order. So how do we manage to keep them in proper order is we use the insertion sort algorithm. So let's say we have this deck of cards which is lying in front of us, and let's say we pick few random cards from the top of the deck. So usually what we do is when we pick up the first card, we simply keep it in our hand because it is already sorted. And when we pick the second card, the card which we have picked, we simply compare it with the card which we have in our hand. And based on the comparison, we either keep that card before or after the first card. The deck of cards which is lying in front of us are basically in random order, or you can say they are basically unsorted form, and the cards which we have in our hand are basically kept in sorted form. So when we pick up the third card from the random cards, now the card which we have picked, we simply compare it with the cards which we have in our hand. So we compare the third card with second and then with the first card, and based on the order which we are following, we simply place the third card either after the second card or in between first and second card or just before the first card. So similarly, let's say we have this unsorted array. So using the insertion sort algorithm, we divide the given array into two parts. One is the sorted part and the other is unsorted part. So how the algorithm works is, from the unsorted part, we take the first element and place at its correct position in the sorted array. So here we are simply picking one element from the unsorted array, and based on some logic, we are simply putting that element into the sorted array at its correct position. So this is done by shifting all the elements which are larger than the first element by one position. So here let's say we are sorting the array in ascending order. So the first element which we pick from the unsorted part, we simply compare the element with each and every element in the sorted array. And all the elements which are larger than the first element, we simply shift them by one position. And as soon as we encounter any element which is smaller than the first element, we simply store this first element just after that. And this process is repeated till unsorted array is not empty. So friends, let's see the demonstration of insertion sort algorithm with an example. We'll take an unsorted array. We apply the algorithm mentioned here and we'll see that how we can sort the array. So friends, here you can see that we have this array from index 0 to 5. So basically there are 6 elements with the value as 3, 1, 5, 2, 6, 4. Now let's say we want to sort this array in ascending order. So how do we start this algorithm is, we simply pick the first element. So here it is 3. And as we have picked the element 3, we know that there is only one element, so it's already sorted. So basically this algorithm starts from the second element because the first element is already sorted. So friends, in our previous slide we discussed that we divide the array in two parts. One is the sorted part and other is the unsorted part. So when we start our algorithm from the second element, so the elements to the left are basically sorted and the elements to the right are basically unsorted. So now what we do is, from the unsorted part, we simply pick the first element, which is 1, and what do we do is, we simply store this element, let's say to a temporary variable. So as soon as we store this element to a temporary variable, what do we do is, we simply provide a hole here that this part is empty. So after providing this empty space, what do we do is, we simply compare 1 with the element in the sorted array. Now as we are sorting this array in ascending order, we simply compare that whether 1 is less than 3 or not. So here 1 is less than 3. So therefore 1 should come before 3. Here you can see there is no space. So what do we do is, as we discussed in our previous slide, we simply shift the elements which are larger than 1 by one position. So here we will simply shift 3 to this empty space. So after we perform this shift, that are there any other elements in the sorted array or not? So here you can see there was only one element 3. There are no other elements. So we simply place 1 at its correct position. So after placing 1 at its correct position, you can see that now our sorted array has two elements, 1 and 3, in sorted form. So now we simply pick the first element from the unsorted array. So we simply pick 5. We store it into a temporary variable and we create an empty space here. Now what do we do is, we compare 5 with 3 and we know that 3 is smaller than 5. Therefore 5 has to be placed after 3, which is this spot only. So there is no shift because the element to which we are comparing in the sorted array is already small from the element which we picked from the unsorted array. So the position of 5 will not change. 5 will be stored at its own position. And here you can see that as 3 was less than 5, we didn't compare 1 with 5 because as this is a sorted array, 1 will be by default smaller than 5. So after placing 5 at index 2, now our sorted array has 3 elements 1, 3, 5, and from the unsorted array we simply pick the first element, which is 2. We store this 2 into a temporary variable and we create an empty space here. Now what we do is we compare 2 with 5. So 2 is less than 5. So we know that 2 must be lying somewhere before 5. But here you can see in sorted array there is no space left. So what do we do is we simply shift the larger element by one position. And as here is the empty space, we can simply shift it here. So 5 comes here and the empty space comes here. So friends, here we are not sure that whether this is the correct position of 2 or not. So what do we do is we simply compare 2 with this element, which is 3. So here you can see 3 is also greater than 2. So we know that 2 must be lying somewhere before 3. So what do we do is we simply shift 3 by a position. And as here is an empty space, 3 comes here and the empty space goes here. So friend, we are still not sure whether 2 must be placed here or not. So we simply compare 2 with 1. And here you can see that 1 is smaller than 2. So therefore we are sure that 2 must be lying after 1. And the position after 1 is empty. So we simply store 2 at this empty position. So friends, after this step, now we have 4 sorted elements and 2 unsorted elements. So we simply pick the first element from the unsorted part, which is 6. We store 6 into a temporary variable. We create an empty space here and we compare 6 with 5. So as 6 is greater than 5, we know that it must be lying after 5. So after 5 we have this empty space. So 6 will be stored at its own position. So now our sorted part has 5 elements 1, 2, 3, 5 and 6, which are sorted. And in our unsorted part we have now only one element left. So we simply pick the first element, which is 4. We store it into a temporary variable and we create an empty space here. Now we compare 4 with 6. So 4 is smaller than 6. So it must be lying before 6. But there is no space left here. So we simply shift 6 by one position here. So 6 comes here and we have empty spot here. So now we are not sure whether we simply put 4 here or not. So we simply compare 4 with the element just before the empty spot, which is 5. So that we are sure that whether 4 can be placed here or not. So as 5 is greater than 4, therefore we know that 4 must be lying before this element. But here there is no space, so we simply shift 5 by one position to this empty spot. and the empty spot reaches here. Now we are still not sure whether we need to place 4 here or not. So we simply compare 4 with 3. Now as 4 is greater than 3, we know that it must be lying after 3. And here you can see after 3 we have this empty space. So we simply store 4 to this empty space. So then after this step you can see the complete array is sorted. So here we saw the insertion sort technique where we divided the array into two parts. One was the sorted part and other was the unsorted part. And with each step we simply picked the first element of the unsorted part and we simply placed it into its correct position in the sorted part. And this we did till the complete array was sorted. So friends, in this lecture we saw the basic demonstration of insertion sort technique. In our next lecture we'll see the working of the code step by step using an animation. I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in our previous lecture we discussed about the insertion sort and we saw the demonstration of the sorting algorithm. Now in this lecture we will see the demonstration of insertion sort algorithm step by step. So friends, here you can see that this is the algorithm to perform insertion sort. So let's say we are given an array having 5 elements which contains values as 5, 1, 9, 2, 10. So here you can see the values are in unsorted form. So let's see the demonstration of this algorithm step by step to sort this array in ascending order. So here the number of elements inside this array are 5, which are ranging from index 0 to 4. So friends, while performing the insertion sort, the first thing we encounter is the for loop. So here you can see this for loop goes from I equal to 1 and it goes till I is less than n. So friends, in our previous lecture we discussed that when we perform insertion sort, we usually divide the array into two parts. One is the sorted part and the other is unsorted part. So here you can see that when we start sorting this array, all the elements are in unsorted part and no element is in sorted part. So what we do is we simply pick one element which is the first element of the unsorted part. So let's say we pick 5 and as soon as we pick 5, as 5 is the only element which we want to sort, therefore we directly place 5 to the sorted part because we don't have to compare 5 with any element. So instead of doing this stuff, we directly start from I equal to 1, which is this position, because 5 is already sorted into its correct position. So usually this algorithm starts from I equal to 1. So here you can see that 5 is in sorted part and all other elements are in unsorted part. So we always start from I equal to 1. And as I having value as 1 is less than 5, therefore the condition in for loop comes out to be true. So friends, here when we perform insertion sort, one rule of thumb is we always pick the first element of the unsorted part and we try to put it in sorted part by comparing 1 with all the elements in the sorted part and placing it into its correct position. So when we perform this comparison in the sorted part, all the elements which are larger than this first element, we simply shift them by one position so that there is an empty space where we can simply put this element. So here you can see the space are already occupied with some numbers. So when we perform a shift, there can be a chance that some numbers can be overridden. So what we do is we simply store this value which we want to compare with the elements in the sorted part we simply store it into a temporary variable. Here, moving ahead. So friends, now we want to compare this element with the elements present in the sorted part. So here you can see, as we have picked the first element of the unsorted part, if we go one position back, we will get the elements of the sorted part. So we simply do I-1, and to access the elements of the sorted part, we simply store it in the j variable. So here j becomes 0. So usually the elements of the unsorted part are accessed via I, and the elements of the sorted part are accessed via j. So friends, now we provide a while loop because we want to compare this element with each and every element in the sorted part, and all the elements which are greater than this element, we simply shift it by one position so that there can be a space where we can simply put this element. And as we are sorting this in ascending order, so here the condition we provide in while loop is that j should be greater than equal to 0, because inside this while loop we are decrementing j by 1. So we have to provide this condition that j should be greater than equal to 0, because we don't want to go outside of this array. And also why we are decrementing j by 1 is we need to compare this element with each and every element in the sorted part so that we can put this element into its correct position. So the first condition is j should be greater than equal to 0. So here j is equal to 0. Therefore this condition comes out to be true. And then we provide one more condition as the element at jth index is greater than temp or not. So here you can see the value of j is 0. So the element at index 0 is 5. And here you can see 5 is greater than 1. So we know that as we are sorting this array in ascending order, 1 should be placed before 5. So therefore this condition in while loop comes out to be true. And we want to find out the correct position of 1. So what do we do is, in the first step, as 5 is greater than 1, and as we discussed in our previous slide, that all the elements which are greater than 1, we have to shift by one position. So how we perform shift is, as we have already stored 1 into this temporary variable, therefore it's like a hole here, and we can shift 5 here. So we simply assign the value stored at jth index, which is 5, to value at j plus 1th index. So j is 0 and j plus 1 is 1. So we are simply storing 5 to this place. So here now 5 has been shifted to this position. And after this shift, we simply decrement j by 1, because now we want to compare 1 with an element just before 5. So we simply decrement j by 1. So as j is 0, j becomes minus 1. So here it means that now j is pointing to minus 1, which is an index which is out of this array. So friends, as here you can see that in our sorted part there was only one element, 5. So we compared that element with 1, and there are no more elements to compare. So therefore this condition where j is greater than equal to 0 comes out to be false, because j is equal to minus 1. So the condition in while loop comes out to be false, and while loop exits. And at the end, we have found a position where we need to store 1. So that position is j plus 1, because as j is pointing to minus 1, so it means j had traveled till minus 1 position to basically shift the largest elements by one position. So when we do j plus 1, here we are simply storing the value 1 at index 0, because as j is minus 1, j plus 1 becomes 0. So we are simply storing 1 at 0th index. So friends, after performing this all steps, now here you can see that 1 and 5 are basically two elements which are sorted. So therefore, with each for loop iteration, we will get one element which will be now part of the sorted array. So here, now 1 and 5 are part of sorted array and rest of the elements are part of unsorted array. So here now we'll increment I by 1. So I becomes 2. So friends, as we already discussed, that we simply pick the first element of the unsorted part in order to make this element to be placed in its correct position in the sorted array. So we simply start with storing the value at ith index into a temporary variable. And why we are storing into this temporary variable is because we want to create a whole year. So moving ahead, now in order to access the sorted array, we simply do I minus 1. So the value of j is 1. In while loop, we simply check whether j is greater than or equal to 0 or not. So j is greater than 0. So this condition comes out to be true. And then we simply check that the value stored at jth index is greater than temp or not. So here you can see value of j is 1. So the value at first index is 5. And 5 is not greater than 9. So therefore this condition comes out to be false. And the while loop exits. So here you can see that as we are sorting this array in ascending order, we want a correct position for 9 in the sorted array. So as there are only two elements which are sorted, 1 and 5, when we compared 9 with 5, we found that 5 was not greater than 9. So therefore the correct position of 9 would be after 5. So here this while loop exits. And at the end we simply store the value 9 in the array at j plus 1th index. So value of j is 1. When we do plus 1, we get 2. So we simply store the value 9 at index 2. So now here you can see the three elements 1, 5, 9 are properly sorted. So therefore 9 will be now part of this sorted array. We increment I by 1. I becomes 3. And now we simply pick the first element of the unsorted array. So we simply store the value 2 into a temporary variable. Because now we want to place this 2 into its correct position in the sorted array. So when we'll perform these steps, we need to shift some of the elements by one position so that we can place 2 to its correct position. So when we'll shift these elements by one position, we need to create a space here. So what do we do is we simply store this value somewhere into the temporary variable, because we need to refer this while comparing it with the elements in the sorted array. So in order to access the sorted array, we simply do I minus 1. So j will keep the track of the sorted array. So now we'll perform the comparison. We'll see that j is greater than or equal to 0. So value of j is 2. Therefore this condition is true. So now we'll compare this 2 stored in this temporary variable with the element stored at jth index, which is 9. So here you can see 9 is greater than 2. Therefore the condition in while loop comes out to be true. And as 9 is greater than 2, we know that 2 must come before 9. So for 2 coming before 9, we need to create a space here. So what do is, we simply shift this value by one position by storing the value at jth index into j plus 1th index. So j is 2. So this value 9 we are storing in j plus 1th index, which is the third index. So 9 comes here with a shift. And as we have already stored this value at temporary variable, we can override this part. So 9 goes to the third index. So now we have compared it with 9. So we simply decrement j by one position, because there can be more elements which can be greater than 2. So j becomes 1. And as j is greater than 0, this condition comes out to be true. And the value stored at jth index, which is 5, is also greater than 2. Therefore the condition in while loop comes out to be true. And we simply shift phi by one position by assigning the value at jth index to value at j plus 1th index. So we are simply shifting phi by one position because value of j is 1. So this value we are assigning it to j plus 1, which is the second index. And then we'll decrement j by 1, because there can be more elements which can be greater than 2. So j becomes 0. Now whereas j is greater than or equal to 0, this condition comes out to be true. But the value stored at jth index, which is 1, is not greater than 2. Therefore we know that this value 2 will be stored somewhere after 1. And as we have already shifted phi to its correct position, this position is actually a space where we can store 2. So here this condition comes out to be false. And at the last step, as j is pointing to 0, we know that we need to store 2 after 1. So we simply store this temp value to j plus 1th index, which is the first index. So 2 comes here, which is actually 2's correct position. Now after this for loop ends, 1, 2, 5, 9 will become part of the sorted array. We'll simply increment I by 1. So I becomes 4. And now we simply want to put 10 to its correct position in sorted array. So we simply store 10 into this temporary variable. Moving ahead. So now as we want to compare the value stored at temporary variable with the elements in sorted array, we need to access the sorted array. So we simply do I minus 1 and we store it into j. So j becomes 3, which is the last element of the sorted array. So as j is greater than or equal to 0, this condition comes out to be true. But the value stored at jth index, which is 9, is not greater than 10. So therefore this condition comes out to be false. And we simply store this value 10 in this array at j plus 1th index, because 9 is at its correct position, and as it is less than 10, therefore 10 should be stored just after that. So we simply store 10 to j plus 1th index. So friends, here you can see that now 10 will also be part of this sorted array. And as there are no more elements left to be compared, because when we increment I by 1, I becomes 5. And as 5 is not less than 5, therefore the condition in for loop comes out to be false. And this for loop exits. So friends, here you can see we have sorted this array into ascending order, storing in the form as 1, 2, 5, 9, 10. So friends, in this lecture we discussed about the insertion sort algorithm by demonstrating the algorithm step by step, where we actually divided the array into two parts, the sorted part and the unsorted part. And with each iteration, we picked the first element of the unsorted part and we compare this element with each and every element in the sorted part to place the element into its correct position. And how we place the element in its correct position is by shifting all the larger elements which was greater than this first element of the unsorted array. So friends, this is the demonstration of the algorithm step by step. Now let's go to Eclipse and see the implementation of this algorithm and its working. I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in our previous lecture we saw the demonstration of the insertion sort algorithm step by step. So in this lecture we'll code the algorithm and we'll test its working. So here I have created one class as insertion sort. This class has method as print array, which simply prints the contents of this array on the console, which we already discussed in our previous lecture. So here let's say we want to sort this array having 5 elements as 5, 1, 2, 9 and 10. So when we'll print these elements on the console, let's say if I run the code, so here you can see it printed 5, 1, 2, 9 and 10. So here the array you can see is not in sorted form. So let's write the code to sort this array using the insertion sort. So here I will be creating one method as public void. Let's say I give the name of the method as sort. So this method will take the array which we want to sort. In the first step, what we do is we simply compute the number of elements inside the array by storing the length of the array to the integer variable n. And then, as we discussed in our previous lecture, that we start our algorithm with a for loop where value of I will be starting from 1 and not from 0, because the first element inside this array, when we pick to sort, we know that it's already sorted. So we simply start from the second element. So I starts from 1 and it goes till I is less than n. So friends, we also discussed that when we perform insertion sort, we usually divide the array into two parts. One is the sorted part and the other is unsorted part. So here the value which is tracked by I is usually the unsorted part, and the value which j tracks, which we'll see later, is usually the sorted part. So here, by providing this for loop, with each iteration we simply pick one element and we place that element into its correct position by applying the insertion sort. So we simply store the first element of the unsorted part into the temporary variable, And after we store this, now we simply access the sorted part. So here you can see that as I is starting from 1, so the element which is stored at the 0th index is already sorted and we can access it via j. So now j will basically keep the track of the sorted part. We provide a while loop where we provide two conditions, that j should be greater than or equal to 0, and as we want to compare the value stored into the temporary variable with each and every element stored in the sorted part, we provide another condition as the element stored at the jth index is greater than temp or not. So if this is true, inside this while loop what we do is we simply shift all the larger elements which are greater than temp by one position. And how do we do it? We simply take the value stored at jth index and we transfer it to the j plus 1th index. So here we are simply shifting larger elements to temp by one position, and after shifting the elements we simply decrement the value of j by 1, because inside this while loop we need to compare the temporary variable with each and every value of the sorted part. So friend, why we are shifting all the larger elements by one position, which are actually larger than value stored into this temporary variable, is because we need to find the correct position of the value stored into this temporary variable. So after we perform the shift by one position, we decrement the value of j by 1 and then we again compare it with the value stored into the temporary variable, and this loop goes on till j is greater than or equal to 0. So this is basically a boundary check, that we don't go to the out of the boundaries of the array. And after this while loop we simply store the value stored into this temporary variable into its correct position, which is at j plus 1th index, because here we'll exit the while loop with these two conditions, and as we have already decremented j by 1, we know that the correct position for the value stored into this temporary variable would be at j plus 1th index. So friend, after this for loop completes for one iteration, our sorted part increases by one value, and with each iteration the sorted part increases and the unsorted part decreases. And finally, when this for loop exits, all the elements of the unsorted part now becomes part of the sorted part. So friend, this is the insertion sort algorithm. We discussed this algorithm in greater detail in our previous lecture, and in this lecture we have simply coded this algorithm. So now we'll test its working. So here we'll call the sort method, we pass in the array, and after the sort happens we'll simply print the array again. So this print array will be called before sort and this print array will be called after sort. So if I run the main method now, so here you can see the array is already sorted. Initially it printed 5, 1, 2, 9, 10, which was the unsorted array, and then it printed 1, 2, 5, 9, 10, which is the sorting of the array in ascending order. So friend, in this lecture we saw the code for the insertion sort and we tested its working in main method. I hope you like this video. Thanks, have a nice day. Hello everyone. So in this video we will discuss about the selection sort algorithm. We will first understand what is selection sort and we will see a small demonstration of selection sort algorithm. So here, as we are performing selection sort, we are basically sorting the elements of an array into ascending order. So let's say we are given with this array with 5 elements as 3, 1, 5, 2, 6. We know these elements are unsorted and we want to sort them in ascending order using selection sort algorithm. So in this algorithm what we do is, we first divide this array into two parts. One is the sorted part and other is the unsorted part. So here you can see at the start all the elements are unsorted. So our sorted part and unsorted part looks like this, that all the elements currently are unsorted and there are no elements in the sorted part. Now what we do inside this algorithm is, let's say we are given with this boundary. What we do is we start with this boundary and we find which is the minimum element among these all the elements in the unsorted part. So once we find out which is the minimum element among these elements, we simply swap it with the leftmost element of this boundary. And as soon as we swap them, we know that the minimum element which we found is at its correct position. So for example, here you can see, when we pick the minimum element and swap it with the leftmost element of the unsorted part, which is this boundary, after swap, the element now becomes part of the sorted array. So for example, among these 5 elements, if we find out which is the minimum element, we can find that 1 is the minimum element. So what we do is, we see which is the leftmost element, which is 3 here, and we simply swap these two values. So it would look something like this, that these elements are swapped, and we also know that as 1 was the minimum element among these all the elements, 1 is at its correct position if we actually sort this array completely. It simply signifies that now 1 is the part of the sorted array and these 4 elements are part of the unsorted array. So this finding of minimum element in the unsorted part and swapping it with the leftmost element of the unsorted part is repeated till all the elements are part of the sorted array and there are no elements left in the unsorted part. So the idea behind this algorithm is very simple. We divide the array into two parts, sorted part and unsorted part. From the unsorted part, we pick the minimum element and we swap it with the leftmost element of the unsorted part. So the element which is next to this boundary, we simply swap the minimum element with this. And after we perform this swap, we know that the minimum element which we figured from this array is at its correct position. So at the each pass, one element from the unsorted part becomes the element of the sorted part. And at the last we only get the sorted part. So let's see the demonstration of this algorithm with a small example. So let's suppose we are given with this array having 6 elements indexed from 0 to 5 and they are unsorted. So let's say if we want to sort them in ascending order, here length of this array is 6. So the first step we do is we divide this array into two parts, sorted and unsorted part. So initially all the elements are unsorted. So therefore the sorted part has no elements and the unsorted part has all the elements. Now let's see what happens when we perform the first pass. So here what we do is we simply start from the unsorted part and we find that there is one element 3. So let's say we are assuming that 3 is the minimum element of this complete array. Now what we do is, we go to its next element and we compare 3 with 1. And we check that whether 1 is less than 3 or not. So here 1 is less than 3. So which means that our assumption is wrong and 1 will become our new minimum. So 1 becomes our new minimum, and simply we go on like this. We check whether 5 is less than minimum. So 5 is not less than minimum. We move ahead. We check whether 2 is less than minimum. So 2 is not less than 1. So we move ahead. And 4 is also not less than 1. 6 is also not less than 1. So here you can see, after we completed the first pass, we found that 1 is the minimum element among all the elements. So now what we do is, we simply swap this 1 with the leftmost element of the unsorted part. So the element next to this boundary, we simply swap it with that. So here we'll simply swap 3 and 1. So 1 comes here and 3 comes here. And after first pass, 1 is at its correct position. So therefore, now our sorted part has one element and unsorted part has the rest of the elements. Now we'll simply do the second pass and we perform the same steps. At first we consider 3 is the minimum element. We compare it with each and every element next to it. So 5 is not less than 3. We move ahead. So here 2 is less than 3. So 2 will become our new minimum. We move ahead. 6 is not less than 2. And 4 is also not less than 2. So after second pass, we found that 2 is the minimum element among the unsorted part. Now after we found out that 2 is the minimum element, what we do is we simply swap it with the leftmost element of the unsorted part. So we'll simply swap it with 3. So 2 comes here and 3 goes here. And we also know that 2 is at its correct position now. So therefore, now our sorted part has 2 elements and unsorted part has rest of the elements. So we'll go with the third pass now. We assume 5 is the minimum element and we compare it with the rest of the elements. We check whether 3 is less than 5. So yes, 3 is less than 5. So therefore 3 will become our new minimum. We compare whether 6 is less than 3. So it is not. So we move ahead. We check whether 4 is less than 3. So 4 is not less than 3. So after the third pass, we came to know that 3 is the minimum element among these elements which are part of the unsorted array. So after finding this minimum element, we simply swap it with the leftmost element of the unsorted part. So leftmost element is the 5. So we'll simply swap 3 with 5. And now our sorted part has 3 elements and unsorted part has the rest of the elements. We'll continue with the fourth pass. We'll assume 5 is the minimum element among the elements in the unsorted part. We compare it with the rest of the elements. 6 is not less than 5. So we move ahead. 4 is less than 5. So 4 will become our new minimum. So after this pass, among these 3 elements in the unsorted part, we came to know that 4 is the minimum element, and we will simply swap it with the leftmost element of the unsorted part. So we'll simply swap 5 and 4. Now our sorted part has 4 elements and unsorted part has rest of the elements. So our fifth pass will start. We assume 6 is the minimum element and we compare it with the rest of the elements. So there is only one element, which is 5. So we check whether 5 is less than 6. So yes, 5 is less than 6. So 5 will become our new minimum. And after the fifth pass, we found that among these 2 elements, 5 was the minimum. So we'll simply swap 5 with the leftmost element of the unsorted part. So 5 will come at this place and 6 will go at this place after the swap. And once we perform the swap, the minimum element which we swapped becomes part of the sorted array. So friends, here you can see that after the fifth pass, 5 came to its correct position and we are left only with one element. So by default this element at its correct position. So we don't have to perform these steps on the last element because it is already at its correct position. So the only thing to consider here is if the length of array is 6, then there are at least 5 passes, which is n-1, which is the length minus 1. So if there are 6 elements, we have to perform 5 passes to get the array in sorted form. So this was the basic idea behind the selection sort algorithm. We usually do 3 steps. First, we divide the array into 2 parts, sorted and unsorted. At the start, all the elements are in unsorted part. And then we apply the selection sort in different passes. So with each pass, what we do is we simply find the minimum element of the unsorted part and simply swap it with the leftmost element of the unsorted part. And after this swap, the minimum element which we just found becomes part of the sorted array. And this process is repeated till all the elements are part of the sorted array. So friends, this was the basic demonstration of the selection sort algorithm. In our next video, we will see the complete animation of the selection sort algorithm step by step. I hope you have liked this video. And in case you have liked this video, then please like, comment, share and subscribe my channel. Thanks, have a nice day. Hello everyone. So in our previous video, we saw a basic introduction to selection sort. And we also saw a demonstration that how selection sort is applied on an array having unsorted elements, and once the algorithm is applied, all the elements become sorted. So here let's suppose we are given with this array where the elements are unsorted. So in selection sort what we actually do is we divide the array into 2 parts. One is the sorted part and other is the unsorted part. So at the start, all the elements are part of unsorted part. And we have this boundary here. So what we actually do, we simply find out the minimum element in the unsorted part. So here let's say the minimum element among all these elements is 1. So what we do is we pick 1 and we simply swap it with the leftmost element of the unsorted part. And once we swap them, so it would look something like this. And we know that 1 is at its correct position because we want to sort the elements in ascending order. So after the swap is done, the element now becomes part of the sorted array. So the boundary goes here that we have now one element in the sorted part and rest of the elements in unsorted part. So this process is repeated for each and every element on the unsorted part till this boundary reaches to the end of the array. So when all the elements are sorted, the unsorted part has 0 elements and all the elements are in sorted part. So in our previous video we saw step-by-step demonstration of the algorithm. Now we'll see the step-by-step demonstration of the actual code. So here you can see this is the algorithm to perform the selection sort on an array, and this algorithm will sort the elements into ascending order. So let's say when we call sort method and pass in an array. So let's suppose this is our array having 5 elements 5, 1, 10, 2 and 9. Now here you can see they are indexed from 0 to 4. Moving ahead, in the first step what we do is we simply store the length of the array in an integer variable n. So value of n is 5 because we have 5 elements. Moving ahead, also friends, in our previous video we discussed that we divide this array into two parts, the unsorted part and the sorted part. So when we start the algorithm, the sorted part has 0 elements and unsorted part has all the elements. So here basically what we do, we find the minimum element in the unsorted part, and once we find that out, we simply swap it with the leftmost element of the unsorted part. And once the element is swapped, now that element becomes part of the sorted array and this boundary will get shifted by 1 position. So here you can see this outer for loop goes from I equal to 0 to a value I less than n minus 1. So here basically I will keep the track of this boundary, and here you can see it will start from 0 and it will go to less than n minus 1, which is 4. So it will go till 3 here. So why we traverse I to less than n minus 1? Because when we are on the last pass, the last element goes to its correct position and we don't perform this algorithm on the last element because we know that that element is at its correct position. So we will see the demonstration of the algorithm and it will be more clear to you. So currently we'll start with I equal to 0 and 0 is less than 4. So the condition in for loop will be true and the for loop will execute. So here whatever the value I is holding, it will be simply the indexes of this array. So it can be symbolically represented like this. So in selection sort, our first task is to find the minimum element among the unsorted part. So here you can see we first assume that, let's say, whatever the value I is holding, we treat it as the minimum value. So here we create an integer variable and we store the value of I. So min will also become 0, which signifies that we are assuming that value 5 is the minimum element among these all the elements. And now we provide the inner for loop. Now this inner for loop is for actually finding the minimum value. So here this is our assumption, and in order to find the minimum value among all these elements, we need to compare this minimum value with all the elements of this array. And once we find any value which is less than the minimum value, our min will point to that value. So let's see how. So here this for loop will start from I plus 1, because here you can see we are assuming that 5 is our minimum value and I is pointing to it. So we start this inner for loop with j equal to I plus 1. So here you can see value of j will become 1, which is 0 plus 1. So which signifies that we are starting from this value, because we need to compare now 5 with each and every value of this array. So j starts from I plus 1 and it will go till j is less than n. So less than n will becomes 4, because we want to compare it with each and every element. So last index of j would be 4. So let's move ahead and see how it works. So in the first step we are simply comparing that whatever we assume to be the minimum value is the value at jth index less than the index value which min is holding. So here you can see the value at array of min would be 5 and array of j would be 1. So now we'll simply compare these two values, and here we are checking that whether 1 is less than 5 or not. So here you can see this condition comes out to be true. So as we have found a minimum value, now what we'll do, we'll simply update the minimum to this value. So whatever the value j is holding, which is 1, now min will point to this value holding a value as 1. So min becomes 1 and symbolically it will point to an index 1. Moving ahead, we'll increment j by 1 because now we need to compare this 1 with rest of the elements. So j becomes 2. Now we'll compare these two values and we check whether 10 is less than 1 or not. So 10 is not less than 1. So this condition comes out to be false. We'll increment j by 1. So j becomes 3. Now we'll compare these two elements. That value of array at min index is 1 and value of array at jth index is 2. So we'll now compare these two values. So here you can see 2 is not less than 1. So this condition comes out to be false. We'll increment j by 1. So j becomes 4. And now we'll simply compare 1 with 9. And we'll simply check here whether 9 is less than 1 or not. So 9 is not less than 1. So therefore this condition comes out to be false. And now we'll increment j by 1. So j will become 5. Which means that j is now out of these boundaries. And this condition here you can see j should be less than n. So j value is 5 and 5 is not less than 5. So therefore this for loop will terminate. And we simply reach here. So here you can see that we have found out the minimum value among these elements, which is 1. And in selection sort what we do is we simply swap it with the leftmost element of the unsorted part, which is being held by the value I. So here we are performing this swap using this temporary variable. So in the first step, we are storing the value 1 into the temporary variable. So temp becomes 1. And then we are simply swapping the value at ith index, which is 5, into this index. So 5 will come here. And at the last step, we are simply assigning value stored at temp into the ith index, which is this. So we have simply swapped these elements. And after we perform this swap, we know that 1 is at its correct position because we need to sort all the elements in ascending order. So now this 1 will go into the sorted part and rest of the elements will be still in the unsorted part. So the call will reach here in the outer for loop, will increment I by 1. So I will become 1. So now I will point to this index, which is 1. In the first step, we are assuming that let's say this is our minimum value among all the elements. So we are simply assigning value of I to min. Moving ahead. Now as we need to find the minimum element from the unsorted part, we need to provide this inner for loop, which will start from j equals to I plus 1. So I is pointing to index 1. So j will start with index 2 and the value of j, which is 2, is less than 5. So this condition comes out to be true. So now here again we are simply performing this check that whether 10 is less than 5 or not by taking in the value at jth index and the value at min index. So min is pointing to index 1 and j is pointing to index 2. So we are taking these two values and we are comparing that whether 10 is less than 5 or not. So this condition comes out to be false because 10 is not less than 5. We'll increment j by 1. So j becomes 3. So still you can see 3 is less than 5. So this condition comes out to be true. Now we'll compare these two values. We check whether 2 is less than 5 or not. So yes, 2 is less than 5. So this condition comes out to be true. And as this condition comes out to be true and we need to find the minimum element among these elements. So now our min will point to this index because we have found a minimum value. Moving ahead, we'll increment j by 1. So j becomes 4. And 4 is less than 5. So this condition comes out to be true. Now here we check that whether 9 is less than 2 or not. So 9 is not less than 2. So this condition comes out to be false. J becomes 5. So now this condition 5 is not less than 5. So this for loop will terminate. And we have found our minimum element, which is 2. So we'll simply swap it with the leftmost element of the unsorted part, which is being tracked by the value I. So we are simply swapping 5 with 2 using these 3 steps. So we'll quickly go over these 3 steps. Temp will have value 2 with this statement. We will transfer 5 to this position by assigning the array value at ith index to the array value at min index. So this becomes 5. And at last we'll store the value of temp into the ith index. So this becomes 2. So friends, here you can see after we perform this swap, now 2 will also become part of the sorted part. With each pass, the sorted array is increasing and the unsorted part is decreasing. So now we'll increment I by 1. So I becomes 2. And 2 is less than 4. So this condition comes out to be true. So now we need to find the minimum element among this unsorted part. So we are assuming that whatever the value I is holding currently, it's the minimum value. So we are simply assigning value of I to min. So value of min will become 2. And now we need to compare 10 with rest of the elements. So for that we need to provide this inner for loop where j will start from I plus 1 because we need to compare this with other elements. So I is already pointing to this element, so we'll start j by I plus 1. So j becomes 3. Now we'll simply compare these two values. And here we are finding that whether 5 is less than 10 or not. So this condition comes out to be true. So we have found our minimum element after this comparison. So we'll simply update min to this value 3. And we continue with our for loop. We'll increment j by 1. J becomes 4. And 4 is less than 5. So this condition comes out to be true. Now we simply check whether 9 is less than 5 or not. So 9 is not less than 5. So this condition comes out to be false. We'll increment j by 1. So j becomes 5, which is out of bounds of this array. And here 5 is not less than 5. So this condition comes out to be false and our for loop will terminate. So here you can see we have found our minimum element, which is 5. Now we'll simply swap it with the leftmost element of the unsorted part, which is being tracked by value I. So we are simply performing this swap where 5 will come to this position and 10 will come to this position. So here after we perform swap, now 5 is at its correct position and now this will become part of the sorted array. We'll increment I by 1, so I becomes 3 and 3 is also less than 4. So this condition comes out to be true. Now at the first step we assume that 10 is the minimum value. So we simply assign the value of I to min, which is 3. So it will point to the third index. And now we need to find the minimum element from the unsorted part. So only 2 elements are left. So we'll start our inner for loop with j equal to I plus 1. So j will start with 4. 4 is less than 5. So this condition comes out to be true. And here we'll simply compare that value at jth index, which is 9, is less than value at min index, which is 10 or not. So 9 is less than 10. So this condition comes out to be true. And we have found our minimum element among these two elements. So min will be updated to 4 by assigning the value of j, which is 4, to min. We'll increment j by 1. So j becomes 5, which means that 5 is not less than 5. So this condition comes out to be false. And then as we have found our minimum element, we'll simply perform a swap with the leftmost element of the unsorted part, which is being tracked by I. So 9 will come to this position and 10 will come to this position using this temporary variable. So first 10 will come here, and then whatever the value is stored here, which is 9, will come here. So after this swap, we know that 9 is at its correct position, so this will be part of the sorted array. So friends, here you can see that at the end there were only 2 elements, and as we sorted the second last element, the unsorted part was left with 1 element. So this algorithm should not be applied to this element because this is already sorted, because this is at its correct position only now. So therefore we provided this condition that I should go to less than n minus 1. So here if we increment now I by 1, I becomes 4. So I will come to this point, but here you can see 4 is not less than 4, which makes sense because now I is pointing to the last element, and if it is the only element left, then we are sure that the last element is actually sorted. So friends, here we saw the demonstration of the selection sort algorithm step by step. And once this algorithm gets finished, we found all the elements sorted into the ascending order. So now let's go to IntelliJ and code this algorithm and test its working. So friends, I hope you have liked this video. And in case you have liked this video, then I would request you to please like, comment, share and subscribe my channel. Thanks, have a nice day. Hello everyone. So in our previous video, we discussed about the selection sort algorithm, and we saw the demonstration of the algorithm step by step using an animation. Now in this video, we'll code the algorithm into this sort method where we simply pass in the array which we want to sort, and we'll simply apply the selection sort and test its working in the main method. So currently we are given with this array 5, 1, 2, 9, 10, and if I run the main method, so here we'll see that we are simply printing the array now using this print array method. So 5, 1, 2, 9, 10 got printed. Now let's code the algorithm in this sort method. So in the first step, what we do is we create an integer variable n which will hold the length of the array, because we will use this value of n in the algorithm while we provide the for loops. Now at the first step, we provide a for loop which starts from integer I equal to 0 to a value less than n minus 1 I plus plus. So in our previous video, we discussed that we are actually dividing the array into two parts, the sorted part and the unsorted part. So basically this I will keep the track of the sorted and the unsorted part. So at the start, all the elements are part of the unsorted part. So therefore the value of I will be 0. And the value of I will go to less than n minus 1. So here you can see we have these 5 elements. So the value of n will be 5. And if we do minus 1, it will be 4. So I will go from 0 to 3. Now why this I will go from 0 to 3 is because if we see the indexes, it starts from 0 and 3 will come to this point. So when we compare these last two elements and we sort them, then we know that both the elements will be at its correct position. So this algorithm should not go further ahead, because if I will come to this point, then we know that this is already sorted. So we are keeping track of the I till less than n minus 1, and which we already discussed in our previous video in great detail. So you can watch that video. Now inside this for loop, as we want to find the minimum element in the unsorted part, so what we do is we assume that min is pointing to index 0 at the start, and we are assuming that the first element is the minimum element, and after that we need to provide a for loop. Now this for loop will start with j equals to I plus 1, and this will go till less than n j plus plus. So here you can see that we are assuming the value held by an array at the ith index is the minimum value. So this is our assumption, and in order to find the minimum element among the unsorted part, we need to provide this for loop where we will compare all the elements with the value held by the min index. And as the min is pointing to the ith index, we are starting this inner for loop with j is I plus 1. And j will go till less than n, because we need to compare this minimum value with each and every element of the array. So j will go till the last index, and inside this for loop we'll provide a condition as if value at jth index is less than value at min index, then we know that we have found one more element which is less than the value at min index. So what we do is we simply update the min value to point to j, because we have found a new minimum value. So now min will point to the jth index, and this for loop will go on till all the elements are compared with the min value. And after this for loop will terminate, we know that we have found our minimum value whose index is being held by the min integer. So after the for loop, we'll simply swap this minimum value with the leftmost element of the unsorted part, which is being held by the value I, because we already discussed that we divide the array into two parts, the sorted part and the unsorted part, and I will keep the track of that boundary. So at the start I will point to 0, which would be the leftmost element of the unsorted part. So we'll simply swap this minimum value with the value stored at the ith index, and we'll use this temporary variable. So we first store the value at minimum index, which would be our minimum value, into the temp. And then we will assign the value at ith index to value at min index. And at the last, whatever the value stored in temp will assign to ith index. So here you can see, after we perform this swap, one element reaches to the sorted part, and then we increment the I by 1. So I becomes 1, and the rest of the algorithm is repeatedly performed on an array till we get all the elements into the sorted part. So in order to understand the selection sort using an animation, you can watch my previous video. So this is the code for the selection sort. Now let's test its working. So after printing the array, we will call the sort method. We pass in the array, and once this method gets executed, we will simply print the array again. If I run the main method, so here you can see initially array was 5, 1, 2, 9, 10, and after we perform the selection sort, it became 1, 2, 5, 9, 10, which is in ascending order. So friends, this was all about the selection sort algorithm. I hope you have liked this video, and in case you have liked this video, then please like, share, comment and subscribe my channel. Thanks, have a nice day. Hello everyone. So in this video we will discuss that how we can merge two sorted arrays in Java. So usually in this problem we are given with two sorted arrays, and both the arrays are sorted in ascending order, and our task is to merge these two arrays in such a way that the resultant array is also sorted. So let's go ahead and see that how we can merge two sorted arrays in Java. So before we start, in case if you are new to my channel, then please subscribe to my channel so that you don't miss any update. So here, let's suppose we are given with these two arrays, array 1 and array 2. And here if you see, both these arrays are sorted in ascending order. So array 1 has 4 elements, 2, 3, 5, 10, and they are sorted in ascending order. And same with array 2, having elements as 4, 6, 11 and 15. Now our task is to merge these two arrays in such a way that the resultant array is also sorted. So the idea behind this algorithm is we create a resultant array whose length is the length of array 1 plus the length of array 2. So in this case array 1 has length 4 and array 2 has length 4. So our resultant array will have length 8 because we need to merge all the elements of array 1 and array 2 into this result array. So in this algorithm, as both the arrays are sorted in ascending order, what we do is we simply compare the elements of array 1 with array 2, and whichever the element is smaller, we simply put it into the result array. So how do we perform this algorithm is, we take 3 pointers. One pointer will start from array 1, second pointer will start from array 2, and there will be third pointer which will start from our result array. So the 3 pointers we create is I, which will point to the 0th index of array 1, j, which will point to the 0th index of array 2, and k, which will point to the 0th index of result array. So here as both the arrays are sorted, we simply compare the elements stored at the ith index of array 1 with the element stored at the jth index of array 2, and whichever of them is smaller, we simply put it into the kth index of result array. So here in first step, we compare 2 with 4 because I and j are pointing to an index having value as 2 and 4. So here we see 2 is less than 4. So therefore we simply update this value to kth index of the result array. So it would look something like this. 2 will come to this position. Now here, as we have filled this value here, so we simply increment I by 1. And as we have filled this position, we also increment k by 1. So now we'll again compare the value at ith index with the value at jth index of both the arrays. So we'll compare now 3 with 4. So here you can see 3 is less than 4. So we simply update the value 3 into this position. And as we have used the value 3, we simply increment I by 1. And we have filled this position, so we increment k also by 1. So now we'll again perform this comparison. We compare 5 with 4. So now here you can see 4 is less than 5. So therefore we put this value 4 into this kth index. Because our task is to merge these two sorted arrays and the result array should also be sorted. So therefore we perform this check, and whichever is the minimum value, we simply put it into the result array. So now we have used the value stored at jth index, so we'll simply increment j by 1. And we have filled this value, so we'll increment k also by 1. So here you can see, wherever we are finding any lowest value in array 1 or in array 2, we are simply incrementing that pointer. And why we are not incrementing the other pointer is because that value still needs to be filled inside this array. So now as we have incremented j by 1, we'll compare 5 and 6 because those values are referred by I and jth index. And here we know that 5 is less than 6, so we'll simply update 5 value at the kth index. And as we have used this value, we'll increment I by 1. We have occupied with this position, so we'll increment k also by 1. Now we'll compare 10 with 6. So here you can see 6 is smaller than 10. So 6 value will be updated here. And as we have used this value 6, we'll increment j by 1. And we have filled this position, so we'll also increment k by 1. Now we'll compare 10 with 11. So here you can see 10 is less than 11. So value 10 will be updated here. We'll increment I by 1. So here you can see, now as we are incrementing I by 1, I will be crossing the boundaries of array 1. So now there is no more element left in the array 1 to be compared with the elements in the array 2. It means all the elements of array 1 are filled into the result array, and we are only left with the elements of array 2 which are already sorted. So now our task is to simply put these values into its respective positions here, because we don't have to compare these values with any other value because these are already sorted in ascending order. So as we incremented I by 1, after filling the value 10 here, we'll increment k also by 1. And now we'll simply copy the remaining elements of array 2 into this result array using the jth pointer. So the first step, we'll simply copy 11 here. Then we'll increment j by 1, and we'll also increment k by 1, and we'll simply copy 15 into this kth index. We'll increment j by 1, So j has reached out of these boundaries now for array 2, and we'll also increment k by 1. So k has also reached to its end. So which signifies that both these array elements are now part of this result array. And as both the arrays were sorted in ascending order, you can see the result array is also sorted in ascending order. So here this is the idea of how we can merge two sorted arrays by simply using three pointers I, j and k. I will traverse array 1, j will traverse array 2 and k will traverse our result array. We will simply compare the values stored at ith and jth index of their respective arrays, and whichever the value is small, we'll simply update it into the result array at the kth index. And after we update these values, whichever value we took either from array 1 or from array 2, we'll simply increment that respective pointers. And as we are filling up the positions in the result array, we will also increment the kth pointer. So friend, this was all about the demonstration of how we can merge two sorted arrays and create a resultant array which is also sorted. In our next video, we will look into the animation of the actual algorithm which is involved in merging these two arrays. So friend, in case you find this video informative, then please like, comment, share and subscribe my channel. Thanks, have a nice day. Hello everyone. So in our last video, we discussed about that how we can merge two sorted arrays in Java. We discussed about the idea that how we can merge two sorted arrays. So in this video, we'll see the step-by-step demonstration of the algorithm. But before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss an update. So here you can see that this is the algorithm to merge two sorted arrays, array 1 and array 2, into a result array and simply return the result array from this method merge. So let's see the demonstration of this algorithm step by step. So initially, when we call this merge method, we pass in the two sorted arrays, array 1 and array 2, and we also pass the length of these two arrays with a variable as n and m. So n will correspond to the length of array 1 and value m will correspond to the length of array 2. So when we call merge method, here you can see that for this example we are taking two arrays which are sorted in ascending order having length as 3. So let's say we are providing these two sorted arrays having length as 3, and here you can see the elements are sorted in ascending order in both the arrays. And now our task is to merge these two arrays into a result array and return that result array from this method. So the length of these arrays are denoted by n and m having values as 3. So in the first step, as we want to merge these two arrays, all the elements should be part of the result array. So first we create that array by name result, and the length of that array would be n plus m, because we need to merge these two sorted arrays and our result array should contain all the elements of both these arrays. So after this line gets executed, we are provided with this array whose length is 6. Moving ahead, and as we discussed in our last video, the idea behind this algorithm is we create three pointers I, j and k. We'll initialize it with 0 value. Now what these pointers are? The pointer I will traverse array 1 starting from 0th index, so we have provided value 0. Pointer j will traverse array 2 starting from 0th index, and pointer k will traverse the result array starting from 0th index. So here you can see the purpose of these three pointers are different. So in this algorithm, at any instant we are comparing the value stored at ith index with the value stored at jth index, and whichever the value is smaller, we are simply updating into the result array at kth index. So these two pointers are used for comparison, and this pointer is used to fill this array. And the filling of this array is sequential, where we place in elements one by one and will increment k one by one. And similarly, this comparison also sequential. We are finding the minimum value at each iteration and we are simply updating into the result array. So here, at the start of this algorithm, we are providing this while loop. Now why we have provided this while loop is because we need to compare the value stored at ith index and value stored at jth index. So it simply means I will traverse the array 1 and j will traverse array 2. So in order to perform this traversal and comparison, we are providing this while loop. And inside this while loop, we have provided two conditions. One is I should be less than the length of array 1 and j should be less than m, which is length of array 2. Now why we have provided this condition is because as we are comparing and incrementing values of I and j, which you can see here, so there can be a chance that j goes out of bounds for array 2 and I goes out of bounds for array 1. So when any of this pointer will exhaust its respective arrays, we'll simply exit this while loop because there are no more elements left to be compared between these two arrays because one array is already exhausted. So therefore we have provided these two conditions. So at the start, I is pointing to 0, j is also pointing to 0, I is less than 3 and j is also less than 3. So therefore this while loop condition comes out to be true. Now in the while loop we are comparing that whether value at ith index for array 1 is less than value stored at jth index for array 2 or not. So here you can see, so we are comparing 2 with 3. So here you can see 2 is less than 3, so this condition comes out to be true. So therefore if block will be executed. Now as we have found a minimum value among these two values and we want to merge these two sorted arrays into this result array in sorted form, then what we do is we simply update the value at ith index for array 1 into this result array at kth index. So 2 will come here. Moving ahead. Now as we have used this value, so we'll increment I by 1. So currently I is 0, I will become 1. And after this if else, we will increment k by 1 because we have filled this position here. So now we need to go to next position to get the next element. So k becomes 1. We'll check both these two conditions. So 1 is less than 3 and value of j is 0. So 0 is also less than 3. So this both the condition comes out to be true. Now we'll again compare value at ith index for array 1 with value at jth index for array 2. So which is we are comparing 5 with 3. Now here you can see 5 is not less than 3. So therefore this condition comes out to be false and else part will be executed. So in the else part, as 3 is less than 5, we'll simply update value of 3 to the result array. So here we are assigning value stored at jth index for array 2 into result array at kth index. So 3 will come here. Now as we have used the value 3, we'll increment j by 1. So j becomes 1. And we are not touching I because we need to still get this value 5 and store it somewhere into the result array. So I will simply point to the same index. We'll increment k by 1 because we have filled its position. So for the new value, we'll simply go to its next index. So k becomes 2. 1 is less than 3 and 1 is less than 3. So this both the condition comes out to be true. We'll compare value at ith index for array 1 with the value at jth index for array 2. So here we are comparing 5 with 4 now. And here you can see 5 is not less than 4. So this condition comes out to be false. And in the else part, as we have found the minimum value as 4, we simply update 4 into the result array by this assignment. And as we have used this value, we'll increment j by 1. And we have filled this position, so we'll increment k by 1. K becomes 3. Here still I is less than n and j is also less than m. 1 is less than 3 and 2 is also less than 3. So this both condition comes out to be true. We'll now compare 5 with 9 because those are the values pointed by I and jth index. And here you can see 5 is less than 9. So therefore this if block condition comes out to be true. So now it's time to update value 5 into the result array. And as we have updated value 5, we'll increment I by 1. So I becomes 2. And as we have filled this position, we'll increment k by 1. So k becomes 4. So still this while loop condition comes out to be true because I is less than n and j is also less than m. We compare these two values, 7 and 9. We found that 7 is less than 9. So therefore this condition comes out to be true. So we simply update value stored at ith index in array 1 into the value 8th kth index for result array. So 7 comes here. And then we'll simply increment I by 1. So I becomes 3. So here you can see now I has crossed the boundary for array 1. We have used this position, so we'll increment k by 1. K becomes 5. So friends, now here you can see that array 1 is already exhausted. So this condition I is less than n, where 3 is not less than 3. So therefore this overall condition will come out as false and this while loop will terminate. So here you can see whenever any of the array gets exhausted, we'll simply break from this while loop. And then our execution point will reach here, where we are encountering two while loops. So friends, here you can see that there can be a chance that array 1 gets exhausted first or array 2 gets exhausted first. So when this while loop will terminate, we are not sure that which array gets exhausted first. So therefore we have provided these two while loops. So here let's say for example array 2 gets exhausted first. So if array 2 gets exhausted first, there can be leftover elements in array 1 which needs to go into the result array. So we are providing this while loop where we are simply traversing I to complete the array 1, get those elements from array 1 and simply fill it in the result array. Because as both the arrays are sorted, we are simply copying the leftover elements from the respective array into the result array. So this while loop is when array 2 will get exhausted and this while loop is when array 1 will get exhausted. So currently for this example you can see array 1 got exhausted. So this while loop will not get executed because the condition here is I should be less than n. So 3 is not less than 3. So therefore this while loop won't get chance to execute because array 1 is already traversed completely. And we know that there are leftover elements in array 2 because j is less than m, 2 is less than 3. So whatever elements are left over in array 2 will simply get copied into the result array because those elements are already sorted. So we'll simply store value 9 into the result array by this assignment. And after doing this assignment, here for this small example you can see that there was only one element, so we simply updated one element here. But let's say if there are many elements And as these arrays are sorted, so we can simply copy those leftover elements directly into the result array, because there are no elements left for array 2 to get compared with array 1, because array 1 is already exhausted. And same thing goes when array 2 gets exhausted and there are leftover elements in array 1. So these two for loops are important because they simply copy the leftover elements from their respective arrays to the result array. And there can be multiple elements which are left over, so therefore we are providing this while loop. So at the last step of this while loop, we are incrementing j by 1 and k by 1. Because we have migrated value 9 into result array, so j will now get incremented by 1. J becomes 3, which means now j has crossed the boundary of array 2. And will also increment k by 1. So k becomes 6. So which means k has traversed the result array completely by filling out each and every position. So now we'll again compare whether j is less than m or not. So here you can see 3 is not less than 3. So therefore this condition comes out to be false, which signifies that we have completely migrated all the elements of array 2 to result array. So friends, finally here you can see that we have merged these two sorted arrays into a result array which is also sorted. So finally we'll return result from this algorithm. So friends, in this video we discussed the algorithm, that how we can merge two sorted arrays. So in case if you find this information useful, then please like, comment, share and subscribe my channel. Thanks, have a nice day. Hello everyone. So in our previous video, we discussed step-by-step demonstration of how we can merge two sorted arrays. In this video, we'll actually code the algorithm and we'll test its working. But before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss an update. So here I have created one class as merge sorted arrays, which is having a method as print array, which takes in an array and print its elements on the console. So we have discussed this print array method in our previous videos. So I will simply use this print array method to demonstrate how we can merge two sorted arrays in Java. So here you can see I will be creating one method as public whose return type would be an integer array, because we want to merge two arrays which are sorted and we want to return back the merge sorted array having elements of array 1 and array 2. So the method name I will be giving as merge. This method will take four things. One would be the array 1, other would be array 2, the length of array 1 and length of array 2, which is being denoted by n and m. So here you can see that array 1 and array 2 are already sorted arrays and we want to merge them together. So at the first step what we do is, as we want to merge them, we'll simply merge them in the result array. So we'll create a result array. Now the size of this array would be n plus m, because we want to accommodate the elements of array 1 and elements of array 2 into the result array. So the idea behind this algorithm is we create three pointers I, which will start from 0. So this pointer will traverse array 1 from start to finish. We'll create one more pointer which will start from 0 and it will traverse array 2, and we'll create one more pointer k which will start from 0 and which will traverse result array. So here why we have created this three pointer is because pointer I will traverse array 1 elements one by one and j will traverse elements of array 2 one by one, and we'll simply compare those two values stored at I and jth index, And based on our comparison, whichever value will be small, we'll simply store it into the result array at kth index. And after we store this value, whichever value of that particular array we get as a small, we'll simply increment pointer of that array. And after filling the result array at kth index, we'll also increment k by 1. So here, in order to perform that, we provide a while loop. And inside that while loop, we provide two conditions. One is I should be less than n and j should be less than m. So these are nothing but boundary conditions where we are simply checking that whether I is in the boundaries of array 1 and j is in boundaries of array 2. And we have provided this AND condition because in this while loop we are comparing the value stored at ith index with the value stored at jth index for their respective arrays. And in case any of this array gets exhausted, which means that either I will cross over array 1 or j will cross over array 2, we simply break from this while loop. So inside this while loop we are providing a condition as if value at ith index of array 1 is less than value at jth index for array 2. So here it signifies if array 1 element at ith index is less than array 2 element at jth index. So if this is the condition, then after this comparison, this value is the smallest value. And as we want to merge these two sorted arrays into a result array, and that also should be in sorted form, so therefore we simply update the smallest value at the kth index, which means storing array 1 element into result. And after we store array 1 element, we have occupied the ith position into the result array. So we'll increment I so that we can go to its next index. And similarly, if this condition is false, then in the else part, we do the opposite of it. We store the value at jth index for array 2 into result, because here we know that if this condition is false, then value stored at jth index for array 2 will be smaller than this value. So we are storing that value into the result array. And as we have used the value stored at jth index, we will simply increment j by 1. So after storing the minimum value among these two values into the result array, we have filled the kth position in the result array. So we'll also increment k by 1 so that k traverses to an unfilled position, so that when this while loop will be executed again, we are left with a unfilled position. So after this while loop gets terminated, there can be two possibilities. Either array 1 got exhausted or array 2 got exhausted. If array 2 got exhausted, which means that all the elements of array 2 are now part of our result array, and whatever leftover elements are there in array 1, we simply copy it into the result array. So for that we'll use the while loop. We provide the same condition as I should be less than n, because we are simply copying the leftover elements of array 1 now. So we copy this and will increment k also by 1 after filling the position. So here this while loop signifies that array 2 got exhausted. And similarly, we don't know that which array got exhausted in this above while loop. So we need to provide the same while loop for the array 2 as well. We provide the condition as j should be less than m. This will signify that array 1 got exhausted first. We'll increment j by 1 and we will keep rest as it is. So friends, here you see that why we have provided these two while loops is because we don't know whether array 1 got exhausted first or array 2 got exhausted first. So if array 2 got exhausted first, we are simply copying the leftover elements of array 1 into result. And if array 1 got exhausted first, we are copying the leftover elements of array 2 into the result using this while loop. And why we are simply copying these elements from the respective arrays, because those elements are already sorted and we don't have to compare it with any other elements. Whatever the comparison we need to do, we have done it in this while loop. So at the end, we'll simply return the result array. So friend, this is the code for merging two sorted arrays. Now let's test its working in the main method. So here I will be creating two arrays. Array 1. Let's say I provide the value as 0, 1, 8, 10. These four values. And here you can see these are sorted in ascending order. And similarly, I create array 2. Let's say I provide value as 2, 4, 11, 15 and let's say 20. So these values are also sorted in ascending order. Now let's print both these array on the console. If I run the code now, so here you can see it is simply printing both the arrays on the console. Now we will call our merge method. We pass in array 1, array 2, length of array 1 which is denoted by n, and length of array 2 which is denoted by m. So this method will return us the result array. So we'll store it into the result variable and finally we'll print the result array. If I run the code now, so friends, here you can see that it returned 0, 1, 2, 4, 8, 10, 11, 15, 20. It merged these two sorted arrays and returned us the result array, which is also in sorted form. So friends, this was all about the code and working of the algorithm. Now why this algorithm is important, because the similar approach is usually used when we actually perform the merge sort, which we will be looking into our upcoming lectures. So there we'll simply use this idea and we'll perform the sorting of array using merge sort. So friends, if you find this information useful, then please like, comment and share this video. And in case if you are new to my channel, then please subscribe to my channel so that you don't miss any new update. Thanks, have a nice day. Hello everyone. So in this video, we will be looking into a sorting technique. We call it merge sort. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So what is merge sort? So here you can see that merge sort is a divide and conquer algorithm. So divide and conquer algorithm is very widely used algorithm to solve the problem. Now as per the Wikipedia, here you can see divide and conquer recursively breaks down a problem into two or more sub-problems of the same or related type until these becomes simple enough to be solved directly. So when we divide a complex problem into two or more smaller sub-problems and we keep on doing it till those smaller problems are easily solved. And after breaking this complex problem into smaller sub-problems, what we do is we solve those smaller sub-problems, we take their solutions and then combine them to give a solution to the original problem. So basically we divide a large problem into various smaller sub-problems and we keep on doing it till those sub-problems are simple enough to solve. And once we solve them, we have their solutions. So what we do is we take their solution and we combine them so that we get the solution to our original problem. So at this step, when we are combining the solution of smaller sub-problems and getting the solution to our original problem is actually the conquer part of it. So let's see how this divide and conquer algorithm fits into merge sort. So when we are given an array and we want to sort them, what we do is we first apply the divide part. Now in this step, what we do is we take the middle point of the array and divide the array into two halves. And once we divide the array into two halves, now the algorithm is carried out recursively on these two halves, and it goes on till there are no more halves of arrays to divide. So we keep on dividing it till there is only one single element left, which is not further divided. So after this divide step ends, what we do is we then conquer. And how we conquer is in this step, from the bottom, we take those smaller half arrays, we sort them and merge the divided arrays and get the sorted array. So we'll see this divide and conquer with an example to make it more clear. So for time being, we divide an array into two halves and we keep on dividing them into two halves till there is only single elements are left and those are not pretty much divided. So when we pick those single elements, those are already sorted. So we simply merge them and get the sorted array, and we keep on doing this till the complete array is sorted. So let's see these two steps with an example. So first we will see the divide part. So now let's say we are given with this array and we want to sort it in ascending order. So in the divide part, what we do is here we can see that there are 7 elements: 2, 10, 5, 3, 6, 4 and 11. Now we simply evaluate the mid position. So here is 3. So how we evaluate this mid position is we'll see later. But here you can see that as there are 7 elements, from 0 to 3 we break it down into one array, and from 4 to 6 we break it down into other array. So here you can see now this was our original problem to solve. We break it down into two smaller sub problems, and after breaking it down into two smaller sub problems, we do it recursively again into this smaller sub parts. So here what we do is after breaking it down into two parts, we take this part and we further break it down into two parts. So this algorithm is pretty much recursive in nature. And now as this algorithm is recursive, we take this smaller half and we break it down into two halves. So here you can see that after breaking this 0 and 1, we are left with single element 2 and 10. So here algorithm decides that okay, we can't break 2 and 10 further down. So what we do is the divide part is done for this piece. So then we conquer. So in merge sort, a single element is already sorted. And in the conquer step, this is the smallest solution we have. That let's say if the array had only one element, it would have been sorted. So now in the conquer part, we actually merge them. So in one of our previous videos, we have discussed that how we can merge two sorted arrays. So this is the first sorted array and this is the second sorted array. So in the conquer step, we merge them, and we merge them in such a way that we compare their respective elements one by one and we try to merge them. So here we compare 2 with 10 and we simply merge them to get the sorted array. So after merging those two sorted arrays, we are left with a larger sorted array. So here 2 and 10 are actually sorted. Now this conquer is done for this particular step. The algorithm then tries to break this part because as this is a recursive algorithm, it breaks it like this. First it breaks in 4, then 2, then 1, 1. And after merging the smaller subunits, it takes the next unit and break it down into smaller pieces. So it breaks 5 and 3 like this. So 5 and 3 cannot be broken down further. So now it conquers it. So here it simply compares 5 and 3 and we get 3 and 5 because 3 is smaller. So 3 comes here and 5 comes here. So here you can see that this is the first sorted array and this is the second sorted array. And now we simply merge these two parts because these are solved problems of our smaller sub problems. So in the conquer step we actually merge them. So after merging these two sorted arrays, it looks something like this. So 2 is compared with 3, it comes here. Then 10 is compared with 3, so 3 is smaller, so 3 comes here. Then 5 is compared with 10, 5 is smaller, so 5 comes here, and then 10 goes here. And this step is done. So now algorithm will pick this part and try to break it down using the divide step. So it will break it down like this, 6 and 4 and 11, because there are 3 elements. And here it will now first pick this part. So it will break 6 and 4 like this. And then it will merge 6 and 4. So which will become 4 and 6. So the only thing to keep in mind is in the conquer step of merge sort, what we are doing is we are merging two sorted arrays and the result is a large sorted array. So here you can see that this was sorted array, this was sorted array. We merged it in such a way that we got a larger sorted array. Similarly with this, we got larger sorted array. And as this part was actually sorted and this part was also sorted, so we merged these two sorted arrays as well. So we got this sorted array. And similarly we did here. So after sorting 4 and 6, as 11 is the only element left, so it goes like this. It comes here and then we have two sorted arrays. We try to merge it. So we get 4, 6, 11. And now here you can see the algorithm sees that okay, we have one sorted array, we have another sorted array. Now we can simply merge these two pieces together like this, 2, 3, 4, 5, 6, 10, 11. So here you can see that the final array which got sorted is actually our original problem which we wanted to sort. So friends, here I will just go back. So we'll go through this one more time. We saw that this was the problem given to us and we wanted to sort it using merge sort. So here we evaluated the midpoint of the array and we break it down into two smaller sub problems recursively. So recursively how it goes is it breaks it down like this and then recursively it goes to here. It break it down like this and then it again recursively go here. Then it break it down 2 and 10 and it sees that okay, it can't be further broken down, so it tries to merge it. So why it tries to merge it? Because this is the sorted array having only single element and the single elements are already sorted, so it treats it as two smaller sub arrays which are sorted and it tries to merge it in the conquer step. So it merges it like this, 2 and 10. So one thing is important, you watched my previous video where we actually saw the algorithm that how we can merge two sorted arrays, and the resultant array is also sorted. So we will get this sorted array. So this recursion ends here. It then goes to this side. It takes 5 and 3, breaks it down like this. It merges 5 and 3, which gives 3 and 5. So this part is done. So once this part is done, it sees that okay, I have got one larger array here and both are sorted. So it tries to merge them. So we'll get 2, 3, 5, 10. And after doing this part completely, it then goes recursively to this part. It breaks 6, 4, 11 into two parts. 6 and 4 on one side and 11 on other side. It recursively sees that okay, I can break this down further. It breaks it down 6 and 4 like this. It merges them. It becomes 4 and 6. And then it goes to this side. It sees that okay, 11 is only the single element left. So it comes here and it sees that okay, I have got two sorted arrays like this. So in the conquer step, I will simply merge them. So when we'll merge them, we'll get 4, 6, 11. And as we have done this step, the algorithm sees that okay, this is the one sorted array, this is the other. It simply merge both of these arrays like this. So friend, this is the basic idea behind divide and conquer algorithm when we are dealing with merge sort. In our upcoming videos, we will see all these steps in greater detail. We will see the demonstration of the algorithm step by step so that this idea becomes more clear to you that how it is actually done. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. So friends, before going into the actual algorithm of merge sort, so before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. We saw that in divide step, we saw that we break the array into two parts or into two sub problems, and that we do recursively. So at a high level, I will simply show you the code. So this code we will be discussing in a greater detail with an animation in our upcoming video. But just for understanding that how it works. So when we break the array into two parts, we are not actually breaking the array from here. Let's say from 0 to 3 it goes like this, and from 4 to 6 it goes like this. We are breaking it based on the three pointers, let's say low, high and mid. So usually array remains the same, and we have something like, let's say low points here, mid points here and high points here. So from low to mid, we consider that this is the sub problem, and from mid plus 1 to high, we consider it as a different problem. But the array structure remains the same. It's only the pointers which decides which is the left part and which is the right part. So here you can see in the sort method, this method gets called two times recursively. So one is for going into the left side and one is going to the right side after breaking it based on the mid element. And as this sort is recursive in nature, so here you can see usually at the start low points to 0 and high points to the last index. And let's say if we calculate mid, so here it will be 0 plus 6 minus 0 by 2, which will give us 3. So mid comes out to be 3. So for example, let's say we calculate mid as 3. So this division here is done based on calling of these two sorts. So what we do is, so when we call this sort, we pass the ranges from low to mid. So low to mid. So it looks like that we are doing like this. And for the right subarray, it says from mid plus 1 to high. So this is the mid plus 1 to high. So it looks like this, but the array remains like this only. It's actually the logical division based on low, mid and high pointer, and this we do recursively. So when we call this, we actually get this, and it again does the same thing again, and here you can see it again recursively calls this. So this is low and this is mid, and this is mid plus 1 and this is high. So it goes on like this till we can't divide them further. So this condition, low less than high, help us in preventing that. So here if you see, low and high point to the same. So we simply return from this, and once we return from this, it goes here, then this sort is called like this, and here similarly this condition help us to make it come back. So after these two steps end, we actually merge the two sorted arrays. So these are the sorted arrays, and you can watch my previous tutorial that how we can actually merge the two sorted arrays. But in merge sort, we actually take the help of a temporary array which help us in merging the two sorted arrays. So this we will discuss in a greater detail in our upcoming videos, but here we will simply see a high level view of merge, how it is actually done. So here you can see that we saw that at the last step we take this sorted array, this is the left array and this is the right array, and we usually merge it. So we do something like this, we compare the elements in the respective arrays and we fill out the array like this, and this is our answer, that we get a sorted array. So this is done via merge method. Now let's see how we can take the help of temporary array and merge it. So this is the same thing which we saw in our previous slide. That so this is the left part and this is the right part. So these are distinguished based on these colors. So usually how we merge it, we create a temporary array of the equal length, and then we first copy all these elements like this. So here it looks something like this. So after we copy every element like this, now what we do is, this array is our original array. We have took every element in the temporary array. Now we create the pointers which traverse to left part and the right part, and based on our comparison, the original array is actually filled. So I'll just remove this. So here we take I for this left part and J for this right part. And how we actually fill is, in the original array we start from here, let's say K. We compare 2 and 4 denoted by I and J. So 2 is less than 4. So we know that 2 will take this position like this. And we are done with this part. So we increment I. And we also increment K because we are done with this filling. Now we compare 3 with 4 and 3 takes this place. We are done with this element, so we increment I. We don't increment J because these values are not filled up, and you can watch my previous video where we actually saw that how we can merge two sorted arrays. So this is the first sorted array, this is the second sorted array, and the concept remains the same when we do the merge sort. So after filling 3, we increment K, and then we again compare 5 and 4. So 4 is smaller, so 4 takes this place. So we are done with this element, so we increment J, and here similarly we do the filling. So in the next iteration, 5 is less than 6, so 5 comes here, we increment I, we increment k. 6 is smaller than 10, so 6 comes here. We increment j, then 10 comes here, and here you can see after filling 10, this element also gets filled. So now there are no more elements left in the left part, and here you can see that we have only left with 11. So this goes out of the boundary, and whatever the values are left in the right part, we simply put it here because they are already sorted. So anything which comes after 11 will be, let's say, 12, 14, xyz, but it will be greater than 11. So they will come directly like this. So we simply copy the elements in the leftover part of the original array. So it goes like this. So this is the merge at a high level using the temporary array. So friends, there are two cases which we need to see. So the case one is when the left array is exhausted. So here you can see after filling 2, 3, 5 into the respective position and even 10 here. Now here left array is exhausted. So we don't touch this now because everything is filled up here. And here you can see as we copied all the elements like this, in the original array, if you see 6, 7 and 8, whatever the values are here, those were actually sorted. And when we actually copied into the temporary array, it came it like this only. So here you can see we don't push it back like this because the right array values are already present in the original array in the same order 11, 12, 17. So we do nothing here. Once the left array is sorted, we do nothing because right array is already having the elements here which are already sorted. Now case 2 comes when right array is exhausted. So here you can see 4, 5, 6, 10, 11. These are all exhausted till this point. So after putting 11, j goes out of this array and k comes to this part because we need to fill 2 more elements and our right array is exhausted. So here you can see that when the right array is exhausted, we have to do something to push left array elements into this 7 and 8 position. So how we do that? We provide a small code which is like this. So here you can assume that mid is this point and I will go till mid, and we simply copy the leftover elements into the respective places using the I in kth index. So here you can see in the original array at kth index we are assigning temp of I. So this is the temp and this is the I. So 12 will go to array of k like this, and then we increment both I and k. So k will go here and I will go here, and this while loop will continue and we'll simply put 15 at this position by this assignment. So after that this while loop will terminate. So friends, here we need to keep these two cases in mind, that if left array is exhausted, we do nothing because when we copied the element into a temporary array, when the left array got exhausted, the right array leftover elements were already present in the original array and that too in sorted form. But in case 2, if right array is exhausted, so here if this array is already exhausted and all these elements are present here and there are elements left over in the left part, so we need to provide some additional code like this to put it into the respective places. So we will see this algorithm in much greater detail in our upcoming video, because that is very complex algorithm. So I just demonstrated at a high level that how it looks. So when we will discuss that algorithm, we will see all the details of sort method, merge method, and how this sort method recursively calls itself and basically divides the array into two halves, and later when the two halves are no longer divided further, then how we actually merge them. So friends, I hope till this point you must have got a high level idea of how merge sort works. In our upcoming video, we will see a detailed animation of merge sort algorithm which will make this idea more clear to you. You can watch this video 2 to 3 times so that you can get an idea of the merge sort at high level. I hope you must have liked this video, and in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw at a high level that how merge sort works in Java. So in this video, we will be looking into the algorithm, and we will also see the step-by-step animation of the algorithm. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon. So here if you see, at a high level, we are going to sort this array having 5 elements. So you just need to keep that at a high level how this algorithm works, so that when we demonstrate actual algorithm, you can relate to it. So here we see the array has 5 elements. So we divide the array into two parts based on the mid index. So we evaluate the mid index. Let's say here it comes as 2. So how we break it? We usually consider this as low, this would be mid, and this would be high. So low to mid is the left subarray, mid plus 1 to high is the right subarray. So here you can see that we break it down logically using these 3 pointers like this. Low to mid is one side and mid plus 1 to high on the other side. So now after dividing the array into two parts, we recursively break the left part further down. So here this will be our low, this will be mid, and this will be high. So we break it down into these two parts, low to mid in the left and mid plus 1 to high on the right part. And this algorithm goes recursively, and we divide now these two elements. So it will be divided something like this, 9, 5, and here we see we can't further divide 9 and 5 because these are the single elements. So these are nothing but our algorithm's base case that we can't divide them further. So here you can see when the division ends for this part, now is the time to conquer it. So here this left subarray is actually sorted because it has only one element, and the right is also sorted. So now we have two sorted arrays and we try to merge them, and we merge them in such a way that the resultant array is also sorted. So we simply do the comparison and we come up with the 5 and 9. So this is the merge step. So after merging the left side, now we go to the right side. So we pick 2. 2 can't be divided further down. So then here you can see we have left subarray and right subarray. Both are sorted. So we try to merge them. So after merging it becomes 2, 5, 9. And after doing this part, as this is the recursive algorithm, we first go to the left and then we go to the right. So here you can see for this point, we have completed all the left side. So now we go and perform the same steps on the right side. We break it down into two parts. then we go to the left, and then we go to right. So when we go to right, we can't further break it down. So here the single element is already sorted. We try to break the right side. We find that it has only one element. So we can't divide them further down. So what we do is we try to merge them. So when we merge them, it becomes 3, 4. And here you can see, now we have these two sub-array which are sorted. So we try to merge them. So 2, 5, 9 and 3, 4. We apply the logic of merging of two sorted arrays. And at the end, we will get 2, 3, 4, 5, 9. So just keep in mind that we will perform these steps when we will demonstrate the actual algorithm, so that you can relate that how at high level this algorithm works. So here you can see that this is the merge sort algorithm, where we have this sort method, and this is the array which we want to sort. In our previous video, we also saw that how we can use this temporary array to merge two sorted arrays into the original array. So here when we'll call this method, so let's suppose we want to sort this array having 5 elements, 9, 5, 2, 4, 3. So here this temp array is actually of equal length of our original array, and at the start it mostly contains the default value, which is 0. So for timing, I have just made it empty. And here you can see that we want to sort this complete array from 0 to 4th index. So we provide low and a high value. So usually at the start low is 0 and high is array.length -1. So this array is of length 5, and if we do -1, we get the last index. So low will point to the 0th index and high will point to the 4th index. And here you can see that as it is a recursive algorithm, this sort method internally calls itself again with some different values. So we need to keep the track of the sort method here in the call stack. So we need to keep the track of these 4 things. One is the line number. So let's say if we are leaving this sort method and calling this sort, so we keep the track of the line number, because when this sort method will end, we need to return back to this method. So this line number will help us that where we actually left and which sort method we left. So we keep the track of the line number here, and 3 fields, low, mid and high. So these 3 fields are very important because they help us in dividing the array, and at the end they also help us in merging the array to make the array in sorted form. So here at the start there will be one sort method. So here we saw that low is 0 and high is 4. So friends, here low should be less than high. So this is nothing but our base case, because as we are calling this algorithm recursively, we need to provide a base case so that we come out of the recursion. So in the simple terms, let's say if we have this array 5, 3, and using this to sort method, if we break it down like this, 5 and 3. So here you can see at this moment of time, low and high will point to the same index. So when we will call this sort recursively on this element, you will find that low is actually equal to high. So therefore we can't divide this array further, so we actually return. And similarly with 3, we return. And once we return, then we know that 5 and 3 are two left and right array. So we simply call the merge method and merge them. And this we do recursively for each and every array which we have divided. So we'll see later. So for timing, this is the base case. So currently low is 0 and high is 4. So this condition comes out to be true. In our previous video, we saw that merge sort is divide and conquer algorithm. So this division goes on till our base case is reached, and once we encounter the base cases, then we try to conquer, and by conquer we mean we try to sort two sorted arrays, which we also discussed in our previous video. So this merge method helps us in doing that. So here we need to divide this now in two parts. And how we can do that? So we try to figure out the mid element, and how we can figure out the mid element is by using this formula. So here we do low plus high minus low by 2. So here low is 0 plus high is 4 minus 0 by 2, which will give us value as 2. It means this index. So usually when you see the merge sort code, you will find that this is somewhat different. Here we do something like low plus high by 2. So basically in the textbooks, most of the time you find this low plus high divided by 2, which give us the mid element. So why we actually do this here and not this is because here you can see this low and high are basically integer values. So usually they have a particular range, and if we cross that particular range, we actually get the garbage values. So if we do low plus high like this, so in most of the cases this works, but if low value and high values are at the very end of the integer value, and if we do sum of it, we'll actually get some garbage value. So therefore, if our array is very huge, this condition gives us the garbage values. So we try to avoid this, and we use low plus high minus low by 2, because if we do high minus low, we will come back into the integer range only. So basically this we use to avoid the overflow of integer value. So now here you can see that we have calculated mid as 2. So mid becomes 2. Here you can see mid is pointing to index 2. So now what it suggests is from low to mid, this would be our left part, and from mid plus 1 to high, this would be our right part. So now we are breaking this array into two parts using this three variables which are low, mid and high. So we are not actually breaking the complete array, we are simply dividing the array based on these three values. So from low to mid, this is our left part. From mid plus 1 to high, this is our right part. And we know that we have to call this algorithm recursively, because we need to still break it down further till they are not further divided. So here you can see after calculating the mid, we are now going into the left side of it to divide it further. So we will divide these three elements further. So here you can see that we are going from low to mid, and as we are leaving this sort method at line number 4, so first we will update the line number here, and then we will call the sort method. So this sort method will be called. So here you can see we pass mid as 2. So this mid for this sort method became high. So now there will be one more method on the call stack which is high as 2, because we have called this sort method from 0 to 2, because now we need to further break it down this left array. So initially there was complete array. Now we are trying to break this left array further down. So high is 2 And here for this sort method, high will come to this point. Low is less than high. We again calculate the midpoint. So here midpoint would be 0 plus 2 minus 0 by 2, which is 1. So mid becomes 1. We update the mid here. It looks something like this. So now what it suggests is this boundary again divides the array into two parts. So from low to mid we have left, and mid plus 1 to high we have right. So now again recursively we try to break the left part from low to mid. So here we are again leaving this method at line number 4. So we'll update the line number 4 here. And here mid is 1. So for the next sort method, this mid becomes the high. So now there will be one more method on the call stack with high as 1. And for this sort method, high will come to this position. So low is less than high. Now we again compute the mid element. So here 0 plus 1 minus 0 by 2, which will give us 0. So now mid becomes 0. We update it here. So mid points to 0. I'll just remove this. So now we have calculated the mid. It means we again have one boundary from low to mid, which is the one element, and mid plus 1 to high, which is the other element. So here you can see that now we are again calling sort because currently our array is of 2 elements, and we can still further break it down to one element from low to mid, which is the 0, and mid plus 1 to high, which is 1 to 1. So we are leaving this sort method at line number 4. So this mid is 0. So here you can see low is 0 and high becomes 0 because we have called this sort method with mid value is 0, and this mid value for this sort method becomes our new high. So we'll simply point high to 0 as high is 0. So friends, here you can see that now we have reached our base case because we can't divide this single element further. So at the start we had this full complete array, then we had this small array, and then we had this small array, and now we are actually having this array. So we can't divide 9 further down. So it means we have reached our base case and we have to return from here. So as we want to return from this sort method, the call will reach to this sort method and we need to begin from line number 4 again. So we'll see how. So this execution point reached here, and we know that we had left its previous sort method at line number 4. So we will start from there. And when we had left this sort method, low, mid and high pointed to 0, 0 and 1. So we again provide them their own values. High becomes 1, mid becomes 0. So it was something like this when we left. So now we move ahead. So here we are done breaking this left part. Now this two sort method actually help us in getting the left part of the array and right part of the array, and then we merge both of them here to make a sorted array. So usually this left and right part are also sorted which we will see later. And in the merge method, we are actually merging two sorted arrays. So we'll see how. So now we need to break 5 or mid plus 1 to high further down. So we need to leave this sort method now, and we need to call this sort again, and we are leaving at line number 5. So we update line number 5, and there will be one more method on the call stack with values as low will be 1 and high will be 1, because when we had left this sort method, mid was pointing to 0, and when we called this sort again, we provided mid plus 1. So it means our new low becomes 1 and high remains the same. So it looks something like this for this sort method, that low is pointing to 1 and high is pointing to 1, like this. And here you can see we can't divide 5 further down. So this is our base case. So now we have to return from this method. And once we return from this method, the execution point will reach here. And that method will be removed from the call stack. So we had left at line number 5. So we start from there. And when we left this sort method, low pointed to 0, mid pointed to 0, and high pointed to 1. So we provide them their own values, like this. So we move ahead. So friends, here you can see that in this algorithm, we are actually recursively going down and down, and we are dividing the array into two parts. So at the end, we are only left with single elements which cannot be divided further, which are actually encountering our base case. So after this two sort method, now it's the time to merge both left part which we got from this sort and the right part which we got from this sort. So here you can see 9 and 5. You can think of it a small array having only one element, and when array has only one element, that array is considered as sorted because there is only one element. So now this merge method will take this left part and the right part, because they have only single element, and compare these two elements in such a way that both these elements become sorted. So that we will see in the merge method. So we are leaving this sort method at line number 6 now. So we'll update line number 6 here. And here we have this merge method. We pass the array, the temporary array, low, mid and high. So because we require all these three values to actually come to know that from low to mid we have left part, mid plus 1 to high we have the right part. So these are the three values. So in our previous video we saw that how we are actually doing the merge. First we are actually copying all the elements from the original array to temporary array. And how we are copying it? We are only copying that much part which we want to merge. So from low to high. So here low is 0 and high is 1. It means we are only copying this and this element. So it looks something like this. We will traverse this for loop quickly. So 9 comes here. And 5 comes here. And this for loop ends. So now we have copied the elements like this here, and we will now merge these two sorted arrays which is having only single elements, left and right. So here we actually take three pointers. One will point to the left subarray. So here I will point to the left subarray. J will point to the right subarray because we know that it is starting from mid plus 1, and k will help us in merging these two sorted arrays back into the original array. So we'll see now. So I is 0, it is pointing to this left subarray. So you can think that this array is like this, left and right. J is 1, so J is pointing to the right subarray. And K is 0, so K will basically start from low because we are merging these two sorted arrays based on this range. So when we copied this element from any particular range, we need to put it back into that range only. So we are starting from k equals to whatever the value low has. So currently it is pointing to the 0th index. So here in our previous videos we actually discussed that how we can merge two sorted arrays. So the idea behind this algorithm or this merge method is pretty much the same. Here I will go till it is less than equal to mid. So I will traverse the left part and J will traverse the right part. So these are the last indexes of these two small arrays. So currently both the condition comes out to be true because 0 is less than equal to mid and J is less than equal to high. So here you can see we have two small arrays of single element which are inherently sorted, and now we need to merge it in such a way that final array also is sorted. So how we do that is we are taking temp value at ith index and temp value at jth index, which is 9 and 5, and we are checking whether 9 is less than 5 or not. So 9 is not less than 5, so this condition comes out to be false and the else part will be executed. So it means at this position among these two values, whichever is the smaller, we'll place it there. So currently temp value at jth index is smaller, which is 5. So 5 goes to the kth index of original array. So it goes like this. And here we have placed 5 at its correct position. So we simply increment j. So j becomes 2. But we know that currently there was only one element. But there could be a possibility that we are trying to merge a very huge array which is equally among the left and the right part. But currently we have only this one element. And as we have filled this position, we'll increment k. So k becomes 1. Now here you can see this condition comes out to be false because j has crossed the limits of high, as j value is 2 and 2 is greater than 1. So this while loop will terminate. And here you can see once the while loop gets terminated, we have only placed 5 here. We need to place 9 at its correct position. So we are providing this small for loop, and we also discussed in our previous video that once the right array is exhausted, we need to provide this small while loop so that all the elements of the left subarray are directly copied back. So they are copied back with this condition which was similar to here, that I should be less than equal to mid. So currently I is less than or equal to mid. And using this while loop we are simply copying back the element from the ith index to the kth index. So 9 goes here. And after placing 9 to correct position, we have used this 9. So we'll increment I. I becomes 1. We have filled this position, so we'll increment k also. K becomes 2. And here you can see that we have merged this left and right subarray. So here now this condition comes out to be false. So here you can see after this merge method ends, we sorted left and right. Both were two sorted arrays and we merged them. So we got the result array of two elements which are now sorted. So now we'll leave this method and we'll go back to the sort method where we actually left. So the point will reach here back. We had left at line number 6, which was this part. So now here you can see, so when we had left, low, mid and high pointed to 0, 0, 1 based on the values we kept here. So it was something like this. So here you can see now this sort method will end because there are no more lines to execute. And also you will find that after this merge method ends in the original array, we have 5 and 9 actually sorted into the range of low to high. So this method will end now. And once this method will end, it will reach to this point because we had left this sort at line number 4. So we again start execution from line number 4. We provide the respective values to low, mid and high. So when we had left this sort, this was our condition. So now we move ahead with our execution. So here you can see this sort method actually sorted the left part. So here you can see if this is the line, this array which is our left is sorted now. So now we try to go to the right part using this sort method. So we provide mid plus 1 and high. So mid plus 1 is the range for the right part and it goes till high. So now we'll again leave this method at line number 5. So this sort method will be called again with low as mid plus 1. So when we will leave this method, mid was pointing to 1. So in the call stack there will be sort method where low will be now 2, which is like this here, and high will point to 2 because the high remains at its own position. Mid was 1 previous to it. So for this method it became mid plus 1. So mid plus 1 is 2 and this 2 became our low for this sort method. So it means now we are going to the right side recursively to divide that array further down. So here you can see we only have this one element. So we have encountered our base case. So we return from here. We reach here. We had left at line number 5. So we start from line number 5. And now here you can see we provide these values to their respective variables. Low was 0. Mid was 1, which is at index 1. And this was our line which divided the left and right. So this is the left and this is the right. So here you can see when we had called merge method previous to that, we actually merged two small arrays having single element 5 and 9, and whatever was the result that was sorted. Then we went to the right and we found that the right part has only one element, so it is already sorted. So now this merge method will take a bigger sorted array and will try to merge with the right subarray. So this merge method will be called. This is our temporary array. High is 2, mid is 1 and low is 0. So from low to mid, so from low to mid, this is the left part which is sorted. and from mid plus 1 to high. This is our right part. Now we are actually merging a slightly bigger array. So we'll go over this merge method quickly. We copy the elements from the original array to the temporary array from low to high. So 5, 9, 2 will be copied to temp at the respective positions. So we'll go over this for loop quickly. 5 comes here. 9 comes here. 2 comes here. And this for loop will end. So friends, here you can see that now we have a left part and the right part which are sorted, and we need to merge these two sorted arrays, and after merging it we need to transfer it back to the original array. So this is the boundary for left, and this single element is in the right. So it's very much similar to what we discussed previous to it. I will be traversing the left part and J will be traversing the right part. So J will start from mid plus 1, mid plus 1 is 2, and I will start from 0 like this, and K will start from the low which is 0. So now we'll again merge these two sorted arrays based on this while loop provided here. So I is less than mid and J is less than equal to high. So both the condition comes out to be true. Now we compare the element at ith index with the jth index, which is 5 and 2. So 5 is not less than 2, so this condition comes out to be false. And into the original array, we first place the smallest element, which is temp of j. So temp of j is 2, so 2 goes here. And after using this, we increment j. So j points to 3. And after filling this position, we increment k. Now here you can see that the right array is exhausted because j value is 3 and 3 is greater than 2. So this condition comes out to be false. So here you can see that we actually placed all the elements of the right subarray into the original array, but the left sorted array still remains, and as it is already sorted, we'll simply copy it back to the respective kth position using this while loop. So I is less than equal to mid. We copy 5 to the kth index, which is 1. So 5 comes here. Then we'll increment both the pointers because we have filled this position and we have used this element. So I becomes 1. And k comes to second index. I is less than equal to mid. We copy 9 to index 2. We fill this position, so k comes here, and as we have used this position, so I comes here. So now this while loop will terminate because value of I is 2. 2 is greater than 1. So this condition comes out to be false. So friends, here you can see now slowly we are merging the arrays and we are actually getting a bigger sorted array. So it started with single element, then we got two elements 5 and 9, and now we are getting 3 elements 2, 5, 9. So we go back to the sort method where we left. So here we left at line number 6, where these were the default values for low, mid and high, and this was the boundary. So here you can see now we have sorted the left part and the right part in such a way that now they are completely sorted with this much range. So this merge method is ended. Call will reach here. So this is the line number where we left this sort method, and the respective values were 0, 2 and 4. So high was pointing to 4th index, mid was pointing to the 2nd index when we actually left at the first sort. So now here you can see we have completely sorted the left side of it. Now we simply go to the right side using this sort method, which is going from mid plus 1. So this range is mid plus 1 to high. So when we will call this sort method again, mid plus 1 becomes our low. So here we'll first update the line number. There will be one more method on the call stack where low will be 3, because mid plus 1 is 2 plus 1, which became our new low for the right part, and high is actually 4 only. So we are simply placing this into the respective indexes for this sort method. Low is less than high. We calculate the mid. Now here you can see first we did this for the left part and we keep on breaking it till we got a single element. Now we are simply doing it for the right part. So now low is 3 plus 4 minus 3 by 2. So this will give us value as 3, because 1 by 2 is 0 and 3 plus will give us 3. So this will give us 3 now. So here you can see now we have got our two boundaries. Low to mid is the left part and mid plus 1 to high is the right part. So first we will go to the left part and try to divide the array. We'll update line number. We'll call the sort method with low as 3, and when we had left this sort method, mid was actually pointing to 3. So for this sort method, here this mid becomes our high. So value is 3. So it looks something like this. So we have reached our base case and we can't divide 4 further down, which is at index 3. So we return back. I'll just remove this. So we had left at line number 4. So we start execution from here. Low, mid and high pointed to 3, 3 and 4. Like this. So here this 4 cannot be divided further, and as this left part has only one element, it is inherently sorted. And now we go to the right part via this sort method. We update the line number, and here we are leaving with mid plus 1, which will become our new low. So mid plus 1 is 4. So in this sort method, low became 4 and high is actually at its own position 4. So it looks something like this. This is our base case because low is actually equal to high. It means we can't break 3 further down. So we return. We had left at line number 5. So we start execution from line number 5. And at that moment, low, mid and high were 3, 3, 4. So we'll assign those values back to them. 3, So here you can see for the right, this is single element array, which is the left, and this is the right, and both are sorted. So we simply merge them to make it a bigger array which is also sorted. So we'll call the merge method. So this was the condition when we left the sort and came for the merge. So it was 3, 3 and 4. So here you can see we are not touching now this part because this left part is already sorted. So therefore we have provided this low, mid and high, because now we'll copy the elements from the original array to the temporary array from low to high, which is from 3 to 4th index. So only these two elements will be copied here. We'll see it quickly. 4 will be copied here. And 3 will be copied here, because we are simply assigning the value at ith index of the original array to temp array. And this for loop will end. So now our task is to merge these two sorted arrays. This is the left and this is the right via this temp array. So I will be traversing the left part, J will be traversing from mid plus 1, which is the right part, and K, which will start from the low, which is the index 3, because we don't have to touch this part now. We have to only sort in this range like this. So here I is 3, J is 4, because J starts from mid plus 1 and K is 3. I will traverse to the left part, J will traverse to the right part, and K will help us in merging them to the original array. So I'll just remove this stuff. So here you can see I is less than mid and J is less than equal to high. So the while loop will execute. We compare the ith index value with the jth index value, which is 4 and 3. So 4 is not less than 3. So the else part will be executed. It means we take 3, which is temp of j, and we put it into the original array at its correct position, because we need to sort these two smaller arrays. So 3 comes here. We have used this element and we have filled this position. So we'll increment j. J becomes 5, which is now out of the boundary for this smaller right array. We'll increment k. K becomes 4. And here you can see the right array is exhausted completely. So we'll break from this while loop. And then we have provided this while loop because we need to still place the elements of the left sub-array back into the original array. And as the left array is already sorted, we simply copy it back to the original array via this assignment. So I is less than or equal to mid. We assign temp of I to kth index of array. 4 comes here. Then we'll increment I and k, because we have used this element. I becomes 4 and we have filled this position, so we are incrementing k also. So this while loop will terminate now, because we are done with our task of placing both the elements into their correct position within their range. And here you can see initially it was 4 3 and now it is 3 4, which is sorted in this particular range. So we go back and we had left at line number 6. So here you can see current status of array is something like this: 2 5 9 3 4. So the left part is sorted, the right part is sorted, and these were the values for low, mid and high when we left. So now this sort method will end because there are no more execution steps. So now call will reach to the previous sort method. We had left at line number 5, and at that moment low, mid and high were 0, 2 and 4. So this is the very starting point where we left the first sort method. So this was the condition. So now here you can see we have a larger left array and a larger right array, and both are actually sorted. So 2, 5, 9 and 3, 4 into their respective ranges they are sorted. It means we have two sorted arrays, and using this merge method we will merge these two sorted arrays in such a way that the resultant array is also sorted. So here one thing, this step, at every point when we called merge method we did merging of two sorted arrays. So at the start we had only one element, then we got two elements, then it became 3, like this, and here it became 2, and now finally we are merging a left array of 3 elements and right array of 2 elements. So let's see this merge method now. We have updated the line number 6 here. So these are the values for low, mid and high, 0 to 4, and this is our current original array. So now here you can see from low to high we copy all the elements to the temporary array, because in the merge we actually do the merging based on this ranges. Here low is 0 and high is 4. It means from 0 index to 4 we'll copy every element to the temp array. So we'll quickly go over this for loop. Two comes here, 5 comes here, 9 comes here. So these are simple assignments. So now this for loop will end. So here why we are copying this element into a temporary array, because this temporary array is helping us with this actual merge which we are doing here, and it is helping us putting the elements into their correct position in the original array. So here the left array is from low to mid. So 0 to 2 is the left array. So this is the boundary for left and right array, and mid plus 1 to high is the right array. So I will traverse the left array and J will traverse the right array, which we already discussed in our previous merge method. I is 0, J is mid plus 1 which is 3, and K is 0 because we need to merge this element from the low to high. So we are starting K with low. IJ comes here and K comes here. And here you can see this is the boundary for left and the right sorted arrays. So we'll quickly go over this step because we have already discussed what it does. I is less than equal to mid and J is also less than equal to high. We compare the ith and jth index value, which is 2 and 3. So 2 is less than equal to 3. So this condition comes out to be true. So we are simply copying now 2 to kth index because this is the smaller value among these two. So it becomes 2. And here we have used this value. So we'll increment I. I will become 1. We have filled this position, so we'll increment k. One is less than 2 and 3 is less than 4. So both the condition comes out to be true. We'll compare ith and jth index values, which is 5 and 3. And here 5 is not less than 3. So this condition comes out to be false. We put the smaller value at the kth index of the original array by this assignment. So 3 comes here. We have used this value, so we'll increment j. J becomes 4. We have filled this value, so we'll increment k. Both these conditions are still true. We'll compare 5 and 4. 5 is not less than 4, so this condition comes out to be false. So we'll simply put the jth value at kth index of the original array. So 4 comes here. We have used this value, so we'll increment j. J becomes 5. We have filled this position, so we'll increment k. So friends, here you can see, now this condition is true, but this condition is false because 5 is not less than equal to 4. It means the right array is exhausted completely. So this while loop will terminate. And once the right array is exhausted, we know that whatever the elements are left in the left array, those are actually sorted in their respective array. So we simply copy them one by one to the original array using this small while loop. So I is less than equal to mid. We copy temp value at ith index into the original array at kth index. So we are simply assigning 5 to this position. We have used this value. We'll increment I. I becomes 2. We have filled this position, so we'll increment k. And similarly, we'll place the last value at its corresponding index. So 9 comes here. This value is used. I becomes 3. This is filled. So k becomes 5. So now this while loop will terminate because value of I is 3 and 3 is not less than equal to 2. So this merge method will end, and here you can see now finally we have sorted complete array 2, 3, 4, 5, 9. So we go back to the method call where we left the sort and we called the merge. So execution point will reach here at line number 6, and these values will be pointing to 0, 2, 4. And friends, here you can see the original array is now properly sorted 2, 3, 4, 5, 9. And there are no more lines to be executed after that. So this sort method will end. So all the method in the call stack has ended and we have got our sorted array. So friends, this was the complex animation of this merge sort which I depicted based on this call stack. I hope you must have got some idea of how it works internally. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw the demonstration of the merge sort algorithm via an animation step by step. So in this video, we'll actually code the algorithm and we'll test its working in the main method. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here if you see, I have created one class as merge sort, which is having print array method, which we have already discussed that it is used to print the elements of an array on the console. So here we will be creating the method as sort, and as we discussed in our previous video that this sort method will take the original array, one temporary array, which will basically help us in sorting the original array. We will take the range from low to high. So usually at the start, low is 0 and high is actually pointing to the last index of the array because we want to sort the complete array. Now in this method, we provide a condition as low should be less than high. Now this is basically a base case because this sort method is actually recursive in nature. We will see later. So in this algorithm, we are actually dividing the array into two parts, the left part and the right part, and we will keep on dividing them till the left and the right part contains only a single element because they can't be divided further. And when low will be equal to high, it means we are having only single element. So we need to return from this method because we can't divide the array further down. So when low is less than high, now we will divide the array into two parts. So for that we need to figure out the mid index. So here we evaluate mid. So we use the formula low plus high minus low divided by 2. So here you can see these are nothing but indexes. We can use this formula which will evaluate as the mid index. So this formula also takes care of the integer overflow condition. Let's say our array is huge, which we have already discussed in our previous video. If the array is very small and it fits into the integer size, we can also use this formula low plus high divided by 2. Because here you can see why we are using this formula is because these are two integer values, and if we are doing addition of it, let's say if low and high are at any particular value of integer, when we do sum of it, it crosses the integer limit. So therefore we will get some garbage value. So therefore on the safe side we do this. We do minus of both the ranges so that the overall value is still in the integer range. So after evaluating the mid, now as this is a recursive algorithm, we'll call sort again. So we break it down the array into two parts, and the range would be, for the left it will be low to mid, and for the right it will be from mid plus 1 to high. So here you can see this is a recursive algorithm and it keeps on dividing till there are only single elements left which can't be broken further down. So after getting to that point, as single elements we treat them that they are already sorted because there is only one element. From there on we try to merge them together, and this merging keeps on going till the final array is sorted. So in the merge method, we pass the array, we pass the temporary array, we pass low, mid and high. Why we are passing all the three values is because in the merge, based on low to mid, that will be our left sorted sub array. From mid plus 1 to high will be our right sub array which is sorted, and we are simply merging two sorted arrays to get a bigger sorted array. So we'll code the merge method now. So here you can see we have this original array and we have this temporary array. We know the range that it goes from low to high. Low to mid is our left subarray. Mid plus 1 to high is our right subarray. So before merging the two sorted arrays, we can't directly merge them in the original array. So in order to merge the two sorted arrays, we take the help of this temporary array. What we do is, we provide a for loop which starts from low and goes till high index. So what we are doing is, now we are simply copying the elements of the original array into the temporary array. So this is what we discussed in our previous video in greater detail. So here we do temp of I, array of I. Now we have got our range from low to high in our temporary array, and we also know that from low to mid we have the left subarray which is sorted. From mid plus 1 to high we have a right subarray which is sorted, and now we need to merge these two sorted arrays such that the resultant array is also sorted. So in one of our previous videos we saw that how we can merge two sorted arrays. So we will apply the same algorithm here. So for more understanding you can watch that video. So here we will create now three variables, I, J and K. So here I will traverse left sorted subarray, J will traverse right sorted subarray, and K will merge both arrays into original array, which is this. So if I is traversing the left sorted subarray, we know that it should start from the low, because from low to mid we have the left part, and J should start from mid plus 1, because we know that the right sorted subarray is from mid plus 1 to high, and we also know that as we are merging the two sorted arrays within a range from low to high, K should also start from low and it will go till high. So after creating these three pointers, we will now compare each and every element of the left and the right subarray, and whichever element is small, we try to fit in that element into the original array at kth index. So this is the basic idea behind merging two sorted arrays such that the resultant array is also sorted. So we have provided while loop, and the condition we provide is I should go till mid and J should go till high, and if any of this condition breaks, the while loop will terminate. So here what this condition suggests is, when we are merging the two sorted arrays, there will be a point where either left array will get exhausted or the right array gets exhausted. So whichever gets exhausted, this condition will break respectively and we will come out of the while loop. So inside this while loop, now we'll try to compare the left array's ith index value with right array's jth index value. And as these two arrays are already sorted, that's why we are doing the comparison with the respective indexes. So we do if temp of I is less than equal to temp of j. So here it means whichever value is present at the ith index, it means the left subarray value is small. So at the original array, at kth index, we will put temp of I, and after placing the temp of I, we know that left array's one element is at its correct position, so we'll increment I, and else we do the other way around, array of k, temp of j, and we'll increment j by one position because we have taken up one element from the right subarray. And here you can see we are actually filling the original array at kth index. So after this if else block, as kth index is filled up, so we also increment k by one position to fill in up the next element. So this while loop will again go on like this till any of the array is exhausted. So here you can see that now there are two cases which can arise. Either the left array gets exhausted or the right array gets exhausted. So here when the left array gets exhausted, all the elements of the right subarray we don't copy it back to the original array because those elements are already at their correct position in the original array. Because when we are copying the elements from the original array to temporary array, and as both the arrays are sorted, so the elements of the right subarray which are left over will usually be at their correct position in the original array. So these two cases we discussed in greater detail in our previous video. Now we only need to keep in mind is if the right array gets exhausted first, then we need to write some logic to put in the left array's leftover elements into the original array. So for that we provide a while loop, and the condition is exactly the same because this I is pointing to an index from where the leftover elements are starting, and we can simply copy it back to the original array. So what we do is we can simply copy it something like this, temp of I k plus plus and I plus plus. So it is a simple loop which is copying the elements at ith index of temporary array into the original array at kth index, and after copying it we are incrementing both the pointers. So once this method will end, the smaller left and right subarray will be sorted, and then as it's a recursive algorithm working like this, so it keeps on merging the left and the right subarray till the point all the elements are sorted in ascending order. So now let's test its working in the main method. So here we have created this array 95243. Here we will call the sort method. We'll pass the array which is our original array, and we need to pass a temporary array, so which is of length same as our original array. So we'll do new int array.length. We pass the low as 0 and high as array.length -1, because at the start low is at the 0th index and high is at the last index, which is array.length -1. And after doing the sort, we will print the array and we'll see whether these 5 elements are actually sorted or not. If I run the main method, so here you can see it's sorted as 2, 3, 4, 5, 9. Now let's suppose if I put one value here as -1. If I call it again, so here you can see it's sorted in ascending order. So friend, this is all about the merge sort algorithm. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss that how we can sort an array having zeros, ones and twos. So we need to sort an array in such a way that zeros are at the start, ones in the middle and 2's at the end. So this problem is also known as Dutch national flag problem because each number basically correspond to one of the colors in the flag. So for example, 0 is, let's say, given as red, 1 to white and 2 to blue. So when we sort an array having 0s, 1s and 2s, 0s are at the start, 1s are at the middle and 2 are at the end. So therefore this problem is also known as Dutch national flag problem. So in this problem we are given an array containing only 0s, 1s and 2s. So let's say if we take this example, we have 0, 1, 1, 2, 0, 1, 2. So these are currently random numbers, and when we actually sort them, we get 0 at the start, 1 in the middle and 2 at the end. So it looks like Dutch national flag like this. Now our task is to sort the array in O of n time complexity and O of 1 space complexity. Because if we sort this array using the language specific sort method, then the time complexity will be n log n. But as we know that there are only 3 types of numbers, 0s, 1s and 2s, we can leverage this idea and achieve O of n time complexity. So let's see how. So friends, before we start the discussion, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So friends, here you can see that this is the piece of code which actually does the sorting in O of n time. Here we have one while loop which does all the trick. So in this video, in order to demonstrate at a high level that how this algorithm works, I have just mentioned the code here. In our next video, we will see the demonstration of this code step by step. So let's see at a high level how this algorithm will work. Now for example, we are given an array of 7 elements from index 0 to 6, and the numbers are 0s, 1s and 2s. So 2, 0, 2, 2, 0, 1, 1. Now we need to sort this array in such a way that 0s are at the start, 1s in the middle and 2s at the end. So this is start, this is middle and this is end. So friends, the basic idea behind this algorithm is we actually use 3 pointers, which is I, J and K. So here in this algorithm, each pointer has a special task to perform. So at the start, I starts from 0, J starts from 0 and K starts from the last index. So I starts from 0, J starts from 0 and K starts from the last index. Now here you can see that after that we are providing a while loop where the condition we are providing is I should be less than equal to K. So here I is our main pointer which will actually traverse the array in this direction, and when it traverses in this direction, K also traverses in this direction, and this loop will go till I is less than or equal to K. So once I crosses K, this while loop will terminate and our array will be sorted in 0s, 1s and 2s format. So here the I is our main iterator of the array. Now its main job is, here we can see at the start we have to provide 0s, in the middle 1s and at the end 2s. So whenever I will encounter 0, let's say here it is encountering 0. So we know that we have to throw 0 to the start. So basically when 0 will be encountered, it will be thrown to J, and whatever value J will hold, it will come at the place of I. So 0s will be at the start and J will help us in achieving that. When 2 will be encountered, I will throw 2 to end, and to the end we have K. So it will throw it to the K and take its value to the ith index. So this will achieve this part. When I will encounter 1, it will do nothing. It will simply traverse ahead. because 1 is already in the middle. So this is the crux of the algorithm, that we have 3 pointers and 3 numbers. When I will encounter 0, it will swap that number with j. When I will encounter 2, it will swap it with k. And when I will encounter 1, it will just move ahead and keep 1 at that position only. So here you can see at the start the numbers are in unsorted form. So we usually draw 4 regions like this. One region is for zeros, other region is for ones, and the third region is for twos. And one region is just to mark which are the unknown elements till now or unvisited elements till now. So at the start all the elements are unknown, so they are marked as unknown, and their range is from I to k. So from I to k. So every number is unknown. So every number has tick. Now slowly when I will move ahead, it will try to encounter these numbers and try to explore them. So these tick will come in these 3 regions, marking for the zeros, ones and twos. At the start from I to k, all numbers are unknown. From start, which is the 0th index, to j minus 1. So j is actually pointing to 0 index. If we do minus 1, we'll reach here. So currently there is no such area or range. From j to I minus 1, j to I minus 1, which is also unknown area. From k plus 1 to end, which is the last index. So if we do k plus 1, we'll go out of this. So this is also the unknown area. So at the start all the elements are unknown and all the regions are unfilled. Now we'll slowly move ahead and try to fill each and every region. So let's see how we can remove this unknown elements and fill the zeros, ones and twos. And one thing to remember, zeros, ones and twos will be filled in a proper order. Zeros at the start, ones in the middle and twos at the end. So we'll see it later here. So here you can see at the start array of I is 2. So this condition is false. This condition is also false. And this condition is true because array of I is equal to 2. So now what I will do, here we saw that whenever I will encounter 2, it will simply swap 2 with the value which k is holding or index k is holding. So when we will do swap, so 2 and 1, which is being referred by I and k, in the swap method we will simply swap them. So 1 will come here and 2 will come here. So here our one task is done successfully, that we have placed 2 at its proper position here. So 1, 2 is at its proper position, and we know that when this while loop will run, one element has become known now. And which is that element which has become known? It's this, that 2 is at its correct position. Also friends, as we have filled this position, we will move k to this direction, because for the other 2, which is here for example, it should come here, right? So k will move to this position and it keeps on moving in this position as many as 2's are encountered, because we need to swap 2 with the value of the kth index. So we do k minus minus. So k comes here. Now here you can see as k is here, we know that from k plus 1 to the last index we have 2. So here we will see this range at every moment of this while loop, and we will figure out that where this tick will go. So if you see here k plus 1 is this index to the last, to the end, which is the same index. We have to mark 2's because one number is known. So this tick will go away and this tick will come here, which says that from I to k still the numbers are unknown and only one number was known, which is placed at its correct position. We have provided tick here. Now here one thing to notice, when we do this swap, 2 will come here and at this position there could be 0, 1 or 2, any of the 3 number. So we are not sure which number is actually getting swapped here. So I will be at the same position only. We will only move k. So this is the one difference. So in the next iteration of while loop, here you can see, now this condition will be false and this condition will be true because area of I is 1. So we discussed when we encounter 1 we will simply move ahead because ones will be in the middle. So we will simply increment I. So I will come here, and as I will come here you can see that unknown is from I to k, which is this portion now, because this number is known. From start to j minus 1 we have zeros, so j is still here, j minus 1 is out of this area. From j to I minus 1 we have to mark 1, so j to I minus 1, which is this part, we have to mark 1. So this element is known, so it will go away and mark will come here because we have found 1 and we have placed at its correct position in this range. So these ranges are important. It will help us in traversing the array and also relocating the values of zeros, ones and twos. Moving ahead. Now here you can see array of I is 0. So this condition will come out to be true. So here we have discussed that whenever I will encounter 0, it will throw it to j and take its value. So here 0 and 1 will be swapped by this method. 0 comes here, 1 comes here. So here you can see now 1 has actually changed its position. Initially 1 was here, we have marked here. Now 1 has actually changed the position. Then what we will do? We will increment I and j both. So why we are incrementing I? Because here we saw that whenever we encounter I as 1, we simply move ahead. And if you see this range, 1 is always one step behind the I. So range is from j to I minus 1. So whenever I will point to 1, it will simply move ahead. So this is the range that 1 is one index behind the I. So we will do I++ and j++. So why we are doing j++? Because we have placed 0 at its correct position. Now another 0 should come here. So we are doing j++. So j comes here. And now if you again look into this ranges from I to k, these are still unknown. And one number is known which we placed here. And we took 1 and placed here. So from start to j minus 1, we have zeros. So one tick will come here because we have identified 1 0. So this will go away. It will come here. And also here you can see that from j to I minus 1, this portion is actually our 1. So now this tick will go away and it will come here. Because we have swapped 0 and 1. So 0 is now at the start, 1 is in the middle and 2 is at the end. And in the middle we have unknown elements. So this is how this algorithm works. Let's see further iterations. Now array of I is 2. So this condition comes out to be true. So we know that what we need to do. We need to simply swap this value with k. So 1 will come here and 2 will go there. 1 comes here, 2 goes there. And then we will decrement k. Because the next 2 value should come here. So this position is filled and one more number is now known. So if we mark again from k plus 1 to end, we will mark 2. So k plus 1, this range will be marked as true. So this tick will go away and there will be one tick here. In the middle we have unknowns. Also friend, one more thing, that here why we are moving I when array of I is 0 and we are not moving I when array of I is 2. Because when we are swapping it with array of k, we don't know what value it will be. It can be 0, 1, 2, any value. But when we are swapping it with array of j, which is here, we are sure that there will be only one single value 1, because we have started traversing I from the middle, and whenever we are encountering 2, we are throwing it here, and whenever we are encountering 1, we are simply moving I ahead. So we are leaving 1 behind, so that will be the only value which will be swapped. So therefore it makes no sense to keep I in the same place, so we move I also with it. But here we don't know whether it's 0, 1 or 2 which is being swapped, so therefore we are keeping I at the same place. So now in this iteration, array of I is 1, which is this condition, so we simply move I ahead. I comes here, this element is known because 1 should be in the middle, so this thing will go away because unknown is from I to k, and I to k is this range. This element is known, we have to put this element here from j to I minus 1, j to I minus 1, which is these two numbers. So one tick comes here. Now in the next iteration, array of I is 2. So what we do is we simply swap and move k in this direction. So we are simply swapping 0 and 2. So 0 comes here and 2 comes here. And then we are decrementing k. Because we have filled 2 at its proper position, so we are moving k here. So k comes here. This element is known, it will go away and it will come here. Because from k plus 1 to end, we have to provide 2. So these are 2's. K plus 1 to end. Now only one element is unknown. So in the next iteration, I is still equal to k and array of I is 0. So we'll simply swap this 0 with the jth element here. So 0 comes here, 1 comes here. This is the proper place of 0. So we increment j. And as we have placed 1 here, we have also seen that whenever we encounter 1 at the ith position, we simply move ahead. So we are also moving I ahead. So I comes here and j comes here. So now every element is known, so this tick will go away. And where this tick will come? It will come here because we have just placed 0 at its correct position. So we'll mark this as true. And as we have swapped 0 and 1, so this tick will go away and it will come here. So it would look something like this. So now if we match the range, we will see that unknown are from I to k. So I has actually crossed the boundaries, so every element is known now. So it's blank. From start to j minus 1. This is start, this is j. Minus 1 will reach here, so this is actually our zeros, which is being marked properly. From j to I minus 1, we have marked ones. So j to I minus 1. So this is the place for ones. We have marked it properly. From k plus 1 to end, we have marked 2. So k is here, k plus 1 is this, to end we have all the 2's, which is what we have ticked here. So friend, this is how this algorithm works. Basically, we need to keep the track of 3 pointers. I is actually doing main work. It is encountering different values at different positions. When it encounters 0, it swaps it with j. When it encounters 2, it swaps it with k. And when it encounters 1, it does nothing, it simply moves ahead. So you need to go through this algorithm few times to understand how these regions are getting plotted and how these zeros, ones and twos are actually segregated that way. In our next video, we will actually see the detailed demonstration of this algorithm step by step. But to demonstrate this in high level, I have just used these regions so that when we encounter this algorithm step by step, we can directly come to know that which element is where. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss the algorithm step by step that how we can sort an array of zeros, ones and twos. In our previous video we saw at a very high level that how this algorithm works. In order to understand this video, you need to watch that video first. So let's see the demonstration of this algorithm step by step. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Here you can see that we are given with an algorithm where the method name is 3-number sort, which takes in an array. Now this array consists of zeros, ones and twos, and we need to sort that array in a linear time. So let's see the demonstration of this algorithm step by step. Now let's suppose we are given with this array having 7 elements 2, 0, 2, 2, 0, 1, 1, and we need to sort this array in such a way that zeros are at the start, ones in the middle and twos at the end. So when we will call 3-number sort method, we'll pass in the array. So friends, in our previous video we discussed that we can solve this problem using 3 pointers I, j and k. We also discussed that I is the main iterator which will traverse from 0 to a value less than or equal to k. And we also discussed that how these 3 pointers help us in sorting the array. So at the very beginning, I starts from 0. J also starts from 0. And K starts from the last index, which is 6th index. Now as we need to sort this array in linear time, we have provided a while loop, and the condition in while loop is I should be less than equal to K. So here I will travel in this direction, K will travel in this direction, and when I will cross K, this while loop will terminate. Now at the start value of I is 0 and K is 6, so this condition comes out to be true. So inside this while loop we have provided 3 conditions: array of I, which is the value at ith index. It can be equal to 0, it can be equal to 1, or it can be equal to 2. So any of this condition will come out to be true. Now here what we do is, when I will encounter 0, it will throw it to j and take its value. So j is mostly behind I, and when we encounter 0, we know that 0 should be at the beginning because we need to sort the array in such a way that zeros are at the beginning. So it's the responsibility of I and j to put 0 at the beginning. So whenever I will encounter 0, it will throw it to j and take its value. Whenever I will encounter 2, it will throw it to k and take its value. So here k is at the last index and we know that we need to place 2 at the end. So I will throw 2 to k and take its value. And whenever I will encounter 1, it will do nothing, it will simply move one step ahead because the 1 is already in the middle. So j keeps the track of placing 0 at the beginning, k keeps the track of placing 2 at the end, and I, whenever encounter 1, simply move ahead and do nothing. So here at the start array of I is 2. So therefore this condition comes out to be false. This condition also comes out to be false. And this condition comes out to be true. So we know that whenever I will encounter 2, it will simply throw the 2 to k and take its value. It means we are swapping the value with the kth index. So we will call swap method. We will pass the positions of I and k, and here it will swap them. So I will be demonstrating swap directly. This we have seen many times in our previous videos. So when we will swap I and k, 1 will come here and 2 will go there. It means we have swapped value at ith index with value at kth index. We have thrown 2 at the end. And after placing 2 at the end, we know that this 2 is actually at its correct position. So now we decrement k because the next 2 will come here. So we do k minus minus. So k becomes 5. Moving ahead, I is still less than equal to k. Now array of I is 1. So this condition comes out to be false. This condition comes out to be true. And whenever we encounter 1, we do nothing. We simply move I by 1 position because we don't have to touch 1. It's already in the middle range. So we move I 1 position ahead. I becomes 1. Moving ahead, I is still less than equal to k. Now here you can see array of I is 0. So this condition comes out to be true. So when array of I encounters 0 or I encounters 0, it will simply swap it with j and take its value. So when we will swap it with j, 0 will come here and 1 will come here. So here, now 0 is at its correct position because we need to arrange 0 at the start. So after placing 0 at its correct position, the next 0 should come here. So what we do is, we increment j and I both, and as I is pointing to 1, we know that we need to simply traverse I also by 1 position. So we do I plus plus, I becomes 2, and we do j plus plus, j becomes 1. So now next 0 will come here. I is still less than equal to k. Now array of I is 2. So this condition comes out to be false. This condition also comes out to be false. Now this condition comes out to be true. So it means we need to throw this 2 to k and take its value. So when we will perform swap, 1 will come here and 2 will go there. And now 2 is at its correct position here. So we'll decrement k. So k becomes 4. Also friends, here you can see that when we are swapping with k, we are only decrementing k. We are not moving I ahead because when we are swapping it with k, whatever value is here, there could be 3 possibilities. It can be 0, it can be 1, or it can be 2. So we are not sure that what value we will encounter here. So therefore we are keeping I at the same position. But when we are swapping it with j, we know that there could be 2 possibilities, 0 or 1. So when we encounter 1, we know that we have to move I by 1 step. But when we encounter 0, it means that I and j are pointing to the same index. And when we will do swap, 0 will come at same position only. And then we will move both the pointers together ahead. So the maximum time the value which we swap between I and j is 1. So therefore after this swap, when I will see that here it is 1, it will simply move ahead by 1 position. But with k, we don't do this because we can get 3 possible values, 0, 1 and 2. And we are not sure that what values it is getting swapped with. Now again I is less than equal to k. Array of I is 1. So this condition comes out to be false. Now this condition comes out to be true because array of I is equal to 1. And we know that when we encounter 1, we simply move I by 1 position because 1 is already in the middle area. So we simply increment I by 1 position. I becomes 3. I is still less than equal to k. Now array of I is 2. So this condition is false. This condition is false. And this condition will be true. So when we encounter 2, we simply throw it to k and take its value. So 2 will come here and 0 will come here, like this. Now this 2 is at its correct position. So we will decrement k. K becomes 3. Now here I is equal to k. So this condition is still true. Array of I is 0. So this condition will be true. When we will encounter 0, we need to throw it to j and take its value, so that zeros are at the start. So when we will do swap, so 0 will come here and 1 will come here. It means 0 is now at its correct position. And as we have encountered 1 here, we first move I by 1 position. So I becomes 4. We have placed 0 at its correct position, so we'll move j also by 1 position. J becomes 2. So friends, here you can see now this condition comes out to be false because I is actually greater than k. So this while loop will terminate. And here you can see that we have sorted the array in zeros, ones and twos form, where zeros are at the start, ones in the middle and twos at the end. So friend, this is all about the algorithm. We usually take the help of 3 pointers, I, j and k. I and j starts from 0th index, k starts from the last index. When I will encounter 0, it will simply swap it with j, because j's responsibility is to place zeros at the start. When I will encounter 2, it will simply swap it with k, because the responsibility of k is to put 2 at the end. And when I will see 1, i's responsibility is to place ones in the middle, and as I is already in the middle, it will simply move ahead. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video, we are going to discuss about a basic introduction to quicksort. In this video and in upcoming few videos, we will discuss completely about quicksort. So quicksort is a sorting technique where we get a collection of elements and we sort them in ascending or descending order. So in quicksort, here if you see, when we discussed merge sort, we saw that it was a divide and conquer algorithm. So by divide and conquer we mean that let's say if we are given a complex problem, we try to divide that complex problem into smaller sub-problems, and when those smaller sub-problems are not further divided, we try to conquer them. And when we conquer each and every smaller sub-problems, we reach to the solution of our original problem. So quicksort is also a divide and conquer algorithm. It involves 3 steps. The first step is the pivot selection. So in pivot selection, what we do is we pick an element from the array and mark it as pivot. Now this pivot element can be the first element, last element or any random element. We just take any element and mark it as pivot. So here, let's suppose we are given this array and we want to sort this array using quicksort. So as we discussed, the first thing we do is we take a pivot element. Now this pivot element can be the first element, any random element or the last element. So we can take any element as pivot. In this tutorial we will take the last element as our pivot. So here the last element, which is at index 8, the value is 3. So this is our pivot. So this is the first step. We take a pivot and we can take any element as our pivot. Now after taking a pivot, what we do is, whatever the element we have taken as pivot, now we actually partition the array. So by partitioning we mean that we reorder the array such that all elements greater than pivot comes after the pivot, and all the elements smaller than pivot comes before the pivot. The elements equal to pivot can go either side of the pivot. So whatever the pivot we took, which we saw in our previous slide, it was 3. So then we partition the array in such a way that all the elements which are greater than pivot comes after the pivot, and all the elements which are smaller than pivot comes before the pivot. So we are actually reordering the array. And the elements which are equal to pivot can go on either side. It can go on the left side or on the right side. So why we are doing this partitioning is, this is the important step. After we perform the partitioning, the pivot is actually at its correct sorted position. Now what it means is, let's say 3 is the pivot and these are the remaining elements. So all the elements greater than pivot should come after the pivot, and all the elements which are smaller than pivot should come before the pivot. So here 3 is the pivot. So now we'll check 9 is greater than pivot, it comes here. Because as it is greater than 3, we know that all the elements which are greater than pivot will go after the pivot. -3 is smaller than 3, it comes here. 5 is greater than 3, it comes here. 2 is lesser than 3, it comes here. 6 is greater than 3, it comes here. 8 comes here. -6 comes here. 1 comes here. And 3 is the pivot, so it is at this position. So here you can see, these are all the elements which are smaller than pivot, and these are all the elements which are greater than pivot. We are not concerned about the order of the elements. Here it's -3, then it is 2, then it is -6. So we are not concerned about the order. Here it is 9, 5, 6, 8, like this. We are only concerned about the partitioning of this array in such a way that this is the left part, which is smaller than pivot, and this is the right part, which is greater than pivot. So why we are actually doing this partition? Here you can see, I'll just remove this. So when we actually partition the array based on what we discussed, here you can see that 3 was our pivot. All the smaller elements are just before the pivot, and all the greater elements are just after the pivot, and it can be in any order. But here you can see that after this partitioning, one unique property with this pivot is, let's say this is low index and this is high index, and this is any jth element. So after this partition, in this array from low to j-1, which is this portion, is less than equal to array of j, which is our pivot, which is less than equal to j plus 1 to high, like this. So when we do this partition, this holds true. And if you see, when we sort this array, so this is the sorted array. So the elements are arranged in ascending order. But here you see that the difference between this partitioning and this sorted array is the pivot after the partitioning and after the sorting doesn't change its position. It's actually at its correct position after the first partition. So here if you see, 3 was our pivot After partitioning it came at index 4, and if we sort this array, you will see that in the sorted array, the pivot doesn't change its index. It will still be at index 4. So this is one critical information about quicksort, that it partitions the array and all the elements which are smaller than pivot comes to the left and all the elements which are greater than pivot comes to the right. But this pivot after partition is actually at its correct position even after the array is sorted. So this is the second step of quicksort, the partitioning step. Moving ahead. Now here you saw that this pivot and this partitioning, it is actually the divide part of the algorithm where we are actually reordering the array in the partitioning step. And now how we will conquer this is based on this recursion step. Whatever we did above, now we recursively apply the above steps on the subarray formed on the left side of the pivot and on the right side of the pivot. So these two steps we will apply on all the elements which are lesser than pivot and on all the elements which are greater than pivot recursively. So this step which we discussed, that after this partitioning the pivot is at its correct sorted position. We don't touch the pivot after the partitioning. We take the left part of the pivot, we take the right part of the pivot, and we apply the above steps recursively on the left side and on the right side. So here pivot in the sorted array is at its correct position like this. But when we do the first partition, this one particular element is sorted. Here you can see in the sorted array, pivot doesn't change its position and it is at its correct position. So we can think from the first partition, we have sorted one element. And now when we are discussing the recursion part, the third step, what we do is, we take the left side of the partition, we take the right side of the partition, we leave the partition as it is at its correct position. Now we apply the same steps of choosing a pivot and then partitioning on the left side of the array and on the right side of the array. So this we keep doing recursively till all the elements are at its correct position. First partition gives one sorted element. If we do this recursively with the left part and with the right part, there will be a time that all the elements will be properly sorted and they will be at its correct position. So the recursion step is important. So these are the three important steps in quicksort: pivot selection, partitioning, and then doing the recursion of these two steps on the left side of the pivot and on the right side of the pivot. And when this recursion will end, all the elements will be properly sorted and they will be at its correct position. So this was the basic introduction of the quicksort at a high level. In our next video we will see how we do this pivot selection and the partitioning. And after that we will see that how this recursion help us in sorting the array, taking the help of these first two steps and applying them recursively. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video, we are going to discuss that what is quicksort partitioning. In the part 1 of this video, we discussed a basic introduction about quicksort. So in this video, we will be discussing what is quicksort partitioning. So friends, in our previous video, we discussed that quicksort is a divide and conquer algorithm, which basically involves 3 steps: pivot selection, partitioning, and recursion. In pivot selection, we actually pick an element and mark it as pivot. The pivot element can be the first element, last element, or any random element from the array. And the second step is the partitioning step, where we reorder the array such that all the elements greater than pivot comes after the pivot and all the elements smaller than pivot comes before the pivot. and the elements which are equal can go on either side of the pivot. So usually in the partitioning step, we actually get a left part and a right part, and in the middle we have pivot. So once the partitioning is done, pivot is somewhere in the middle. Also we discussed that after this partitioning, the pivot is at its correct sorted position. So here you can see at whatever index pivot comes after the partition, if we sort this complete array, the pivot will lie at the same index only. So it means after the partitioning, one of the element is sorted. So in the recursion step, we apply this pivot selection and partitioning recursively in the left side and in the right side, and we keep on doing that till the complete array is sorted. So in this video we will see that how we do pivot selection and partitioning. So let's say we are given with this array. So here we can choose any element as our pivot, but here we choose the last element as our pivot. So 3 is the pivot, and as we discussed in our previous video that after we partition and reorder the array in such a way that all the elements smaller than 3 comes before 3 and all the elements greater than 3 comes after the 3. So it would look something like this, that this part is the left part and this is the right part and this is our pivot. So if you see, when this array will get sorted completely, so this is the sorted array. So here you will see that the pivot after the partition was at 4th index, and once the array got sorted completely, it was still at the same index, because when we partition the array in such a way that this condition holds true, which we discussed in our previous video as well, after the partition the pivot is actually at its sorted position. So now let's see how this partitioning happens. So here is the algorithm to partition the array. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Also please like this video and watch it till the end. So here you can see that let's suppose we are given with this array of 9 elements, 9, -3, 5, 2, 6, 8, -6, 1 and 3. So when we will call partition, we are actually partitioning complete array. It takes low and a high pointer. So low actually starts from the 0th index and high starts from the last index, because we need to partition the complete array. So low starts from 0 and high starts from 8. So when we do partition of the array, the first thing we need is the pivot. So we can select the pivot as the first element, last element or any of the random element in this array. So here we will choose the last element as our pivot. So array value at higher index, which is the 8th index, will give us our pivot. So pivot is 3, this value, which is at array of high. Now after this pivot selection, what we do is we reorder this array in such a way that all the elements smaller than pivot comes in the left part, then comes the pivot, and all the elements greater than pivot comes at the right part. So this reordering is done by two variables I and j. Both are starting from low, which is the starting index of our array or the starting range of the array from where we need to do the partitioning. So I starts from low, which is 0 index, and j starts from the low, which is 0 index. So friends, now we actually traverse each and every element of this array and we provide a while loop where condition is I will traverse till it is less than equal to high. So friends, the basic idea behind this algorithm is why we are creating two pointers. If you see closely, then we have these 4 pointers. So usually from low to j minus 1, we actually have smaller elements and equal elements to pivot. Means all the smaller elements to pivot comes from low to j minus 1, including the elements which are equal to pivot. From j to I minus 1, we will have all the greater elements to pivot. And from I to high, the elements are yet to be traversed. So after every execution of while loop, you can see these conditions and you can figure out that how these ranges works. So at the start from I to high, every element is yet to be traversed, and low to j minus 1 and j to I minus 1 goes beyond the array. So therefore there are no elements in these ranges. Currently I is less than equal to high, so this condition is true. Now we are trying to explore the first element, which is 9. So here what we do is, in one of our previous videos where we saw that 3 number sort or how we can sort 0 and 1, we apply the small part of the same logic here as well. So what we do is, this 9 which is at array of I and this 3 which is our pivot, there can be two possibilities. Array of I can be less than equal to pivot, or array of I can be greater than pivot. So if array of I is greater than pivot, it means whatever value we have here, it is actually greater than pivot. So here you can see, we know that greater elements lies from the range j to I minus 1. So when array of I is greater than pivot, what we do is, we simply move I by one step, and if array of I is less than pivot, we perform a swap between I and j, and then we move j and I simultaneously. So you will understand why we are doing this once we perform few of these iterations. So at the start, array of I, which is 9, is greater than pivot, so this condition comes out to be false. So if array of I is greater than pivot, we simply traverse I ahead. I becomes 1 and we reach to index 1. So here you can see that why we actually traversed I one step ahead when pivot was lesser than array of I. 9 was greater than 3. So greater element should lie from j to I minus 1. So here you can see j to I minus 1. So this element. So this is the only range which can help us to figure out that it has the greater elements to pivot. You will understand more about these two ranges and these 2 points when we traverse ahead. Now I is less than equal to high, so this condition is true. Array of I is minus 3. Minus 3 is less than equal to pivot, so this condition comes out to be true. So when array of I is less than equal to pivot, we simply swap the value at I and jth index. So after we perform swap, we will see why we are actually doing that. So these 3 steps I will be going somewhat fast because we have already discussed how we can do this swapping. So minus 3 will come here and 9 will come here. Now after this swap, minus 3 has came here, 9 has came here. So here when array of I encounters a value lesser than pivot, it simply throws it into this direction, because from low to j minus 1 we need to put the smaller and the equal elements to the pivot. So how I can throw it in this direction is by swapping it with j, and after we perform this swap, we increment j and I both, because this value is placed at its proper position, that it is lesser than the pivot. So now we'll increment j also. So j becomes 1, and as these two elements are already explored, we will increment I as well. I becomes 2. Now our execution point reaches here, and here you can see that from low to j minus 1 we have smaller and equal elements to pivot. So from low to j minus 1, which is this element, this range are the smaller elements to pivot. From j to I minus 1, j to I minus 1, this element is in the range of the greater elements to pivot. So over these two conditions are still holds good. I is still less than or equal to high. So this condition comes out to be true, and the while loop will execute. Now 5 is greater than pivot. So this condition comes out to be false. And once this condition comes out to be false, we know that we need to simply traverse I ahead. I becomes 3. So now here you can see this part is smaller elements range, and these two elements 9 and 5 are greater than pivot. So it is separated by j and I in such a way that from low to j minus 1 we have smaller elements, from j to I minus 1 we have larger elements. So therefore when array of I is greater than pivot, we simply traverse I ahead, we do nothing. And when array of I is less than equal to pivot, it means we have found one element lesser than pivot, so we simply throw it to the starting range, and we simply shift the larger element range ahead. So here initially 9 was here, which was the larger or the greater elements to pivot. When we did the swap, 9 actually shifted in this direction, so that there could be a place for the elements which are smaller than pivot to come in this direction. So now similarly we will do this for the rest of the elements. From I to high, the elements are yet to be traversed. Currently I is less than equal to high, so this condition comes out to be true. 2 is less than equal to pivot, so this condition is true. So now here you can see, we know that 2 should lie somewhere in this range, at the starting range, and j keeps the track of the smaller elements from low to j minus 1. So at j we have one greater element, and we need to put 2 somewhere here so that this 2 comes at its proper position, but here we already have 9. So therefore we do this swap so that 9 can come here, and this range of the greater element is still maintained in the middle somewhere, and it simply shifts in this direction. So I'll remove everything. So now we'll do this swap. 2 will come here and 9 will come here. Two came here and 9 came here. So the range of greater elements simply shifted in this direction, because we need to create a space so that smaller elements can come in this direction. We'll increment j now. We will increment I, because this element which was here is actually being traversed. So from low to j minus 1 we have smaller elements range. From j to I minus 1 we have larger elements range or greater elements range. I is still less than equal to high, so this condition is true. 6 is greater than pivot, so this condition comes out to be false. It means 6 is at its proper range, we don't have to touch this, we will do I++. So I simply moves ahead. I becomes 5. Now this element also got into the range of greater elements, because from j to I minus 1 we have the greater elements to pivot. I is still less than high, so this condition is true, so the while loop will execute. Now array of I, which is 8, is greater than pivot, so this condition is true, therefore this condition comes out to be false. And as array of I is greater than pivot, we do nothing, we simply traverse I ahead. I becomes 6, and this element becomes part of our greater elements range from j to I minus 1. I is still less than equal to high, this condition is true. Now minus 6 is less than 3, so therefore array of I is less than equal to pivot. Now we need to throw this pivot in the left direction, and we know that j is actually keeping the track of that. So this condition is true. First we perform swap between I and j so that this minus 6 comes in this range, and we simply shift the one of the greater element in this direction. So we'll perform this swap using a temp variable. So minus 6 came here and 5 came here. So after placing a smaller element at this spot, we will increment j. J becomes 3 because for the next smaller element, this would be the right place, so we increment j as well. And as we have already traversed whatever the value was here at this index, we will also increment I. So I becomes 7. So here you can see this range from low to j minus 1, we have smaller elements. From j to I minus 1, we have greater elements to pivot. Value of I is 7, so 7 is less than equal to high, which is 8. Now 1 is less than equal to 3, so this condition comes out to be true. We need to throw this 1 because it is lesser than or equal to pivot in this direction so that it can come in this range. We simply swap I and j. So 1 came here and 9 came here. So here you can see when we are actually encountering a value lesser than pivot, we are doing this swap and putting that at the starting range, and whatever value j is pointing from j to I minus 1, we have greater elements. So at j we have one greater elements. So we are simply shifting the range which is greater than the pivot just ahead. So 9 came here, but still if you see, the range is intact. All the elements which are greater than pivot are in sequence. The order will not be maintained, but the range will be maintained. So now after using this spot, we will increment j. J becomes 4. And we will increment I because this element is traversed and it got shifted here. So we simply traverse I ahead. I becomes 8. So here you can see from low to j minus 1, this range is of smaller elements. J to I minus 1, this range is of greater elements. Now for the last time, this while loop will execute because I is equal to high. So here you can see that now we are actually encountering the pivot itself, and this is one critical step. Because we need to put this pivot at its correct position somewhere between the range of smaller and greater elements to pivot's range. So this equal to condition does that, and it is very important. So currently array of I is equal to pivot. So 3 is equal to 3, which is the pivot. And we can place this 3 because smaller and equal elements to pivot will lie from low to j-1, and j is at the spot which can take lesser or equal values to the pivot. So 3 at index I will be swapped with j. So 3 comes here, which is our pivot, and 6 comes here, which is the value greater than to pivot. So after placing an element which is less than equal to pivot at its correct position using j, we will increment j so that next element can come here. But as there are no elements, but still we do this j++. So j becomes 5. And we will increment I because we are done with this element. So I becomes 9, which goes out of the boundaries of this array. So this condition comes out to be false because value of I is 8 and I is 9. So I is actually greater than I. So this while loop will terminate. And here you can see that in quicksort partitioning, when we do this partitioning, at the end we need to return the index of the partition, that from which index the partition is happened. So here we can see that from low to j-1 we have smaller and equal elements to pivot. So I will redraw this. Low to j-1, smaller and equal elements to pivot, j to I-1, so I value is 9, so j to I-1, which is still 8. These are the elements greater than pivot, and from I to I we have traversed all the elements. So if you observe closely, j is actually pointing to a place where the next smaller elements to pivot will come. So we will simply return j-1 because we know that from low to j-1 we have elements smaller and equal to pivot. So 3 comes here, which is at index 4. So we will return the index of the pivot. So in this partition, whatever value we return is actually the index of the pivot after the partitioning, which is j-1. So index 4 will be returned. So this is how we do partitioning, and this partition method is very frequently used in the quicksort. Similar kind of logic is used when we do sorting of 0 and 1, or putting even or odd integers in certain sequence, or we sort the 3 elements 0, 1 and 2. So for 0 and 1, this code is pretty much similar. So this partitioning logic which you are seeing here is very important for many of the algorithms, and this traversal with this range is very important to understand because the same logic applies to many of the algorithms. So we will see the partitioning logic, how it applies to quicksort. In our next video, we will see that how this recursion happens, where we apply the same logic of partitioning in the left side of the array, which have smaller elements, and the right side of the pivot, which have the greater elements. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss about quicksort recursion. In part 2 video of quicksort, we discussed that how we can partition an array. So in this video we will see that how we can perform quicksort recursion. So in the previous video we discussed about the pivot selection, that we pick an element and mark it as pivot. The pivot can be any random element. It can be first element, last element, or any random element. Now based on what we choose as our pivot, we do the partitioning. We reorder the array such that all elements greater than pivot comes after the pivot. All elements smaller than pivot comes before the pivot. The elements equal to pivot can go on either side of the pivot. And once this partitioning is done, based on the reorder of the array, the pivot is actually at its correct sorted position. So this we already discussed in our previous video. So in this video we will be looking into the recursion part, where after partitioning the array, we perform these two steps, the pivot selection and partitioning, recursively on the subarray formed on the left side of the pivot, which has the smaller elements to pivot, and on the subarray formed on the right side of the pivot, which has the greater elements to pivot. So here above two steps we perform recursively on the left side of the pivot and on the right side of the pivot. So let's see at a high level how this recursion looks. So let's say we want to sort this array using quicksort. So here you can see that this is a small piece of code which does the sorting. It takes in an array and it takes in a range that from which index to which index we need to do the sorting. And here you can see that the first step we are doing is the partition step, and once we get the partition index, now we have two arrays. One is on the left side of the partition and one is on the right side of the partition. So we recursively call the sort method, which is the same method, from low to p-1, which is the left part, and from p+1 to high, which is the right part. And this happens recursively because the method is calling itself again and again. After the partition, we are actually rearranging the array in the partition method in such a way that the element present at the partition index, which is the position of our pivot, that element is correctly sorted and placed at its proper position. So with one partition we can get one element and place that element at its correct position such that that particular element is sorted. And we will keep on doing this recursion till low is less than high. So this is our base case. So at a high level, let's see how this recursion looks. In our next video, we will see the step-by-step demonstration of this quicksort algorithm. But for time being, we can just see at a high level that how this recursion looks like. So here at the start, we need to sort this complete array. So this will be our low and this will be our high. Now low is less than high. We call the partition method. So in the partition method, we take the last element as our pivot, like this. So 3 is our pivot. Now after this partition method will end, we get the index of the element 3, that where it belongs. So in our previous video we saw that how we can perform this partition, and we took the same example. So in the first partition you will see that 3 comes at index 4, and in the partition the array is rearranged in such a way that all the elements lesser than pivot comes in the left side, all the elements greater than pivot comes on the right side. So here we are doing the logical division of the array and we are partitioning into two parts, left and right. So we are not breaking the array. It's just for the demonstration purpose that it looks like this. If you see the index from 0 to 3, we have smaller elements. From 5 to 8, we have elements greater than the pivot. So this is the pivot index. Now after we get the pivot index, if we sort this array directly, you will see that in the sorted array, 3 will be always at index 4. It means when we perform this partition, one of the element is sorted and it is placed at its correct position. So once it is placed at its correct position, we don't touch this element now. What we do is we call the sort method on the left side recursively. So it goes deep down like this. And the range we took is low to p minus 1. So p is the pivot and this is p minus 1. So now we will call the sort by taking this left side, only these 4 elements. And this will happen recursively. Low should be less than high. This would be our base case. So here when this sort method will be executed for this left array, you can see that this sort method will be executed again. Low will be the same, but high will become p minus 1. So this would be our high. Low is less than high. Now we will again call partition method. We will pass in the array. We will pass in low and high. So now in the partition method, only these 4 elements will be reordered because we are providing the range of low and high in the partition. At the start, low and high were the complete range of the array from 0 to 8. Now this partition method will only partition 0 to 3. So in the partition method, we will first choose the pivot element, which we have discussed that we choose the last element. Now we need to do the reordering such that all the elements lesser than 1 should come on the one side and all elements greater than 1 should come on the other side. So here we will see that the partition method will reorder the array in such a way that it looks like this. This much part are the elements which are lesser than pivot and this much part are the elements which are greater than pivot, which is 1. But here we will see the index which we get is 2 because it returns the final position of the pivot. So index 2 will return. Here in the first partition index 4 was written. So based on this p minus 1, we took the left side of the array and we did the partition again. So now here if you see, if we sort this array completely, you will find that 3 is at 4th index, which is sorted. And after the second partition, 1 will be at 2nd index. So this element is also sorted. So now we don't touch 1. Here if you see, we again go on the left side from low. So this was our low and this is our p and this is our high. So we again call sort method from low to p minus 1, which is we are taking the left side of the array. So when this sort method will be called again, low will be at the same spot but high will become this spot. So it means now we are actually picking up this 2 elements and we are trying to sort them and we are trying to apply this logic. So this will be our low and this will be our high. Low is less than high. So it means we have 2 elements. So we can again do the partitioning of the array from low to high. So in the partition method, we will take the last element as our pivot. And now we will partition the array in such a way that all the elements lesser than minus 6 will go on the left side and all the elements greater than minus 6 will go on the right side. So this partition method will reorder only these 2 elements now because we are providing the ranges and it will touch the array into these ranges only. So it looks like this. So as there are no elements which are smaller than minus 6, so minus 6 will be the only element on the left side which is at index 0 and minus 3 is greater than minus 6, so this will lie on the right side. So friends, here you can see that now this is our low and this is our pivot index. So after we get the pivot index, we will again call sort on this one element. We will try to sort its left part from p minus 1. So p is at 0 index. If we do p minus 1, it will go minus 1. So here if you see, when we partition the array, pivot was at 0th index. It is the only element now. So on the left side of pivot, we have no elements. So if we call sort method again, passing in low as 0 and high as p minus 1, so it will take the value of the new high as minus 1. So here we will reach the base case and we will simply return from this method because low value is 0 and high value is -1. So therefore we can't further divide -6, and at whichever index -6 will be there, that will be the properly sorted position for the element -6. So now this method is done because when we call sort again, we will reach this base case and we will return. So this method will be done. So now this sort method will be executed and we go to the right side of the pivot. It means now we are taking in the elements which are greater than -6, which is the only element -3. So p plus 1 will be our new low. This will be our low and high will remain the same index. So here if you see, we will again encounter the base case. Low is actually equal to high. So it means we can't divide from low to high further down. So based on this base case, this sort method will end and the call will reach here again. And the sort method which we called from here, this will also get end. So -3 will be also at its correct sorted position. Like this. So here with these two sort methods, we are going in this direction and then we are going in this direction. So with this sort, we went to this direction. This is sorted. And with this sort, we went to this direction, which is sorted. So we will return back to the left side. And here you can see when we'll return back here, when we had called sort on this part, we went in this direction. And as we are returning back from here, so we will return from here like this. And now when these two elements are sorted, we will go in this direction to sort the greater elements to this pivot, because we are doing this algorithm recursively. So first the left side is done, and once that left side is done, we go on the right side. So this side is done completely here. Now we go on this side. So here 2 is the only element left. So this will be sorted because the base case will be fulfilled. For this element, low and high will be at the same spot because this is our P, and if we are going on the right side, we do P plus 1. So P plus 1 will be the index 3, which will be our low, and high is already at index 3. So this is sorted like this. So now execution point will reach back here, and here you can see left side is now properly done. So it will go back here, and now we perform the same steps recursively on the right side of the elements which are greater than 3, which is our index 4. So now we perform the same step on this right side. So if we are going on the right side, we are doing P plus 1. We are going on the right side. The low will be from P plus 1 to high. So this is P. This will be our low. And this will be our high, because this high has not changed its value. So now we will partition it again based on what we saw here. So 6 will be the pivot. And now when we will partition it, it would look something like this. So 6 is properly sorted. Now we go on the left side first. So 5 is the only element left. So it will encounter the base case. This is our P and this is our low. So for the left side, if we do P minus 1 to take all the elements which are lesser than 6, this will become our high. And as high is equal to low, we will return from the recursion and phi will be at its correct position. So we go back like this and then we try to sort the right side. So we call the recursion again by taking P plus 1 to high. So this was high. Like this, and if we do P plus 1, this will be our low now. So now we are actually partitioning two elements. So we take 9 as the pivot. We do the partition. So our pivot lies at the 8th index. There is only one element which is lesser than pivot, which is on the left side of the array. And there are no elements which are greater than pivot. So after the partition, at whichever position the pivot lies, this is the properly sorted position for element 9 and we are left with only one element. So we first go on the left side like this. We take from low to p minus 1 because if we do p minus 1 we'll get the left side range. So this will become our new high, and as this is the only element left, low is equal to high, so we can't divide or partition this piece of sub-array further. So 8 will be also at its correct position like this. So if I remove everything, so here you can see that we are performing the recursion on this array recursively and we are doing the partitioning, and with each partition one element is getting sorted and placed at its correct position. So if you try to combine all these indexes, you will see that if we sort this array, the array would look like, if I just plot it here, it will look like first -6, -3, then 1, 2, 3, 5, 6, 8 and 9. So if you see that this would be our finally sorted array, and if you see the indexes of all the elements from 0 to 8, you will see that at 0 we have -6 like this. At index 1 we have -3 sorted. Index 2 we have 1. At index 3 we have 2. Index 4 we have 3. At 5th index we have 5. 6th index 6. 7th index we have 8, and at the 8th index we have 9. So here you can see that how this recursion and this partitioning is helping us to perform the quicksort. So friends, here if you see, at the start we took complete array, we took a pivot, we did the partitioning, all the elements lesser than pivot were on this side and all the elements greater than pivot were on this side. Then we recursively took the left part, we took the pivot and we did the same steps like this. Then we took the left part again, we did the same steps, and finally we got -6 and -3 at 0 and 1 index, which are sorted. And after taking this left and right part and sorting them, this left part was done properly. Then we picked the right part of this pivot and this was sorted. And after we sorted this, all the elements were done for the first left sub-array. Then we went to the right part and we did the same steps again. We first went on left, then we went on the right. We first went on the left, then we went on the right. And at the end, you see all the elements are at their proper indexes. So if we sort this array, you will get this array. So friend, this was all about the quicksort recursion. If you didn't understand any of the recursion logic here, in our next video, we are going to see the step-by-step demonstration of the quicksort algorithm. There it will make sense that how this recursion is happening, where this sort method is again calling this sort method 2 times. After partitioning, we go on the left side first and then we go on the right side. So we will understand this recursion in our next video with a detailed demonstration. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video of quicksort, we discussed about the quicksort recursion. So now in this video, we will see the step-by-step demonstration of the quicksort algorithm, and we will see that how the algorithm works via an animation. So this is the quicksort algorithm, and we will see the step-by-step demonstration of the algorithm. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So in quicksort algorithm, we have this sort method which takes in an array which we want to sort, and we pass basically a range that from low to high we need to sort. So at the start, let's say we want to sort this array having 6 elements 5, 2, 0, 1, 6, 3. So when we will call sort method, we will pass in the array. The low will be 0 and high will be array.length -1, which is the last index. So low is 0, which is pointing to 0 index. High is 5, which is pointing to the last index. So we are telling that we need to sort this array completely from 0 index to 5th index. And here you can see that this sort method is recursively calling this sort method again here and here. So in order to demonstrate the recursion, we are using this call stack, which will have the method calls and the state of the method stored in low, p and high. So when this sort method will be called, there will be one method on the call stack by name sort. Low is at 0 index, high is at 5th index, and p is the index of the pivot which we will be calculating here. Moving ahead. So here we know that quicksort is divide and conquer algorithm. So here we actually divide this complex problem of sorting into smaller sub problems, which means that we are dividing this array into 2 parts, and we keep on dividing the array into this recursive sort methods based on range low and high. So when low will be equal to high or low will be greater than high, when low will be equal to high, so it will be something like this, that low is equal to high. It means we can't further break down the array because it has only one element. So therefore, when this condition will arrive, we need to simply break from this recursion, because this sort method is recursively calling this sort and it keeps on going. So when low will be equal to high or greater than high, then we need to tell recursion that we have reached our base case and we need to stop the recursion. So currently low is less than high, low is 0 and high is 5. So this condition comes out to be true. So friends, in our previous video we discussed that how we actually do the quicksort. We first do the pivot selection, where we pick up a random element from an array and then we actually partition the array. And we partition the array in such a way that the elements which are smaller than the pivot usually lie on the left side, and the elements which are greater than pivot usually lie on the right side, and the equal elements can go on either side. So here this is the first step. We actually call the partition method. We pass the array. We pass the range from low to high. So currently we are telling that we need to partition this complete array. And in this partition method, we actually do the pivot selection and reordering of the array. So this method we have discussed in our previous videos in a greater detail. You can watch that video to get more understanding. But here also we will see that how this partition works. So when we will call partition method, we are leaving this sort method. So the execution point will leave the sort method and the partition method will be on the call stack. So before we leave this sort method, we need to store the state of this sort method, that low was at 0 and high was at 5th index. And as we are leaving this sort method, we need to keep the track of line number, because once this partition method will end, we need to begin this sort method from line number 3 only, because we are leaving this sort method at line number 3. So here we will update the line number 3 like this, which tells that we are leaving this sort method at line number 3, and when we will come back to this sort method, we will start our execution from line number 3, and when we will start our execution, low will be at 0 and high will be at 5. So we are simply storing the state here. So now we'll see this partition method with this array, low as 0 and high as 5. So we are partitioning this complete array. We have discussed this method in greater detail in our previous videos. You can watch that video. so that once we go through it again, you will get more better understanding. So first we do the pivot selection. We can choose any random element from the array as our pivot. We can choose the first element or any element in the middle or the last element. So here we choose the last element as our pivot, which is denoted by the end of this range. So pivot becomes array of I, which is 3. So this is our pivot. And after this pivot selection, our job is to do this partition. Elements lesser than 3 will go on one side, which is on the left side. Elements greater than 3 will go on the right side. And the elements which are equal to pivot can go on either side. So when we perform the partition, we take the help of two variables I and j. Here I and j both starts from low. Currently low is pointing to 0 index. So we are not starting I and j from 0th index. We always start it from the low index. Because currently as we are partitioning complete array, low is pointing to 0. There could be a chance that we only need to partition these 3 elements. So at that moment, low will be a 3rd index. So we need to partition from 3rd index to 5th index. So therefore we create 2 pointers I and j, both starting from low. I is 0 because low is pointing to 0. J is 0. Now as we need to partition, we need to provide a while loop where we traverse each and every element of the array. Using the iterator I, it goes till it is less than equal to I. So this is very important algorithm and it is used in many problems. Here what we do is, we have these 4 pointers and once we partition the array, it looks something like this. Smaller and equal elements to pivot are on the left side. Then we have the pivot and then we have the elements greater than pivot. So this is the ranges, and if we use these 4 pointers, the range varies like this. From low to j minus 1, we have smaller elements or equal elements to pivot. From j to I minus 1, we have the elements greater than pivot, and we have discussed this in greater detail in our previous videos as well. From I to high, we have elements yet to be traversed. So at the start we need to traverse every element. So from low to j minus 1 and from j to I minus 1 we don't have any elements because all the elements are yet to be traversed. Therefore we have provided this condition that this while loop will run till I is less than equal to high. So we'll see how this algorithm works. And also we need to keep this if condition in mind. So here when we are partitioning, we need to compare each and every element with the pivot. And if it is less than pivot, the first thing we do is we simply swap the values at I and jth index in the array. Because as this element is less than equal to pivot, it should come at the starting range because we need to partition it that way. So we will see how these 3 steps work. And if the element is greater than pivot, we do nothing. We simply leave the element there and we traverse I ahead. So this condition is true, I is less than equal to I. So in the if condition we check whether array of I is less than equal to pivot or not. So we are simply checking whether 5 is less than 3 or not. So 5 is greater than 3. So this condition comes out to be false. So when array of I is greater than pivot, which is our case, we simply leave that element there and simply traverse I ahead. So I becomes 1. I is still less than equal to I. Now array of I, which is 2. 2 is less than 3. So this condition comes out to be true. And once this condition comes out to be true, we know that we need to swap the values at I and j index. It means we need to swap 5 and 2. So here why we are doing this swap is we need to partition the array in such a way that smaller element should come at the starting range. then our pivot should come, and then the elements greater than pivot should come. So when array of I is less than equal to pivot, we simply throw the element which is at ith index to jth index and take its value. So when we will do this swap, I will go over these steps quickly. 5 will come here and 2 will go there. So 2 came here and 5 came here, and we know that now we need to increment j and I both. So why we are incrementing j is because j has placed one of the smaller elements here. So this space is occupied. So j moves ahead. J becomes 1. And we will simply traverse I also ahead because this element is also explored. So I becomes 2. So friends, one thing to note here is, irrespective of any of this condition is met, we simply traverse I ahead in both the cases. So therefore it is written here. Now I is less than equal to I. Array of I, which is 0, it is less than 3. So this condition comes out to be true. So we need to throw 0 to j and take its value by doing this swap. So 0 goes here and 5 comes here. So friends, here you can see that as 5 is greater than pivot, the elements which are greater than pivot, they are actually shifting in this direction. But the element which are lesser than pivot, we are simply throwing it to j to put it at that particular index, and j actually holds one of the greater element to pivot, because from j to I minus 1 we have the elements greater than pivot. So j is actually pointing to one of the greater elements than pivot, and once this swap is done, we are simply taking a greater element and shifting it ahead. And by doing this swap, we are creating one space here so that the elements which are lesser than pivot can come here. So therefore we do the swap. We throw whatever the element is at the ith index to j and take its value. So this spot is filled now properly. So we will increment j. So j becomes 2. We will increment I. I becomes 3. This condition is still true. I is less than equal to I. 1 is less than 3. So this condition is true. So we perform these steps again. So we are performing this swap using this temp variable. So 5 comes here and 1 goes there. And after filling this position with a value smaller than pivot, we move j ahead. So j becomes 3. And we have explored the array till this point, so we move I also ahead. I becomes 4. So friends, here you need to keep watch on these two ranges. From low to j minus 1, we have the elements smaller than pivot, which is true. From j to I minus 1, we have elements greater than pivot. So this is j, I minus 1. So 5 is actually greater than pivot. So this both the conditions are true when we are doing these steps. Now I is still less than equal to I. So this while loop will execute. Array of I, which is 6, is actually greater than pivot. So this condition comes out to be false. So when array of I is greater than pivot, we know that this element is greater than pivot and it is at its proper position. So we don't touch this element. We simply move I ahead like this. So still you can see from j to I minus 1, we have elements greater than pivot. So therefore when we encounter a value greater than pivot, we simply move ahead. And when we encounter a value lesser than or equal to pivot, we simply throw it into this direction so that we can perform a swap between I and j. Now I is actually equal to I. So this loop will run one more time And now here you can see our pivot and array of I are the same elements. So why we are running it one more time is because smaller than or equal to pivot. So we have got a value equal to pivot. So we need to make it lie in the range of low to j minus 1. So j is holding a value greater than pivot. So we do this swap here. So 5 comes here and 3 goes there. So it means our pivot has landed into its correct position. Then we will increment j. J becomes 4. And we will increment I. I becomes 6. So as I has become 6, this while loop will terminate because value of I is 5. So friends, this partition method does two things. First, it returns the index of the pivot, which is j minus 1, which is 3. And second, it takes in the original array and reorders it such a way that all the elements smaller than pivot are on the left side and all the elements greater than pivot are on the other side. So when this method will end, we will return j minus 1, which is the index of this pivot from where this partition has happened. So the execution point will reach to this sort method and the array has been reordered. We have left this sort method at line number 3. So we will start from line number 3. This partition method has written a value of p, which is the index of pivot, which was 3. So value of p will be 3, like this here. So this is what we saw in the partition, that all elements smaller than pivot are in this side and greater than pivot are on this side. So friends, here you can see that if I sort this array directly, the sorted array would look like 0, 1, 2, 3, 5 and 6. And here you can see that once this partition is done, when we are putting all the smaller elements before the pivot and all the greater elements after the pivot, so when we sort this array completely, you can see that the index of the pivot remains the same. 3 is at index 3 and after sort also it will be at the index 3 because here it's 0, 1, 2, 3, 4, 5 index. So it remains at the third index only. So this is one important step in the partitioning, that after the partition, pivot is actually at its sorted position. So now what we do is we don't touch this pivot because it lies at its proper sorted position. Now our task is to perform this pivot selection and partitioning on the left side of the pivot and on the right side of the pivot, and that too recursively. So this sort method will keep on calling itself till the base case is reached. So now we call the sort method again, and this time we only take these 3 elements and we try to sort them. So here we are calling this sort method, we are passing in this array. Low value will be 0 only. High value will become p minus 1 because we are calling this sort method with p minus 1. It means we are taking in this range. This is p, so this will be p minus 1. So when this sort method will again gets called, our high will become p minus 1. So as we are leaving this sort method and we are calling this sort method, so first we will update the line number here and we are storing the state of the low, p and high. So we update line number 4 here and we leave this sort method and again call the sort method. So this sort method will be called with low as 0 and high as p minus 1. So this was our p previously, p minus 1, which is 2. So here now we are doing the sort from low to p minus 1. So this is the range of our array which we need to sort now. So high becomes 2, p minus 1 which is 2. So our new high became 2. Low is less than high. So now we'll partition only the left side of the pivot, which is these 3 elements. So we will leave at line number 3 this sort method. So this partition method will be executed again, and now we are not taking in complete array. We are taking the array from range low to high, which is 0 to 2 index, like this. So this partition method will only touch these 3 elements. So first we select the pivot, which is the last element of this range. So array of high will become our pivot. So 1 becomes our pivot. We start the partitioning with a value of I and j is low, which is 0. And as we already discussed how this algorithm works, we'll go over this quickly. We need to keep these ranges into mind and these two conditions into mind. So I is less than equal to high. This while loop will execute. Array of I, which is 2. It is greater than pivot, so we do nothing. We simply move ahead. We do I++. I becomes 1. I is still less than high. Now array of I, which is 0, it is less than equal to pivot. It means we need to throw it to j and take its value. So we do this via a swap. So 2 comes here and 0 goes there. So 0 goes there. And as j has filled this position properly, we'll increment j. J becomes 1. We'll also increment I. I becomes 2. I is actually equal to high. So this loop will run one more time to put this pivot at its correct position. Now 1 is equal to pivot. So we do this swap again. So 2 comes here and 1 goes there. Then we increment j. J becomes 2. And we increment I. So I becomes 3. And this while loop will terminate because value of I is 2 and j is 3. So 3 is not less than equal to 2. So here you can see that now we need to return the index of the pivot, which is at j minus 1, which is this. And here you can see that when we did partition of these 3 elements, these are actually elements which are lesser than pivot, which is 1, and these are the elements which are greater than pivot, which is 2. So currently it has only one element. So we have reordered the array and we are returning the pivot as 1. So execution point will reach here. We know that we have left at line number 3. So we start from here. This method returned the value of pivot as 1. So p becomes 1. Like this. So friends, we know that after doing this partition, we recursively call the sort method again. And this time we go from low to p minus 1, which is the left side. And then we go from p plus 1 to high, which is on the right side. So first we go on the left side. So here you can see this recursion is happening till the array is getting divided. So now when we will leave this sort method, we will first update the line number here, which is 4. And then we will call this sort method where low will be 0 and the value of high we pass is p minus 1. So P minus 1 will be 0. So this value will go to high and this value will go to low in the next sort method. So we have updated the line number and we have called this sort method again. So it looks like this, that this low which was 0, it's 0. P minus 1 which is 0 index, so high becomes 0. So it looks like this. So friends, here you can see now low and high are pointing to the same index. It means that we have left with only one element and we can't divide this array further down or partition this array further down because we have only left with one element. So therefore we have reached our base case. So low is equal to high. So this sort method will end and this sort method will be removed from the call stack and the execution point will reach here back. So it looks like this. This method was removed from the call stack and execution point reached here. We know that we left this sort method at line number 4. So we start from line number 4. And when we had left this sort method, low was at 0, P was at 1, high was at 2. So we position them back to their respective indexes. High was at 2, P was at 1. And here you can see that we are done with this left part now. So this sort method is done. And now we go on the right side. So we call this sort method again. Now this time we are passing the value of low as P plus 1. So P is 1 and P plus 1 is 2. So when we go on the right side, the value of low changes, and when we go on the left side, the value of high changes. Here you can see, if you are going on the left, value of high changes. If you are going on the right, value of low changes. So now we will leave this sort method. We first update the line number here, that we are leaving at line number 5. And we are calling this sort method with P plus 1 as our low, which is 2, and high as 2. So there will be one more method on the call stack with low as 2 and high as 2. So it would look something like this. Moving ahead, here you can see that now we are actually partitioning the elements which are greater than pivot, which is only this element 2, which is only one element. As low is equal to high, it means we have reached our base case and we are telling to this sort method that please stop the recursion and go back. So this method will be removed from the call stack because we can't divide 2 further down. And the execution point will reach here. So when this sort method was left, we had left at line number 5. So we start from line number 5. And at that moment, value of low, P and high were 0, 1 and 2. So we give them their respective indexes. So it was like this. And now after executing line number 5, there are no more lines left to be traversed. So this sort method will also end and the execution point will reach to this sort method because this sort method was actually being called by this sort method. So this method will be removed from the call stack. And when we had left this sort method, we had left at line number 4. So we start from line number 4. And at that moment value of low was 0, P was 3 and high was 5. So we give them their respective indexes. So this was the state when we had left this sort method. So here this sort method is done. It means that when we had done our first partition, the pivot came out to be index 3. And in this sort method, we went to the left side of the pivot and we did the sorting. And here you can see these 3 elements are sorted. So we had done with this method. Now our task is to go on the right side, call sort method again recursively. We pass the value of low as p plus 1 because we need to now go in this direction, and high remains the same. So here we are leaving this sort method. We'll update line number here, which is 5, and we are calling this sort method, passing in low value as p plus 1, which is 4. So it looks like this. Low becomes p plus 1, which is 4. So it looks like this. Low is less than high. It means we have 2 elements. It means we can divide this 2 elements further down. So we call the partition method again. We pass in the range from low to high. We are telling we need to partition the array of these 2 elements only. So this is our range. So when we are calling this partition method, we first update the line number here, and we have stored the state already in low and high. So line number 3 comes here. We leave this sort method. We call this partition. We need to partition from low to high. That is in this range. We are not touching this side because we have already done the sorting and partitioning of these elements. So we are now only touching these 2 elements. Array of high will be our pivot. So first we are doing the pivot selection. So 5 becomes our pivot. We create 2 pointers I and j, which start from 4th index. And then we perform the same step which we have discussed already. We provide a while loop, and the condition is I should be less than equal to high. We need to keep 4 things in mind. These 2 ranges and these 2 conditions. So array of I, which is 6, it is greater than pivot. So we simply traverse ahead. We do nothing. We do I plus plus. I becomes 5. I is equal to high. So this condition is true. Now array of I is 5, and 5 is our pivot as well. So therefore, when array of I is equal to pivot, we need to throw whatever value is at ith index to j and take its value. So we first perform the swap. So 6 comes here and 5 goes there. We have placed 5 at its correct position, which is our pivot position. So we increment j. And then we increment I. So now this while loop condition comes out to be false because value of I is 6 and high is 5. So we simply return the pivot index which is at j minus 1. So j minus 1, which is the 4th index. So we return 4 from this partition method, and we have also reordered the array in such a way that all the elements lesser than pivot are on its left side. So currently there are no elements which are lesser than pivot because we are not touching this side. We are touching from low and high. So from low to j minus 1, we have elements smaller than or equal to pivot, which is true. And from j to I, which is 6 minus 1, which is only this element, having a value greater than pivot. So we simply return index 4 from here. So the execution point will reach here. We had left this sort method at line number 3. So we start it from line number 3. The partition method returned the value as 4. We have placed 4 here. So P becomes 4. Now we go on the left side of the pivot from low to P minus 1. So here you can see low and P are pointing to the same element. So when we call this sort method, we first update the line number, which is 4. And then there will be one sort method on the call stack. So here, when we had left this sort method, we called this sort method from low to P minus 1. So when we did P minus 1, our high became 3. So here you can see that low is actually greater than 3. So it means we have reached our base case, and which makes sense because there are no elements on the left side of the pivot to be divided further down. So we simply return from this method, and the execution point will reach here. We had left at line number 4. So we start from line number 4, and low P and 5 had values as 4, 4, 5. So we give them their respective values, 4, 4 and 5. And now we go on the right side of the pivot, which is at P plus 1 to high. So P plus 1 is index 5. So first we update the line number here, because we are leaving this sort method. And then we are calling sort. So there will be one more method on the call stack with P plus 1 as our new low, which is 5, and high remains 5 only. So it looks like this. So here we can't divide this 6 further down. It means we have reached our base case. Low is actually equal to high. So this if block will not be executed. So the condition in if block comes out to be false, and we simply leave this method. So this method will be removed from the call stack, and the execution point will reach here. We had left this sort method at line number 5. So we start from line number 5. And at that moment, low, P and high were at 4, 4 and 5th index. So we reassign them their indexes like this. And as there are no more steps left to traverse for this sort method, so this sort method will also be removed from the call stack, and the execution point will reach here. So when we had left this sort method, we had left at line number 5. So we start from line number 5, and at that moment low, P and high were at 0, 3 and 5th index like this. And also friends, here you can see that after line number 5 we have no statements to execute. So this sort method will also be removed from the call stack. So friends, here you can see after every method got removed from the call stack, we have actually performed the sorting of the array. We have used the quick sort and we have sorted the array. So friends, this was all about the step-by-step demonstration of quicksort algorithm, where this sort method recursively calls this sort method. One is when it goes on the left side of the pivot, which is the smaller elements, and one when it goes on the right side of the pivot, which are the greater elements to pivot. In this partition method, we do the pivot selection and reordering of the array in such a way that smaller or equal elements are on the left side, then our pivot comes, and then the elements greater than pivot comes. So this steps we do recursively till all the elements are sorted. So friend, this was all about quicksort algorithm. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video we will be discussing a coding problem, squares of a sorted array in Java. So if you see, in this problem we are given an integer array which is sorted in ascending order. So here you can see this is the input -4, -1, 0, 3 and 10. So it's sorted in ascending order. Now what we need to do is we need to return an array of integers such that we need to square them, and whatever is the outcome we need to simply return that array. So for example, the output would be 0, 1, 9, 16 and 100. So how this output came is, after squaring each and every number, you will see the array will become -4 into -4 will give us 16, -1 into -1 will give 1, 0 into 0 will give 0, 3 into 3 will give 9, 10 into 10 will give 100. So this is the array which will be generated after we square each and every element. Now the complexity part is we need to sort this array and return from the method. So after we sort this part, it will become 0, 1, 9, 16, 100. So friends, the brute force approach would be we simply square the array. So it will become like this: 16, 1, 0, 9, 100. And then we again use arrays.sort. We pass in the array and we get this result array. But this is a brute force approach which is not very efficient. So if you see, at the last step, if we sort the array, the time complexity will be n log n. So which is not good. We need to see that whether can we do it in O of n, because these operations are constant, and if we iterate each and every element once, we get O of n time complexity. So let's see the algorithm and its demonstration step by step. So here is the algorithm. So here you can see it is only taking one for loop and we are not sorting the array anywhere. So let's see the demonstration of this algorithm step by step. But before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So we'll call this method, we pass in the array. So let's say if we take this array, -4, -1, 0, 3 and 10. So the length of the array is 5. So at the start, we simply calculate the length of the array by doing array.length and we store it in integer variable n. So n will become 5. Now as you want to square each and every element and return this array all together in a sorted form, we'll first create our result array. So this result array will store all these elements squares in sorted form. So we'll create this new array. We pass in the length as 5. So it will look something like this. So these are the default values of the integer array. So here the idea is we take 2 pointers I and j. So I will start from 0 and j will start from n-1, which is the last index. So it would look something like this, that I is pointing to 0 index and j is pointing to the last index, which is 4. So here if you see, when we do the squares of any negative number, we usually get the result in positive side of the numbers. So therefore this problem becomes complex, because if suppose our array had only positive numbers, then this problem would have been straightforward. We just do the squares, and as the array is already sorted, the squares would have been in sorted form. But here, as we are including these negative numbers, here you can see 3 is greater than -4. But if we take the squares of both the numbers, -4 into -4, we will get 16, and 3 into 3 will get 9. So before doing squares, -4 is less than 3, but after doing square, this number 16 is actually getting greater than 9. So it means when we will return the result of the squares in sorted form, this -4 square will come after 3 squares, because 9 will come before 16. So this algorithm becomes very tricky to find the exact position of these negative numbers among the positive numbers. So what we do is, we try to fill this result array from the end. So here we create a for loop where k starts from n minus 1. So k is starting from 4 because value of n is 5. So it means we will try to fill this result array from the last. Why we are doing it from the last? Because this is the extreme point where we are sure that what value will come. So for example, this array is sorted. So here will be the smallest number and can be negative, and here will be the largest number. So if we do square of these both numbers and we try to compare them, we will get one value for sure which will be greater than overall all the numbers squares, and we can simply put it here. So let's say for example, if we take minus 4 and 10, so minus 4 into minus 4 will give 16, 10 into 10 will give 100. So if we compare 16 with 100, we are very much sure that 100 is greater than 16, and any number in the array won't get bigger than 100 because we are actually comparing the extremities of this array. So here let's say if it would have been minus 11, if we would have done the square, we would have got 121, and 10 square is 100. So we are very much sure that if we are comparing the extremities, we will get a square which will be the largest among all the numbers, and we can safely put it in the last index. So this idea will be more clear when we will actually see the demonstration of this algorithm. So I'll just remove this. So here k's value is 4 and it is greater than or equal to 0. So this condition is true. So here you can see why we created these two pointers and we pointed at the extremities, because as the array is sorted in ascending order, the element square won't be necessarily sorted in ascending order. So here what we do is, we take the absolute value of the value at ith index and the absolute value at the jth index. So what this absolute method returns is, let's say if the value is minus 4, it will give us 4. Let's say if the value is minus 1, it will give us 1. Let's say if the value is 10, it will give us 10. So it gives the absolute value without the sign of it. So here we are actually comparing the numbers without their sign. And why we are doing it? Because this negative sign, when we do square, this becomes minus into minus becomes positive, and we actually do the square of the number which will give us 16. So it's plus 16. So this minus doesn't play any role in the square part. But as these numbers are sorted and we can encounter negative values as well, so therefore we are comparing the absolute values of the start and the end. So here if you see, the math.absolute value of I will be 4 and j will be 10 is not greater than 10. So this condition comes out to be false. So the else part will be executed. So this actually signifies that we can safely take 10, do its square and place it into the end of the result array, because we are very much sure that this value can be safely placed here because we have compared it with the extreme left value. So here we do 10 into 10, which is 100, and we simply put it into the result array at kth index. Now after placing it, we know that we have used this value, so we'll simply decrement j. So j becomes 3. Now we'll simply decrement k because we have used this place, and k is still greater than or equal to 0. So friends, here you can see the importance of doing math.absolute. We are actually discarding this negative signs, and as the array is sorted, we are comparing the extremities of I and jth index, and whichever will be the greater number, that square will come directly here. So here math.absolute of array of I will be 4 and math.absolute of array of j will be 3 only. So 4 is greater than 3. So this condition comes out to be true. So we simply assign the square of this value -4 into the result array at kth index. So -4 into -4 will give us 16. So we'll simply assign 16 here. And as we have used this -4, we'll increment I. So I will point to index 1. We'll decrement k because we have used this spot. K is greater than or equal to 0. Now we'll do math.absolute of -1, which will give us 1, and math.absolute of 3, which will give us 3. So this condition comes out to be false because 1 is not greater than 3. So we can safely put 3's square here, which will be 9. We have used this spot, so we'll decrement j now. So j becomes 2. We'll decrement k because we have filled this spot. K becomes 1 and 1 is greater than or equal to 0. Now we do math.absolute of -1, which will give us 1, and math.absolute of 0, which will give us 0. So 1 is greater than 0. So this condition comes out to be true. And what we do is we simply assign -1 into -1, which is 1, into this spot. We have used this spot, so we'll increment I. I becomes 2. We'll decrement k because we have used this spot. So k is equal to 0. So this condition still comes out to be true. And here we are left with only one element. So 0 is not greater than 0 because math.absolute value of 0 is 0. So this if block condition comes out to be false. And we simply assign 0 into 0, which is 0, to this spot. So it becomes 0. Now we have used this spot, so we'll decrease j. So j becomes 1, which will point here. We'll decrement k because we have used this spot. So k becomes -1. It means it has gone outside of the boundaries of the array. Therefore this condition will come out to be false. And here you can see at the end we will simply return the result. So this is the result where we have squared each number, and after squaring each number you can see the result array is still sorted. And we have used this algorithm without using arrays.sort. So the time complexity of this algorithm is O of n. So we'll simply return the result. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video we saw a problem, squares of a sorted array. We saw the animation of the algorithm step by step. So in this video we'll actually code the algorithm and we'll test its working in the main method. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here in our arrayUtil class, I will be creating one method as public. static will give a name to this method as sorted squares. So this method will take in an array, and what this method will do is it will do the square of each and every element of the array, and whatever the array it will return, that array will also be sorted. And this array is already sorted. So in our animation video, we saw that we can solve this problem using two pointer technique. So here first we will create an integer variable n. This will store the length of the array. Then we will create one pointer I, which will start from the 0 index, and one pointer j, which will start from the last index. So the last index will point to array.length -1. Now as we want to return a sorted array, so we'll create a result array. The size will be the same as our input array. Now here what we will do is we'll provide a for loop, and inside that for loop we will try to fill this result array from the end. So here we will start from k equals to n-1, because n-1 is the last index, and it will go to when k is greater than or equal to 0, k minus minus. So from kn-1 it will go to 0, and with each iteration it will get decrement by one position. So friends, here you can see that this array is actually sorted array. So if I take this example, so here you can see that this array can contain negative values. So if the array contained only positive values, this problem would have been very easy. We would have just done the square of each and every number and simply place it into the result array at their respective indexes. But as this array contains the negative elements also, so here for example, let's say it was given something like this. So we can't directly do the square of each and every number and put it into the respective position, because this will result something like this. -4 into -4 will give 16. -1 into -1 will give 1. 0 into 0 will give 0. And 3 into 3 will give 9. So here you can see we can't directly just square the numbers and put it into the respective position, because this array is not sorted and we want to return the sorted array. So one thing is we just square and at the end we just do the sorting explicitly and return. But that would be a very bad algorithm time complexity wise, because we are actually using the sorting technique. So in this algorithm, using this for loop, we will try to sort this array properly so that it would look something like this, that 0 should come here, then 1, then 9, and then 16. So usually in order to do that, what we can do is we try to compare the absolute extreme values. So whichever value is greater, we do their square and we simply put it into the last index. And similarly we go on doing like this. So for example, if we do the absolute value of -4, we'll get 4. And we see that 4 is greater than 3. So it means if we do 4 into 4 or -4 into -4, we'll get 16, and we can safely place 16 at the end. And after filling this position, we just come to this position, and after using this -4, we just shift here. So in the next iteration, we simply compare the absolute value of -1, which will give us 1, and we'll compare 1 with 3, and we see that 3 is greater than 1. So we simply do 3 square and we put 9 at this position, and similarly we keep on doing like this. So here the main idea is to take the absolute values of the extreme values, try to compare them, and whichever is the greater, do their square and put it into the result array at the index which is starting from the last index, which is n minus 1. So here we provide a condition as if math.absolute of array of I. So we have created these two pointers. One would be at the start and other would be at the end. If it is greater than math.absolute array of j, so what we can do is, if the absolute value at ith index is greater than absolute value of jth index, then in our result at kth index we will assign array of I into array of I. So we are doing the square of this number and we are assigning it to the result array. After doing that, we know that we have used, for example, we have used this position of the I. So we simply increment I, because we need to now take another value because we are done with this value. Let's say for example, and else, then we can simply assign array of j into array of j. And as we are assigning array of j and it is basically starting from the last index, so it signifies that we have used this value, for example, and now we need to go one step before to it. So what we do is we do j minus minus, and after the first iteration of for loop in our result array, let's suppose if we take this example, 16 got occupied at this place. So we are doing k minus minus because now we need to fill this position. We have filled this position, now we need to fill this, and with each iteration we will fill one position, and at the end we'll simply return the result. So friend, this is the algorithm. Now we will test its working in the main method. So here I will be using this array which we discussed in our slide as well. Here we will get the result array. We will call sorted squares. We pass in the array, and at the end we'll simply print the array. And if I run the main method, so here you can see that we got the answer at 0, 1, 9, 16, 100. So this 0 came from this 0, this 1 came from minus 1, 9 came from 3, 16 came from minus 4, and 100 came from 10. And how it came? We simply squared them, and using this for loop we actually placed them at their respective position so that the final array is also sorted. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.
Hello everyone. So in this video we are going to discuss a problem: rearrange sorted array in max-min form. So let's see what this problem is and how to solve this. So in this problem we are given a sorted array of integers in ascending order. Now we need to rearrange the array in such a way that the first position will have the largest number, which is the rightmost number. The second will have the smallest. Second will have the smallest, which is the first number. The third will have the second largest. So the third number will be second largest, and it will go on. So fourth number will be second smallest, and here it will be third largest, third smallest, and then fourth largest. So friends, the only constraint is that we can't create a new array and do this rearrangement. We need to solve this problem in O of 1 extra space. So here if we create a new array of same size, which would be our result array, then this problem becomes simple, because then we can create one pointer here and one pointer here, and we can alternatively put the elements in the array and return. So the space complexity of the problem will become O of n, because we are creating a new array and then we are putting the elements in max-min form. So if we are using O of 1 extra space, it means we need to modify the same array and return it back. So let's see how we can solve this problem in O of 1 extra space. Let's suppose we are given with this array which is sorted 2, 3, 5, 6, 8, 9, and our output array will become like this: 9, 2, 8, 3, 6, 5. So 9 is the largest, 2 is the smallest, 8 is the second largest, 3 is the second smallest, and so on. So as the array is sorted, we know that we can get the largest element if we start from this index, which is the max index. So this pointer max index will help us in giving the largest, then second largest, then third largest, and so on. And the smallest elements will be given by min index. So here both these pointers will help us in giving largest and smallest numbers, second largest and second smallest number. So min index will travel in this direction and max index will travel in this direction. And here we will have a iterator I, which will travel one element in this direction, because we have to solve this problem in O of 1 extra space. We can't create a new array and simply put the elements in alternate fashion. So somehow we need to modify the original array only. So we create this pointer which will travel in this direction and try to fill the elements in this form. Also friends, here you can see in the output array 9 being the largest. So if I write here largest, if you see the indexes of the largest elements, 9 is at 0, then comes the second largest 8, which is at 2, third largest at 4. So for this simple array, if I write the indexes, it would be 0, 2, 4. And for the smallest, it is 1, 3 and 5. So the indexes would be 1, 3 and 5. So here if you see, we need to arrange this array in max-min form. And to place the elements in respective indexes, we have this idea that the largest numbers will be placed at even indexes and the smallest number will be placed at odd indexes. So this is one thing we need to keep in mind. So this iterator, when it will travel in this direction, at whichever index it is, we will first deduce that whether it is an even index or odd. If it is an even index, then we will take the help of max index, take that value and somehow place it at the index denoted by I. And if the I is at odd index, then we will take the help of min index, take that value and somehow place it where I belongs. So I will write here max index, min index. So we need to keep this information in mind, that the largest will be at even index and will be placed with the help of max index, which will be starting from the last index. The smallest will be at odd index. The numbers will be provided by min index starting from the 0th index. Min index, after placing 1 smallest element, will travel in this direction, and max index, after placing the largest element, will travel in this direction. So if you closely observe between these two arrays, you will see we need to arrange the array in max-min form. So at the start, when I will be at 0th index, here we know that we need to put 9 at the first spot. So as we can't create a new array, we need to put 9 somehow here. But here you can see we have already 2, because 2 will lie in this index after the output. But 2 will see there is a 3, and if you see 3 will lie in this index here, and when we will place 3 here, it will see that it has 6, because 6 will lie in this index here, and it has 8, so 8 will lie in this index. And similarly, if you see, we can't directly replace the elements because it has already one element which we need to place it at its correct index so that it looks in max-min form. So friends, the trick to solve this problem is, instead of storing 9 directly here, what we can do is, we take 9, we take 2, we apply some formula and generate, let's say, an integer. Let's say we combine 9 and 2 in such a way based on such formula and we get a number x. So we will store x here instead of 9. So why we are storing these numbers is, so as we are storing a combination of number based on a formula. Now let's say if I take an example, here we have 8. Now this 8 we need to somehow place it index 2 here like this. So let's say to this number I denote it as A and this number let's say I denote it as B. So we'll take B and A and apply some formula and generate a number x. So this x we will store here. Instead of 8 directly, we will store a number x which will be a combination of B and A, 5 and 8. Now why we are storing both the numbers is, in the output array 8 should come here but 5 will be lost. So we need to prevent both the numbers, because if I put 8 directly here then 5 will be lost and we can't figure that what we need to place at this index, because 5 should come here in the output array. So this x we store in such a way, we will see the formula later. This x we store in such a way that it will help us in giving A back and B back. So that after storing x here, in the resultant array at this index will somehow deduce A, and when we will reach here, we take that x and we can somehow deduce B, so that we can place 5 directly here. So this is very important that we are using some formula here and storing a number x, and this x will help us in generating A and B back. So here what we do is, as the array is sorted, the last index will be the maximum value. We will take a variable which is greater than our largest number. So here what we can do is we can simply do 9 plus 1. Let's say 10. We are going to last index, we are taking that value and adding 1. We will see why we are doing that. So friends, the formula we use to store two numbers is, let's say if the I is at even index, we need to store the largest number, and that largest number will be given by max index here, and the max we have is 10. So let's say if we are at index 0 and we need to place 9 here like this. So if I use this formula, so at this index what we will store? We will store the whatever the value here we have, which is the 2, which is important for us because this is our, let's say, B. So we take 2, we take the number which we are shifting, which is 9, we do modulus by 10, which is 9 divided by 10 will give us a remainder, and we do multiply by 10. Now here you can see it will give us 2, the remainder is 9 into 10, the number is 92. So at array of 5 we are storing the number 92. It was 2 and we are storing 92. So here if I write number 92. So here you can see this number is our x, and how we can deduce A and B back is 92, the max which we took. Let's say if I divide 92 by 10, so we will get 9, which is our A. And if I do 92 mod 10, we'll get the remainder, which is 2. So here you can see this largest number which we are taking, it is generating a number which is storing our both the integers, the number which we are shifting here and the number which is already here. So we can deduce 9 and 2 back. So now let's see how this algorithm will move ahead. So this mod you will understand when we reach here. So now I will come here and we assume that max index somehow has placed this value here. So the max index will now come at index 4 to take the second largest value. Like this. So now I is at odd index. So now we will use the formula for odd index. We will take the help of min index. The formula is pretty much same. Only the value in array for max index and min index is changing here. So now here you can see that this step will be more clear to you why we are doing this modulus. So at index 1 we need to put the smallest number we are taking this formula. So we take the value here, which is 3, because we don't want to lose this value. And here you can see we'll take the value at min index. So currently if I take the value at min index, it is not 2. 2 is gone. We have 92. So I will simply write 92 mod 10 into 10. Now you will understand that why we are doing first mod is because there could be a chance that we get an overridden value. So here we have 92, and we know that from x we can deduce our overridden value, which was 2, and the number which is transferred here. So 92 divided by 10 will give 9. 92 mod 10 will give remainder, which is 2. So here therefore we are first taking this remainder so that first we get the original value. And even if this value is not overridden, let's say it was 2 only. So 2 mod 10, this will again give us 2 only. So here this formula is important, that we are doing mod with the max value first to deduce our original number, and then we are simply multiplying it by 10 so that something like this can happen. So 3 plus 2 into 10, the remainder is 2, so it will give 23. So here this number 23 is suggesting that we will store 23 here, and now this value is overridden. 23 comes here, and what it is telling is it is storing two numbers, the number which is getting shifted here and the number which was already here. So we'll go over this quickly now because we have a fair amount of idea what we are doing. So for 2 it is an even, so we use this formula. So we take the value 5 plus, we are using this formula, value at max index is 8, so we are doing 8 mod 10 into 10. So here you can see that this value is not overridden, so therefore even if we do mod 10 we get the same value back. So 5 plus 8 into 10, which is 85. So we are storing 85 here for this index I, and then I will come here and this max index will come here, and as we have used this 2 also here, so we will move the min index to here. So now as I is at 3, which is odd index, we need to take the smallest value. We move min index in this direction because we assume that we have placed 2 here somehow, the step which we did previous to 85 while we placed 23 here. So min index used this value and it shifted here. Now at this spot what we do is we are taking this formula because value of I is 3. So here we take 6, 23 like this, the remainder will be 3, it will give 36. So here now this value will become 36. This has been overridden and this has also been overridden. So these are the now original values at these spots. Now after taking the help of min index will come here. We will move I ahead, and now value of I is 4. We will take the largest number and we'll use this formula. So 8 plus the value at max index is 36 mod 10 into 10. So this will give us 8 plus 6 into 10. It will be 68. So we are storing 68 here. So this 8 will be overridden with 68. So this value will be overridden and max index will come here. Because it has used this value, I will go here, and at the last index, being an odd index, we will take that value 9, because we are using this formula. We are taking the value 9, then plus value at min index, which is 85, because min index is pointing to index 2. So 85 mod 10 into 10. 9 plus 5 into 10. So this will give us 59. So we are storing 59. So I'll just remove this now, everything. So now instead of these numbers, we have a combination of numbers. So let's say if I denote this number as x and we need to get back b and a. So we know that will give us a, will give us b. We know this formula already. So now we will iterate this array one more time. And now what we do is, we need to store 9 here, which is our a. So what we do is, 92 divided by 10 will give 9. So 9 comes here. Here 23 divided by 10, 2 comes here. And similarly 85 divided by 10 will give 8. 36 divided by 10 will give 3. 68 divided by 10 will give 6. 59 divided by 10 will give 5. So this is how this combination numbers will give us output array, which is our answer. So friends, these are the formulas we need to keep in mind. And now let's move ahead and see the demonstration of this algorithm step by step. So we have method arrange max min, which takes in an array. And here you can see that we are not creating any additional array. So this problem is solved in O of 1 space complexity. So friends, before we start, if you want to master algorithms and data structures, then you can subscribe to my channel and click the bell icon so that you never miss any update. So we call arrange max min, we pass in the array. So this is our original array, which is here, and this is our resultant array, which is our output array. So here, as we will modify this array, this number will be getting overridden. So to understand what the previous number was, you can refer this array because this is our original array. Moving ahead, we create a max index starting from the last index, array.length -1. Array.length is 6, -1 will give 5. So max index will start from here, because this max index will give us the largest, then second largest, then third largest, and so on. We'll create a min index starting from 0. This min index will give us smallest, then second smallest, and third smallest, and so on. So as the array is sorted, we have created 2 pointers starting from very extreme ends. And then we will evaluate a max value, which we already discussed, that we simply take the value at the last index, which is the maximum. Because this array is sorted, we do +1. So max will become 10. And now we will apply the for loop where we are traversing I in this direction, starting from 0 and going till 5th index via this condition. So currently I will start from 0th index. 0 is less than array.length, which is 6. So friends, in our previous slide we discussed that first we evaluate whether this I is at even index or at odd index. So if I divided by 2, if it gives remainder as 0, it means it is an even index. And if I mod 2 doesn't give us a remainder 0, it means it's an odd index. So currently value of I is 0. So I mod 2 will give remainder as 0, which means that we are at even index. And as we are at even index, we know that we need to place the largest numbers, which will be given by max index. At odd index, we will put the smallest numbers, that will be given by min index. So here we are using the same formula. So as I is at 0th index, we are taking the help of max index to take the maximum value and place it here. So we will store a modified number here, which is the combination of this and this number. So we will take 2 plus value at max index, which is 9, mod 10, which is our max, into 10. So this will give us 92. So we store 92 here. And then we decrement max index, assuming that max index has placed 9 at its proper spot. So the max index will come at index 4, like this. We will increment I. I comes at index 1. Now I mod 2 will give remainder as 1. So therefore we know that 1 is an odd integer. So the else part will be executed. So now here we will take the help of min index to get us the smallest numbers. The formula is pretty much the same which we already discussed in our previous slide. Here we will take this number, which is 3. We will take the number at min index, which is 92. We will do mod 10 multiply by 10. We are doing mod 10 is because we need to get back the original number, which was 2. So 92 mod 10 will give us 2, because we need to put 2 here somehow. So in the output array, here you can see 2 will come here. So at this index we need to place 2. So therefore from 92 first we are deducing 2 via this modulus. So 3 plus 2 into 10, this will give us 23. So 23 will come here. So now we assume that min index has taken 2 and somehow placed it at its correct spot. So this value and this value we assume that we have used up. So we increase min index value so that we can get a second smallest value now. Min index becomes 1. We will increment I. I comes at index 2. I mod 2, which is 2 mod 2, which will give us 0. So it means 2 is even index. So we apply the formula. We take this value phi plus. Now we take the value of max index because we need to put 8 somehow here. So 8 mod 10 phi plus 80. It will give us 85. So 85 comes here. Now we will decrement max index because this value is used up. Max index becomes 3. So it means we have used up this value now. We will increment I. I comes at third index, which is odd index. So this condition will fail because 3 mod 2 will give us remainder as 1, which is not equal to 0. And here we will take the help of min index and take the second smallest value now. So we will take this value, which is 6. We take 23. We'll do mod 10 because at index 3, you see the number we are shifting is now 3 should come here in the resultant array. So first we need to deduce this 3 back. So 23 mod 10 will give remainder as 3, which was our original number here. And then we do multiply by 10. So this will give us 6 plus 30, 36. So 36 comes here. And now we assume that we have placed 3 here properly somehow. So this number will be used up and min index will come to this spot. So we'll increment min index like this. We'll increment I. I comes to this spot. Now value of I is 4, which is an even index. So this condition comes out to be true. We take the value 8. And here we will take the help of max index because we need to put the max value here. So first we will deduce what number we need to shift. So we'll take 36 mod 10 into 10. This will give us 6 into 10, 60. 8 plus 60 will give 68. So 68 comes here. And then we have used this 6 also. So we will decrement max index now. It will come at index 2 now. We will increment I. I becomes 5. 5 is still less than 6. 5 mod 2 will give a remainder as 1. So therefore the else part will be executed. And here we will take help of min index. So at min index the original value was 5 and we know that 5 needs to come here. So first we need to reduce 5 out of 85. So we'll use this formula. We take 9 here plus. So this formula will help us in getting 5 back. So we'll take 85 mod 10 into 10. This will give 9 plus 5 into 10, which is 59. So 59 comes here. And then we will increment min index. Because we have used this value also. So now when we will increment I will become 6 and 6 is not less than 6. So therefore this for loop will terminate now, which makes sense because we have used up all the values. So now this is our modified array. At the start we have taken this array which was our original array. We transformed it into this array. And now our task is to transform this array into this array. So for that we are using this for loop. And we have already discussed how we can do that is. Let's say we take 92. We know that we have stored both the numbers. The number which was getting shifted here and the number which was already here. We can reduce both the numbers. So let's say if I denote 92 as x. So here x will give us a via x by max, which is our 10 here, and x will give b via x mod max. So if I take 92, if I do 92 by 10, we'll get 9, which is our a. If I do 92 mod 10, it will give us 2, which is our b. And our task is to store the largest element here. We know that we can get it via division. So we iterate this array back from I equal to 0. It will go till the last index. So we'll go over this formula quickly because it is very simple. So I is 0. Now at the same spot we are taking 92, dividing it by max, which is 10, and storing it back at the same index only. So here it will come 92 divided by 10 will give 9, like this. Moving ahead, I becomes 1. 23 divided by 10 will give 2. We increment I again. I becomes 2. 85 divided by 10 will give 8. We increment I. I becomes 3. 36 divided by 10 will give 3. We'll increment I. 68 divided by 10 will give 6. We'll increment I. 5 is still less than 6 because array dot length is 6. So this for loop will execute one more time for the last index. 59 divided by 10 will give 5. And now when we'll increment I, it will go beyond the boundaries of array. So this for loop will terminate. And here you can see after this for loop will terminate, our algorithm will also end. And here you can see that now we have got our output array, which is in max min form. And one thing to note is we have modified the same array which we received. So therefore we have used O of 1 extra space. So friends, in order to understand this problem more, you need to go over this video 2-3 times to understand these formulas, which is helping us to store two numbers instead of one. And then here we are deducing one of the number out of it. So this x is giving b here and a here. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.
Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss about the introduction to graphs. So friends, what is a graph? So friends, below you can see a figure. It represents a graph. Here it contains few nodes, say 1, 2, 3, 4, 5, and these 5 nodes are connected through some lines. So a graph is a non-linear data structure used for storing the data. So we can store the data inside a graph, but it's not a linear data structure like arrays and linked list. So friends, it is a set of vertices. So here you can see 1, 2, 3, 4, 5 are nothing but vertex of the graphs. And it also has a collection of edges that connects a pair of vertices. So here you can see two vertex are connected by an edge. So in a graph, if we take any two vertex and if you want to connect them, we just provide an edge. So here you can see between these 5 vertex, there are 6 edges, 1, 2, 3, 4, 5 and 6. So in simple terms, we can represent a graph as set of vertices and a collection of edges that connects a pair of vertices. So friends, why graphs are important? So here you can see a graph which is nothing but social networking site. So in computer applications, graphs help us to implement social networking sites such as Facebook and Twitter, and we can term it as social networking graph. So friends, here in this social networking graph, the names of people which you can see here as Ankit, John, Bill, Kathy and Max, we can see them as the vertices of this social networking graph. So if we consider an example of Facebook, then friendship between two people can be represented as an edge of the graph. So here you can see Bill is friend to Kathy and Kathy is friend to Bill. So therefore there is a link between them which is nothing but friendship link. So we can represent this graph where people are the vertices and the friendship link between them is nothing but the edge. Another application of the graphs would be the web content over the internet. So friends, let's suppose we are having few web pages as google.com, udemy.com, youtube.com, twitter.com and facebook.com. And let's suppose from google.com there is an edge to udemy.com. So this edge is nothing but a link. And similarly, let's say from Udemy there is one link which can take us to facebook.com, and from Facebook to Twitter, and from YouTube to Twitter and vice versa. So here we can take these web pages as the vertices of this graph and the links as the edge between these vertices. So friends, in computer application, this web content can be represented as a graph where web pages are nothing but the vertices and the edge which connects between them is nothing but the link. So friends, this was the introduction to graph. In our upcoming tutorial, we will discuss the graphs into further detail. I hope you like this video. Thanks, have a nice day. Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss how we can represent an undirected graph. So one of the way in which we can represent a graph is adjacency matrix. So friends, first of all, what is an undirected graph? So here in the figure you can see 5 nodes, 0, 1, 2, 3, 4. So these nodes are nothing but the vertices of the graph, and you can see here an undirected edge. So here between the vertex 3 and vertex 4 there is an undirected edge. So what is an undirected edge? The undirected edge doesn't have any direction. So if suppose we are on vertex 3, then we can go to vertex 4, and if suppose we are on vertex 4, then we can go to vertex 3, and as such there is no direction between the two vertices. So a graph which has this two-way edges are termed as undirected graph. So if we take an example, then social networking graph which we discussed in our previous tutorial is nothing but an undirected graph. So let's suppose in a social networking graph there is a set of vertices which is nothing but the names of people. So let's suppose John is a friend to Max. So here John and Max are nothing but the vertices of the graph, and the friendship between them is nothing but the edge of the graph. So here if John is friend to Max, then it implies that Max is also friend to John. So it is nothing but an undirected graph. So here John is friend to Max is same as Max is friend to John. So this social networking graph can be seen as an undirected graph where edges are undirected, they don't have any direction. Moving ahead. So friends, graph can be represented by a two-dimensional array which is nothing but a matrix. So let's suppose we are given this undirected graph where 0 is connected to 1, 1 is connected to 2, 2 is connected to 3 and 3 is connected to 0. So in order to represent this graph in a data structure, we usually use the matrix which is nothing but a two-dimensional array. So friends, here if you see, there are 4 vertices. So therefore we create a 4 cross 4 matrix. So this 4 cross 4 matrix goes from indices 0 to 3, and this matrix is nothing but a 0 1 matrix. So why we call it a 0 1 matrix? Because in order to represent an edge between two vertices, we just provide a 1 which signifies that there is an edge between the two vertices. So friends, here you can see from 0 to 1 there is an edge. So when we want to represent an edge in matrix, we follow this rule that the first vertex is the row and the second vertex to which this edge is going is the column. So if I take an example, then between 0 and 1 there is an edge. So in the graph we can represent it as from 0th row to 1th column there is an edge which is nothing but 1. Similarly, if we are at node 1 and if we want to go to node 0, then there is an edge. So from the first row to 0th column there is an edge. And as it is an undirected graph, therefore we can go both ways, from 0 to 1 and 1 to 0. So let's suppose if you want to go from 3 to 2, so from the third row, second column, there is an edge which can be represented as 1. And similarly, it is an undirected graph, therefore from 2 we can go to 3. So from the second row to third column, there is an edge. Also here you can see that from node 3 to node 1 there is no edge. Therefore, from the third row to first column there is no edge. Therefore, we have represented it as 0 because it signifies there is no edge between 3 and 1. So in the matrix, wherever you want to represent an edge, we usually put 1, and wherever we want to represent a no edge, then we put 0. So friends, here we use the matrix to represent an undirected graph. I hope you like this video. Thanks, have a nice day. Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss the adjacency matrix implementation of an undirected graph. So friends, in our previous tutorial we discussed what is an adjacency matrix and how we can represent an undirected graph into it. So friends, in this tutorial we will see how we can implement an adjacency matrix to represent an undirected graph through a demonstration. So friends, let's suppose we are given an undirected graph with 4 vertices as 0, 1, 2, 3, where 0 and 1 are connected through an edge, 1 and 2 are connected through an edge, 3 and 2 are connected through an edge, and 0 and 3 are connected through an edge. So friends, using this code here, we can actually represent this undirected graph into a form of matrix. So let's see this demonstration step by step. So in our previous tutorial we discussed that using a matrix we can represent a graph. So here in our Java class graph we are having this adjacency matrix, and in the constructor we are initializing this adjacency matrix with the number of nodes in the graph. There is a method add edge which takes 2 parameters, let's say u and v. So here suppose if you want to add an edge between 0 and 1, so 0 would be u and 1 would be v. So through this code we can add an edge between u and v. So we'll see its demonstration step by step. So let's suppose in our main method first we initialize the graph with the number of nodes. So here you can see there are 4 nodes. So we are passing the number as 4 here. So now the execution step goes into the constructor of graph where nodes is having value of 4. So in the constructor we simply initialize an object of matrix by providing the value of row and column as the value in the nodes, which is nothing but 4. So after execution of this step, it will create a two-dimensional array, which is nothing but a 4x4 matrix. So it would look something like this. So here it will be represented as an adjacency matrix, which is a 4x4 matrix. Moving ahead. So friends, here you can see that from 0 to 1 there is an edge. So by calling add edge method, we pass 0 and 1 because we want to create an edge between 0 and 1. Here we simply apply this rule that between a row and a column we just provide a 1 which represents an edge. So if you want to represent an edge between 0 and 1, so 0 will represent a row and 1 will be representing as a column. So between 0 and 1 there would be an edge which will be represented by 1. So let's see how. So as the value of u is 0 and v is 1, so here in order to represent an edge between 0 and 1, in the matrix 0, 1 we provide a value as 1. So in the matrix 0 and 1 we just provide a value of 1. So it would look something like this. So this represents an edge between 0 and 1, which is 0 row and 1 column. Moving ahead. So friends, in the second step what we do is, as this graph is undirected graph, there is no direction between the edge. Therefore we can see it something like as there is an edge between 0 and 1, and we can also see it as there is an edge between 1 to 0. So friends, this information we need to store into the matrix. So in the first step, 0 to 1 we provided a value as 1. So similarly in the second step, from row 1 to 0th column we'll provide a value as 1. So it would look something like this. So in an undirected graph, basically an edge represents a 2 points into the adjacency matrix, because if we are at vertex 0, then we can go to vertex 1 because there is an edge, and if we are at vertex 1, then we can go to vertex 0 through this edge. So therefore in the matrix this edge represents these 2 points, that from 0 to 1 there is an edge, and from 1 to 0 there is an edge. Moving ahead. Now we want to add an edge between 1 and 2. So we simply pass the parameters as 1 and 2. So into the adjacency matrix, to row 1 and column 2 we need to provide a value 1 to represent an edge. So it would look something like this. Moving ahead. Now similarly we have to provide an edge from row 2 to column 1. So we provide a value as 1. So this represents an edge between row 2 and column 1. Moving ahead. Similarly vertex 2 and vertex 3 are connected through an edge. Therefore in the matrix, from the row 2 and column 3 we'll provide a value as 1. Moving ahead. And similarly from the row 3 to column 2 we'll provide a value as 1. Because if you want to traverse from third node to node 2, we know that there is an edge, and that can be figured out through this matrix, that we can directly figure it out that from row 3 and column 2 is there any edge or not. So if the value is 1, we can come to know that there is an edge. Moving ahead. And the last edge is between vertex 3 and vertex 0. So it would be represented as row 3 and column 0, which is this value, will provide a value as 1. Moving ahead. And finally from the row 0 to third column will provide a value as 1. So friends, this is how we can represent an undirected graph into a matrix. And also one point to note, that as it is an undirected graph, therefore for each edge there will be two values of 1 into the graph, which will be actually demonstrating a two-way graph. Here from 0 to 1 there is a way, and similarly from 1 to 0 there is a way. So into the matrix we represented it something like from 0 to column 1 there is an edge, and from 1 row and 0 column there is an edge. So friends, this is how we can represent a graph in the form of a two-dimensional array, which is nothing but a matrix. In my next tutorial we will actually code this algorithm into the Eclipse. I hope you like this video. Thanks, have a nice day. So friends, here I have created one class by name graph, which is having a main method. So into this class we'll code the implementation of graph through adjacency matrix. So first we'll create an integer variable and we'll give it a name as v. So this v is nothing but a number of vertices in the graph. We'll also create one more integer variable. We'll name it as e. So this e would be number of edges in graph. We'll also create a two-dimensional array, which would be our adjacency matrix, and it would represent a graph. So it would be a two-dimensional array, and in the constructor we will initialize these three values. So this graph constructor takes in number of nodes. So here if simply we can assign nodes value to v, and as we are in the constructor of graph, therefore value of e would be equal to 0, because till now there are no edges into the picture. And finally we'll initialize the matrix with the number of nodes. So if suppose the graph has 4 nodes, therefore this should be a 4 cross 4 matrix. We'll also create an add edge method, which will actually add an edge from u to v and vice versa. Therefore here simply we can do is to uth row and vth column we'll assign a value of 1, which represents an edge, and vice versa we'll do from v to u, because it is an undirected graph. So therefore for every edge in the matrix there will be 2 points which will be representing an edge. After adding the edge, we'll increment the count of edge by 1, so it would be e++. So friends, in our main method we'll create a graph and add an edge between few nodes. So we'll create an instance of graph and we'll provide a value of 4. So this will actually create a graph of 4 nodes, and also it will create an adjacency matrix which is of 4 cross 4. So we'll actually create a graph which we saw in our previous tutorial. We'll add an edge from 0 to 1, then from 1 to 2, then from 2 to 3, and finally from 3 to 0. So friends, here we have added 4 edges. which we actually saw in the slide of our previous tutorial. Here I will create one method which will give us the string representation of this graph, and I will name it as toString. So first we'll create a string builder. We'll append v, which would be vertices, e would be our edges, and then we'll simply provide a for loop. Now this for loop will iterate over each and every vertex, and inside this for loop we'll append and now we'll provide one more loop which will iterate over the adjacency matrix for a particular vertex. So here we'll append so here we are simply printing the matrix. So SB and finally we'll return sb.toString. So here we'll simply print G, and if I run this code now, so friends, here you can see that there are 4 vertices as we have passed a value into the graph as 4, and there are 4 edges because we have created 4 edges from 0 to 1, 1 to 2, 2 to 3 and 3 to 0. And below is the string representation of this graph, which is nothing but our adjacency matrix. So this matrix we discussed in our previous slide. You can refer that slide and you can come to know that it represents the same matrix which we discussed. So friends, in this tutorial we saw the implementation of the graph using an adjacency matrix. I hope you like this video. Thanks, have a nice day. Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss the representation of an undirected graph through adjacency list. Friends, in our previous tutorial we discussed about the representation of undirected graph through adjacency matrix. So in this tutorial we will discuss one more way to represent an undirected graph, that is through adjacency list. So this adjacency list is nothing but an array of linked list. So friends, let's suppose we are given an undirected graph having 4 nodes 0, 1, 2, 3, and from 0 vertex there is an edge to vertex 1, from vertex 1 there is an edge to vertex 2, and from vertex 2 there is an edge to vertex 3, and finally from vertex 3 there is an edge to vertex 0. So friends, this undirected graph can be represented as an adjacency list, which is nothing but array of list. So here you can see there are 4 nodes. So we create an array of linked list having the size as 4. So here you can see each and every index hold a linked list, and what this linked list contains. Friends, let's suppose we are on vertex 0 and there is one edge to vertex 1 and one edge to vertex 3. So friends, these two edges from the vertex 0 is represented as, in the array index 0, the linked list which it holds has node 1 and node 3. So this structure tells us that from node 0 there is an edge to 1 and there is an edge to node 3. Similarly, if you can see, from vertex 2 there is an edge to vertex 1 and vertex 3. So in order to represent this structure at index 2, we have node 3 and node 1. So it signifies that from 2 there is an edge to 3 and from 2 there is an edge to 1. Similarly, here you can see that from 3 we have one edge to 2, which is this edge, and from 3 we have one edge to 0, which is this edge. So friends, this is one more way to represent an undirected graph, that is by using an array of linked list. So the length of this array is same as the number of vertices in the graph. So friends, in our upcoming tutorial we will discuss more about adjacency list. We'll see its code and working through animation. I hope you like this video. Thanks, have a nice day. Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss about the implementation of the undirected graph using adjacency list. So friends, in our previous tutorial we discussed about the representation of an undirected graph through an array of linked list. We also discussed that how this undirected graph can be represented into an array of linked list. So friends, in this tutorial we will look into the code and see its demonstration step by step. So here is the code to implement a graph using an array of linked list. So we will see the working of this code step by step through animation, and we will see that how we can represent this undirected graph into an array of linked list. So let's start. So in the step 1 we initialize a graph and we pass in the number of vertices the graph can have. So here if you see, this undirected graph has 4 nodes, therefore we are passing the value as 4. So into the constructor the value of nodes is 4. So in the first step what we do is, we have taken this instance variable which is nothing but an array of linked list. So we initialize this array of linked list with the number of nodes. So it would look something like this, that here you can see an array of linked list. So as currently the linked list is not being initialized, so they point to null. Moving ahead, so then we provide a for loop and we iterate over each and every vertex, and to this array of linked list it will initialize the linked list to each and every index. So as I starts from 0, therefore at 0th index it will initialize a linked list. So it would look something like this. Currently linked list is empty and head is pointing to null. Moving ahead, then I becomes 1, and similarly at the index 1 it will initialize a linked list. Moving ahead, I becomes 2, so at index 2 it will again initialize a linked list. And similarly at the index 3 it will initialize a linked list. So now I becomes 4, therefore the condition in for loop comes out to be false because 4 is not less than 4. So friends, here we have created an array of linked list, and to each index we have a separate linked list. So here you can see from vertex 0 to vertex 1 there is an edge. So we'll call this add edge method and we'll pass the value as 0 and 1, stating that there is an edge between 0 and 1. So friends, value of u is 0 and value of v is 1. And also in our previous tutorial we discussed how we can represent an undirected graph into an array of linked list. So what we do is, as there is an edge from 0 to 1, therefore at the 0th index linked list we add 1. So first we get this linked list at the 0th index and add 1 to it. So it would look something like this, that at the 0th index linked list we are adding 1. Moving ahead, and similarly as this is an undirected graph, therefore from vertex 1 there is an edge to vertex 0. Therefore, to the linked list at vertex 1, we'll add the value 0. So it would look something like this. So here it represents that from 0, there is an edge to 1. So the linked list at 0 index has an edge to 1. And similarly, here you can see from the vertex 1, there is an edge to vertex 0. So it is represented by the linked list at index 1 has a value 0, which signifies that there is an edge from 1 to 0. Moving ahead, then we can also see that there is an edge from 1 to 2. So we call this add edge method by passing 1 and 2. So in the first step, what we do is the linked list at index 1, we add the value 2. So it would look something like this. Moving ahead, and similarly the linked list at index 2, we will add value 1. So at index 2, we will add the value 1. So it would look something like this. Moving ahead, now there is one more edge from the vertex 2 to vertex 3. So this can be demonstrated as, to the linked list at index 2, we will add the value 3. So here, to a linked list at index 2, we will add the value 3. So it would look something like this. Moving ahead, and as it is an undirected graph, therefore to the linked list at index 3, we will add the value 0 2. So it would look something like this. Moving ahead, so in the last step, there is one more edge from the vertex 3 to vertex 0. So we'll pass the value as 3, 0. So in the first step, what we do is the linked list at index 3, we will add the value 0. So it would look something like this. Moving ahead, and similarly the linked list at index 0, we will add the value 3. So friends, this is the code to implement an undirected graph through an array of linked list. Here you can see that each and every node is being represented by an index of this array. And in order to represent an edge, we simply add those values into the linked list of that particular index. So here you can see that from 0, there is one edge to 1 and one edge to 3. So at the linked list at 0 index, we are adding 1 and 3. So this is a type of a metadata which can help us to know that okay, from 0 there is an edge to 1 and from 0 there is an edge to 3. And similarly, if I take this vertex 2, there is an edge to 1 and there is an edge to 3. So the linked list at index 2 has 1 and 3. So friend, this is how we actually represent a graph into an array of linked list. In my upcoming tutorial, we will actually code this implementation into Eclipse and see it's working. I hope you like this video. Thanks, have a nice day. So friends, in our previous tutorial, we actually discussed about the implementation of an undirected graph through adjacency list. So in this tutorial, we will code that implementation into Eclipse. So here I have created one class by name graph having a main method. So here in the graph class, we'll first create an array of linked list. We'll import the linked list from java.util. We'll also create an integer variable and we'll name it as v. So this integer variable will be having a value of number of vertices in the graph. So it represents number of vertices. And similarly, we'll create one more integer variable and we'll name it as e. So this integer variable will be having a value of number of edges in graph. We'll also create one constructor and to this constructor we'll pass the number of vertices the graph can have. So we'll give this integer a name as nodes. So here what we can do is, as v represents the number of vertices in a graph, so we'll simply assign the value of nodes to it. And as this graph is getting initialized, so the value of e will be 0, because currently there are no edges. And finally we'll create an instance of array of linked list. So this dot adj equals new linked list, and we'll pass the value of nodes to it. So after creating an instance of array of linked list, currently each and every index of this array will point to null because the linked list has not been initialized. So we'll provide a for loop, and we will iterate over each and every vertex, and we'll create a separate linked list for each and every index of the array. So adj of v So friend, in this for loop we are iterating over each and every vertex, and as we have created this array of linked list, therefore we need to initialize a linked list for each and every index. Moving ahead, we'll create a method as add edge. So this method takes in a two value. Let's say we give the name to as u and v. So by calling this add edge method, what we are doing is we are creating an edge between u and v. Friends, in our previous tutorial we saw that in order to create an edge between u and v, we have to provide the value of v into the linked list of u, and similarly we have to provide a value of u into a linked list of v. So here what we do is, into the linked list of u we add the value v, and similarly into the linked list of v we add value u, and finally we increment the value of e by 1 because it signifies that an edge is being placed between u and v. Therefore we are incrementing the e by 1. So friends, in the main method we'll first initialize the graph with the number of nodes. So friends, in our previous tutorial we saw an undirected graph which had 4 nodes. So we'll initialize this graph with 4 vertices. So we provide a value as 4, and then we'll add an edge from 0 to 1, and then from 1 to 2, then from 2 to 3, and finally from 3 to 0. So friends, here we have created one graph of 4 nodes and we have added 4 edges. So friend, in order to test its working, I will create one method as toString. So friend, this method will return back as a string representation of this graph. So in the first step I will be creating a string builder. So to this string builder, first I will append vertices and edges. And then we'll provide a for loop and we'll simply iterate over each and every vertex. So here to string builder we'll append v So friends, here in the for loop, we are getting each and every value of vertex. So friends, as we are looping over each and every vertex, we have the vertex value. We'll provide one more for loop which will bring back the linked list associated with that vertex and will iterate over it and print its content. So here we'll provide one more for loop. So in order to iterate over a linked list associated with a particular vertex, what we do is we simply pass the value of that vertex and we'll get the linked list associated with it. So here if I have taken example, then we have added an edge from 0 to 1 and there is one edge from 3 to 0. Therefore when we call the linked list associated with vertex 0, we'll get the two values. One is the value 1 and one is the value 3 because those two values are there in the linked list. So in this for loop, we'll simply append the value present in the linked list for that particular vertex. And finally we'll append one line break and we'll simply return the string representation of the string builder. So friends, in our main method, we'll now sys out the value of g and we'll run this code. So friend, here you can see the graph has 4 vertices and 4 edges. Because we have initialized the graph with 4 vertex, therefore the value of v is 4, which is the number of vertex. And as we have added 4 edges, we are getting the value of the number of edges as 4. And here in the toString representation of it, what we are doing is we are iterating over each and every vertex, that is from 0, 1, 2 and 3. And here you can see that there is an edge from 0 to 1 and 0 to 3. Therefore, from the vertex 0, there is an edge to 1 and there is an edge to 3. And similarly, from vertex 3, there is an edge to 2 and there is an edge to 0. There is an edge between 2 and 3 and 3 and 0. So into the linked list of this third index, there are values 2 and 0, which represent that there is an edge between 3 and 2 and 3 and 0. So friend, this is how we actually represent a graph through an array of linked list. I hope you liked this video. Thanks, have a nice day. Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss the breadth first search of an undirected graph. So friends, breadth first search is nothing but a traversal or a searching technique which we apply to the graphs to visit each and every node of the graph. So here breadth first search is also known as level order traversal. So let's suppose we are given a graph of say 5 nodes where 0, 1, 2, 3 are connected by an edge and 4 is connected to 2 by an edge. So therefore, what do we mean by level order? So suppose if we are starting from 0, then this is at level 1. So this will be visited first. And then here you can see that from 0, 3 and 1 are connected. So these both nodes are at level 2. So after 0, 1 and 3 will be visited because they are at level 2. And then you can see that from 3 there is an edge to 2 and from 1 there is an edge to 2. So therefore the node 2 is at level 3. So after visiting 1 and 3, 2 will be visited because it is at level 3. And then here you can see node 4 is connected to 2. Now this is at level 4. So therefore 4 will be visited after 2. So 0 is at level 1, 1 and 3 are at level 2, 2 is at level 3 and 4 is at level 4. So using breadth first search technique we can traverse the graph level by level. So friends, here is the algorithm for it. So friend, in this algorithm we usually use queue data structure. So this data structure is nothing but FIFO data structure, which means first in first out. So the element inserted into this data structure first will be first to be removed from the queue. So we are using queue because it will help us in traversing the nodes of a graph level by level. So friends, we apply the same algorithm while we are traversing the tree, but there is a slight catch in the graph, because in the graphs it may contain a cycle, which you can see here. So therefore we need to keep the track of the nodes which are being visited. So we usually keep the track of the nodes into a boolean array. So friends, let's see the working of this algorithm step by step. So we'll start with the value 0. So in this method we'll pass the source node as 0. So in first step what we do is we create a boolean array whose size is equal to the number of vertices in the graph. So this vertices is nothing but the instance variable which we discussed in our previous tutorial. So here you can see in this graph there are 5 nodes. Therefore we'll create a boolean array by name visited having a size of 5. So it would look something like this. And as it is a boolean array, so initially all the values inside this array is marked as false. And we have marked it false because initially we haven't visited any node of the graph. Moving ahead, we'll then create a queue data structure. Now this queue data structure will help us in traversing the nodes of a graph level by level. So it would look something like this. So here in our previous tutorial, we also discussed how queue data structure works. So you can watch my those tutorial to get more in depth of how queue works. So it's simply a FIFO data structure where element inserted first will be first to be removed. Moving ahead. Now friend, as we are starting from 0, so we will mark the visited index as true, that we have visited this node. In the array we'll make it true, and here we will mark it that we have visited this node. So friends, after we visit the node, we simply put that node into the queue. So as we have visited 0, we'll put the 0 into the queue. So it would look something like this. Moving ahead. So friend, as we want to traverse each and every node level by level, then we'll apply a while loop and we'll check whether queue is empty or not. So currently you can see queue is not empty because there is one value inside the queue. So the condition in while block comes out to be true. So in the first step, we simply pull this element out of the queue, which is 0, and we'll assign it to the integer variable u. So it would look something like this, and it will be assigned to u. Moving ahead, we'll simply print this element on the console that it is visited. So 0 is printed on the console. So here in breadth-first search, after visiting any particular node, we then go towards its adjacent nodes. So here you can see the node adjacent to 0 are 1 and 3. And in our previous tutorial we saw the representation of a graph through adjacency list. So now we'll apply a for loop which will traverse the adjacent nodes of 0. So here if we look the adjacency list of graph, then the node adjacent to u would look something like this. That in the adjacency list 0 is connected to 1 and 0 is connected to 3. So here 0 is connected to 1 and 0 is connected to 3. So now we'll traverse each and every adjacent nodes of 0. So we'll start with 1. So here v becomes 1. And the first step will check that whether 1 is already visited or not. So here in the array we see that value of index 1 is false, therefore it's not visited. So in the if block, first we'll mark this node as visited by providing a value of true to index 1 of this boolean array. So it would look something like this, and here we'll mark it as visited. And after marking the node as visited, we'll simply put it into the queue. So we'll put 1 into the queue, so it would look something like this. Moving ahead, now v becomes 3. We check whether 3 is visited or not. So here in the boolean array 3 is not visited. So we will first mark 3 as visited by making the value as true, that we have visited this node, and then we'll simply put 3 into the queue. Moving ahead. Now as we have visited all the adjacent nodes of 0, therefore this for loop will terminate. And we will come back to our while loop and we'll check whether queue is empty or not. So here you can see queue is not empty. So we'll poll from the queue. So 1 will be polled out. So it would look something like this. And you will have value as 1. We'll print 1 on the console that we have visited it. So friends, now we will actually traverse the adjacent nodes of 1, which is nothing but 0 and 2, because they are connected to 1. And if we look the adjacency list of 1, then it would look something like this, that 1 is connected to 0 and 1 is connected to 2. So now in the for loop we'll iterate over these two elements. So we'll start with 0. So v becomes 0. We will check whether 0 is visited or not. So here you can see 0 is already visited. Therefore we'll simply skip this if block. And then now v becomes 2. We check whether 2 is visited or not. So here you can see 2 is not visited. So we will first mark the value at index 2 as true, that we have visited this node, and also we are marking it as we have visited this node. Moving ahead, and then we'll simply put the 2 into the queue. So it would look something like this. Moving ahead. Now friends, here you can see we have visited each and every adjacent nodes of 1. So therefore the for loop terminates. And then we'll come back to our while loop. We'll check whether queue is empty or not. So queue is not empty. We'll poll the first element from the queue, which is 3. So it would look something like this. And we'll assign its value to u. So u becomes 3. Moving ahead. We simply print 3 on the console, that we have visited it. And friends, then we'll provide a for loop which will iterate over the adjacent nodes of 3. So here you can see the adjacent nodes of 3 are 0 and 2. So if we see the adjacency list of 3, then it would look something like this, that 3 is connected to 0 and 3 is connected to 2. So now we will visit the adjacent nodes of 3 and we'll start with 0. So v becomes 0. We check whether 0 is visited or not. So here you can see that 0 is visited. So we simply skip this if block. Now v becomes 2. And we check whether 2 is visited or not. So here you can see 2 is already visited. Therefore we simply skip the if block. So friends, there are no more adjacent nodes to 3. So therefore this for loop will terminate. We'll come back to our while block. We check whether queue is empty or not. So queue is not empty. We poll the first element from the queue, which is 2. So it would look something like this. And we'll assign it to integer variable u. So u becomes 2. And then we'll simply print the value of u on the console, that we have visited it. So friends, now we will actually traverse the adjacent nodes of 2. So here you can see the nodes adjacent to 2 are 3, 1 and 4, because they all are connected by 2. So if we look the adjacency list of value 2, then it would look something like this, that 2 is connected to 3, 2 is connected to 1, and 2 is connected to 4. So therefore now we'll traverse each and every adjacent nodes of 2. So we'll start with 3. So V becomes 3. Moving ahead, we will check whether 3 is already visited or not. So here you can see in the visited array at index 3 the value is already true and it's already visited. Therefore we simply skip this if block. Now V becomes 1. We know that we already visited 1. Therefore we will skip this if block. Now V becomes 4. And here we will check whether we have visited 4 or not. So we haven't visited 4 because the value at index 4 in the visited array is false. So in the first step what we'll do, we'll mark this value as true, that we are visiting it. Moving ahead, and then we'll simply offer 4 into the queue. So it would look something like this. So friends, now there are no more adjacent nodes left to be traversed. So this for loop will terminate. We'll again check whether queue is empty or not. So queue is not empty. We'll pull the first element out of the queue, which is 4. So it would look something like this. And we'll simply assign this value to u. So u becomes 4. We'll print this value on the console. And then we'll simply traverse the adjacent nodes to 4. So here in the diagram you can see the adjacent nodes to 4 is only 2. So if we see the adjacency list of index 4, so it would look something like this, that there is only one node which is adjacent to 4. So V becomes 2. We'll check whether 2 is visited or not. So here you can see 2 is already visited because the value at index 2 of the visited array is true. So we simply skip this if block. And here we already visited all the nodes adjacent to 4. So therefore this for loop will terminate. We'll check whether queue is empty or not. So currently you see queue is empty. Therefore condition in while block comes out to be false. So friends, here you can see that we have visited each and every node of this graph using breadth-first search algorithm. And you can see in the output that we have visited all the nodes level by level. So we started with level 1, which is 0. So we visited it. Then we went to level 2 where there were 1 and 3. So we visited those 2 nodes. Then we went to level 3 where the only node was 2. So we visited 2. And then we went to level 4 where the only node was 4. So we visited 4. So friends, this was a demonstration of the algorithm. Now let's go to Eclipse and see the working of this code. In our previous tutorial, we actually saw the demonstration of breadth-first search algorithm in Java. So in this tutorial, we will actually code that algorithm and see its working. So friends, in my previous tutorial, I have created one class by name graph, and we represented graph using an adjacency list. So friends, in order to understand more about graph, you can watch my previous tutorials. So in this tutorial, we will actually code the breadth-first search technique. So here I will be providing one method by name BFS. And as we know that this method will take a source value, which would be nothing but a starting point from where we will actually start our breadth-first search. So in the first step, what we do is we actually create a boolean array which will actually keep the track of the visited nodes. I'll give the name as visited. And friends, here you can see that to this graph we are actually storing the number of vertices into this instance variable v. So the size of this boolean array would be v. Moving ahead, and then we'll simply create a queue. So we'll import it from java.util package. Friends, moving ahead, we will mark the source node as visited by assigning a value true to the visited array at index s, and then we'll simply offer s into the queue, which we actually discussed in our previous tutorial. Then we'll simply provide a while loop, and inside this while loop we place a condition that whether queue is empty or not. So this while loop executes if queue is not empty. So in the first step, what we do, we simply poll an element from the queue, and after polling the element from queue, we simply print it on the console. So friends, whatever the element we have polled from the queue, then we simply traverse its adjacent nodes, which we actually discussed in our previous tutorial. So we'll provide a for loop which will traverse the adjacent nodes to u. So let's say we give it as v, and in order to get the adjacent nodes to u, we simply bring the adjacency list at index u. So friend, in order to understand this more, you can watch my previous tutorial that what is adjacency list and how we can fetch the linked list associated with any particular index. Moving ahead, we will check that whether v is visited or not. So if it is not visited, then we'll simply mark it as visited by assigning the value as true, and then we'll simply offer it to the queue. So friends, in our previous tutorial also we discussed that this boolean array is kept to keep the track of the visited nodes. We are using this queue which will help us in traversing of this graph level by level. So what here we do is we actually visit a particular node at level, and after visiting it we go to its next level. So friends, this is the algorithm for the breadth first search. Now let's test its working. So here you can see we have already created a graph of 4 nodes. So here we will apply this breadth first search to the graph which we saw in the slide. So that slide had 5 nodes, so I will provide a value of 5 here. And here you can see that there is an edge from 0 to 1, 1 to 2, 2 to 3 and 3 to 0. So we'll provide one more edge from 2 to 4, which we actually saw in the slide. And then we'll finally call the breadth first search method, and let's say we are giving the source node as 0. So if I run this code now, so friends, here you can see it printed 0, 1, 3, 2, 4, and we also know that as we have started from 0, so this was at level 1, and from 0, 1 and 3 were connected, which we actually saw in the previous tutorial. So they printed after that. 2 was connected to 1 and 3, so then 2 was printed, and finally 4 was connected to 2, so 4 got printed. So here you can see that we have traversed each and every node level by level. I hope you like this video. Thanks, have a nice day. Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss depth first search of an undirected graph. So friends, in our previous tutorial we actually discussed breadth first search traversal of a graph. So in this tutorial we will discuss the iterative way to perform depth first search traversal of a graph. So friends, here you can see that we are given an undirected graph. So by undirected graph we mean that edges that don't have any direction. So if we are on any particular node, let's say 0, then we can go to 1, and if we are on 1, then we can go to 0. So the edges don't have any direction, therefore this is an undirected graph. So here you can see the algorithm to perform depth first search of an undirected graph. So let's see the demonstration of this algorithm step by step. So friends, whenever we perform depth first search on an undirected graph, we usually pass in the source node, that from where we need to start the depth first search. So let's say we start our depth first search from 0. So the value of s will become 0. So friends, whenever we traverse any undirected graph, we usually keep the track of its node through a boolean array, which actually tells us that which node is visited and which node is not. Because here you can see the graph may contain a cycle and we don't want to visit any particular node more than once. Therefore we keep the track of each and every node into this boolean array. So whenever we initialize this array, we actually pass the size as the number of vertices. So here you can see the number of vertices are 5. So this boolean array will look something like this. That here each index represents a node, and at the start each and every value in this boolean array is false because we haven't visited any of the node till now. Moving ahead. So friends, in order to perform depth first search in an undirected graph, we usually take the help of stack. So the stack data structure is nothing but LIFO data structure, which means last in first out. So the element inserted last into this stack will be the first one to be removed. For more detailed information about the stack, you can watch my previous tutorials. So here in this step, we'll simply create a stack of integers. So currently stack is empty. Moving ahead. So here first we push the source node into the stack. So 0 will be on the stack. Moving ahead. So friends, whenever we want to perform depth first search of an undirected graph, we are providing a while loop, and inside this while loop we are providing a condition that whether stack is empty or not. So when the stack is not empty, this while loop executes. So currently you can see stack is having one element, therefore stack is not empty. So the condition in while block comes out to be true. So in the first step what we do, we simply pop the element from the stack and we'll assign it to an integer variable u. So it would look something like this, that 0 will be popped out and it will be assigned to integer variable u. So u is having value as 0. Moving ahead. So then we actually check that whether we have actually visited 0 or not. So here in the visited array at 0th index we see the value. So currently you can see the value is false, therefore we haven't visited this node. So the condition in if block comes out to be true. And in the if block we simply mark the value at index 0 as true, that we are now about to visit this node. And we'll simply print it on the console. So 0 is printed on the console. Moving ahead. So friends, in depth first search what we do is whenever we visit any particular node, then we look for its adjacent nodes. So here the adjacent nodes of 0 are 1 and 3. And in our previous tutorial we also discussed about the adjacency list. So the adjacency list of 0 would be a linked list having the values as 1 and 3. So it would look something like this. The adjacency list of 0 will have values as 1 and 3 because these two nodes are adjacent to 0. For more information about the adjacency list, you can watch my previous tutorials on graph. So here we are providing a for loop which will iterate over each and every element of this adjacency list. So we'll start from 1. That value of v becomes 1. And in the for loop we'll check whether we have visited v or not. So value of v is 1 and the value at index 1 is false, therefore we haven't visited this node. So the condition in if block comes out to be true. So in the if block we simply push 1 on the stack. Moving ahead, after visiting 1 we go to 3. So now v becomes 3. We check whether we have visited 3 or not. So here in the visited array at index 3 the value is false, therefore we haven't visited this node. So the condition in if block comes out to be true and we'll simply push 3 on the stack. Moving ahead. So friends, now we have traversed each and every element of this adjacency list. So this for loop will terminate and the call will reach back to this while loop. So in the while loop we'll again check whether stack is empty or not. So here you can see stack has 2 elements, therefore it's not empty. So the condition in while block comes out to be true. So in the first step we'll simply pop an element from the stack and we'll assign it to u. So u will hold the value as 3. Moving ahead, we then check whether we have visited the value 3 or not. So here you can see in the visited array at index 3 the value is false, therefore the condition in if block comes out to be true. So in the if block first we mark the value at index 3 as true, that we have visited this node, and then we'll simply print it on the console, which signifies that we have visited this node. So friends, after we have visited 3, we look for its adjacent nodes, which is 0 and 2. So the adjacency list of 3 will look like that it has values 0 and 2, which are adjacent to 3. And we'll provide a for loop and we'll iterate over each and every element adjacent to 3. So we'll start with 0. So v becomes 0. We'll check whether we have visited 0 or not. So here you can see the value at index 0 is true. Therefore we have visited this node. So the condition in if block comes out to be false. Now v becomes 2. We check whether we have visited 2 or not. So here you can see the value at index 2 is false. Therefore we haven't visited this node. So the condition in if block comes out to be true. And we'll simply push 2 on the stack. Moving ahead. So friends, we have visited each and every adjacent nodes to 3. So this for loop will terminate and the call will reach back to this while loop. We again check whether stack is empty or not. So here you can see stack is not empty because it contains 2 elements. So the condition in while block comes out to be true. In the first step we'll simply pop an element from the stack and we'll assign it to u. So here u will become 2. We check whether we have visited 2 or not. So here you can see the value at index 2 is false, therefore we haven't visited this node. So the condition in if block comes out to be true. And in the if block, first we'll mark the value at index 2 to be true, that we have visited this node now. And then we'll simply print 2 on the console. Moving ahead. So friends, after visiting this node, we actually look for its adjacent nodes, which is 3, 1 and 4. So the adjacency list of node 2 will look something like this, that it has 3 values, 3, 1 and 4, because these 3 nodes are connected to 2. And we will iterate over each and every element of this linked list. So we'll start with 3. So here v becomes 3. We check whether we have visited 3 or not. So here you can see the value at index 3 is true. Therefore we have visited the node 3. So the condition in if block comes out to be false. And now v will become 1. We check whether we have visited 1 or not. So here you can see the value at index 1 is false. Therefore we haven't visited 1. So the condition in if block comes out to be true. And we'll simply push 1 on the stack. And now v will become 4. We will check whether we have visited 4 or not. So here you can see the value at index 4 is false. Therefore we haven't visited this node. So the condition in if block comes out to be true. And we'll simply push 4 on the stack. So friends, here we have visited each and every element adjacent to 2. Therefore this for loop will terminate and the call will reach back to this while loop. We check whether stack is empty or not. So here you can see stack is not empty because it contains 3 elements. So the condition in while block comes out to be true. We pop the element from the stack and will assign it to u. So the topmost element on the stack is 4. So 4 will be popped out and the value will be assigned to u. So u will have 4. We check whether we have visited 4 or not. So here you can see that value at index 4 is false. Therefore we haven't visited 4. So the condition in if block comes out to be true. And in the if block, first we'll mark the value at index 4 to be true, that we have visited this node. And we'll simply print it on the console. So friends, after visiting node 4, we'll look for its adjacent nodes. So here you can see the adjacency list of 4 will look something like this. That the linked list will have only one element, which is 2, because only 2 is connected to 4. And here we are providing for loop so that we can iterate each and every element adjacent to 4. So we'll start with 2. So here v will become 2. And we check whether we have visited 2 or not. So here you can see the value at index 2 is true. Therefore we have already visited this node. So the condition in if block comes out to be false. And also friends, here we have visited each and every element adjacent to 4. Therefore the for loop will terminate. And call will reach back to while loop. We again check whether stack is empty or not. So here you can see stack has 2 elements, therefore it's not empty. So the first step will simply pop the element from the stack and will assign it to u. So the last element inserted in the stack is 1, therefore 1 will be popped out. So u will now have value as 1. Moving ahead, we check whether we have visited 1 or not. So here you can see the value at index 1 is false. Therefore we haven't visited 1. So the condition in if block comes out to be true. So in the if block we'll simply mark the value at index 1 to be true, that we have visited this node now, and we'll simply print it on the console. And then we'll provide a for loop so that we can traverse over adjacent nodes to 1. So friends, after visiting the node 1, we'll look for its adjacent nodes, which is nothing but 0 and 2. So the adjacency list of 1 will look something like this. That node adjacent to 1 is 0 and 2. So we'll provide a for loop and we will iterate each and every element adjacent to 1. So we'll start with 0. So v becomes 0. We will check whether we have visited 0 or not. So here you can see the value at index 0 is true. Therefore we have already visited 0. So the condition in if block comes out to be false. Now v becomes 2. And we'll check whether we have visited 2 or not. So here you can see the value at index 2 is true. So the condition in if block comes out to be false. And also friends, we have visited each and every node adjacent to 1. So this for loop will terminate and the call will reach back to this while loop. We again check whether stack is empty or not. So here you can see stack has one element, therefore it's not empty. So in the first step we'll simply pop an element from the stack and we'll assign it to u. So 1 will be popped out and u will have value as 1. Then we'll simply check whether we have visited 1 or not. So here you can see the value at index 1 is true, therefore we have already visited the node 1. So the condition in if block comes out to be false. We again check whether stack is empty or not. So here you can see stack is empty. So the condition in while block comes out to be false and while block terminates. So friends, here you can see using this depth first search algorithm, we have visited each and every node of the graph. So friends, in this tutorial we actually saw the demonstration of this algorithm. Now let's go to Eclipse and see the working of this code. Hello friends. In our previous tutorial we actually discussed the depth first search algorithm of an undirected graph. So in this lecture we'll actually code the algorithm and we'll test its working. So friends, in our previous lectures we actually created one class by name graph and we have implemented the graph using the adjacency list. We also discussed the breadth first search algorithm. So in this tutorial we'll actually discuss the depth first search algorithm. So here we will be creating one method as public void dfs, and we also know that the depth first search will start from a source node. So S will represent the source node. So friends, in our previous lecture we actually saw the demonstration of the depth first search step by step. So friends, in the first step we'll simply create a boolean array. We'll give it a name as visited. And we'll initialize this boolean array with a size equal to the vertices of the graph. So friends, here we have created this boolean array which will keep the track of the nodes which we have already visited. Because while traversing a graph, there may come a situation where graph contains a cycle. So in order to visit a particular node only once, we usually create this boolean array which will keep the track of the nodes which are visited. And then we'll create a stack. So we'll import the stack from java.util package. So friends, we are using this stack which will help us in performing depth first search, and its significance we already discussed in our previous lectures. So after creating the stack, we'll simply push the source vertex on the stack, and then we'll provide a while loop. So in this value, we'll provide a condition that whether stack is empty or not. So this while loop will keep executing with a condition that whether stack is empty or not. So the stack is not empty, this while loop will keep on executing. So inside this while loop, as we discussed in our previous lecture, that we pop the element from the stack and we'll assign it to u, and then we simply check that whether we have visited u or not. So if we haven't visited u, so the condition in if block comes out to be true. So first we'll mark the value at index u to be true, that we have visited this node, and we'll simply print u on the console. So friends, after visiting u, we simply provide a for loop which will iterate over each and every element adjacent to u. So friends, here after visiting any particular node, we look for its adjacent nodes, and we can get the adjacent nodes through the adjacency list, and we'll simply iterate each and every element of this adjacency list one by one. So in the for loop, we simply check that whether the adjacent node to u, which is v, has been visited or not. So if the node is not visited, we simply push it on the stack, and this we do for each and every element adjacent to the already visited node. So friend, this is the code to perform depth first search over an undirected graph. Now let's test its working in the main method. So here you can see we have created a graph with 5 nodes, and we have added the edges between the nodes, say from 0 to 1, 1 to 2, 2 to 3, 3 to 0, and 2 to 4. So this is the same graph which we discussed in our previous lecture. So here in the main method, we simply call the DFS method, and we'll pass the value of the source node as 0, that we have to start our depth first search from the node 0. So if I run the code now, so friends, here you can see it printed each and every node of the graph in the following order. First it printed 0, then 3, then 2, then 4, and then 1. So this is the same output which we discussed in our previous lecture while demonstrating this algorithm step by step. So friend, this is how we actually perform a depth first search over an undirected graph. I hope you like this video. Thanks, have a nice day. Hello everyone. So in this video, we will be looking into the recursive depth first search algorithm to traverse an undirected graph. So in our previous video, we actually saw the depth first search using the iterative approach. So in this video, we will see that how recursive algorithm works. So here you can see that this is the algorithm which is recursive depth first search. Here you can see this DFS is calling itself here, making it recursive in nature. So let's see the demonstration of this algorithm step by step. But before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. In our previous video, where we discussed about the iterative approach, we used the stack data structure to traverse the graph. And in our previous algorithm, where we saw breadth first search and depth first search iterative, there we were given with a source vertex, and from there we started our DFS. But usually the graph is given in form of like this. So here you can see 0, 1, 2, 3, 4. They are connected together, and there is one more node which is 5. So this vertex is not connected with rest of the elements. So basically a graph is provided like that there could be components which are basically disconnected. So we need to visit this graph and its each vertex. So here we actually use this for loop which traverses each and every vertex and help us visiting the vertex using depth first search. So let's see the demonstration of this algorithm step by step. So here, as the algorithm is recursive, we will keep the track of the DFS method which is getting called on a call stack. And here you can see when we are calling DFS on any particular vertex V, after visiting it, we try to traverse its adjacent nodes one by one. So those adjacent nodes we denote it by W, and if they are not visited, we call the DFS again. We pass the W value to it because we want to now traverse the adjacent vertex to V. So when this DFS will be called, this W will become our new V. So we need to keep that in mind while traversing our call stack. So at the start we simply call DFS. So one method is on the call stack. Now friend, as this graph can be connected and can form a cycle, so when we perform DFS, this visited array, which is boolean, help us in knowing that which nodes are already visited or which vertex are already visited. So this capital V, we already discussed in our previous videos that this represents the number of vertices. So currently we have 6 vertex from 0 to 5. So we created a boolean array of 6 elements. We start from V equal to 0. So V is 0. We first check whether V is already visited or not. So currently we see at index 0 VF false. So therefore it's not visited. So we call DFS, and as we are leaving this DFS at line number 5, we update line number here. So now there will be one more method on the call stack with V as 0 and the visited array you can see here. So when we call DFS on any vertex, the first thing we do is we mark that vertex as true, that we have visited it. So we mark it as true, and here you can see we made it yellow. And by visiting the node we mean processing the node. So here we are simply printing it on the console. So 0 will be printed. Now we look for the adjacent nodes to vertex 0. So this adjacency list we discussed in our previous videos. So this adjacency list is an instance variable which holds all the vertex and their corresponding edges. So when we do adjacency of 0, it has 2 elements 1 and 3, because these 2 elements are adjacent to 0 and they are connected. So it looks like this. So after traversing 0, we try to traverse his adjacent nodes. So we can start from any node. So here we pick 3. So here you can see W becomes 3. We check that whether 3 is visited or not. So here you can see 3 is not visited. So we call recursively depth first search on 3. So this 3, which is W, when we will call DFS again, it will become our new vertex to visit. And here you can see we are leaving
this DFS on line number 15. So we need to update line number here, because once this DFS will finish, we should know that from where we need to start this DFS. So we update line number 15 here. And there will be one more method on the call stack with our new v as 3. So you can think of it something like this. We are going like this. Moving ahead, v becomes 3. We mark 3 as visited like this, and then we print it on the console, and then we look for the adjacent elements to 3. So if we see the adjacent elements to 3, we will get 0 and 2. So the adjacency list of 3 will give us 0 and 2. Now we need to visit 0 and 2 because those are adjacent to 3. So we can start with any node. So we pick 0. So W becomes 0. We check whether 0 is already visited or not. So here you can see 0 is already visited, marked as yellow. So this condition comes out to be false. So now we go with vertex 2. So W will become 2 now. We check whether 2 is visited or not. So here you can see 2 is not visited. It is marked as false. So this condition comes out to be true. And now we again call DFS with W as 2. We are leaving at line number 15. So first we update line number here. There will be one more method on the call stack where v will become 2, because now we need to traverse 2. So we first mark 2 as visited like this. Then we print it on the console 2, and then we try to traverse its adjacent vertices. So here you can see adjacent to 2 is 3, 1 and 4. So the adjacency list will give us 3, 4, 1. So we can start with any node. So we start with 3. So W will become 3 here. We check whether 3 is visited or not. So here you can see 3 is already visited. So this condition comes out to be false. We then take 4. W becomes 4. We check whether 4 is visited or not. So 4 is not visited. So then we do the DFS on 4. So we call DFS with W as 4. We first update the line number here because we are leaving this DFS now. So there is one more method on the call stack with our new vertex to visit is 4. So v becomes 4. We first mark index 4 as true because we are about to visit it. We print it on the console. So 4 gets printed. And now we check for the adjacent elements to 4. So here you can see the elements connected to 4 is only 2. So its adjacency list will have only 2. So we try to visit 2 now. So W becomes 2. We check whether 2 is visited or not. So here you can see 2 is visited. So this condition comes out to be false. And here you can see the adjacent elements of vertex 4 is all visited. So now this for loop will terminate and this DFS will also get terminated, and our call will reach to that DFS which actually called this DFS, because we are done with the
all the adjacent elements of vertex 4. So this method will be removed from the call stack and the execution point will reach here. And we know that we had left this DFS at line number 15. So we start our execution from line number 15. And when we left this DFS, the value of V was 2 and the value of W was 4. So it means we were traversing the adjacent elements of 2 and we just visited 4. So if we see the adjacency list of 2, we visited 3 already, then we went to 4, so we are done with 4 also. So now our time is to visit 1. So W will become 1 in the next iteration. 1. We check whether 1 is visited or not. So 1 is not visited. So this condition comes out to be true. And we call DFS again with W as 1. So we update the line number 15 here. There will be one more method on the call stack with V as 1. We mark vertex 1 as visited. We print 1 on the console. So this is also visited. And now we actually check the adjacent elements of 1. So here you can see it has 0 and 2. 0 and 2. So we start with 0. W becomes 0. 0. So here you can see 0 is already visited. So this condition comes out to be false. Then we go to vertex 2. W becomes 2. And 2 is also visited. So this condition comes out to be false. So here you can see all the elements adjacent to vertex 1 are visited. So this for loop will terminate and this DFS method will be removed from the call stack. And execution point will reach here. So we start this DFS from line number 15 and we were actually traversing vertex 2 and the recent adjacent element we visited was 1. So W becomes 1 and V becomes 2. So if we see the adjacency list of 2, we are done with 3, 4 and 1. So in the next iteration, this for loop will terminate because there are no more adjacent elements to vertex 2. So now this DFS will end. And call will reach to its previous DFS. We will start from line number 15. And we had left this DFS when value of V was 3 and the recent adjacent element to 3 which we tried to visit was 2. So V is 3, W is 2. So if we see the adjacency list of 3, here you can see 0 we already visited and we went to 2 and 2 also we visited. So now this DFS will end for vertex 3. Execution point reached here. We start from line number 15 and when we left this DFS we were actually visiting the adjacent elements of vertex 0 and the recent we visited was 3. So V is 0 and W is 3. And if we see the adjacency list of 0, so here you can see the recent element we visited was 3. So now we go with the vertex 1. So W becomes 1, 1. We check whether 1 is visited or not. So here you can see this visited array is helping us to not to visit the vertex again because 1 is already visited. It is marked as true. So this condition comes out to be false. So now we are done with the adjacency list of 0. So this DFS will end and this method will be removed from the call stack. And we go back to the starting DFS method where we left at line number 5. So we start from line number 5 and we are done with visiting 0 vertex. So here you can see this for loop will now help us in visiting 5 because when we started with 0, all these nodes were directly or indirectly connected with 0. So we visited everyone using the DFS. So this phi is not connected to any of these vertices. So using this for loop, we will visit phi as well. So we'll increment v becomes 1. So vertex 1 is visited, so we do nothing. V becomes 2. So 2 is visited, we do nothing. V becomes 3. 3 is also visited, so we do nothing. 4 is also visited. And now V becomes 5. So here 5 is not visited. So we call DFS on vertex 5. We update the line number and here we call this DFS with 5. So here it should be 5 because we are leaving this DFS when vertex V was 5. So now we call DFS on vertex 5. We mark vertex as visited. This is visited now. We print it on the console and then we try to visit the vertex 5 adjacent elements. So here you can see there are no adjacent elements to vertex 5. So this for loop will terminate and this DFS method will be removed from the call stack. And we go back to the previous DFS at line number 5 where V was 5. And then we increment V, it becomes 6. So now this for loop will terminate and everything will be removed from the call stack. So here you can see in this order we visited each and every vertex of the graph. And here using this for loop, we even visited vertex which were disconnected. So friend, this was all about the recursive depth first search. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.
Hello everyone. So in this video we are going to discuss that what are connected components in an undirected graph. So friends, here you can see that we are given a graph having 6 nodes from 0 to 5. Now here if you see that we have 3 connected components. So one is having nodes 0, 1 and 3, which is this connected component. Another connected component is 2 and 4. And the third connected component is a component having only one node, which is 5. So usually with a graph, we are given a graph in the form of connected components. So one such query comes is that we need to evaluate that in a graph, how many connected components are there. So in this graph, we have 3 connected components. And also one such query comes is we are given with 2 vertices, let's say 0 and 2. And we need to find whether 0 and 2 are connected or not. So here you can see 0 is in the first connected component and 2 is in the second connected component. 2 is connected with 4, 0 is connected with 1 and 3. So 0 and 2 are not connected. So such queries are given. So usually in real world, let's say we can think of these connected components as a graph of a small region where these 3 nodes form a road, this 2 forms another road, and there could be a query that whether this road is connected with this road or not. And similarly for other applications, we can think as network connections. We just need to query whether this connection and this connection are connected or not. So such queries can be handled via connected components. So in this video we are going to see the algorithm that how we can figure out the numbers of connected component and how we can figure out whether any node is connected to another node or not. So here is the algorithm, and here we are using the same graph which we discussed in our previous slide. So let's see the demonstration of this algorithm step by step. So friends, before we start, in case if you want to master data structure and algorithm, you can subscribe to my channel and click the bell icon so that you never miss any update. So here you can see that to find the number of components and to find whether any of the vertices are connected or not, we need to process each and every node. So here what we do is we apply the depth first search. Now this algorithm is recursive in nature. Here you can see depth first search is again calling here itself. So it's a recursive algorithm. So therefore we will maintain the calls to the DFS in the call stack, and we need to keep the track of the vertices we are visiting. So at the start we call DFS. Now when this method starts execution, there will be one method on the call stack by name DFS, and now this method will start its execution. So we are storing the state of v, w and count for this DFS, and this we will do for each and every recursive calls here, because when we are calling this DFS from this DFS, this method will store the state into the call stack and then it will again call DFS. So once this DFS will end, the method will return to this DFS and we will assign back the values of the variables from where this DFS left. Moving ahead. So friends, here you can see that as we are calling this DFS on an undirected graph, there could be a possibility that this graph contains a cycle like this. So what happens is we create a boolean array visited. Now this boolean array will help us to check whether any of the vertices are already visited or not, because let's say if we visit 0, then 1 and then 3, then from 3 if we go to 0, this boolean array will help us knowing that 0 is already visited. So in order to keep the track of visited node, we create a boolean array, and here in our previous videos we know that the capital V is nothing but number of vertices. So currently we have 6 vertices from 0 to 5. So this boolean array will have 6 vertices from 0 to 5 index, and each index corresponds to a node in a graph. So at the start all the values of the visited array will be false because no node is visited as of now. Now we will create yet another array which we will call component ID. We will see its significance later, but here you can see this component ID will store the ID of any particular component in the form of integer. So you can think that as we have 3 components here, so this component ID for 3, 0, 1 will store, let's say, an ID of 0 for example. For 2 and 4 it will store 1, and for 5 it will store 2. Now this will state that we have 3 components, 0, 1 and 2. Node 3 belongs to 0 component, 0 belongs to 0 component and 1 belongs to 0 component. So that will be evaluated with this component ID. And similarly 2 will belong to component 1, 4 will belong to component 1 and 5 belongs to component 2. So there could be so many nodes in a graph. So this component ID will denote a group of nodes which will be represented by an ID. So we will see its significance later. So this array would look like this, that at the start for all the vertices the value will be 0, or what we can do is we can also initialize this array as a wrapper of integer, so every value will be null, stating that the nodes are belonging to no component at the start. Moving ahead. Then we will create a count variable. Now our task is to first count number of connected components, and our second task is to return true or false for a query that whether X and Y are connected or not. So we are using this algorithm to figure out these two problems. So we are creating a count variable which is suggesting that how many connected components are there in this graph. So at the start in this DFS method, count will be 0 because we are yet to start the processing of this graph. Also friends, here you can see in this method we are creating these three things: visited array, component ID array and count. So usually for these two queries we take these three variables at the class level so that we can use them directly in any of our methods. But here for time being I have created these three variables in the method itself so that I can demonstrate the algorithm that how it works. So these three things you can create outside of the method at the class level. We can make these variables as instance variables. So for time being you can think that these are part of the method itself, and for the actual DFS algorithm we are actually passing them directly into the method. Or else if they are at instance level we don't need to pass them like this. Now we will start the processing of graph from vertex 0 and it will go till it is less than the number of vertices, which is 6. We need to go from 0 to 5. So at the start v is 0. So we update 0 here. Now the first thing we check is whether v is already visited or not. So here you can see as we are starting the processing of the graph, v is not visited. Here value at 0 index is false. So therefore this condition comes out to be true, which means we can apply the depth first search on vertex 0 now. So here now this DFS will be removed from the call stack and this DFS will be called. So first we update line number here because we are leaving this DFS now. So we are leaving at line number 7 so that when this DFS method will finish, we come back to this DFS and we start the execution from line number 7 itself, and we assign this values back to v. So now there will be one more method on the call stack and the execution point will reach to that DFS with v as 0, count as 0 because we are passing count 0 and v 0. We will see what this w is here, and visited array and component ID array you can refer here. Now when we will call DFS on any particular node, what we do is we first process that node, and how we can process that node is we can perform any typical algorithm on that particular node, and we first mark that node as visited, that we are done visiting this particular node. So in the visited array at 0 index we simply assign a value true stating that we have visited node 0, like this. We have visited this node, and here what we can do is we can either process some algorithm on top of this node, we can print this node, and we can do anything on this node based on the algorithm we are trying to process. And now what we do is this count variable which we have passed into the DFS here, this count variable will help us in finding the ID of the component. So as we discussed that these three nodes belong to component ID 0, this 2 belongs to 1 and this belongs to 2. So this ID can be anything. So here what we are doing is we are taking the count only as our ID. So in the component ID array at vertex 0 we update count as 0, like this. Now after visiting a particular node, what we do is we recursively visit its adjacent nodes. So in our previous video we have discussed that what this adjacency list is. This is actually a list. We are passing a vertex 0 because value of v is 0 and we are asking to return its adjacent nodes. So it would look something like this. I'll remove this. So here this list states that 0 is connected to 3 and 1, and it is denoted in the form of an adjacency list. You can watch my previous videos to understand more about this. So here what we are doing is we are iterating the nodes one by one. So 0 is connected to 3 and 1. So we can process these nodes in any order. So this for loop will process one node. So at the start value of w will be 3. Let's say we are taking 3 to visit. Like this. Now we need to visit 3. So what we do is first we check whether we have already visited 3 or not. So here at index 3 we have a false value. It means we haven't visited 3. So now our task is to recursively call DFS with w will become our new v in the next DFS call, and we are applying this DFS now for vertex 3 because we haven't visited this vertex. So before calling this DFS, we know that we are leaving this DFS at line number 18. So we'll update line number first here like this. And then this DFS will be called. So there will be one more method on the call stack like this. An execution point will execute this DFS. Here w was 3. When we called this DFS, it becomes our new v. So you can think it is going like this. So now we are applying this DFS on vertex 3. We have passed count as 0 as we are directly propagating the count to this DFS. So v becomes 3 now. We know that we haven't visited 3. So we will first visit 3 by marking the index 3 as true. Like this. That we have visited 3 now. And in the component ID array at index 3 we will assign the value 0 because value of count is 0 like this. Now this 0 is actually telling us that this 0 and 3 are actually connected because their IDs are same. After visiting 3 we will visit its adjacent nodes. So we will iterate the adjacency list of 3. And it has only one node 0 because 3 is connected only to 0. So at the start w will be 0 like this. And now as we are processing the adjacent nodes of 3, we first check whether 0 is already visited or not. So here you can see at index 0 we have value true. It means we have already visited 0. So this condition comes out to be false. And here you can see for vertex 3 there are no more nodes adjacent to 3 left to be traversed. So this for loop will terminate, and after this for loop gets terminated, this DFS method will also get terminated, and this DFS will be removed from the call stack, and execution point will reach to this DFS. And here we know that we had left the previous DFS at line number 18. So we start from line number 18. At that moment v was at 0. So v will come back to 0. W was at 3. And if we see the adjacency list of 0, we have processed one of the adjacent nodes of 0, which is 3. Now in the next iteration we will pick 1 and we will apply DFS on 1 because we need to visit 1 and then visit its adjacent nodes recursively. So W becomes 1 here. We check first that whether 1 is already visited or not. So at index 1 we have a value false. It means 1 is not visited. So we will call DFS again, and we are leaving this DFS at line number 18. So we will update the line number here, 18. There will be one more method on the call stack. As we have called this DFS with W as 1, this W will become our new V here for this DFS. So it will go like this, and count will go with a value 0 only. The first step we do is we mark the vertex 1 as visited. So at index 1, we mark it as true, like this, that we have visited 1 now. In the component ID array, at index 1, we put the value of ID as 0, which suggests that 0, 1 and 3 are connected. Now after visiting 1, we will visit its adjacent nodes recursively. So if we call the adjacency list of 1, you will see that it is connected only to 0. So we have only one vertex. So W will start from 0. We'll first check whether 0 is already visited or not. So here you can see 0 is already visited. In the visited array, at 0th index, we have true. So this condition comes out to be false. And there are no more vertex adjacent to 1 left to be traversed. So this for loop will terminate. And this DFS method will also get terminated and removed from the call stack. So execution point will reach here. We had left the previous DFS at line number 18. So we'll start from line number 18. At that moment V was 0 and W was 1. And V was 0, it means we were visiting the adjacent nodes of V. We visited 3 and we have visited 1 recursively. So now there are no more nodes in the adjacency list of 0 to visit. So this for loop will terminate and this DFS method will also get end and it will be removed from the call stack. An execution point will reach to this DFS, which we left at line number 7. So we start from line number 7. At that moment V was at 0. So here you can see that after performing the DFS on any of the node, here we started with 0, it recursively visited its neighboring nodes. So once this DFS will end, we know that we have visited one component fully. So now what we do is we simply increment count. So our count becomes 1. Now this count is suggesting that we are done processing of one connected component and we have found one connected component. So count becomes 1. We'll increment V. V becomes 1. Now it means we are going to the vertex V and trying to apply DFS on vertex V. So first we check that whether 1 is already visited or not, because there could be a possibility that its previous vertex or any of its previous vertex must have visited 1, because 1 must have been connected to that vertex. So here you can see 1 is already visited. So this condition comes out to be false. We will increment V. V becomes 2. We check that whether 2 is visited or not. So here at index 2, we have a value false. It means 2 is not visited. So we can apply the DFS now on vertex 2. So we are leaving this DFS at line number 7. And we are calling this DFS with V or vertex as 2. So there will be one more method on the call stack with V as 2 and count as 1. First we mark 2 as visited like this. So here I am just representing it with a different color. In the component ID at index 2 we put 1. Now here this count was increased, so our ID also increased, which also help us in figuring out that 2 belongs to a different component. Now our task is to visit the adjacent nodes of 2 recursively. So 2 is only connected to 4. So adjacency list of 2 will have only node 4. So we'll start with 4 first. W becomes 4. We first check whether 4 is visited or not. So 4 is not visited. So we call this DFS with W as 4. So this 4 will become our new V in the next DFS call. So first we update line number here because we are leaving this DFS. And there will be one more method on the call stack. So the W which was in previous DFS becomes our new V and count is propagated directly. We first mark 4 as visited here like this, and in the component ID array at vertex 4 we assign a value 1. This suggests that 2 and 4 are part of one single component because they have same component ID. Now we will traverse the adjacent nodes of 4. So adjacency list of 4 will have only one vertex, which is 2. So W starts from 2. We first check whether 2 is visited or not. So here you can see index 2, we have value true. So 2 is already visited. So this condition comes out to be false. And this for loop will terminate because there are no more nodes adjacent to 4 left to be traversed. And this DFS method will end. And execution point will reach to previous DFS. We start from line number 18. At that moment V was at 0. So V comes back to 0. W was 4. Which suggests that we were visiting the adjacency list of 2. Which was this. We know that we recently visited 4. And there are no more adjacent nodes to 2 left to be traversed. So this for loop will terminate. And this DFS will be removed from the call stack. And execution point will reach to previous DFS. We start this DFS at line number 7. At that moment V was at 2. So it suggests that we just finished one more DFS on one of the vertices, which was 2, and it must have marked its connected vertices in the visited array. So we'll increase the count now because we are done processing the second connected component. So count becomes 2. We'll increment V. So V becomes 3. Now we need to apply this DFS again on vertex 3. But first we check whether 3 is already visited or not. So here you can see 3 is already visited. So this condition comes out to be false. We increment V. V becomes 4. 4 is also visited. So this condition comes out to be false. We'll increment V. V becomes 5. So here you can see vertex 5 is not visited. So this condition comes out to be true. So now we'll apply DFS on vertex 5. So we are leaving this DFS at line number 7. So we update line number 7 here. And there will be one more method on the call stack with V as 5 and count as 2. Now the first thing we do is we mark 5 as visited like this. And in the component ID array at index 5, we assign a value 2 because value of count is 2. Now here it suggests that this 5 belongs to a different component because value of count has changed. Now we'll visit the adjacent nodes of 5. So here you can see in this connected component we have only one node and 5 is connected to no other node. So therefore this for loop will terminate and this DFS method will also end. Execution point will reach to this DFS. We start from line number 7 and V as 5. So after this DFS is done, we know that we have just visited one more connected component. So we increase the count. Count becomes 3. We'll increment V. V becomes 6. And we know that we have only nodes from 0 to 5. So this for loop will terminate and this DFS will be removed from the call stack. So now here you can see, if you see in the visited array, we have visited all the elements. In the component ID array, you can see 0, 0 and 0 are at indexes 0, 1 and 3, which suggests that 0, 1 and 3 are connected. If you see 2 and 4, they have a same value 1, 1. It means they are connected. And here if you see at index 5 we have 2. It means it's a connected component having only one vertex. So friends, here you can see that if we take out these 3 variables as our instance variable, and we can provide one method as something like public int get count of connected components. So this we can return the value of count like this. So this will solve our first query. The second query we can provide a method as public boolean, and we can give the method name as is connected, and to this method we pass x and y. So here we can simply return comp id of x whether it is equal to comp id of y. So let's say if we pass x, y as 0, 2. So this is our x and this is y. So the value at index x, which is 0, we have 0, and value at vertex 2 have 1. So here you can see we are comparing whether 0 is equal to 1 or not. It means this condition comes out to be false and we return false, stating that 0 and 2 are not connected. Now for example, if we pass 3 and 1 like this, so 3 is x and y is 1. So comp id of 3, we are checking it with comp id of 1. So this will give value 0 and this will give value 0. So both the values are equal and this condition is true. So we simply return true, stating that 3 and 1 are connected and they are part of the same component. So friends, this was all about the connected components in an undirected graph. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video, we are going to discuss a problem, number of islands. Now let's move ahead and see what this problem is and how to solve this. So here we are given an m cross n matrix like this, which is 2D binary grid. So binary grid we mean that we have this matrix having only ones and zeros. Now in which ones represent a land. So you can think wherever we have 1, it actually represents a land, and zeros as water like this. Now our task is to return the number of islands. Now what do we mean by island? So as per the definition in the problem, you can see an island is surrounded by water. So this is the one thing, that an island is surrounded by water, and second is formed by connecting adjacent lands horizontally or vertically. So this is a land, this is a land. So one thing is there should be a connection horizontally or vertically, and second they should be surrounded by water like this, and we may assume all 4 edges of the grid are surrounded by water. So beyond this grid here you can think that there is only water. It means that it has zeros. So here we have 0, here we have 0, here we have 0. So here these 3 ones form an island because these 3 are connected horizontally and vertically and they are surrounded by water. This single one forms one island because it is also surrounded by water, and this one also is surrounded by water. So the answer is 3. We have 3 number of islands. We don't have to consider this diagonal relationship. As per the problem, we need to look horizontally or vertically. So here you can see that how we can solve this problem is, if you look closely, then we are given with a graph indirectly here, if I plot this one, so this is one node and the node adjacent to it is also one. So we can think that there is a connection via this edge horizontally like this. And there is a edge vertically because we need to consider vertical edge also. So this forms another connection like this. So you can think this island in the form of this graph. And if we look closely to it, it's look like this. 1, 1, 1. Like this. So you can also think that we are given with this 5 nodes of a graph, that they are connected horizontally and vertically, and if there is a vacant space here, it means that it is surrounded by water. So in one of our previous videos, we discussed about connected components. So this forms one connected component, this forms another connected component, and this forms another connected component. And we also discussed that how we can process a connected component, and we also discussed that how we can find the number of connected components. So this problem is very much similar to that. So in the connected components problem, we applied the DFS, which is a depth first search. So here also we'll apply the same. So the only difference is there we had this actual nodes connected by edges, and here we are taking this adjacent lands horizontally or vertically in the form of edges. So keeping these constraints in mind, let's move ahead and see the demonstration of this algorithm step by step. So friends, before we start, in case if you want to master data structures and algorithm, you can subscribe to my channel and click the bell icon so that you never miss any update. Now this is the algorithm to find the number of islands. We are given with a matrix where we have only ones and zeros, and they are provided in the form of a character. And here we need to return the number of islands in this grid. So here we have created integer variable number of islands, and at the end we are returning this number of islands. So let's see the demonstration of this algorithm step by step. We call the number of islands method passing in the matrix, which is our grid. Now let's say we take the same example where we are given with this matrix and we know that we have 3 islands here. One is this island, another is this, and the third one is this. Now let's see how we can find out the number of islands. And we also know one property, that lands should be connected vertically or horizontally. So this can be treated as a vertex of graph and this can be treated as an edge. So this is a horizontal edge and this is a vertical edge. So friends, here you can see that wherever we will find land, we need to apply depth first search on top of it so that we can figure out that how much deep that connection is via this property. Now here we are given this m cross n matrix. So this m cross n represents row and column. So the number of rows, which is m, is given by grid.length, which is 4. We have 4 rows, 1, 2, 3 and 4 with an index of 0, 1, 2 and 3. Similarly, we have 4 columns denoted by n. So this is first column, second, third and fourth column with an index of 0, 1, 2 and 3. So friends, when we apply depth first search here, we know that we need to consider horizontal and vertical relation. So here let's suppose we are given with this sort of graph. Let's say here we have this 1, so it must look like this. So if we are applying depth first search on top of it, we know that once we visit any particular node, then we visit its neighboring nodes recursively. So usually in the graph, we can encounter these cycles. So here let's suppose we have visited this node. Then we go to this node, we visit this. And let's say if we are going to this node and we are visiting, then here we are visiting. But if we go back here, this node we have already visited. So this is a rough example to just demonstrate that when we return back to this node, we know that we have already visited this node. But how we can mark that we have visited this node? Because when we will reach to this node, then the algorithm will keep on visiting this node again and again. So we have a cycle. So in order to keep the track of the visited nodes, we create a boolean array, or here you can see that we have created a visited matrix. Here, as the graph is given in the form of a grid, and here each index represents a vertex. So therefore we have to create a matrix of m cross n, which will actually help us to figure out that which nodes are visited and which are not. So it looks something like this. It's a boolean matrix. So at the start, every node is unvisited, being denoted by f, which is false. As we need to return number of islands, so we initialize this integer variable with 0, because at the start we haven't found any island. So the number of island is 0. So friends, when we apply depth first search on a graph, we visit each and every node of that graph. So here each index value can be considered as a node of a graph. So here you can see that we have 16 such vertex, and they are given in the form of matrix m cross n. So we need to apply these two for loops to travel each and every vertex and apply the depth first search on top of it to figure out the number of islands. So here I will traverse the rows and j will traverse the columns. M denotes our rows, n denotes the columns. So at the start, I is 0, j is 0. So it means that we are on index 0, 0, like this. Also friends, as we need to find the number of islands, we can apply the depth first search on the nodes which have values as 1, because zeros represent water. So when we encounter water, we need to skip the water, and once we found even one of the land, then we can apply depth first search on top of it, with an only condition that this one should not be visited, because there could be a possibility that if we are going in this direction, then we are coming back, then going down, and they are going up. So there could be a possibility that we encounter the nodes which are already visited, so which is being tracked by the visited 2D array. So the only condition we need to keep in mind is that in the visited array at 0, 0, we should have false value. It means this node should not be visited, and the value of this node should be 1. If we encounter 0, then we will simply skip this element, because this denotes the water. So here at the start we found 1, which is a land, and this land is not visited. So therefore we can apply depth first search on top of this one, considering the graph horizontally and vertically. So when we will apply DFS on top of this grid at index 0, 0, it would look something like this, that this method will now call DFS method, like this. So here we have this grid and this visited 2D array. We pass the row as 0, 0. So on the call stack, there will be one method DFS having row as 0 and column as 0, because we found 1 and that is not visited. So here we are maintaining this call stack because this algorithm is actually recursive. As we are applying the DFS, we know that it's a recursive algorithm where we actually process any node and then we try to process its adjacent nodes recursively. So therefore this algorithm is recursive. So in order to keep the track of this method calls, we are maintaining a call stack. This is our base case to stop this recursion. We will see this later. So now at the start we are processing a value at an index 0, 0 in this grid matrix, because we have found one land denoted by 1 and which is not visited. So here you can see this is our base case. Now as we will apply this depth first search horizontally and vertically in all the directions, because this land can be connected to another land. So let's say we have a land here. If above this land we have another one, here we have another one, and here we have another one, and below we have another one. So this land, if you see it, is connected like this, like this, like this, like this. So we need to go in 4 directions to figure out the extent of this island, because we are given in the problem that we need to see in the horizontal and in the vertical direction. So here in the normal DFS, where we are given with a vertex, we visited a node and then we visited its adjacent nodes recursively. Here the adjacent nodes, as we discussed, will be given by these 4 directions, which is up, left, right and down. So currently what this base case says, that after processing any node, if we are going to a level above, let's say if we are going to top of this one, then we are going outside the boundaries of this matrix, because beyond 0, 0 the index doesn't exist in the matrix. So here this is the base case that we may go out of the matrix. So if row is less than 0 or column is less than 0, then we simply return from the DFS method. So this is our base case. The another conditions are, if row and column goes beyond this or this, then also we need to return. And the last 2 conditions are, let's say if we are on this node and if we go to right, so here we are finding a water which is being denoted by 0. We only keep the track of the lands which are connected adjacent, and as soon as if we find a water, we simply return back. So here if this grid at a row and column, if the value is 0, then we will simply return. And one last thing is, let's say if we have visited this one, we went here. For this one also we need to go up, so we'll go back to this one. But here we know that we just visited this node and came here, and then we are going up. So if in the visited 2D array at row and column, if we find any true value, then also we need to return, because we have already processed the node. So these 6 conditions are very important because they form our base case. We should not go beyond the boundaries with these first 4 conditions. We should not go in the water with this condition, and we should not go to a land which is already visited. So at the start, we are within the boundaries of this matrix because we are at 0, 0. This vertex is not visited and the value is 1, which is not 0. So therefore all the conditions comes out to be false. So which suggests that we have found one land. And now as per the DFS, we will visit this land, and in the visited 2D array we'll mark it as true, like this. So friend, one property of DFS is, after visiting any particular node, we visit its adjacent nodes recursively, and we know that in order to find the adjacent nodes to 1, as per the problem, they should be horizontal or vertical. So we need to apply this DFS horizontally and vertically. So it means we have to go in 4 directions, left, up, right and down, to visit the adjacent nodes of 0, 0 recursively. So here if you see, if we are on a particular row, let's say 0, 0, here we can travel in any direction. So what we are doing is, we are going first to left, then up, then right and then down. So here when we are going left, it means we are going in this direction. So currently here you can see that whichever box is yellow, that is our current row and column, which is 0, 0, this. If we want to go in the left, it means we are going in this direction. So when we are going in this direction to the left, row actually remains the same. Here you can see value of row is 0, so it remains the same. As we are going on the left, the value of column decreases by 1. So here we have column 0, here it can be -1, because we are going in this direction. Similarly, if you are going up, let's say we are here, and if you are going up, here row is 2, now it becomes 1. So here row is actually decreasing, but column remains the same. So when we go up, row decreases, column remains same. When we go right, let's say if we are here, if we are going in this direction, so row remains the same and column actually increases from 1 to 2. So we do col plus 1. And if we are going down, let's say if we are going down from here to here, so row was 1, now it became 2 because we have reached here. So row is actually increasing and column remains the same. So this 4 direction we need to keep in mind. If we are going on the left, column decreases. If we are going up, row decreases. If we are going on the right, column increases. If we are going down, row increases. So this 4 direction we need to keep in mind, because For any particular land, we need to see its horizontal and vertical adjacent nodes to figure out whether it has land or water. So we need to call this DFS 4 times because we need to visit a particular row and column in 4 directions, going left, then going up, then going right, and then going down. So first we will go left, where row remains the same and column decreases by 1. So here you can see that we are leaving this DFS at line number 8 and we are calling this DFS. So first we will update the line number here, 8, that we are leaving this DFS at line number 8. So once this DFS will end, we will return back to this DFS, but we need to keep the track of the line that from where we left this DFS. So this line number 8 will help us knowing that we had left this DFS at this line. So we'll start our execution at this line, and whatever the value of row and column will be, we'll assign those values back to the row and column. So now here you can see this method will be called where row will remain same and column will decrease by 1. So there will be one more method on the call stack like this. Here row remains the same and column decreased by 1. So it became -1. It means we are going to the left. So here we went outside the boundaries of this matrix where column became lesser than 0. So it means we have encountered a base case. So we simply need to return back to 0, 0. So this DFS will end because we are now returning back. So this method will be removed from the call stack. Execution point will reach here. We'll start from line number 8 and we have visited the left side and we came back to 0, 0. So we are coming back to 0, 0. And now we know that we are done with the left. We need to go up. So when we go up, row decreases and column remains the same. So we are leaving this DFS now at line number 9. So we'll update 9 here. So there will be one more method on the call stack where row will decrease from 0 to -1 and column remains the same. So here you can see now we went to outside the boundaries of this matrix in upper direction. So now row has become less than 0. So therefore we need to return from this DFS. So we will come back to 0, 0. We will start from line number 9 here and we will come back to 0, 0. And now we go towards its right. So when we go towards right, column increases. So here it will increase from 0 to 1 because we are going to the right direction, and row remains the same. So we execute this DFS and we leave this DFS at line number 10. There will be one more method on the call stack where row remains the same and column increases by 1 because we are going towards right. So now here you can see we are going to 0, 1. So we reach to this index which is 0, 1. So now we are within the boundaries of this matrix. So first 4 condition comes out to be false. This condition in the visited 2D array we have false. So this comes out to be false. And we know that at this index 0, 1 we don't have 0. We have 1. So therefore this condition also comes out to be false. So here you can see all the conditions came out to be false because we are within the boundaries. This value is not 0 and it is not visited. So it denotes that we have found an adjacent land which is being denoted by 1 and it is not visited. So first thing we do is we mark this as visited like this. And as we know that how DFS works, now for this vertex we will visit its adjacent nodes recursively. So now for value 0, 1 we will apply the DFS into 4 directions. So for this node first we'll go to left. We'll update line number 8 here. We will have one more method on the call stack. And as we are going on the left, column decreases. So column was 1, it decreased to 0. Row remains the same. So it means we have reached back to this land. Here you can see this node is within the boundaries of this grid, but if you look in the visited 2D array at row 0, 0, we have already visited this node because we are actually applying the DFS from this node only. We reached to this node and then we are coming back to this node. So we have already visited this node. So though this condition is false that we are encountering a land here, but we have visited this land already. So we'll simply return from this DFS, and this DFS will be removed from the call stack. Execution point will reach here, and to whichever DFS we were, we simply start from line number 8 here. We know that we were at 0, 1. So we were at 0, 1. So we return back to this node like this. And for this node, we just went to its left and came back. So now we'll go up. So first we update line number here because we are leaving this DFS. So now there will be one more method on the call stack. We are going up. So row will decrease. So from 0 it will become -1 like this. It means from 0, 1 now we have went to outside the boundaries of this matrix. So it means row is less than 0. So we need to return back because this condition comes out to be true. It means we are returning back to 0, 1 now. So this method will be removed from the call stack. We will reach to this method. We simply start our execution from line number 9 here. And at that moment row was 0 and column was 1. So we come back to this 0, 1 like this. So with this line we went up and then came back. So now we'll go towards right. So first we update the line number here, which is 10, because we are leaving this DFS. We are going towards right now. So there will be one more method on the call stack. As we are going on the right, column will increase. So from 1 it becomes 2. Row remains the same. So we are going towards right. It means we are going to 0, 2 here. And here you can see that we have found a water. So we need to simply return from this node because we have found water. And this is actually stopping this land to go beyond that. So we have encountered a water, so we'll simply return back. This method will be removed from the call stack. Execution point will reach here. We'll start our execution from line number 10 because we had left at line number 10. So we come back to 0, 1 because when we left this DFS we were at 0, 1. So we came back to 0, 1. So we visited left, up, right. So now we'll go down here. First we update line number here, which is 11. Then we will call this DFS again. There will be one more method on the call stack. If we are going down, row will increase. So from 0 it become 1. Column remains the same here. So we'll simply return because we have found the water here, which is 0. So we simply return back. This method will be removed from the call stack. Execution point will reach here at line number 11. At that moment we were at 0, 1 because now we are returning to 0, 1 back like this. So here you can see that for this node we went to its left, up, right and down. And after that we are done with this node. So after 11 this DFS will end. It means this DFS will end. So this method will be removed from the call stack and we go back to its previous DFS that we had left at line number 10. So we start from line number 10 and the value was 0, 0. So we are actually returning back to 0, 0 like this because we went to its right when we visited 0, 1. Here you can see that we executed DFS, we went to right and now we are coming back. So we have came back to 0, 0. So for this node, now we need to go down. So we'll update the line number here, 11. There will be one more method on the call stack. We are going down, so row increases. So it became 1 from 0 and column remains the same. It means we are going down. We came here. We are within the boundaries of this matrix. So first 4 condition comes out to be false. This land is not visited because value is false here and we have actually came to a land. So it means all the conditions comes out to be false. It means we are on a valid land which is adjacent to our previous land. So first we mark this land as true. So in the visited array at 1, 0 we put a value true like this. So we are putting this value true because in case if we return back to this node, we can come to know that we have already visited this node. Now friends, there could be a possibility that here we have 1 or here we have 1. So as we have reached to a land, now we need to apply the DFS to its adjacent nodes as well, because let's say if here we have 1 and then we have 1, then 1, 1, 1. So this land would have expanded till the last row and last column. So we need to apply this DFS now for this node in the 4 directions, left, up, right and down, to figure out whether this land is also surrounded by any other land or not. So now first we go to the left, so it means we are going in this direction now. So we update line number here 8. There will be one more method on the call stack where column will decrease, it becomes -1 and row remains the same. So it means we have went outside the boundaries of this matrix where column became -1, which is less than 0. So this condition comes out to be true, and as it is a OR in all the conditions, so if any condition comes out to be true, we simply return. So we simply return back to 1, 0 here. So this method will be removed from the call stack. We reach here at 1, 0 and we start our execution from line number 8. We just went to the left of 1, 0, so we are returning back to this node like this. So now we actually go up. So first we update line number here, which is 9, and then we are leaving this DFS. So there will be one more method on the call stack. We are going up, so row decreases. So from 1 it became 0. So it means we have reached here. So friends, here you can see that from this node we actually went here. So for this node, this one is also adjacent. So when we reached here, we know that we have already visited this node. So how we can figure this point out is, we can simply look in the visited array at 0, 0. We find a value true. So we are in the boundaries of this matrix. So first 4 conditions comes out to be false. But here you can see this condition, visited row column, this comes out to be true. So it means this land is already visited. We need to come back. So we simply return from this DFS. Execution point will reach here. We'll start from line number 9. And at that moment we were at 1, 0. So we come back to 1, 0. Because we are returning from 0, 0 back to 1, 0 here. And for this node we just went to up and came back. So now we go towards right. We update line number 10 here. There will be one more method on the call stack. So we are going now towards right here, where value of column will increase. So from 0 it became 1. We reached here. So in this DFS we are now at 1, 1. So we reached here. Now here we have encountered a water. So this condition comes out to be true. So we simply return. Because as we are encountering water, we need to return back. This method will be removed from the call stack. We come back to previous DFS. We start from line number 10. So we come back to 1, 0 like this. And now we go down. We just visited the right. Now we go down. So we first update line number here, which is 11, that we are leaving this DFS at line number 11. And now there will be one more method on the call stack. We are going down, so row will increase. So from 1 it became 2 and column will remain same. So with this DFS, now we reach to 2, 0 here. And as we have encountered a water here, so this condition comes out to be true. So we simply return back. So this method will be removed from the call stack. Execution point will reach here. We start from 11. And at that moment we were at 1, 0. So we come back to 1, 0 here. And for this node, we visited its left, up, right and down. And after that, this DFS will end. So for this node, we have visited its all the directions. So this will be removed from the call stack. We reach back to this DFS. We start from line number 11 and at that moment we were at 0, 0. So we come back to 0, 0 here. So here you can see that we started our DFS with this index 0, 0 and after traversing recursively all its adjacent node, we are returning back to 0, 0, which means that we have visited left, up, right and down. So the last direction we visited was down here and we came back. So after this line, this DFS will end, which signifies that we have visited all the lands connected horizontally and vertically. So we'll return from this DFS. So this DFS will be removed from the call stack. And we will simply go back to the method which called this DFS at the start. Here. And this is our condition as of now, that we have visited this one and this one. And we have found one connected component which is our island. So we'll increase the number of islands value because we have just found one island. So it becomes 1. Moving ahead. So now we are done with this node 0, 0. So we'll increment j. J becomes 1. We go to 0, 1 here. Because there could be a possibility that from here only another land starts or another island starts. So here first we check that whether the value is 1 or not. So here you can see the value is 1. But we also check that whether we already visited this land or not, because in our previous DFS we started here, then we visited this land and then we visited this land. So we know that we have already visited this land because value is true here. So therefore this condition comes out to be false because we are going only to those lands which are not visited. Here we have just visited this land in our previous DFS. So this condition will prevent going into another DFS call. So the condition in if block comes out to be false. Now we'll increment j. J becomes 2. So we are on 0, 2. Here you can see that we have landed on water. So it means we need to skip this element because we need to identify an island. So an island can only be found by a land which is 1. So if we are landing on water, it means that we need to skip this node and proceed ahead. So this condition comes out to be false because value is 0 here. So friends, here you can see that now we will go somewhat fast because whenever we encounter 0, we'll simply move ahead because these conditions will come out to be false. So we'll increment j. J becomes 3. We'll simply skip because we have landed on water. So now we'll increment j. So j will go beyond the boundaries of this matrix. So this condition comes out to be false. So this for loop will terminate. And the execution point will reach to the upper for loop. Because now we need to process the second row. So first we increment I. I becomes 1. So now we are processing this row. We are done processing this row. So we start from j equal to 0. So it means now we are on 1, 0. We know that we have found one land denoted by 1. So this condition is true. But we also know that we have already visited this land. So this condition comes out to be false. We'll increment j. J becomes 1. So now we are processing this value at 1, 1. So friends, here you can see this 0, 0, 0, 0. This phi will be skipped because we are landing on water. And as we are traversing this matrix, we will now encounter 5 waters. So we will go over this somewhat quickly. So this is a basic traversal of matrix. We have found water. So this condition comes out to be false. J becomes 2. This condition comes out to be false. J becomes 3. This condition comes out to be false. So now we are done processing the row 1. So we go to row 2. We'll increment I. I becomes 2. We'll start with j equal to 0. So we are at 2, 0 now. This condition comes out to be false. J becomes 1. This condition comes out to be false because we are landing on water, so we need to skip it. J becomes 2. So friend, now here you can see that we are on a particular land because this condition comes out to be true. And if we go to the visited array at I, j, which is 2, 2, here, we have a false value. It means we haven't visited this land. So both the condition comes out to be true. So it means as we have found a new land, we'll apply DFS on top of it to actually figure out its adjacent lands horizontally and vertically. So this DFS will be called with 2, 2. So on the call stack there will be DFS with row as 2 and column as 2, like this. So now we'll apply the same algorithm which we applied to this node. We are in the boundaries of the matrix. Visited is false and the value at this row and column is 1. So all the condition comes out to be false. So first we mark this land as visited by assigning a value true to the visited 2D array at 2, 2. Now we simply go to left of 2, 2. So when we go left, row remains same and column decreases. So we are leaving this DFS. So first we update line number here, which is 8. Now on the call stack, there will be one more method by name DFS, where row remains the same and column decreases. So we are at 2, 1 now. It means we are going towards the left of 2, 2, which is 2, 1. Here we know that we have landed on water, so we simply return. So this DFS will end. Execution point will reach here. So this DFS we had left at line number 8. So we start from line number 8. We have encountered the water, so we simply return. So we come back to 2, 2, because at this moment row and column were at 2, 2. So we come back to 2, 2. Now we go up. So first we update the line number here, which is 9. There will be one more method on the call stack. If you are going up, row decreases, column remains same. So row became 1 from 2. It means we have went here 1, 2. Here you can see that we have landed on water again. So we'll simply return. So we come back to 2, 2 now. This method will be removed from the call stack. We'll start from line number 9. We come back to 2, 2. And now we are going towards right. So first we update line number 10 here. There will be one more method on the call stack. If we are going towards right, row remains same and column increases. So from 2 it became 3. And we are going to 2, 3 now. Here. Here you can see that we have again found a water. So we simply return to 2, 2. We start from line number 10. We return back to 2, 2. And now we simply go down. So first we update line number 11 here, because we are leaving this DFS at line number 11. There will be one more method on the call stack. We are going down, so row will increase. So from 2 it became 3 and column remains the same. We are at 3, 2. And here you can see we have found a water. So we'll simply return back to 2, 2. This method will be removed from the call stack. We return to this DFS at line number 11. So we return back to 2, 2. And here you can see that we have visited all the adjacent nodes of this land. So this DFS will end now because there are no more lines to execute. So now we'll go back to the method which actually called this DFS at 2, 2. So this is the condition. So here you can see after we finish visiting all the lands adjacent to this land horizontally and vertically, we know that we have found one more island. So we'll increase the value of number of islands, which becomes 2. Now we'll increment j. J becomes 3. So here you can see this is a water, 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 water. So for the next 4 iteration we'll simply skip these values. So we'll go over this quickly. This condition comes out to be false. Now we are done with processing the row 2. So this for loop will terminate. We'll increment I. I becomes 3 because now we are processing the last row. We'll start from j equal to 0. This condition comes out to be false. J becomes 1. This condition comes out to be false. J becomes 2. This condition comes out to be false. And at the end j becomes 3. That we have found a land which is actually not visited because value is false. It means that now we can apply DFS on top of this land. So we'll call DFS. We pass the value of I and j, which is 3, 3. There will be one method DFS with row as 3 and column as 3, like this. We are within the boundaries of the matrix and we haven't visited this land. So all the condition will come out to be false. So we will first mark this land as visited by assigning a value true in the visited array at row 3 and column 3. And now we'll perform the same steps. We go left, up, right and bottom. So we'll go over this quickly because we know that we are performing the same steps what we did here and here. So we need to keep this thing in mind when we are going to the different directions. So first we are going left, so we update line number here. There will be method on the call stack. We are going left, so column decreases. So from 3, 3 it became 3, 2. We have reached here. Now this is a water, so we'll simply return back to 3, 3. We start from line number 8. We come back to 3, 3. And now we actually go up. We update line number here. And there will be one more method on the call stack. As we are going up, so row will decrease. So it became 2, 3 now. We reached here. This is the water, so we return back to 3, 3. We start the execution on line number 9. We come back to 3, 3 because value of row and column is 3, 3 in this DFS. Now we go towards right. We update line number 10 here because we are leaving this DFS and there will be one more method on the call stack. We are going towards right, so column will increase. So here you can see that we have gone outside the boundaries of this matrix. So value of column is actually equal to grid of 0.length, which is equal to 4. It means we are outside the boundaries of this matrix. So we'll simply return. We return back to 3, 3. We start the execution at line number 10. Like this. And now we simply go down. So we update the line number here, 11. As we are going down, row will increase. And we have went outside the boundaries of this matrix. So here, now value of row is equal to grid.length, which is 4. So we'll simply return. We start the execution from line number 11 and we return back to 3, 3. And after that there are no lines to execute. So this DFS will be removed from the call stack. And we go back to a method which called as DFS at row and column 3, 3. So this is the condition. So we know that we have visited one more island. So we'll increase the value of number of islands, so it becomes 3. We'll increment j, so j will go beyond the boundaries of this matrix, so this for loop will terminate. And as we have visited the last row, we'll increment I, so I will also go beyond the boundaries of this matrix. It means we have visited a complete matrix. And at the end, after visiting all these islands, we'll simply return the value 3, because there are 3 islands, this, and this. Here you can see we have visited this, and this. So friends, this was all about that how we can solve the number of islands problem. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.
Hello everyone. So in this video we will discuss about hashing data structure and we will see a basic introduction to hashing. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So what do we mean by hashing? So before discussing that, we will see that why we actually need a concept called hashing. So usually when we need to perform any search operation, we have few options such as linear search, where what we do is, let's suppose we are given with this array of 10 elements. And let's suppose we want to search for a particular element, for example let's say 10. So in linear search what we do is, the value which we want to search, which is 10, we compare it with each and every element of this array. And when we reach here, we find that 10 is there in this array. And we simply say the value 10 is found in this array. Also, let's suppose if we want to search for a value, let's say 20. So what we need to do here is, we need to compare 20 with each and every element of this array. And after comparing with the last element, if we don't find 20 in this array, then we simply return that 20 is not found. So here the problem is, in case if the key which we want to search is not present in this list or array, then the time complexity basically goes to O of n, because we need to compare the key with each and every element, and then only we can come to know that whether the key is present in this array or not. So this is one problem with the linear search. The other form of search we have is binary search. Now in binary search what we have is, let's say we are given with this array of 10 elements. In binary search, the array we have is already sorted. So here you can see, here the elements are sorted in ascending order. So when the elements are sorted in ascending order, we basically use this property to make this search quicker. So for example, let's say if we want to search for an element 8. So here we don't compare the key which we want to search with each and every element of this array. As we know that the array is already sorted, we take the lower index which is 0, we take the higher index which is 9, and using these two indexes we try to find the mid index. So here we simply do 9 plus 0 divided by 2, which give us 4.5, and if we take the integer value, the mid value will come to 4. So what we do is, whatever the value is at index 4, which is 10, we simply check that whether 8 is less than 10 or greater than 10. We know that 8 is less than 10, so it must be lying somewhere to the left of mid index, because here we know that the elements of array are already sorted. So what we do here is, we simply discard the right sub array completely, because we know that searching in elements after 10 will never give us 8. 8 will only come before 10. So we simply discard the right sub array. So after discarding the right sub array, our array becomes from 0 to 4, where we take 0 as the lower index and 4 as the higher index. We do 4 plus 0 divided by 2. We get 2 as mid index. So whatever the value is at mid index, which is 5, when we compare 5 with 8, we know that 8 is greater than 5. And as the array elements are sorted, we simply discard the left sub array because we know that 8 must be lying to the right of 5. So now after we discard the left part, our array becomes of 3 elements from 2 to 4, and then we again find the mid index. We do 4 plus 2, which is 6, and if we divide it by 2 we get 3. So whatever the value is at third index, which is mid, we see it is 8. We come to know that we have found our key, and here you can see that compared to linear search, binary search works pretty much faster when the array elements are sorted. So friends, with binary search, with each iteration we simply discard half of the array because we know that the element which we want to search can be found at 3 places. One is at the mid index, or it can be on the left sub array or on the right sub array. So if it is on the left sub array, we simply discard the right sub array, and if it is on the right sub array, we simply discard the left sub array. So here you can see on each iteration we are discarding half of the array. So the time complexity of binary search comes out to be O of log n, which is pretty much faster than O of n. But here the problem still remains, which is there any data structure or is there any search technique which give us a time complexity of O of 1? Because searching an element in linear search takes O of n, which is not feasible for the search operation, and for the binary search takes O of log n. But here we have this constraint that element should be sorted, which is usually never the case. We have always elements in unsorted form, and if we want to sort them, we need to apply sorting algorithms whose complexity can reach to n log n. So after we sort the elements, then our search becomes faster and we get O of log n. So how can we achieve a time complexity of O of 1? So if you see, one solution is if we take array data structure. Now why array? Because array can be used to provide O of 1 searches using indexes. So let's suppose if we are given with these elements 6, 1, 3, 5, 9, 7, and let's say if we want to search in these elements and we want that the search should be of O of 1 time. So what we can do is, among these elements we will see which is the highest element, which is 9. So what we can simply do is, we can create an array whose last index is 9, which means we create an array of 10 elements where the last index is 9. And what we do here is, we take 6 and we store 6 at 6th index, 1 at first index, 3 at index 3, 5 at index 5, 9 at index 9, 7 at index 7. So we simply store all these elements into their respective indexes in an array. And let's suppose if we are given, let's search for a value 3. So what we can do is, we simply go to third index of array by accessing the array with index 3, and we see whether 3 is there or not. So this operation takes time complexity of O of 1 because we can access array elements directly. So here at third index we see that there is a value 3. So our answer is found. And let's say if we want to search for 0. So what we do is, we go to 0th index and we see there is no value. So our answer is not found. So friends, here you can see that arrays can give us a time complexity of O of 1 when performing the searches using their indexes. So the time complexity of this scenario will be O of 1, which is pretty much fast. So let's suppose we take one more example. Let's say we are in a classroom and we have this 30 students. So what we can simply do is, we can assign a roll number to each and every student, and we can create a data structure which is array of size 30 where last index is 29, and we can assign the indexes to each and every student. And let's suppose we are storing a student object on each and every index. So here when these students are sitting in a classroom, the teacher can directly go to a particular seat, let's say 5, and let's say the teacher has a device where she can directly type 5 and gets the information for the student that the student name is John. These are his marks in particular subject and all of the information for the student John. And similarly, if she searches for 29, she can get the information for Tina. So here also we can use array data structure and we can get the time complexity of O of 1. So to this type of storage we simply call direct addressing. Moving ahead, now whatever the example we saw, their array was a perfect data structure for searching in O of 1 times. Now where the problem will still arise is, let's say if we want to store Aadhaar card number which is of 12 digits, or you can also take an example of storing the social security number in an array. So here if you see that Aadhaar card number is of 12 digits and it gives an identity of a particular citizen of India based on his Aadhaar number. So the problem is, if we take an array to store the Aadhaar card number, then if we want to store this big number into an array which is nothing but direct addressing with its index, then there would be a huge array to store all the Aadhaar card numbers. So this is one problem, that we need to create such a huge array where the Aadhaar card number matches the index of that array. And the second problem is, let's say if the Aadhaar card number is designed with 12 digits and we have created a huge array to store the Aadhaar card number, and let's suppose we have only distributed 10 to 12 Aadhaar card to the people, and if we try to store those Aadhaar card numbers into the array, then after storing we will see that most of the memory of the array elements will remain unutilized and wasted. So this is the problem with arrays, where we can't use direct addressing because we need to store such a huge number. So to basically address these problems, hashing was introduced. Now what is hashing? So here you can see that hashing is a technique which is used for storing, retrieving and removing the information as quick as possible. And how do we perform the hashing is, here it is a process of converting an arbitrary size key into a fixed size value. So here what we are simply saying is, let's suppose we have our keys which are huge, let's say the Aadhaar card number or social security number. So what we can do is, we can't directly store the key into the respective indexes of the array because that problem we discussed in our previous slide. So what we do is, we take that particular huge key and we try to convert that key into a fixed size value. And how we perform this conversion is, this conversion is done by a special function which we call hash function. So we will discuss hash function in our upcoming videos. But for time being, we can think that let's say if we have array of 1000 elements and we want to store a 12-digit Aadhaar card number. So what we do is, we take the Aadhaar card number which is of an arbitrary size or a huge size, we pass that number to our hash function, and this hash function will give us a fixed size value. Let's say if we are taking the size of the array where we want to store the Aadhaar card number is of 1000, then it will give us a fixed size value between 0 to 1000, and we can simply use that fixed value and store that particular Aadhaar card number. So this conversion of a large key into a fixed small size is done via hash function. So we will discuss this hash function in detail in our upcoming videos. So for time being, you can simply think that hashing is a technique which is used for storing, retrieving and removing the information as quick as possible, and the operation which hashing supports, such as storing, retrieving and removing an information, have average runtime complexity of O of 1. So friends, in this video we saw that why we actually require the hashing technique, or why we require a hashing data structure. Because we need average runtime complexity of O of 1 when we want to store, retrieve or remove any particular piece of information. So in our next video we will see that what are hash functions and how it helps in converting a huge size key into a fixed size value. So friends, in case if you find this information useful, then please like this video, and if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day. Hello everyone. So friends, in our previous video, we discussed about what is hashing. So in this video, we will see that what are hash functions. So friends, before discussing about hash function, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So in our previous video, we saw a basic definition of what is hash function. So a hash function simply takes an arbitrary size key and provides fixed size value, also called as index. So here, using a hash function, we can take a key of any size, and once we pass that key to hash function, it returns us back a fixed size value, which we also called as index. Now this fixed size value is basically small and can be taken up as index, and using that index we can store the key which we want, and also by using this hash function we can even retrieve that key. So we'll see the importance of hash function more in our upcoming videos. So for this video, you can simply think of hash function is, let's suppose we are given key of any size. What we do is we simply pass this key to our hash function, and whatever key we passed, hash function return us an index which is of fixed size. Now using this index value, what we actually do is we simply store this key into a smaller size data structure, and we can perform storing, retrieving and removing of this key very fast. We will see those implementation details later in upcoming videos. So for timing, you can simply think that to our hash function we pass in a key and it returns back as a smaller fixed size value index. We will see its usage in greater detail in our upcoming videos. So friends, a hash function can be of any type. You can basically write your own hash function where what you do is you simply take a key and it should return you back a smaller fixed size value, so that you can use that fixed size value and store that huge key into a data structure, so that the retrieval, storing and removing of that particular key becomes faster. And how does hash function help us in achieving a time complexity of O of 1? We will see later in upcoming videos. So one such typical hash function which is mostly used in hashing data structure is modular hash function. So what this hash function does is, the modular hash function simply takes a key and a size. Now what it returns is remainder by dividing key by size. So usually the remainder which hash function returns us back is used as an index to store the key in an array of the provided size. So here you can assume that key has a large value which cannot be taken up as an index of an array, which we discussed in our previous video, that it creates the problem. So what hash function will help us in doing is, let's say we take a smaller size array. So when we pass the key and the size, hash function will return the remainder by dividing key by that size, and whatever the remainder is returned, that remainder is taken up as an index to store the key in an array of provided size. So here you can see, instead of using an array for direct addressing, which we discussed in our previous video, here what we do is we simply take an array of smaller size, and let's suppose the key has a very large value. Now how we can store that key into the array of small sizes? We simply take the key, we divide the key by the size, and whatever the remainder we get, that will be taken up as an index to store this particular key. So let's see how modular hash function help us in storing large keys into a smaller size array. So here we usually take the hash function as h of key, which is the hash function which takes in a key and usually returns us back an index. And this hash function can be any implementation you provide, but here we are simply discussing the modular hash function. So here we take the key, we do modulus by size, which is key mod size. Now this modulus operator always returns us back the remainder when we divide the key by size. So here let's say these are our keys which we want to store. Now here you can see the keys are 5, 1, 10, 26 and 99. So we can't take an array of length 100 to store only 5 elements for the direct addressing. So what we do is we simply take a smaller size array, let's say of 10 elements. Now size of this array is 10. Now how we store these keys into this array is we take the key, we pass into the hash function. So here 5 modulus 10, which is 5 is the key, modulus size which is 10. So if we divide 5 by 10, we get remainder as 5 because 5 is not divisible by 10. So the remainder we get is 5. So here we simply take this key, go to the 5th index. Here this is the index which it returns. So we go to the 5th index and we store 5. Now we take 1. So 1, when we divide 1 by 10, we get remainder as 1. So we take this key, go to index 1 and store 1. Now we take key as 10. So when we divide 10 by 10, we get remainder 0 because 10 is divisible by 10. So here you can see that here 10 cannot fit into this array if we take it as a direct index. So this hash function is helping us to get a smaller index. So when we do 10 mod 10, we get 0. So here what we do is we simply go to the 0th index and we store 10 here. Similarly, if we take a value 26, if we do 26 mod 10, it means if when we divide 26 by 10, we get the remainder as 6 because the 20 gets divisible by 10 and we get the remainder value as 6. So here we go to 6th index and we store 26 there. And similarly when we take 99, when we do 99 mod 10 or when we divide 99 by 10, we get remainder as 9. So here we go to 9th index and we store the value 99. So friends, here you can see that here instead of doing the direct addressing of the key with array index, we are using a simple hash function, and whatever is the value of key, we don't care. We simply divide it by the size, and whatever the remainder comes out, we simply take that as an index and we store those values at that particular index. So friends, here we used the modular hash function to store these key elements into an array of fixed size. So similarly, we can search a particular key based on our hash function. So if we take this example, let's say if we want to search that whether 26 is present or not. So when we were storing this value in this array, we used modular hash function. So similarly, when we want to search, what we do is we take the value which we want to search, we pass to our hash function, it returns us back an index. We simply go to that index and we simply see that whether that key is present or not. So here in this case 26 goes to the hash function and the hash function returns us the remainder as 6. So we go to the 6th index, we see there is a value, we compare this value with the key which we want to search and we see that 26 is present. So now here you can see the hash function is helping us store the keys which are very large in size, and here you can see that for storing 99 we didn't take an array of 100 size elements, we simply took an array of 10 elements and we stored these values in the array. So friends, here hash function can be implemented in many different ways. So one of the most popular hash function which we saw here was modular hash function. Now friends, one more problem arises here is as we are mapping large keys into a smaller fixed size array, there could be a possibility that let's say if we want to store one more value as 109. So when we do 109 mod 10, we get remainder as 9. And when we go to 9th index for storing 109, we already see that there is a value 99. So now there is a problem that what do we do with initially stored 99 value, because in array we can store only one value at a time. So we will see these problems in greater detail in our upcoming videos. The idea which you are seeing here is using a smaller array and storing the larger size keys. This data structure, if we implement in such a way using a hash function, such data structure are basically called as hash table. So in our upcoming video we will see what is hash table. So friends, I hope you find this information useful, and in case if you find this information useful, then please like this video, and if you are new to my channel, then please subscribe to my channel so that you never miss any update. Hello everyone. So in this section we will discuss about a basic introduction to hash table. In our previous video we discussed about what is hashing and what are hash functions. So in this video we will look into a data structure which is hash table, and we will see the concepts which we discussed in our previous videos like hashing and hash function, and we will see how they are used to implement a hash table. So before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. In one of our previous video, we discussed that array can be used to store, retrieve and remove an information with a time complexity of O of 1 based on indexes, but we also saw that array had a limitation while implementing the direct addressing strategy via indexes. So we introduced the concept of hashing. Now based on those concepts, when we implement a hash table, we basically take a generalized form of an array. So internally the data structure for implementing hash table is pretty much an array, but it is used with the concepts of hashing and hash function. Now what do we do with the hash table is, the data is stored in the form of key value pair. So in our previous video we discussed that how a key is passed to a hash function and an index is returned. So based on the index we store this key value pair. So basically in a hash table we simply put the data in form of key value pair, where we take the key, we pass it to the hash function, and hash function returns us an index. So this index is nothing but an index of an array where we simply store our key value pair. So this key can be a huge key, but our hash function takes that key and returns us back a fixed and a small value which is nothing but an index of our array. Now what we do is, we take that index and we store the key value pair in the array, and the primary operations which are supported by hash table are, first is the put, which takes in a key and a value. Now what does this operation does is, it adds the key value pair against a unique key. So here our key is unique, and if we try to add a different value with the same key, then that value gets updated and the older value will be removed. So here the key is unique because this key usually goes into this hash function, and based on the hash function calculation our index is returned, and on that index this key value pair is stored. Similarly, after storing, when we do get, then the value is returned for that provided key. So here this key goes into the hash function, our index is returned, and based on this index, whatever the value is stored in the array, that value is returned for that provided key. And the third operation is remove, where we pass the key. So what it does is, it removes the key value pair from the hash table. So these are the three primary operations supported by hash table. And here if you see, all these three operations use a hash function, and we will discuss all these three operations in greater detail in our upcoming lectures. These all three operations internally use the hash function, which takes in a key, returns as an index, and based on the index, put, get and remove operations are performed. So all these three operations are pretty much fast. the average running time of all this operation is O of 1. And if you see in our Java collection framework, we have a hashmap class which is pretty much same as the hash table class. So if we want to deal with key value pair, then we simply use hashmap class, and if we want to deal with only keys, then we use hash set. So here if we want to store any data in form of key value pair, then we simply take the help of hashmap class in Java, which is nothing but an hash table. But if you only want to deal with the keys and not with the value, then we simply use the hash set class. And the idea behind both the classes to store the keys remains the same, which we discussed here. So friend, let's see a simple hash table where we have provided with the hash function as key mod size, and size is nothing but the length of this array. So this array is the internal data structure to implement a hash table. So we simply call it a hash table only. Now let's say if we want to store these key value pairs in this simple hash table. So what we do is, let's say key is 5 and the value is John. So when we try to store this key value pair in a simple hash table, what we do is we take the key, we pass it to hash function, and this hash function returns us an index. So we simply go to that index and store this key value pair. So for example, 5 mod 10. So when we divide 5 by 10, we get remainder as 5. So this is our index, which is being returned by the hash function. So here we simply go to the 5th index and we simply store key value pair. So this array can be taken up as array of key value pairs, which can be our own type object which takes key and a value. Now if you want to store 1, Tom, so 1 divided by 10 gives remainder as 1. So here we go to the first index and we store 1, Tom. If we want to store 10, James, we do 10 mod 10. So we get remainder as 0. So we go to the 0th index and store 10, James there. For this key value pair, we get 6 as the remainder. So we go to the 6th index and we store 26, Tina. For this key value pair, so if we divide 99 by 10, we get remainder as 9. So we go to the 9th index and we store 99, Sana there. Now if we take the last value, 105 mod 10 will give a remainder as 5. So friend, this is a simple hash table. So now here you can see, if we try to go to 5th index, here you can see that we already have this value 5, John. Now the problem is, what should we do with this key value pair? So whenever this kind of situation comes where we are simply storing key value pair in a particular index and we already encounter a key value pair there, this concept in hash table is called as collision. Because now there is a collision between these two values, that what should we do? So friends, here you can see that these kind of situation usually arrives when we implement a hash table, because here you can see the size of this hash table is only 10 and the keys which we are trying to store is more than 10. So usually after storing few values, a hash table simply encounters this collision frequently. So this is a simple hash table. So in our future video we will see that how this hash table can be implemented to resolve these collisions. And also friends, there are strategies to resolve these collisions which we'll discuss in our upcoming videos. So friends, I hope you find this information useful. And in case if you find this information useful, then please like this video. And if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we discussed about a simple hash table. We saw what hash table does, and we also saw that when we use hash function to store the key value pair in a hash table, there will come a situation when there will be a collision. So in this video we will see that how we can resolve that collision using a collision resolution technique which we call as separate chaining. So in our previous video, we saw a simple hash table where we had this array of key value pair and of size as 10. Our hash function was key mod size, where we divided key by size, and whatever was the remainder, we used that remainder as an index to store these keys with its values in this array. So 5 mod 10 gave value as 5. So at the fifth index we stored 5, John. At the first index we stored 1, Tom. At the 0th index we stored 10, James, because when we do 10 mod 10 or when we divide 10 by 10 we get remainder as 0. On the 6th index we stored 26, Tina. On the 9th index we stored 99, Sana. And when we encountered a value as 105, so our hash function returned us a value as 5, because when we divide 105 by 10 we get 5 as the remainder. So when we went to 5th index, we saw that there is already a value stored 5, John at 5th index. So this resulted in a collision which we discussed in our previous video. Now in this video we will see that how we can resolve this collision using a strategy called as separate chaining. So friends, what we do in separate chaining is, in case if we encounter a collision, let's say when we try to store 105, on the 5th index we already found that value as 5, John. So what we do is, when this collision occurs, then at the 5th index we simply store both the values in a list. So that list is nothing but a simple linked list, where whenever we encounter a collision we simply add that element in that list which belongs to that particular index. So when we try to store many values which are huge in a small fixed size array, then there will be a situation where we encounter frequent collisions. So we simply add those elements into the list which belongs to that particular index. So when this list grows, it looks like a chain. So therefore, the resolution strategy is separate chaining, where with each index we create a separate chain or linked list to store the values which are getting collided. So let's see an example. So friends, in our previous videos, when we discussed about the linked list, we saw that how we can create a singly linked list, doubly linked list, and circular singly linked list. So if we take the example of singly linked list, we saw that there is a head from where basically the singly linked list starts, and each node basically points to the next node in the list, and the node which is at the end points to null. So here, instead of taking the array of key value pair, what we do is we take the array of hash nodes. So here if you see, let's say if you want to store 5, John, we first pass the key into the hash function, we get the index which is 5. So instead of directly storing at this index, we create a hash node. So this hash node is pretty much similar to the singly linked list node, where we had a data and a reference to the next node. So here we simply add one more value which is the key. So here our hash node has 3 attributes. One is the key, other is the value, and the third is the reference to the next hash node in this list or chain when some collision occurs. So this terminology you can simply take it as hash node. So in our upcoming videos we will discuss in greater detail what is hash node. Now let's say if we want to store 1, Tom. So at the first index we store 1, Tom in a form of a hash node. At the 0th index we'll store 10, James. And similarly the other values. But when we encounter 105, Mary, so our hash function is returned a index as 5. So here when we go to index 5, we see that there is already a hash node available having key as 5, value as John. Now here we have encountered a collision. So what we do is, as this hash node can be treated and converted into a list or chain, what we do is we can use its next reference and we can simply store 105 as key, value as Mary, and its next is pointing to null. So here whenever we encounter a collision, we keep on adding those elements in this chain, which we also say that it's a form of a linked list. So by separate chaining technique, we can resolve these collisions and we can store the values in the form of a linked list when any collision occurs. So we'll see the importance of this hash node and this linked list in our upcoming videos when we will implement a hash table using the separate chaining technique. So friends, I hope you find this information useful, and in case if this information is useful to you, then please like this video. And if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video we will discuss that how we can represent a hash node in a hash table. So in our previous video we discussed about one of the collision resolution technique, which was termed as separate chaining. And when we discussed about the separate chaining, we saw that how we can remove the collisions via a hash node and create chains where one hash node is pointing to other hash nodes. So let's see the structure and representation of a hash node in a hash table. But before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So here, a hash node class in hash table consists of 3 data members. Now the first one is the key. So the key is basically a unique value which helps us in storing the data, and here this case simply represent a generic type in Java. The second data member is value, which is the actual data which is being stored in a hash table in a location which is being computed by the key and the hash function. So here V simply signifies the generic type, it can be any type. So K and V can be any type. And the third data member is hash node next. So it simply refers to the next hash node in a chain of hash nodes. So chain of hash node is nothing but a list of hash nodes which help us in resolving the collisions where one hash node simply refer to the other hash node and they form a chain. So here these are the 3 data members, and if we see the symbolic representation of it, then hash node consists of 3 things: the key, which is unique and which help us in storing the value via hash function, and the hash node simply points to the next hash node in a list when there is a collision. So here hash node is very much similar to the list node which we discussed in our singly linked list videos. The only difference is, in the list node there was value and a reference to the next node, but here in hash node we also store the key. So we will see why these key value pairs are stored and how the primary operation in a hash table are implemented. And if we see a representation of it, it looks something like this, that it has a key, value and a reference to the next hash node in the list of hash nodes. So friend, this is how we actually represent a hash node in a hash table. So usually when we implement a hash table, then the hash node is nothing but a private class inside a hash table which help us in implementing the operations which are being performed by hash table. So those operations we will discuss in detail in our upcoming videos. I hope you must have liked this video, and in case if you are new to my channel, then please subscribe to my channel. Thanks, have a nice day. Hello everyone. So in our previous video we actually discussed about that how we can represent a hash node in a hash table. So in this video, we will see that how we can implement a hash table via separate chaining collision resolution technique. So here, in order to implement a hash table, I will be creating few videos which will be in series. So you can consider it as a part 1 of how to implement a hash table. But before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So friends, in order to implement a hash table, we will first look into some of the terminology which we will be using frequently in upcoming videos to understand different parts of hash table. So here, as we already discussed, that hash table is nothing but a generalized form of an array. Now let's say if we take the example of this array whose length is 10 and having index value from 0 to 9. So when implementing a hash table via separate chaining collision resolution technique, we discussed that we actually use the hash node. So here, in order to store key value pair, we simply take this as an array of hash nodes. So to this array, we simply call it as buckets and we denote it something like this, that each container at a particular index is termed as bucket, and this array basically stores hash nodes which has key value pair and a reference to the next hash node. And here we will also create a variable which would be number of buckets. So this number of buckets is nothing but the length of buckets array, which is also called as capacity of hash table. So for example, if we want to store a key value pair, let's say if our key is of integer type having value as 10 and a value of string type which takes in a value as James, and if we want to store at 0th index, what we do is the 0th index bucket simply points to a hash node storing key, value and has a reference to next node. So currently if there is only one element, then the next node will point to null. Similarly, let's say at index 1 if we want to store a key value, so it would look something like this. So here you can see that the way we are storing this key value pair is via hash function, which we already discussed in our previous video and which we will be discussing in our upcoming videos also. That here you can see the key is 10 and here let's say if we take the hash function as key mod the number of buckets, which is also the length of this array, then we get 10 modulus 10, which will give us a remainder 0, and whatever we get from the hash function, it is nothing but our index. So at the 0th index you can see that we have stored a key value pair like this, and similarly at 5th index we are storing a key 5 with a value as John. So here 5 when divided by 10 gives remainder as 5 only. So at 5th index we are storing a key as 5 and we usually term it as hash node, which we have already discussed. Now let's say if we want to store a key of 105. So when we divide 105 by 10, we get remainder as 5, which would be the value returned by our hash function. So if we go at index 5, we will see that there is already a value. So there is a collision. So in order to resolve this collision, we are taking help of hash nodes, because here you can see that the third data member is nothing but a reference to the next hash node. So here we can use the next reference to store this key value pair, which also corresponds to 5th index. So here when we store this key value pair in form of a linked list, the first element is simply treated as head, and this linked list is also termed as chains because we are discussing separate chaining collision resolution technique, and which is being implemented via chains. So here when a collision is encountered, the key value pairs are stored in a form of chain, and this chain can be the way you want to implement. You can simply add the newly inserted node at the end or at the beginning, or you can insert in a sorted form, like based on the keys, that 5 comes before, 105 comes later, and then 205, 305, something like that. So you can insert multiple key value pair, which is also called as hash node, in a way which you want. And similarly, we can store other values like this. Also friends, here you can see that length of this array is 10, which is also a value stored by number of buckets, and which is also called as capacity of our hash table. But here you can see that this hash table currently has 1, 2, 3, 4, 5 and 6 hash nodes. So the size of the hash table is 6 because it has hold 6 key value pairs, and the capacity is of 10. So this is the difference between the capacity and size. So when we talk about size, you can think of it the number of key value pairs inside a hash table, and when we talk about capacity, number of buckets or length of buckets, we are simply talking about the array length. So friend, these are the few terminologies which are being associated with hash table. So here, when we implement a hash table, you can see that we have 3 members here. One is the buckets array, which is of type hash node. The second value is number of buckets, which is also the capacity of our hash table. And the third variable is size, which is the number of key value pairs being stored in a hash table. So here you can see that hash table has a constructor which takes in a capacity. So when we create an object of hash table, we need to provide that what's the capacity of our hash table. It means we are providing that how many buckets the hash table will have. And here you can see that internally our hash table is using hash node class, so which we already discussed that it has a key and a value and a reference to the next hash node. So here you can see that we are taking key as integer and value as string. So this can be any generic type. So for the understanding and demonstration, I will be using the key as integer and the value as string. So basically most of the things remain same when we take any generic type of key and value. So here after taking key as integer and value as string, and the third member is a reference to the next hash node, which help us in storing the key value pair in a chain when the collision occurs. So here what we do is, at the start we simply call and create an instance of hash table, and let's say we pass capacity of 10 to our hash table. So it looks something like this, that capacity value is 10, and in the hash table constructor what we do is we assign the capacity to number of buckets, so it becomes 10, and then we create an array of hash node and we provide the capacity. So it looks something like this, that internal data structure is array of type hash node. It is being termed as buckets, and each compartment here you can see is a bucket which holds the hash nodes in a form of a chain. So here when we create this array, at the start every index or bucket points to null because there are no hash nodes currently into this array of hash nodes. So at the start size remains 0 because we currently don't have any key value pairs inside this hash table. So size is 0. So friends, in this video we saw an initial implementation of a hash table via separate chaining collision resolution technique. In our upcoming videos, we will see that this hash table has many operations where we put a key value pair, we remove a key value pair, and we can get a value based on a key. And there are many other operations which we will be looking into our upcoming videos. So this is just a basic and initial implementation of a hash table. So now let's go to our IntelliJ IDE and we'll simply code this part into the IDE. I hope you have find this information useful, and in case if you find this information useful, then please like this video, and if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we discussed about initial implementation of hash table. We saw the structure of hash table and we also saw that how it uses hash nodes internally. Now in this video, we'll simply code for the internal structure of hash table, and in upcoming videos we will see the different operations performed by hash table, and then we'll test its working in the main method. So here I have created one class as hash table. Now as we discussed, hash table will consist of few instance variables. One is array of hash node, which we term as buckets, and as it is using the hash node class internally, here we will create an inner class hash node. And as we already discussed that this hash node class will have three members. One would be our key. So this can be generic type. The second member would be value, and this can also be any generic type. So here for the demo purpose I am using the key as integer and value as string. And the third member would be the reference to the next hash node, and it will have a constructor which will take two things, key and a value. We will assign the key to this dot key and value to this dot value. So here the hash table consists of an array of hash node which we called as buckets. It also has an integer variable, number of buckets, which is also capacity, and it also has an integer type size, which is nothing but number of key value pairs in hash table, or number of hash nodes in a hash table. So basically in a hash table, the number of hash nodes represents the size of the hash table, and here we will provide a constructor to our hash table class. So when we will create an instance of hash table, it will simply call the parameterized constructor providing a default capacity. So here we will create one more constructor which will take a capacity. So here we can provide a customized capacity by calling this constructor, and if we call this constructor, it will create a hash table with a default capacity of 10. So here what we'll do is, to number of buckets we will assign the capacity, and now number of buckets is holding the capacity. So what we'll do, we will create the array of hash node whose length would be the value stored in the number of buckets. So here when we'll create the instance of hash table, let's say with the capacity we provide, so the number of buckets will hold that capacity, and the array of hash node will be of size which represents the number of buckets. And usually at the start, when there are no hash nodes in a hash table, the size will be 0. So this is what happens when we first initialize or create the instance of hash table. Now here you can see that this is the initial implementation of hash table. So in a hash table there are many operations. So one of the operation is that we want to know the size of the hash table, that how many key value pairs are there. So we provide a method as size, and here we simply return the size. One more method we provide is boolean. We check whether the hash table is empty or not. So we provide the method as is empty, and here if size is equal to 0, then we return true, stating that hash table is empty, and if size is not equal to 0, we are returning false. So friends, in our upcoming video, we will look into the primary operations of a hash table, which is put, which basically put a key value pair in a hash table. So the parameters are key and value. So this method basically takes in a key value pair and it simply puts that key value pair in our hash table. So we will discuss about this method in greater detail in our upcoming videos. So this is one of the primary operations. The other operation is get. So this method simply takes in a key and returns the corresponding value associated with it. So for time being, I am simply returning null to compile this method. So here, whatever the key value pairs are stored in hash table, so if we want to get any value associated with a key, we simply pass key here and we get its corresponding value. And one more method is remove, where we pass the key and that key value pair will be removed and the value associated with that key will be returned. So when we call get, the key value pair remains in the hash table. We only get the value out of the hash table. But when we do remove, that key value pair is completely removed from the hash table and its corresponding value is returned. So here these are the three main operations which are being performed by hash table, and all these three methods have a time complexity of O of 1, which is the average time complexity of a hash table. So friend, this was basic and initial implementation of a hash table. In our upcoming videos, we will see all these primary operations in great detail. So friends, in case if you find this information useful, then please like this video. And if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw a basic implementation of a hash table. We saw that hash table internally has an array of hash nodes, and we also saw the representation of an hash node which contains key value and a reference to the next hash node. So after creating a basic structure of hash table, in this video we will see that how we can put a key value pair in a hash table, and the strategy which we will be using for collision resolution would be separate chaining. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So here you can see that in our previous video, we saw a basic structure of hash table where we can create a hash table by providing in a capacity which also signifies the number of buckets in a hash table. So when we will call this line, here you can see the hash table internally uses an array of hash node which we call as buckets, and at the start each hash node at a particular index points to null. So friends, when we try to put a key value pair into the hash table, there are various scenarios which comes into picture. So the one scenario is when we take the key and we pass it to our hash function, then that hash function returns an index. So what we do is we simply go to that index and see that whether the hash node is pointing to null value or to any other node. So in case if it is pointing to null, then we simply insert key value pair in a form of a hash node, and we simply assign that hash node to that particular index. And in case if there are multiple hash nodes already present, then what we do is we first check that whether that key is already present in the sequence of hash nodes or not. And if the key is already present, then we simply update the value. We don't insert a new key value pair. And one more use case is, let's say if there are multiple nodes but the key value pair is not present. So what we do is we simply create the hash node from the key value pair which we want to insert, and we simply insert that hash node at the beginning of the list which is being formed by the hash node at a particular index. So currently you see all the hash node at a particular index is pointing to null. It means that each list which will be getting formed at a particular index starting node is null because there are no key value pair currently in this hash table. And at the start we have this number of buckets, value as 10 because we are providing the capacity to be 10, and currently as there are no elements, so the size is 0. Now let's say if we want to put a integer key and a string value, so here key is 105 and value is John. So at the start here you can see that key is very long and we need to accommodate this key somewhere in this small buckets array, so that when we put this key value pair and when we want to find that key value pair, it should be pretty much fast. So what we do is we simply pass this key to our hash function. So here we will take the example of modular hash function, which will take the key and will simply divide the key by buckets.length or number of buckets, and whatever is the remainder, that would be our index which will be written by this method. So we are using this method as our hash function, which is nothing but the modular hash function. So if we divide 105 by 10, we get the remainder as 5. So that 5 will be returned from this method and will be our bucket index. Now what we do is we simply access the hash node at this bucket index. So we go to the 5th index and we access this hash node. So currently you can see it is pointing to null, so which simply means that there are no hash node at this index, and as this is pointing to null, it will signify that head is pointing to null because at this index we are storing a hash node. So this hash node has next reference which can store other hash nodes, and if there are many hash nodes, then the first hash node is always our head. So this is also what we already discussed when we discussed about the singly linked list, where we normally had a list node with a value and a reference to the next node. So here the only difference with hash node is it has key value pair and a reference to the next hash node. So here you can see currently head is pointing to null, which means at this index there is no hash node. So what we can do is we can increment the size because we can directly put this key value pair here at this point. So first we create the hash node with key as 105, value as John, and when we create a new hash node, the next always points to null. So friends, now what we do is whenever we insert this key value pair or hash node into this buckets array, we can use different strategies. One would be that we can insert this node at the beginning of the list, or we can insert this node at the end of the list, or we can store this node based on some sorting logic such as the ascending order of the keys. So there are various strategies by which we can insert this node. So here we will be simply inserting this node at the beginning of the list. So friends, in our previous videos we have seen that how we can insert a node at the beginning of the list or a singly linked list. So here the concept remains exactly the same. Now here you can see as head is pointing to null. So at the first step what we do is, as we want to insert this node at the beginning of the list, and there could be a possibility that there are already nodes here, as currently there is no nodes, but there could be a possibility that head is pointing to a chain of nodes. So at the first step what we do is we simply assign node next value to head, because we want to insert this node at the beginning of the list. So if node next is pointing to head, then only this node will be at the beginning of the list. But currently head is pointing to null, so node next is already pointing to null. And then what we'll do is, this hash node which is pointing to the head will break this link and will try to point it to our hash node which we want to insert. So it would look something like this. This null value goes away and this node will be inserted. Now let's say we want to insert a key as 21 and a value as Tom. So the bucket index would be 1, because 21 mod 10 will give remainder as 1. So we simply access the hash node at index 1. We see it is pointing to null, so it is the same case like what we saw here. So we simply increment the size by 1 and then we put the key value pair in the form of hash node. So now here you can see that our hash table has 2 key value pairs, therefore the size is 2. Now let's say we want to insert a key value pair as 31, Sana. So here now this case is when there will be a collision. So how this separate chaining strategy comes into picture, we will see now. If we do 31 mod 10, we get remainder as 1. So our bucket index is 1. So we simply go and access the hash node at index 1. So we see that there is already a hash node at this index. So now here is a collision. So the way we insert this key value pair now is, we create the separate chains in a form of list. So that's why we have created this hash node which has a next reference, so that chain of nodes can be added with ease. So at the first step what we do is, to whichever hash node this index is pointing, that would be our head. So this is the first step. Now what we do is, as we don't know that how many nodes are there, and there could be a possibility that this key might exist already in this hash table. So what we do is, we start from the head, we compare its key with the key which we want to insert, and if that key is already present, then we simply update its value. We don't add a key value pair in this hash table, we simply update the value. So that case we will see later, but now here you can see head.key is 21 and the key which we want to insert is 31. So therefore they are not equal. So what we do is, we move head to its next node, because so let's say if there are 5 nodes, then we need to compare all the 5 nodes key with a key which we want to insert, because we don't want to insert a key which is already there. So we simply move head to its next node by assigning head.next to head. So now here you can see head is pointing to null. It means that this key is not present, and we can safely insert this key value pair at this index at the beginning of the list. And as we are adding this key value pair, we'll increment the size by 1 and then we'll bring head to its first position again. Now we'll create our hash node with this key value pair. So key is 31, value is Sana, and its next is pointing to null. So here now we are inserting this node at the beginning of the list. So what we saw already here. So at the first step what we do is, as we want to insert this node at the beginning of the list, we simply assign the value of head to node next, so that node next currently pointing to null should point to head. So it looks something like this, that now node next is pointing to head. And as node next is pointing to head, now we can safely break this link and we can assign this reference to our newly created node. So it would look something like this. This link will go away and now there will be a reference to this hash node from this index. So it would look something like this. So here there is a reference from this index to this node which we want to insert, and from this node there is a reference to the list of nodes which were already there. So currently there is only one node, but there could be a chain. So when we rearrange this, it would look something like this, that node is inserted at the beginning of the list and this node simply shifted by one position. So friends, now here you can see, let's say if you want to insert a key value pair where key is already present. So here we have these three nodes. We are trying to insert key value pair where key is 21 and value is Mary. So when we will divide 21 by 10, we get remainder as 1. So our bucket index become 1. So we simply access the hash node at this index and the first hash node is our head. And if there is a hash node already present, so now our first task is to verify that whether this key is already present in this hash table or not. So the way we do it is we do head.key, which is 31 here. We compare it with our key. So here you can see they are not equal. So what we do is we traverse head to its next node via this reference. So now we again compare head.key. So here you can see it's 21 and our key which we want to insert is also 21. So therefore they are equal. So what we do is, by this check we came to know that key is already present. So we don't have to insert a new key and increase the size. What we do is we simply update the value when we actually put a key value pair. So here instead of Tom, now the value will become Mary. So friends, this was all about this video. In our next video we will see the code for adding this key value pair in a hash table via animation. I hope you must have liked this video. And in case if you are new to my channel, then please subscribe to my channel. Thanks, have a nice day. Hello everyone. So in our previous video we saw a demonstration via an animation that how we can put a key value pair in a hash table using the separate chaining collision resolution technique. So in this video we will see the code for that and we will see its demonstration step by step with an animation. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So when we create the instance of hash table, this is what we discussed, that at the start what happens, that all the hash nodes on each index points to null. So which means that on each index we have a list of nodes and the starting node is basically our head, which is being pointing to null. And here you can see when we start, as we are providing the capacity of 10, it means we are creating the array of hash nodes with a length as 10, which is nothing but our number of buckets, and size as 0. So let's say if we want to put a key and a value as 105 and John. So we call the put method. We take key as 105 and value as John. So in our previous video we discussed the idea that how we can insert this key value pair. There are many use cases which we will be seeing later. So each use case at the start, what we do is we take the key and we pass it to our hash function, which gives us an index, and we take that index and we try to insert the key value pair in the form of hash node into this buckets array. So here you can see the get bucket index method is nothing but our hash function. So here we are using the modular hash function where we are taking the key, we are dividing it by number of buckets, and whatever is the remainder we are returning it from this method, which would be nothing but our bucket index. So when we pass 105 as key, and if we divide 105 by 10, then we get 5 as the remainder. So the bucket index is 5. Now what we do is, we try to access the hash node at this bucket index, so which is 5. So here you can see it points to a hash node having value as null. So here you can see it is referring to a null value. So it means at this index there are no hash nodes. So we can directly insert this key value pair. And as the starting node is pointing to null, we are creating a hash node by name head, which points to the first node at this index, which would be null. So head is pointing to null. So friends, here you can see that on each index there can be multiple hash nodes which are connected via the next reference which hash node has. And when we discussed singly linked list, we saw that the starting node is head. So here we are simply referring head as the starting node of the singly linked list, which will be formed by the chain of hash nodes. So here why we need this head is because in this while loop, at this particular index there could be a possibility that, let's say, there are many nodes. So in this while loop we are checking that whether the key is already present or not. So here you can see as head is pointing to null, it means that this key value pair is not present. So we exit from the while loop, and as key value pair is not present, we can simply add this key value pair in the form of hash node. So first we increment the size. So now size become 1. And now here you can see that, let's suppose at this index there could have been multiple nodes connected via next reference. So in this while loop there is a possibility that head might travel to some of the nodes to check whether the key is present or not. So after this while loop we bring back head to the first node by again assigning the hash node at bucket index. So head will again point to null. And now as we want to insert the node, so first we create the hash node with key value pair which we want to insert. So it would look something like this. Key is 105, value is John, and its next is pointing to null, and it is being referred by node. Now as we want to insert this node at the beginning of the list which is starting from head, what we do is we simply assign the value of head to node next, because we want to insert this node just before the head, which would be the beginning of the list. So node next should point to head, so we are simply assigning value head to nodes next. So currently node next is already pointing to null. And now as we want to insert this hash node in this buckets array, so at this index whatever the reference would be, we simply assign it to the node. So at the bucket index we are simply assigning the value of node. So it would look something like this, as node is pointing to this node. Now this hash node will point to the node which we want to insert. So here you can see that we have inserted one hash node, and from now onwards there would be multiple hash nodes on this index in case some collision will occur. So let's put one more key value pair where key is 21 and value is Tom. So size is already 1, key is 21, value is Tom. We first calculate the bucket index from our hash function. So when we'll call get bucket index, we pass in the key. So 21 when divided by 10 will give remainder as 1. So the bucket index will become 1. So now what we do is we simply try to access the hash node at this bucket index. So when we call buckets and we pass bucket index as 1, we are accessing this value. So here you can see that the hash node which it refers is null. So it means that there are no nodes in this list here. So head will point to null. Now we will simply check whether 21 is present in list of nodes at this index or not. So currently its head is pointing to null. This condition in while loop will come out to be false. And we know that this key value pair is not present. So we'll simply increase the size by 1 because now we are simply adding key value pair into this buckets array. So size becomes 2. And we already discussed that head might travel in this while loop to some of the nodes to simply compare whether 21 is present or not. So we simply bring back head to the starting of the list by again assigning the hash node at bucket index. So head will again point to null. We'll create the hash node with key as 21, value as Tom, and next pointing to null. And as we want to insert this node at the beginning of the list, first we assign the value of head to nodes next. So head is pointing to null. So here node next will point to null. And then we will simply add node into this bucket array by assigning the value of node at the bucket index. So it would look something like this. That now it will point to the node which we want to insert. So friends, here you can see that we have added 2 nodes now. Now let's say we want to add one more key value pair where key is 31 and value is Sana. So this is the case where we will actually see the collision and we will see the importance of this next reference. So key is 31 and value is Sana. We calculate the bucket index. 31 divided by 10 will give remainder as 1. So bucket index will become 1. We will access the hash node at this bucket index, which is at index 1. And to whichever node it is pointing, our head will point to that node because that would be our starting of this list. So head will point to this node. So now we'll see that whether 31 is present in this list of nodes or not, which is at this index. So currently you see head is not equal to null. So there could be a possibility that this key and value might exist already in the buckets array. So in the while loop we check whether head.key, which is 21, is equal to 31 or not, which is the key which we want to insert. So this condition comes out to be false because 21 is not equal to 31. It means this key value pair is not present for this node. So what we do is we simply traverse head to its next node because there could be possibility that this list can contain, let's say, n number of nodes. So we have to compare the keys for this n number of nodes by traversing head 1 position with each iteration. So we simply assign head.next value to head. So head.next is pointing to null. So now head will point to null. We check whether head is equal to null or not. So head is equal to null. So this condition comes out to be false, which signifies that this key value pair is not present in this buckets array. So we can safely insert a key value pair. So this condition comes out to be false and while loop will terminate. So rest of the steps remains the same. As we are now inserting this key value pair, we will increment size by 1. So size will become 3. And here you can see that head has already traversed into this list of nodes. So we again bring back head to the starting point of the list by again assigning the hash node at bucket index, which is our first hash node. So it would look something like this. Head comes back to the first position. And why we are bringing head to the first position is because we are trying to insert this key value pair in the form of hash node at the beginning of the list. So we usually need the head for that, which is nothing but our first hash node of the list. So here we are simply creating the node with key value pair. So key is 31, value is Sana, and its next is pointing to null, which is being referred by node. And now as we want to insert this node at the beginning of the list, which means let's say there are n number of nodes already here, and if we insert this node our node should come before head which is having key as 21. So the node having key as 31 should insert before the node having key as 21, which is nothing but our head. So what we do is we can't directly break this link and assign it to our node, because if we break this link, this chain will go away. So first we need to hold this chain. So how we can hold this chain is we assign the value of head to nodes next, because we want to insert this node before the head. So node next should point to head. So after this assignment, it would look something like this. That node next is pointing to a node to which head is pointing. And then we can simply break this link and assign it to our newly created node. So it would look something like this. This link will go away, and there will be a link from this index to the hash node which we want to insert. So if we rearrange this structure, it would look something like this. That the node which we want to insert is at the beginning of this list, which is just before our old head. So friends, now let's see one last use case where the key is already present. So here you can see if we put key as 21 and let's say value as Mary. So here if the key is already present, we don't put the key value pair in the buckets array, we simply update the value, and that we do with the help of this while loop. So let's see how. Key is 21, value is Mary. The bucket index will come out to be 1, because 21 divided by 10 will give remainder as 1. So bucket index is 1. So we simply access the hash node at this bucket index, which would be nothing but our head. So head will point to this node. We check whether head is equal to null or not. So here you can see currently head is not equal to null. So in the while loop, we simply check whether key 21 is already present or not. So that is done via this if condition. We simply check head.key is equals our key or not. So 31 is not equal to 21. So this condition comes out to be false. And we simply traverse head to its next node by assigning head.next to head. So via this reference, head has traveled to its next node, because we want to compare each and every key present at this index with our key, because there could be a possibility that 21 is already present in this list. So after this assignment, we again check whether head is equal to null or not. So we encounter one more hash node. So head is not equal to null. But now here you can see head.key is 21. It is equal to our key 21. So this condition comes out to be true, which means that key is already present in our buckets array. So we don't increment size here. What we do is we simply assign the value as Mary to head.value. So head.value is Tom, which will be updated by Mary. So here we are simply updating the value with the recent value. Old value is discarded, and the size of the hash table remains the same because key is already present. And after updating the value, we simply return from this method. So friends, here you can see that we saw various use cases that how we can insert a key value pair in the form of hash node in a hash table. We saw that how we can add a key value pair. We also saw that how we can update a key value pair. We also saw that what happens when there is a collision. And we also saw the importance of our hash function, that it can take a large key and provide us with a small index so that we can add this key value structure into this buckets array. So friends, I hope you must have find this information useful. And in case if you have find this information useful, then please like this video. And if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw that how we can put a key value pair in a hash table. We also saw different use cases which comes into picture when we actually put a key value pair in a hash table. So one use case is if the key is not present, we simply put the key value pair and increase the size. And the second use case is if the key is present, then we don't put the key value pair, we simply go to that key and simply update the value for that key. So if the key is present, then we simply update the value. We don't add the key value pair in our hash table because key is already there. So here before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here you can see that our hash table internally has an array of hash nodes which we call as buckets. It also has the capacity which is nothing but buckets.length, and it also has size which is nothing but the number of key value pairs in a hash table, or we can say the number of hash nodes which this array holds. We also saw that how internally hash table uses hash node class. So here it has key value pair and a reference to next node. So for our implementation we can take any key value pair, but here I have taken key as integer and value as string. We also saw about the size method which returns the number of hash node in our buckets array, and if size is equal to 0, isEmpty method will return true. Now we'll see the implementation of the put method which takes in a key and a value, and we'll see that how we can put this key value pair in our hash table. So at the start we simply provide simple edge cases where we simply check that if key is equal to null or value is equal to null, then here either we can return from this method or we can throw an exception. Let's say I throw illegal argument exception saying key or value is, let's say, null. So friends, here you can provide your own edge cases. So this is one of the simple edge cases I am providing. Now here, in order to put this key value pair in our hash table, the first thing we do is we try to evaluate bucket where we can put this key and value. So for that we will be using modular hash function. So here we first evaluate bucket index. So we will call our hash function whose name is getBucketIndex, and we pass our key to it because this key can be a very huge key, and in order to accommodate a huge key in simple or small size array, we need a hash function which takes in the key and returns us a smaller index value so that we can use that index and put this key value pair. So here I will be creating one private method as getBucketIndex, which will return us back the index value for this key. So it will take key, and here I am using the modular hash function. So we'll simply return key mod divided by number of buckets, and whatever is the remainder that will be returned from this method. Here we all can also use buckets.length instead of number of buckets. So after getting the bucket index, we will try to access the hash node which is at that bucket index. So we do buckets, we provide the index to it, and whatever the hash node it will return, it will be the head of the list which this index is holding. So that would be our hash node, and it will be head. So after getting the head, what we do is we can't directly put this key value pair in our hash table. We first try to search each and every element present at this bucket index, which is a list whose first node is referred by this head. So what we do is we simply provide a while loop, and we provide the condition as head should not be equal to null. So if head is not equal to null, then first thing we do is we try to search for our key. because in case if our key is present, then we don't put this key value pair in the hash table. We simply update the value corresponding to this key. So if head is not equal to null, we provide if condition. We check head.key equals the key which we have passed to this method, and if it is true, what we do is we simply update the value associated with this head node with our value. So here you can see that we are using this head to simply traverse the list at this index, and we are comparing the head key with the key which we have passed. So this case handles if the key is already present in our hash table. So after we update the head's value with the new value, we simply return from this method because we don't want to add this key value pair again. So if this condition is false, what we do is we traverse head to its next node by assigning head.next value to head. And this is important because let's say we have found a list of hash nodes which is being referred by head. So we need to compare this key with each and every node which is being referred by this head. So therefore we have provided this while loop, and as soon as we have found our key, we are updating its value and returning from the method without adding this key value pair. And if we are not finding it, then we are simply traversing it to its next node. So there would be a condition when head will reach to the end of the list. So at that moment this while loop will terminate. And at that moment if while loop terminates, it means that we never found our key. So we can now directly add this key. So what we do in the first step is, as we are adding this key value pair in the hash table, we will increase the size by 1. And also friends, here you can see that we can add this key value pair in the form of hash node, and that hash node we can insert the way we want. So here we will be inserting this hash node at the beginning of the list. So in order to get the beginning of the list, what we do is, there could be a possibility that in this while loop the head must have traversed. So what we do is we simply do this step again, and we make head reach to the first position by again assigning a hash node at this bucket index. So after this step, now head is pointing to the first node of the list, and we want to insert this hash node before head. So the first step we do is we create the hash node. Let's say we give name as node, and here we provide the key and the value. So here it looks something like this: key, value, and its next is pointing to null. So now how we can insert the node at the beginning of the list is, we simply assign head to node.next. Here you can see head is pointing to the first node of the list, and we want to insert this node just before that. So it means its next should point to head. So this is the first step. And the last step is hash node at this bucket index is currently pointing to head. So we need to break that link. So here what we do is we do bucket index, and we assign the value of node to it. So friends, here you can see the hash node at this bucket index was initially pointing to head, and as we inserted our node just before the head, now hash node at bucket index is pointing to node which we want to insert, and node next is pointing to the head in order to keep the rest of the nodes intact. So this is how we can put a key value pair in a hash table. Now let's see it's working in the main method. So here we'll create a main method. First we will create the hash table. Let's say we provide the capacity as 10, which means number of buckets will be 10. And now what we do is we simply put few values. Let's say we put 105 comma, let's say Tom. We put 21 Sana. And now what we do is, let's say we do table dot, we print the size. So if I run the code now, so here you can see it printed 2. Now what we do here is, we again call table.put, and here we are again providing a key which is already there, and this time we are providing the value as Harry. So if I run the code now, the size should remain the same. So here you can see it came out to be 2. And here if I debug this, so here you can see, if we open buckets array, that 105 was added at index 5 based on our hash function, where we divided 105 by 10 and remainder was 5. So if I open this, you will see the value as Tom and key as 105 and next pointing to null because we only inserted one value. If I open the index 1, here you will see that we have only one value as next is pointing to null, but here you can see the updated value is Harry. Initially it was Sana, now it became Harry, and here we simply updated the old value with the new value. And let's suppose if we add something like 31 Dinesh, and if I rerun it, so here you can see 31 divided by 10 will give index 1. So if I open index 1, you can see that 31 is inserted at the beginning of the list. And now here you can see initially it was 21. So now 31 got inserted before that. And its next is now pointing to 21. So this is how we actually put a key value pair in our hash table. I hope you must have found this information useful. In case if you find this information useful, then please like this video. And if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Hello everyone. So in our previous video, we saw that how we can put a key value pair in a hash table using the separate chaining collision resolution technique. And in this video, we will see that how we can get a value by key in a hash table. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So friends, let's suppose we are given with this hash table having buckets array where number of buckets is 10, which is the length of this hash node array, and the size is 3 because we have inserted 3 key value pairs in the form of hash node, and where we have detected a collision, there we have inserted the nodes in the form of chains. Here index 1 is nothing but our bucket index, which correspond to this list whose index is 1, which is being generated by the hash function by providing a certain key. So friends, here you can see the advantage of searching a value corresponding to a key in this hash table is it is very much fast. So for example, let's say if we want to search for key 105, so here you can see that the number of buckets in the buckets array is only 10 and we are storing a huge value in this buckets array. So after storing these values in the form of chains, there one question arises that how we can get that value, because storing is easy, but how we can get a value corresponding to a key, and that too very much fast. So here, as we discussed, the way we put the key value pair into the hash table using the hash function, the same way we use the hash function and deduce the index and try to search for a key. So here you can see that size is 3. So inside this buckets array there can be thousands of elements in the form of key value pairs. So how hash function help us in searching our particular key value pair fast is, let's suppose if we call table.get and pass in a key as 105. So via this method we are asking that please get us the value corresponding to this key. So here what happens is, key is 105. So at the start what we do is we pass this key to our hash function, and hash function provide us with an index and we try to search only in that particular index. So this type of searching makes our data structure very much efficient in searching. So here our hash function is, we pass the key. So here we can take any hash function which we like, but here I am taking this modular hash function where we are simply taking the key, we are dividing it by buckets.length or number of buckets, and whatever is the remainder that we are simply returning, which will be treated as our index. So if we divide 105 by 10, we get remainder as 5. So our bucket index is 5. So it means that this key can only present in the chain of nodes corresponding to index 5. So we simply access the hash node at index 5, and to whichever node it is pointing, that would be our head, because there can be multiple hash nodes in this list. So the first node is usually our head. So we simply point head to it, and now our task is to search for our key. So here we do head.key, which is 105. We try to compare it with our key, and if they are equal, then we simply return its value, which is John. So friends, here you can see there are so many elements, but with just simple hash function we quickly searched for our key. So this is the simple case where our first node became the key which we want to search. So after this, let's say we search for 21. So key is 21. If we divide 21 by 10, we get remainder as 1. So our bucket index will come 1. So we directly go to index 1 and we will try to access its first node. So head will point to the first node via this link. And here what we do is we simply compare head.key, which is 31, with 21. So they are not equal. It means for this node the key is not present, but there are other nodes in this chain. So what we do is we simply traverse head to its next node via this reference. So head comes to this position, and now we again do head.key. We compare 21 with our key and we see that we have found our key. So what we do is we simply return the value as Tom. Now let's suppose if we want to search for a key which is not present in this hash table. For example, if we call table.get and we pass the key as 88. So here we see 88 is not present. So key is 88. When we will divide 88 by 10, we get remainder as 8. So the bucket index becomes 8. We go to the 8th index and try to access the hash node which it refers. So here you can see the head will point to null, which simply signifies that this key is not present in this hash table. So we simply return null from this hash table. So friends, these are the simple use cases where we can get a value by key in a hash table. In our upcoming video, we will see the code to get a value corresponding to a key from the hash table, and we will see the demonstration of the code via an animation. I hope you have find this information useful, and in case if you find this information useful, then please like this video, and if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw an animation that how we can get a value by key in a hash table. So now let's look into the code with an animation. But before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here the example which we discussed in our previous video, we will use the same example and we will see that how it works via this code. So let's say if we are calling get method and passing in the key, so here key becomes 105, and here you can see currently our bucket has 3 nodes in the form of key value pairs, so the size is 3. So at the first step, if you want to get a value corresponding to a key, the first thing we do is we try to find the bucket where that key might belong. So how we can do that is we simply call our hash function, we pass the key to it and it will return us back the index. So when we will call getBucketIndex, passing in the key, it will return us back the index by simply taking in the key, dividing it by the buckets.length or number of buckets, and whatever is the remainder, it will return us back that index. So here we can use any hash function, and here I have used this modular hash function, which is taking the mod of key and buckets.length and returning us back the remainder. So when 105 will be divided by 10, we get remainder as 5. So the bucket index is 5 for this key. It means that at index 5, this key will be present or it might not present. Moving ahead. Now as we have figured out the index, so we try to access the hash node at this index. So we do buckets and we pass in the index. So this will return us a hash node, which would be nothing but the head of our list of nodes which can be there on this index. So head will point to this hash node because this is the first hash node in a list of hash nodes. Now how we can search for our keys, we provide a while loop, and why we are providing this while loop is because here you can see there is only one hash node, but there could be a possibility that there are n number of hash nodes. So we need to compare each and every hash node's key with the key which we want to search. So we are simply checking whether head is equal to null or not. So if head is not equal to null, it means that there are nodes present at this index. So we provide a if condition and we simply check whether head.key, which is 105, whether it is equal to the key which we want to search. So here you can see this condition comes out to be true because 105 is equal to the key which we are searching. So the if condition comes out to be true and we simply return head.value because we have found our key and we want to return its corresponding value. So we simply return head.value. So John will be returned. Now let's say if we want to search for a key which is somewhere in between of this list at a particular index. So here we are calling get method with key as 21. So at the first step what we are doing is we are calling the hash function get bucket index. We are passing in the key. So this method will return us an index where we can search for this key. So when 21 will be divided by 10, we get remainder as 1. So the bucket index will be 1. So now we'll simply access the hash node at this bucket index and that will be our head. So at index 1 we have this hash node. So head will refer to it. We provide a while loop because here we are having a list from which we want to search our key. So we simply check whether head is equal to null or not. So here you can see head is not equal to null. So this condition comes out to be true. We provide a if condition that if head.key equals key, which means that we have found our key. So currently head.key is 31. We compare it with 21. So this if condition comes out to be false because 31 is not equal to 21. So we simply move head to its next node by assigning head.next value to head. So head is pointing to this node, its next is pointing to this node. So via this reference, we will simply traverse head to its next node. We again check whether head is equal to null or not. So head is not equal to null. We check head.key, which is 21, whether it is equal to the key which we are searching. So yes, head.key, which is 21, is equal to 21 which we are searching. So this condition comes out to be true. And we will simply return the value corresponding to this key, which is Tom. Now friend, let's say if we want to search for a key which is not present in this hash table. So we call get method. We pass in the key as 88. So key is 88. We calculate the bucket index. We divide 88 by 10 and we get the remainder is 8. So the bucket index will be 8. So we access the hash node via the bucket index, which is this node, which would be our head now. So head is pointing to null. And then we are providing this while loop because there could be a possibility that it contains the chain of nodes. So here you can see the condition here is head should be not equal to null, but here head is equal to null. It means that key which we are searching is not present in this hash table. So at the end we are simply returning the null value, which signifies that 88 is not present in this hash table. So friends, I hope you have find this information useful, and in case if you have find this information useful, then please like this video, and if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video we saw an animation that how we can get a value via its key from a hash table. So in this video we will actually code the algorithm and will test its working in the main method. So before we start, if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here in our previous videos we saw an initial implementation of hash table, and we saw that how we can put a key value pair in hash table, which internally uses the hash function, which is nothing but get bucket index. And here the hash function which we are using is modular hash function, which is using this modulus operator. Now in this video we will see that how we can get a value by providing its key. So when we saw the implementation of put, we provided this edge case that key or value, if they are null, then we simply throw illegal argument exception saying key or value is null. And as we are not putting any null key or null value, when we will do get, we simply provide this check again, and here we'll simply check if the key is null, then we throw illegal argument exception saying key is null. So this is the simple edge case which we are providing. And now how we can get a value associated with this key which we are passing to this method. Because in hash table, internally it is using buckets array of type hash node. So how we can find our key and return its corresponding value? We basically use the hash function which takes a key and return us back an index, and corresponding to that index we try to search our key. So here you can see we first evaluate the bucket index where this key might lie, because there could be a possibility that this key is not present in our hash table. So what we do here is, whatever the key we are passing, we call get bucket index method, we pass the key to it. So this is our hash function. So it will return us back the index where this key might lie. So after getting the bucket index, what we do is we try to access the first node of the list which corresponds to this index. So here we simply access buckets, we pass the bucket index, it will return us back the hash node, which would be the starting node of the list of hash node. So we are assigning it to head. Now after getting the head, our task is to find the key. So for that we are providing this while loop, and here we are providing the condition as head should not be equal to null. So friends, here you can see this is exactly what we did in put, and also we provided while loop where we were simply searching for that key, and if key was found we were simply updating its value. So here I will simply copy this and will paste it here. So the only change we do here is, if we find our key, then what we do is we simply return head.value, because we wanted the value associated with this key. So we searched for the key and we checked that whether any key is matching to our key or not. So in the if block we provided the condition, if head.key is equal to our key, then simply return its value, and if it is not, then simply move head to its next node by assigning head.next to head. So friends, here when we are accessing the hash node at this bucket index, there could be a possibility that this hash node will point to other hash node, and there can also be possibility those hash nodes point to other hash nodes. So we are accessing the head, we are comparing the key. If key is matching, then we are returning the value, and if key is not matching, we are simply going to its next node and doing the same steps again. So friends, if the key is present, its corresponding value is returned, and if it is not, then we are simply returning null here. Now let's test its working in the main method. Here in our previous video, we added few keys along with its values. So if I run the code now, you will see there would be 3 keys. So it printed the size of the hash table as 3, because the key values pairs are 3, 105, 21 and 31. Here this 21 was already present, so when we call put, the Sana was replaced with Harry, so it simply updated the value. It never inserted a new key value. Now here what we do is, let's say if we do table.get and say return me the value associated with key 31, and we print it. So if I run the code now, it should print Dinesh, so which is corresponding to key 31. So now if we do table.get and pass the key as 21, if I run the code, it should print Harry, because Harry is the updated value for key 21. And last, let's say if we print a key which is not present, let's say 90. If I run the code now, so it should print null, so it is returning null. So friends, in this video we saw that how we can get a value associated with its corresponding key. I hope you have find this information useful, and in case if you have find this information useful, then please like this video. If you are new to my channel, then please subscribe my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video we saw that how we can get a value from a hash table via its key. Now in this video we will see that how we can remove a key from a hash table. So basically we will see the demonstration of remove method, which takes in a key and it removes that key from the hash table and also returns its corresponding value back to us. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So let's suppose if we are given with this hash table having 3 hash nodes where size is equal to 3. Now let's suppose if we want to remove a particular key. So what we do is, we are given with a key, we first try to find the index associated with that key via our hash function. Then we go to that index and we try to search for that particular key. In case if we find that key, then we simply remove that node from the corresponding list of that index, and if we don't find the key, we simply return null. So here you can see that there are various cases which needs to be handled while removing a key. The first case is what if the key is not present, so we simply return null. The second case is, let's suppose the key is in the middle somewhere. So when we find that key, we can't directly delete this node, because if we delete this node directly, then there are other nodes associated with this node which will also get deleted. So what we do is, let's suppose if we want to delete this key, then when our node will reach to this point, we compare the key and we find that we need to delete this node. We have to break this link. So in order to break this link, we need to somehow access this node, and this is accessed via a temporary node which is previous to our current node which we want to delete. So here, after we find the key which we want to remove, the previous node will help us in removing this node. So what we do is, as previous is pointing to this node, we have to break this link and make a link from this node to currents next, because we don't want to remove the nodes after that. So we simply assign currents next to previous next. So this link will go away and this link will point to currents next, which would be the leftover nodes after we remove this node. So friend, this is also one case where the key which we want to remove is in the middle of this list. So for that we simply keep the track of its previous node, which we will see later. So let's suppose if we want to remove a key having value as 105. So at the first step we pass this key to our hash function, which takes the key divided by buckets.length, which is the number of buckets, and return us back the remainder of it, because here we have this modulus operator. So whatever the remainder is returned, that is nothing but our index where we can find that particular key. So if we divide 105 by 10, we get remainder as 5. So the bucket index becomes 5. We simply access the hash node at bucket index 5. So this will be our head. So as head is pointing to the first node, at the start we assign a null value to our previous node. So this previous will simply track the previous node to our head. We will see why it is needed later in this video. So currently previous is pointing to null. Now using the head, we will simply search for our key, which we already discussed in our previous videos. So we do head.key, which is 105. We compare it with our key. So here head.key is equal to the key which we want to remove. It means we have to remove this hash node. So what we do is, as previous is pointing to null, it means we want to remove the first node of the list. So currently head next is pointing to null. So there could be a possibility that there are n number of nodes after that. So it means that we want to remove the first node from the list. So what we do is, in order to remove this node, we have to first break this link so that there is no reference to this node and it can be freed up. But we can't directly break this link because there could be nodes after that. So these nodes which can be after the head will also be removed. So what we do is, so first we decrease the size. So size becomes 2. And now what we do is, if we do head.next, we will get the remaining hash nodes in the form of chain. And as head.next is pointing to the nodes after that, if we assign head.next value to buckets at this index, so this node can be freed up and this reference will point to whatever the head.next is pointing. So currently it is pointing to null. So what we do is, if previous is null, which means that we want to remove the first node of the list, so here we will assign head.next value to bucket index 5. So it would look something like this. Head.next is null. So this link will be removed and it will point to null. And now we can simply remove this node and we can return head.value, which is John. So it would look something like this. Now let's say if you want to remove key as 21. So 21 divided by 10 will give remainder as 1. It means the 21 key can be present at index 1. So we access the hash node of index 1. So this would be our head. At start we assign null value to previous. Now here first we search for our key. So we do head.key, which is 31. We compare it with our key, which is 21. So here you can see 31 is not equal to 21. So what we do is, before moving head to its next node, in order to search for the key, we first assign the value of head to previous, because we need to keep the track of the previous node, so that in case if we find a key, then we can use its previous and break the link, so that the key which we have searched can be removed easily. So here, as head is pointing to this node, now previous will point to this node, and we will simply traverse head to its next node via this link. Now we again compare head.key, which is 21, with our key. So here you can see that we have found our key. So our task is to now remove this node. But there could be a possibility that after this node, there are many other nodes. So what we do is, as we want to remove this node, first we decrease the size. So size will become 1. And we simply check whether previous is pointing to null or not. So here you can see previous is not pointing to null. It means that our key is lying somewhere in the between of this list. Because if previous would have pointed to null, then we would have sure that head is pointing to the first node of the list. But as previous is pointing to this node, so what we do is, we simply assign head next value to previous next. So why we do that? Because we need to first break this link. So when this link will be broken, then this node will have no reference, so this can be garbage collected. But there is one problem. Head.next will refer to other nodes as well. So those nodes will also be removed if we break this link directly. So what we do is, head.next will point to the nodes after that. So we simply assign head.next value to previous next. So instead of previous next pointing to head, it will now point to heads next. So this node can be freed up. So it would look something like this. This link will go away, and as head.next is pointing to null, so it will point to null. So now this hash node can be removed easily. We will return the value Tom, and then we will simply remove it. Now friend, let's say we are given with these two nodes and we want to remove 31. So what we do is, we do 31 divided by 10, which gives remainder 1. So bucket index is 1. We simply access the hash node at index 1. We give it a value as head, because this is the first node of the list. We will assign previous a value of null, and then we compare 31, which is head.key, with our key, so that we can search for that particular key which we want to remove. So here you can see head.key is equal to the key which we want to remove. It means we want to remove this key. So first we simply decrease the size, so it will become 1, because we are removing this key now. And after that, we need to break this link so that this node can be freed up. But if we remove this link directly, then all the nodes in this list will be removed. We only want to remove this node and keep all the nodes after that intact. So what we do is, how can we access all the nodes after that is, we simply do head.next. And if we do head.next, we reach to this node. So here, we break this link and we assign a value of head.next to it. So now, this link will go away and it will point to this node and the nodes after that. So here, we are simply assigning head.next value to buckets array at index 1. So it would look something like this. This link will go away and it will point to this node. And once the method will end, this node can be safely removed, and we can simply pass the value associated with this key. So after it gets removed, it would look something like this. So here there could have been multiple nodes after that. So we have kept that list intact and we have removed the node from the middle. So this is also one of the use case. Now let's suppose if we are given with this hash table with two nodes and we want to remove a key which is not there in this hash table. So key is 88. If we divide 88 by 10, we get bucket index is 8. We access the hash node at index 8. So here it is pointing to null, which means that key is not present in this hash table. So we simply return null. So friends, these are the cases which are involved when we actually remove a key from our hash table. I hope you find this information useful, and in case if you find this information useful, then please like this video. And if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video we saw that how we can remove a key from hash table via an animation. So in this video we will see the algorithm via an animation and we will see that how it works step by step. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here you can see that this is the algorithm to remove a key from the hash table. So let's see the demonstration of it step by step. We will take the same use cases which we discussed in our previous video. So when we will call table.remove and pass the key as 105, the remove method will be called with the key 105. Now at the first step what we do is we search for that key, and how we can search for that key is first we get the bucket corresponding to this key. So we call our hash function getBucketIndex. We pass in the key and it returns us back an index by dividing key by buckets.length or number of buckets and return us back the remainder because it has this modulus operator. So here if we divide 105 by 10, we get remainder as 5. So this method will return us the bucket index as 5. Now what we do is, we have got the bucket index and we know that key 105 will lie at this bucket index. So we simply access the hash node at this index, which is 5 here. So the first hash node is nothing but our head, and there could be n number of hash nodes. So head will point to the first hash node. Now in order to keep the track of the previous hash node, we simply assign it with the null. And why we keep the track of the previous hash node, we will see later. So we are providing this while loop, which is pretty much same what we saw in our previous videos, that we are trying to search the key first. So currently head is not pointing to null, so this condition comes out to be true. We check whether head.key, which is 105, is it equal to the key which we want to remove. So here you can see this if condition comes out to be true. So what we do is, as soon as we find the key which we want to remove, we simply break from this while loop because we have found our key and now it's time to remove that key. So when we break from this while loop, it will come here, and here we encounter one use case that head could point to null, so which we will see later. So currently head is pointing to a hash node which is not null, so this condition comes out to be false. So now here you can see, as we want to remove this node, we will first decrease the size by 1. So size will become 2. And after that we encounter a if else block, which is very much important because here if previous is not equal to null, so this is the if condition. If previous is equal to null, it means we are trying to remove the first node of the list. Let's say if we take this example, and if head is pointing to this, so previous will point to null. So it means we are trying to remove the first node of this list. And if previous is not equal to null, it means the key which we have found is somewhere in the between of this list. So that use case we'll see later. So currently you can see previous is pointing to null. So our if condition comes out to be false. And the else part will be executed. and here we want to remove this node from the list. So what we do is, and we know that this is the first node which is being referred by buckets array at bucket index. So in order to free this node, we need to remove this link. We will assign head.next value to buckets array at bucket index. So the hash node referred by bucket index, which is this, instead of pointing to this node, it will simply point to head.next, because we want to remove this node, and this node can also have other nodes. So we can't directly break this link. We simply assign head.next value to this index. So currently for this use case, you can see head.next is pointing to null. So here we simply break this link and we assign head.next, which is null. So it will point to null. And here you can see after this method gets end, first we return the value associated with it, which is John. And once this method will end, this node will be garbage collected. So it would look something like this. Now let's suppose if you want to remove a key 21. So first we'll find its corresponding bucket. So 21 divided by 10 will give remainder as 1. So the bucket index is 1. So we simply access the hash node at bucket index 1, which is this node. And there could be a list, so we assign head to this node, because this is the first node of the list. We create a hash node previous, and at the start we assign a null value to it. And now as we want to remove the key 21, so we search in this list using this while loop. So currently head is not equal to null. If head.key equals the key which we want to remove, then this if condition will come out to be true. So here head.key is 31, it's not equal to 21. So the condition in if block comes out to be false. So this is the key, we are comparing it with 21. And as this condition is false, we will reach here. So usually we search for the key in complete list. So for this node, the key didn't match. So before going to its next node, by assigning head.next to head, what we do is we simply keep the track of this node. Because let's say if we find this key here, then we can use the previous node and we can simply remove this link here, so that this node can be freed up. So before moving head to its next node, we assign the value of head to previous. So it would look something like this. And now we simply move head to its next position by assigning head.next to head. So head.next is pointing to this node. So via this link, head will now point to this node. Head is not equal to null. If head.key equals the key which we want to remove, so head.key is 21 and 21 is equal to 21. So this condition comes out to be true. And here we know that we have found our key which we want to remove. So we simply break from this while loop. We first simply check whether head is equal to null or not. If head is equal to null, then we simply return null. So currently head is not equal to null. It means we need to remove this key. So we first decrease the size by 1. Size becomes 1. And now here you can see previous is not equal to null. Previous is pointing to this node, therefore this condition comes out to be true. So why we provide this check is, if previous is equal to null, it means we are trying to remove the first node of the list, and if previous is not equal to null, it means the key which we have found is somewhere in the middle of the list, because previous is providing that information to us. So in the if part, what we do is, we need to remove this link, and we can't directly remove this link because head.next may point to the other nodes. So what we do is, we simply assign head.next value to previous next. So it would look something like this, that now previous.next is pointing to null. And why we did that, because let's suppose if there are n number of nodes after that, and we want to only remove this key, we don't want to touch other nodes. So to whatever value head.next is pointing, previous.next should point to that node, but here it is null, so previous.next is pointing to null. We will return the value Tom, and this node will be removed from the hash table. Now friend, let's suppose if we want to remove a key as 31. So we calculate the bucket index. 31 divided by 10 will give remainder as 1. So 1 will get returned from our hash function. So bucket index becomes 1. We access the hash node at this bucket index, and to whichever node it is referring, that will assign to head. So head will point to this node. At the start we do previous equals null, and then we search for our key. So we check whether head is equal to null or not. So head is not equal to null. So the while loop will start. Then we provide a if condition to search for that key. So if head.key equals the key which we want to remove, head.key is 31, and the key which we want to remove is also 31. So this condition comes out to be true. It means we have found our key. We break, and then we check whether head is equal to null or not. So head is not equal to null, it is pointing to a key which we want to remove. And before removing the key, we decrease the size by 1. So size becomes 1. And now here you can see previous is pointing to null. So the else part will be executed. And in the else part you can see that why we are doing head.next. In use case 1, head.next was pointing to null, but here you can see there is possibility that head.next is pointing to other nodes. So we can't directly break this link. So to buckets array at bucket index we assign the value head.next. So now this link will be removed, and as we are assigning head.next to it, this will point to this node because head.next is this node. So it would look something like this, that we are assigning head.next value, which is this node, to buckets array at bucket index. So now here you can see this node can be freed up easily by returning the value Sana. And if we rearrange it, it would look something like this. So here we removed a node and we saw the importance of doing head.next, because we can't directly break the link, this link. We need to assign it head.next so that it should refer to the remaining nodes of the key which we want to remove. So friends, one last use case is this use case where we want to remove a key which is not there in this hash table. So we'll calculate bucket index. 88 divided by 10 will give remainder as 8. So bucket index is 8. We access the hash node at this index. So here it is pointing to null, which means head will point to null. We create previous and we assign a null value to it. Here head is pointing to null, so it means this condition comes out to be false. And here, as head is equal to null, it means that size remains the same and key is not present, so we simply return null. So in this video we saw that how we can remove a key from a hash table, and we saw the demonstration of the algorithm step by step. I hope you have found this information useful, and in case if you have found this information useful, then please like this video. If you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw that how we can remove a key from a hash table, and we saw the working of the code through an animation. Now in this video we will actually code the remove method, which takes in a key and return us back the value associated with the key which we are trying to remove. So here in our previous videos we saw how we can put key value pair, how we can get a value corresponding to a key. So now we'll see that how we can remove the key. So friend, at the start, I'll simply copy this part. So here if we are passing key as null, then we are simply throwing an exception saying key is null. So this is the illegal argument exception which states that key is null. So this is the simple edge case. And now in order to remove a key, what we do is we pass this key to our hash function, and this hash function will return us an index where we can search for this key, and once we find that key we simply remove it. So it will return us back the bucket index. After getting the bucket index, we access the hash node at that bucket index, and as that index is pointing to a hash node which is the starting point of the list corresponding to this bucket index, we give a name to it as head. So friends, here you can see that these two steps are being used in get method also and in put method also. Now what we do is, in order to remove a key, let's say at this index, if I simply copy this part, and here at this index, let's say we have this list of hash nodes, something like key as 21, value as Tom, now let's say it has 3 nodes, something like this. Where key 31 has value Harry and key 41 has value, let's say, Sana. Now head is pointing to this node because this is the first hash node of the list. Now our task is to remove this key. So let's say if we want to remove the key as 31 and head is pointing to this. So first we will search our key by traversing head to each and every node. And if we find the key, let's say if we find the key 31, so somehow we need to access this hash node because this link needs to be removed in order to free this node. And if we free this node directly, then all the nodes after this node will also be removed. So what we need to do is, as head has traversed to this node, so first we simply keep the track of its previous nodes. So wherever head will go, we will keep a reference to its previous node, which is very important while removing a key from the hash table. So if head is here and key matches, so previous will be here. So to previous next, we have to break this link. So to previous next, we need to assign head next because we need to keep these nodes intact. We will assign head.next value to previous next. Head.next is this node, and the nodes after that, it will be assigned to previous next. So this link will go away from this node to this node, and then we can simply remove this hash node. So for that what we do is, at the start we create a previous hash node, we assign it a value as null because as head is pointing to this node, at start we are doing previous as null. So now what we do is we search for the key. So for that we provide the while loop, and here we will use the same while loop which we did in the get. So here we are providing the condition as head should not be equal to null, and if head is equal to null, it means we have traversed this complete list and we didn't find our key. And if head is not equal to null, what we do is we compare head.key with the key which we want to remove. And after we find our key, what we do is we simply break from this while loop, because after this while loop, head will point to the key which we want to remove. Let's say here 31. So head will point to this key because this condition matches. So let's say if we take this example and if we want to remove a key as 31. So in this while loop, head will first check it with 21. This condition comes out to be false. Then we go to its next node. Head will come here. It is not equal to null. Then we'll compare head.key, which is 31, with the key which we have passed to this method. So as soon as we find our key, head is pointing to this node. And here what we do is, before moving the head to its next position, what we do is, how can we keep the track of this previous node is, we first assign head to previous. So previous and head will point to this node. And then we simply traverse head to its next node. So previous is a step behind the head. And why we are keeping previous just behind the head is because, let's say we have searched for the key which we want to remove. So we break from this while loop. And as soon as we break from this while loop, previous is here and head is here. So after this while loop, what we do is, we first check that if head is equal to null or not. So if head is equal to null, it means we didn't find any key in this list, because this while loop would have terminated when head would have pointed to null, which is the last node next. So if head would have reached here, it means we haven't found our key. So we are simply returning the null value. And if head is not equal to null, then the first thing we do is we decrement the size by 1, because now we are about to remove the key. So here now two condition arises. One is, at the start, previous is pointing to null and head is pointing to, let's say, 21. And what if we want to remove 21 only? So in that case, we are simply removing the first node of this list. And how we can come to know that is the first node only is via the previous. Because if previous is null and after this if block, we can come to know that head is not equal to null. So it means head must be pointing to this node only, and which means we have to remove this key. So here we provide the if condition and we check that previous is equal to null or not. So if previous is equal to null and if our code has reached here, it means head is also not equal to null, which signifies this head is pointing to the first node. So in the else part, what we do is we have to remove the first node, and it is being referred by this. The hash node at bucket index is the first node. So here what we do is we simply reassign this value to something like, we do head dot next. So it means that our buckets array at this bucket index was pointing to a hash node to which our head was also pointing. And now we need to remove this node. So head is pointing to this node. If we assign head dot next to this, then this node will be removed easily. And now our buckets array at bucket index will point to this node, because 21 would be removed. So this is the small change which we do if previous is pointing to null. And if previous is not pointing to null, now let's say if we want to remove 31. So head will point to this and previous will point to this. So now instead of doing this stuff, what we do is we do previous dot next and we assign head dot next to it. So here you can see head dot next remains the same. As previous is not equal to null, it means we can't use this stuff, because this is only used in case if we want to remove the first node of the list. But if we want to remove, let's say, a node in the middle, then previous will help us in removing that. So head was pointing to this and we want to remove this. and previous was pointing to this. So to previous next, we assigned head next this value. So now this hash node next will point to this hash node, and this hash node can be removed easily. So this step does that. So after this reassignment, head is still pointing to this. So at the end what we do is we simply return head.value, and once this method will get terminated, this head is our local variable, so it will be garbage collected. So friends, what we did in the remove method, we took the key, we evaluated the bucket index where this key might lie. The starting hash node we denoted with head, we created previous, and at the start we provided a null value to it. And now in the while loop, we tried to compare each and every key with the key which we want to remove, because if we don't compare, then we will not able to get which node we want to delete. So as soon as we found the key which we want to delete, we break from this while loop and we perform the assignments here. But let's suppose if the key is not found for the first iteration, then what we do is we have to move head to its next node. But if we move head to its next node, we can't delete this node. We need to keep the track of its previous node as well. So before moving head to its next node, we are assigning the value of head to previous, and then we are moving head to its next node, so that when we will find any key in the middle, we have reference to a node before that, so that we can reassign its next pointer. Here you can see we are reassigning it. So if the key which we want to remove is at first node, then we simply assign head.next value to buckets array at this bucket index. And if it is somewhere in the middle or end, then we have this previous reference. We simply assign head.next to previous next. And finally we return head.value. And once we return head.value, this method gets terminated and the node gets freed up. So now let's test its working in the main method. So here you can see, let's suppose we have this 3 keys 105, 21, 31, and if I run the code now, you will see size will come as 3 because there are 3 hash nodes or key value pair. Now what we do is, let's say we remove 21 and we print its value on the console. So here you can see it printed Harry because Harry was associated with key 21. Now let's say if we want to remove 31. So now if I run the code, you can see it printed Dinesh. And if I print the size of it, so here we have removed 2 nodes. So it should print 1. So it has printed 1. So here you can see only 105 remains in the hash table because we have removed 21 and 31. So here if I simply copy this part, so here before removing these 2 values, we had hash table something like this. This is 3. Dinesh 21 Harry, and let's say if I remove this for time being. So this was our hash table at index 1 because we are removing 21 and 31. So if we evaluate the bucket index, 21 divided by 10 will give remainder as 1. So this is for the index 1. We first added 21 using put, and then we added 31. So 31 came before 21 because we are inserting the hash node at the beginning of the list. So this was the situation. So when we removed 21, head started with this node, then it reached here, and previous reached here. So 21 matched with our key, and at the end what we did, previous next was assigned with heads next, which is null, and then we removed 31, so this node was removed, and when we printed the size it printed 1. Only this key value pair exists and we removed these two key value pairs. So friends, I hope you have find this information useful, and in case if you have find this information useful, then please like this video. If you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.
Hello everyone. So in this video we are going to discuss a problem contains duplicate. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here in this problem we are given an integer array and our task is to return true if any value appears at least twice, or return false if every element is distinct. So let's understand the problem with an example. Now let's suppose we are given with this integer array having elements as 1, 2, 3, 1. Now our task is to return true if any value appears at least twice. So here you can see that 1 appears at 2 places, therefore we return true, and return false if every element is distinct. So here you can see in the second example the array is 1, 2, 3, 4. So all the elements are distinct, therefore we have to return false. So here our task is to check whether the array contains duplicates or not. Now let's move ahead and see how we can solve this problem via various techniques. So let's suppose we are given with this array 7, 3, 1, 4, 1, and we know that 1 appears at least twice, therefore we know that it contains duplicates. So the first way to solve this problem is a very brute force approach, where we take each element and compare it with the rest of the elements in the array, and we figure out whether the element is duplicate or not. So when we try to solve this problem, we take a pointer I and let's say the value is 7. We take another pointer j and we compare the values at I and jth index. So at the start 7 is compared with 3. They are not equal. So j moves to the second index. 7 is not equal to 1. So j moves to third index. 7 is not equal to 4. So j moves to the fourth index. 7 is not equal to 1. So therefore we figure out that 7 is unique among these elements. So after that I moves to 3 and j points to index after I, because 7 is already being compared with 3 in the previous iteration. So 3 is compared with 1, they are not equal. So j moves to third index. 3 is compared with 4, they are not equal. So j moves to the fourth index. 3 is not equal to 1. So therefore we come to know that 3 is also unique in this array. So we increment I. Now I comes to the second index. So j starts from the third index. 1 is compared with 4. So they are not equal. So j moves to the fourth index. Now here 1 is equal to 1. So therefore we come to know that there are duplicates in this array and 1 is appearing at least twice. So therefore we return directly true from the method. So if we see via this approach, we need two for loops. One for I and one for j. So using these two for loops, we can figure out whether the array contains duplicates or not. So the time complexity of this method is O of n square, because this approach contains nested loops. So this is not very efficient solution. Now can we reduce the time complexity from O of n square to less than that? So one thing we can do is, we can actually sort this array. So when we sort this array in ascending order,
the elements will rearrange something like this: 1, 1, 3, 4 and 7. And now after sorting we can use one for loop to check whether the neighboring elements are equal or not. So if they are equal, we just return true, and after the loop ends, if we didn't find any duplicates, then we can return false. So via this approach, when we are sorting the array, the time complexity comes out to be n log n. So this is a better approach and time complexity. Now is there any other way where we can reduce this time complexity? So we'll look into that. So in order to reduce the time complexity, what we can do is we can use an additional data structure. So let's say if we are using a hash set, the property of hash set is it only contains unique elements. Now what we can do is we can iterate over this array. We can take one element and we check whether the hash set contains that element or not. If it doesn't contain, then we simply add it to the hash set. And if hash set contains that value, then we are sure that it contains duplicates. So for example, the first value is 7. We check whether hash set contains 7 or not. So it doesn't contain, so we put 7 into the hash set. Then we check for 3, whether the hash set contains 3 or not. So it doesn't contain, so we put 3 into the hash set. Then we take 1. So 1 is not in the hash set, so we put 1 into the hash set. Then we take 4. 4 is not in the hash set, so we put 4 into the hash set. At last we get 1. So when we check whether 1 is there in the hash set or not, we come to know that 1 is already there. So therefore we directly return true, that we have found a duplicate. Now let's say instead of 1 there would have been 6. So we would have checked whether 6 is there in the hash set or not. So it was not there, so we put 6 into the hash set, and after that there are no elements in this array to be traversed. So at the end we would directly return false, that there are no duplicate elements in this array. Now by doing this, the time complexity is we are iterating this array once. So time complexity becomes O of n, but space complexity increases because we are using an additional data structure. So the space complexity is O of n, but this is a much better approach because the time complexity is reduced. Now let's move ahead and see the animation of this algorithm step by step. So this is the code where the method name is contains duplicate. We pass in the array. So at first, when we call contains duplicate method, we pass in the array. Now let's say if we are given with this array having values as 1, 3, 5, 4, 1. So at the first step what we do is we create a hash set. So this is our set. Now as we discussed, we just iterate each and every value once. So we provide a for loop where I starts from 0 index like this, and I goes till nums.length. So here the array contains 5 elements, 1, 2, 3, 4, 5. So nums.length is 5. So it goes from 0 index to 4th index. So currently 0 is less than 5. So this for loop executes. Now hash set has a method contains. When we call this method, it actually returns true or false. If the element is present in the hash set, returns true, and if the element is not present, it returns false. So nums of I is nothing but the value at 0th index. So we check whether set contains 1 or not. So here you can see set doesn't contain 1. So set.contains will return false because this element is not present. So we add this element into the set. So 1 is added into the set. Now we increment I, so I becomes 1. 1 is less than 5. We check whether value 3 is present in the set or not. So set.contains return false because 3 is not present. So we simply add 3 into the set. We increment I, so I becomes 2 and 2 is less than 5. So this for loop will execute. Now nums of I is nothing but value present at second index, which is 5. So we check whether set contains 5 or not. So set doesn't have 5, so it returns false. So we simply add 5 into the set like this. We increment I becomes 3. 3 is less than 5, so this for loop will execute. We check whether value at third index, which is 4, present in the set or not. So this actually returns false because 4 is not present into this set. So we simply add 4 into the set. We'll increment I becomes 4. 4 is less than 5. So this for loop executes. Now here value at ith index is 1, and when we check whether 1 is present in the set or not, so 1 is already present in the set. So set.contains return true. So it means we have found a duplicate in this array because 1 we inserted into the set at the beginning, and again we found a 1. So set.contains return true because 1 is already present in the set. So it means that our array contains a duplicate. So this if block gets executed. So here we directly return true, which states that our array contains the duplicate. Now let's say if our array doesn't contains the duplicates. So instead of 1, we put a 6. So after placing 1, 3, 5, 4 into the set, the last element would have been 6. And if we do set.contains 6, so it returns false and if block doesn't get executed. So we simply add 6 into the set. Now when we increment I becomes 5. And 5 is not less than 5. So therefore this for loop will terminate. So at the end we directly return false, stating that our array doesn't contain duplicate. It contains unique elements. So friends, in this video we discussed the problem of contains duplicate. I hope you must have liked this video. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss about a very important topic, which is intervals. So in this video we are going to see a basic introduction to intervals, and we will also see what are overlapping intervals. Now this is a very important topic for the coding interview. There are questions asked on the concept of overlapping intervals. So let's move ahead and see what are intervals and what are overlapping intervals. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So first we will see a basic introduction to an interval. So usually an interval is actually a range which is represented by two numbers, something like 5, 8, 6, 10. So an interval is a range where two numbers are involved. Now that two numbers are termed as start and end. So here 5 will be our start and 8 will be our end. So these two numbers are basically start and end of the interval, which actually represent a range. Now usually when we talk about interval, they are correlated with time. Now when it is related with time, this start and end can be any unit of time. It can be milliseconds, seconds, minutes. So here let's see the time interval of few tasks. Let's say task A has a time interval of 1, 3. B has time interval of 4, 5. C has time interval of 8, 10. D has time interval of 9, 11. So if we take a time axis like this, now here it could be seconds, milliseconds, nanoseconds. It can be anything. So let's say if we want to plot this task on this time axis and we take it as seconds. So it suggests that task A has start time of 1 and it has end time of 3. So if we plot task A on this time axis, it would look something like this. That A task starts from 1 and ends at 3. So it means if we take it in the form of seconds, task A takes 2 seconds to complete from 1 to 3. If we plot B, it starts with 4 and ends on 5, so it takes 1 second. If we plot C, so the start is 8 and end is 10, so it takes 2 seconds to complete. And if we plot D, so it starts at 9 and ends at 11, so it also takes 2 seconds. So usually these time intervals represent a range, let's say for a task or for a process. And mostly the coding interview problems are given with these intervals. So here we saw that an interval has two numbers, start and end. Now let's see how we can represent this interval in form of a code. So the interval representation looks something like this, that there is a class interval. Now this is a custom class which we will create, which has two properties, start and end. So this start will represent the starting point of the interval and end will represent the ending point of the interval. So any interval takes only two numbers, start and end. And if we want to create an interval, we have provided this constructor which takes in a start and end and initialize a particular interval with these numbers. So this is how we actually represent an interval class. So now let's move ahead and see the concept of overlapping intervals. So what are overlapping intervals? So let's say if we have interval something like 1, 5 and another interval as 2, 6. So if we plot these intervals, it looks something like this. This is 1, this is 5 and let's say 2 is here. And let's say this is 6. So here if you see, this is the first interval with 1, 5 and this is the second interval with 2, 6. So now if you closely look, they are actually overlapping in this region from interval 2 to 5. So this actually suggests that these two intervals are actually overlapping with each other in this region 2, 5. So for an overlapping intervals, we actually require two intervals at minimum. Let's say if we denote it by A and B. So there will be some relationship between these two intervals. So the first relationship would be that A and B do not overlap. So it means A starts and ends here and B starts and ends here. So here if we take an example, let's say 1, 3 and 4, 5. So this is one interval and this is another interval, but they don't overlap. If we have interval something like 1, 3 and 3, 4, then that will overlap because the end time of first interval is equal to start time of another interval. But here there is a gap between these two, so they don't overlap. The another thing would be A and B overlap, but B ends after A. So it would look something like this, that A starts here and ends here and B starts here and ends here. So here B is ending after A and this is our overlapping interval. So if we take an example, let's say 1, 4 and 3, 6. So here you can see these two intervals actually represent this condition, that A interval starts from 1 and ends at 4 and B starts at 3. So it means this is 1, this is 4, this is 3 and this is 6. Here B is ending after A, so we can visualize these two intervals like this. The third would be A completely overlaps B. So it would look something like this, that A is actually overlapping B completely. So if we take an example, it could be like 1, 6 for A and B could be 2, 4. So here 1, 6, 2 and 4. So it says that A is completely overlapping B. So this could be one such case. So the fourth case is A and B overlap. A ends after B. So this is pretty much same as this, but here it looks something like this. Here B was ending after A, but here A ends after B. So these two are pretty much same, only the names of the intervals have changed. B completely overlaps A. So this is pretty much same as A completely overlaps B. So it would look something like this. Here A was completely overlapping B, and now here B is completely overlapping A. So here we just need to change the order of A and B. So if this was A and this was B, so here A would be 2, 4 and B would be 1, 6. Rest everything remains the same. And the sixth case is B and A do not overlap. So this is pretty much same as A and B do not overlap. So it looks something like this. So friends, these are the 6 cases where we can demonstrate the overlapping intervals. So for a situation where these overlapping intervals come, we at least need minimum of 2 intervals. And there could be many intervals like A, B, C, D which can overlap with each other, but we actually require minimum of 2. So friends, in this video we covered what are intervals and what are overlapping intervals. In our future videos we will see few problems related to overlapping intervals. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we discussed about what are intervals and what are overlapping intervals. So now in this video, we will look into a problem of merge intervals. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So if you look at the problem, you are given with a list of intervals. You need to merge all the overlapping intervals and return a list of non-overlapping intervals. So let's see it via an example. Let's say we are given with a list of intervals like 2, 6, 1, 3, 8, 10, and this intervals can be in any random order. So we need to merge only those intervals which are overlapping to each other, and at the end we have to return a list of all the non-overlapping intervals. So the output would be 1, 6 and 8, 10. Now how this output came, we'll see in a diagram. So let's say we have this time axis and we have this intervals 2, 6, 1, 3 and 8, 10. We will plot these intervals on this time axis. So first we will take 2, 6. So the start is at 2 and end is at 6. So this interval takes 4 units of time. Now let's say if time axis is in seconds. So this will take 4 seconds. If we plot 1, 3, it would look something like this. 1 is the start and 3 is the end. And after that we will plot 8, 10. So it looks like this. So this is 2 seconds interval and this is also 2 seconds interval. So here if you see, this 1, 3 and 2, 6 are overlapping to each other. So this is the area where they are overlapping. So it means we have to merge all the overlapping intervals. So if we merge these 2 intervals together, we will get a bigger interval whose start will be 1 and end will be 6. So here, as these 2 are overlapping intervals, when we will merge these 2, you can simply take this first interval and put it on the top of the second interval, and that will be our merged interval. So it looks like this. The start will remain the same because this interval came first, and the end will actually depend that which interval has the maximum capture duration. So here in this case, the first interval is completed at 3rd second and the second interval is completing at the 6th second. So we will take the max of 3 and 6 and it merges to 1, 6. So this is the merged interval because these 2 intervals are overlapping to each other. But here if you see 8, 10, as we have only 3 inputs, 8, 10 is not overlapping with any of these intervals, and we have to return a list of non-overlapping intervals. So 8, 10 will remain as it is like this. So therefore our answer is 1, 6 and 8, 10. If this 8, 10 would have been 6, 10 or 5, 10, then our answer would have been one complete merged interval of 1, 10. So let's move ahead and see how we can solve such problems. So for the overlapping interval, in our previous video, we saw the different use cases that when 2 intervals are overlapped with each other, what happens. So one such condition is A and B do not overlap. So it looks something like this, that there is a gap between these 2 intervals, so we can't merge them. Now if A and B overlap, but B ends after A, so it would look something like this. Now here one thing we are assuming is A will always come before B. So this diagram will make sense that B ends after A, and if A and B overlap, it would look something like this. A completely overlaps B, so it would look something like this. But still A is coming before B. B completely overlaps A in a case that both have same start time. So B is completely overlapping A, but A should come either before B or it can start at the same time. So therefore we are taking this assumption, and we will come to know later why it's important. So this is one such case where B will completely overlap A, but as A should either start at the same time as B or before B. This would be one such use case. Now we will see all these cases and why they are important. So with the first case, when A and B overlaps and B ends after A, so this is the case. So when we will merge these two intervals A and B, and let's say result we denoted by a C. Now as we are merging these two intervals A and B, here you can see the range of C, which is start and end, would be A start and B end. So here you can think of any two intervals, but one thing is sure, both of the intervals either will start at the same time or one of the interval would be coming first. So whichever interval is coming first, its start will become C start, and the value of C end will depend on the maximum expansion of any of this interval. So here you can see as B ends after A, B's end value will become C's end, and after merge it will look something like this. So let's say if A starts from 1 and ends at 3, and B starts from 2 and ends at 5. So here you can see this is the overlapping part. So when we will merge these two intervals, let's say we put A on the top of B, so it will become something like it starts from 1 like this and ends at 5. So this is the merging. We'll see another use case. Let's say A completely overlaps B. So in this case, if we merge these two intervals, let's say we put A on top of B, so it would look something like this, that C start becomes A start because this is the start of the interval, and as A completely overlaps B, C's end will become A's end like this. So this is one such use case. If we look at the third use case, where A start is actually equal to B start and B ends after A. So in this case, if we merge both these intervals, it would look something like this, that if we put A on top of B, the C start will be either A dot start or B dot start. It will be same, but the end will be B's end because this is the start and this would be the maximum value till both the interval goes. So in all these three use cases, one thing to keep in mind is we are assuming A will either start before B or at the same time of B. So C start will be equal to A start. This is sure. And C end, there will be a condition that we will take max of A and B end, and whichever is the maximum value, that will be assigned to C's end. So in this case, here you can see A end is 3 and B end is 5. So C end becomes 5. Here you can see A completely overlaps B. So A end is greater than B's end. So therefore C end becomes A end. And similarly here, as B is completely overlapping A, so B end is having a greater value than A ends. So whichever is the maximum, that gets assigned to C end, and that will be our merged interval. Now one thing we discussed, that A should start before B or at the same time. But if we look into the problem, we are given the intervals in random order. Let's say 10, 19, 3, 4, 1, 2, and let's say 2, 3. Now we have to merge all overlapping intervals. So one thing we need to keep in mind is we have to first sort all these intervals based on their start time. Once we get the start time, this condition will come into picture, that one of the interval is starting before the other. And once we sort it based on the start time, all the intervals start time will be in ascending order. So we can directly compare one with the other and see if they are overlapping with each other or not. So in order to solve this problem, the first thing we need to do is we need to sort the intervals based on the start time. So this condition will come into picture, that A dot start will be less than or equal to B dot start. So here A dot start in this case is less than b dot start. In this case also it is less than b dot start. But in this case a dot start is equal to b dot start. So this condition is important. So when we will sort these intervals, the merging becomes easier. Here if you see, let's say if you want to merge these two elements, we know that a dot start is before or equal to b dot start. So c dot start will directly becomes a dot start because a is coming before b. But c dot end, which we discussed here, its value will be depend on whichever interval is going to greater time span. So it would be max of a dot end and b dot end. So here in this case a dot end was smaller than b dot end, so c became b dot end. In this case if we merge these two elements, then b dot end was lesser than a dot end. So when we merge it became a dot end. And similarly here b dot end is greater than a dot end. So therefore on merging c end becomes b dot end because we have to take the maximum of a dot end and b dot end. So these two conditions are very important. And once we do the merging of let's say two intervals, we can keep proceeding ahead with all the overlapping intervals and we can check which are overlapping intervals and we can merge them. So friend, let's see the demonstration of this algorithm step by step. So we have this merge method which actually merge the overlapping intervals, and we are given with a list of interval and our task is to merge the overlapping intervals and return a list of all non-overlapping intervals. Because once we merge all the overlapping intervals, they all become non-overlapping. So first we will call the merge method. We pass in the list of intervals. So it would look something like this. That this is the list of interval 7, 9, 2, 6, 1, 3 and they are in random order. So the first thing we have to check that whether interval size, whether it is less than 2 or not. So if it is less than 2, it means list has either 0 elements or 1 element. It means there is only one interval or 0 interval. So we don't have to merge anything, we have to simply return the same list back. So this is one edge case. So currently intervals.size is 3, therefore it is not less than 2. Now in order to compare whether all these intervals are overlapping to each other, what we need to do is we have to sort all these intervals based on their start time so that we can come to know that whether there is any overlap or not. So the list has a sort method which takes in a comparator, and comparator has a comparing int method which actually returns a comparator. Now in this method, this is a static method. So in this method we are simply telling that take each interval and sort it based on the start time. So this comparing int method will take this intervals list, will sort it based on the start time. So the intervals will become something like this: 1, 3, 2, 6, 7, 9. So start time, so 1 is less than 2, 2 is less than 7. So it has sorted based on the start time. Moving ahead. Now as we need to return a list of all non-overlapping intervals, we will create a result list like this. So currently it's empty. Now as we have sorted the intervals based on the start time, we will compare the adjacent intervals so that we can check whether they are overlapping or not. So in order to compare all these intervals, the first thing we do is we simply take the first interval as it is. So this is the time axis and the first interval is 1, 3. So if we plot it here, it looks something like this. Now our task is to compare this 1, 3 with 2, 6 and check whether anything is overlapping or not. So for that we will create two variables start and end. We will see its significance later. So to the start variable we will assign first.start because we are starting with this interval. So start becomes 1 because first.start is 1. And to end variable we will assign first.end. So first.end is 3. So we are simply taking this two intervals start and end as 1, 3. And now as we have to compare it with other intervals, we will take all these intervals in a for loop and we will start with 1 because 0 is already taken. So this is 0, this is 1 and this is second index. So we will start I from 1. So it would look something like this, that we are now picking up 2, 6 and I is less than intervals.size. 1 is less than 3. So this condition comes out to be true. Now you can think start and end represents first And in the for loop, currently we are on 2,6. So this becomes our current interval and this can be treated as previous intervals. So from this list, we will get that interval by calling intervals.get. We'll pass the value as 1. So we will get 2,6. So this will be assigned to the current like this. And if we plot it here, you can see 2,6. Now our task is to simply check whether 2,6 is actually overlapping with any of the previous intervals or not. So we will check whether current.start is less than equal to the end. So we are not doing first.end because there could be many intervals before this current interval, and start and end will represent just the previous interval which are being merged or non-overlapping. We will see its importance later. So we are simply comparing current.start whether it is less than equal to end. So here you can see value of end is 3, current.start is 2. So this is the start for current. It is less than end. So it means that there are overlapping intervals. And if you see why this example 1,3 is actually overlapping with 2,6. So this condition comes out to be true, which means we have to merge these two intervals now. So once you merge these two intervals, let's say the result interval is C. So we also saw that C.start was equal to A.start, which always remains A.start because A is either starting before B or at the same time as B. So here our start will remain 1 only, it won't get changed. But C.end will become the max of A.end and B.end. So here this is the condition for that we are simply taking the maximum value of current.end, which is the current interval, and value of end, which is the value of its previous intervals, which is 3. So if we do 3,6 max, we get 6. So here you can see our start will remain the same, but end will change to 6 now because we are merging these two overlapping intervals. So end will become 6. Moving ahead. So here you can see one reason of picking start and end in a different variable is as we have merged these two intervals, start became 1 and end became 6, and there could be a possibility that once we move ahead in the array, there could be another intervals like this. So here in this case, all this interval will get merged together. So therefore, only the end will get expanded till the intervals are overlapping and start will remain the same. So therefore, we have created these two variables which are doing those things. These two variables are keeping the state of the previous intervals which are merged or which are yet to merge. So now we'll increment I. I will become 2. 2 is less than 3. So this condition comes out to be true. Now this is our current interval 7,9. So when we will do intervals.get 2, we'll get 7,9 as our current interval like this. So now our task is to merge current with previous already merged intervals. So we have to check whether 7,9 is overlapping with any of the previous intervals or not. So that value is actually held by start and end. So here if we see current.start is this value and current.end is this value. So here you can see current.start is 7 and value of end is 6. So it means current.start is not less than or equal to end because value of end is 6 and current.start is 7. So here you can see there is a gap between these two intervals. Therefore they are not overlapping with each other. So this condition comes out to be false. So the else part will be executed. And in the else part, as we have already found one gap in between these two intervals and this interval, we can now safely merge these two intervals because when we go ahead, these two intervals will not be get affected and we can simply merge them and add it to the result. So in the result, we are adding new interval start, end. So we are creating a new interval of start and end, which is 1, 6, and we are adding it to result. So it would look something like this, that it is merged like this and it is added to result list. Moving ahead. So once we have merged these two intervals and there is a gap between the current and this merged interval, now our task will be to focus from 7,9 to rest of the elements ahead. We have to forget this merging now because we have already merged these two intervals and there are no more intervals which can get merged to these two intervals. So therefore we have to forget this part now. And as we have started with 1,3 at the start because that was the first interval, now we have to start from 7,9 thinking it is the first interval. So therefore now start will become current start. We will assign the value of current dot start, which is 7, to start, and end will become current dot end, which will become 9. So this is now our fresh interval, and if there are more intervals after 7,9, this 7,9 will be compared with these intervals, and these intervals are already merged and they are added to the result list, so we don't touch them now. Moving ahead, we will increment I. So I will become 3 and I is not less than 3. Therefore this condition comes out to be false. And for loop will terminate because there are no more elements left to be compared with this 7,9. So this for loop will terminate. And one thing to notice, as soon as this for loop will terminate, whatever the value start and end will hold, that will hold an actual interval which also needs to be added to the result. So here you can see 7,9 was the single most interval left and there are no more intervals left which can be merged with 7,9. So this 7,9 also needs to be added to the result list. So at the end we have to add the 7,9 also to our result list because this is a non-overlapping interval. So we do result.add new interval and we pass the value of start and end, which is 7,9. So it would look something like this, that this is also one such non-overlapping interval. And our task was to merge all the overlapping intervals and only return the non-overlapping intervals. So 1,3 and 2,6 got merged to 1,6 and 7,9 didn't get merged with any of the intervals, so it came out as 7,9. So these two are our answers, 1,6 and 7,9. So at the end, we will simply return the list of interval which is our result list. So friend, this was all about the problem how to merge an overlapping intervals and return back all the non-overlapping intervals. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we actually saw the problem of merge intervals. So in this video, we will actually see one more problem, insert interval. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So in this problem, we are given with a list of non-overlapping intervals which are sorted by their start time. We are also given with an interval which we need to insert into the list at a valid position in such a way that if that interval overlaps with any of the intervals which are given in the list, then we have to merge all those intervals and return back a list of mutually exclusive intervals, which means we need to return back a list of intervals which are different and non-overlapping. So let's see an example. Let's say we are given with this list of intervals 1,3, 5,7, 8,10. Now they are non-overlapping and sorted by their start time. And let's say we are given with this new interval 4,9. Our task is to insert this 4,9 into this list in such a way that if this new interval overlaps with any of the interval given in this list, we have to merge it with new interval and return back a list of mutually exclusive intervals. So the output is 1,3 and 4,10. Now how this output came, let's see via diagram. So this is our time axis, and if we plot all these intervals on this time axis, it would look something like this: 1,3, 5,7, 8, 10. We have to insert 4, 9. So it will go from 4 to 9. So here you can see this 4, 9 doesn't overlap with 1, 3. So 1, 3 doesn't get affected by insertion of 4, 9 because they are not overlapping. So 1, 3 will be part of our answer because it's mutually exclusive. So this is the first part. Now here you can see when we will insert 4, 9, it will affect 5, 7 and also 8, 10. So as 4, 9 is completely overlapping 5, 7, if we put 5, 7 on top of 4, 9, that means merging of these two intervals will not get affected because 4, 9 is already overlapping completely 5, 7. But in this case, 4, 9 is ending at 9 and 8, 10 is ending at 10. So if we put 8, 10 on top of 4, 9, the region will get expanded till 10. And as 4 is less than 8, so start will remain the same, but end will change because 4, 9 is overlapping with 8, 10. And when we merge these two intervals, we take the end time of both the intervals and we see which is the maximum. So here 10 is the maximum. So the merge interval will be something like this. It would be 4, 10. So the next output is 4, 10. Now let's move ahead and see some of the concepts behind this insertion and merging. Let's say we are given with these two intervals. We need to insert A. So A and B are non-overlapping. So it means we can simply insert A without touching B. So we simply insert A. Now let's say A and B are overlapping. So when we will merge these two intervals, their area will be from here to here. So this is the start of A and this is the end of B. So if we take this interval as C, then we have to keep a formula as C. Start time will become the minimum of A dot start and B dot start, and the end time will become the max of A dot end and B dot end. So this condition comes into picture if they are overlapping. So here you can see, let's say if we give it a value as 1, 4, 3, 6. So we know that when we will merge these two intervals, the minimum of 3 and 1, so C will become 1 and maximum of 4 and 6 will be 6. We know that the area of this merging will be 1, 6 because we have to accommodate both the intervals. So this formula comes handy. Minimum of A dot start and B dot start. A dot start is 1, B dot start is 3. So minimum is 1 and C's end will become max of A dot end and B dot end. A dot end is 4, B dot end is 6. So C's end will become 6. So this interval will expand from 1 to 6. So C becomes A dot start, which is this, and B dot end, which is this. Similarly, here A completely overlaps B. So if we apply this formula, the C will become A dot start because A dot start is coming before B dot start, and C dot end will become A dot end because it is coming after B dot end. We have to take the max value. And if this is the scenario, then by applying this formula, C start will become B start and C's end will become A's end. So this would be the area of the C interval. And if B completely overlaps A and if we want to insert A, so by applying this formula, C start will become B start and C end will become B's end. So this is how we actually insert and merge the intervals together. Now let's see via an example. If we have these 4 intervals which are non-overlapping, sorted by their start time, and we have to insert a new interval 4, 9. So if we plot all these intervals on the time axis, it would look something like this: 1, 3, 5, 7, 8, 10, 11, 12. Our task is to insert 4, 9. So here, as we want to insert this new interval from 4 to 9, there will be 3 regions around this 4, 9 which will get affected when we will insert this new interval. So one region is just before 4, which is this. Another region is this, between 4 to 9. and the third region is just after 9. So here we are taking the region 1 as just before 4, not even equal to 4, and here just after 9, not even equal to 9, because if any of the interval touches this boundary like this, then they also need to be merged because they are overlapping with each other. And so we need to keep this condition in mind, that in region 1 we have to simply check for less than intervals. In region 3 it should be greater than the end time, and in this region if they overlap we have to directly merge them. So how we can solve this type of problem is, we have to take these 3 regions. First we have to take all the intervals which are part of region 1, and all the intervals which are part of region 1 will satisfy this condition, that their end time, let's say this part, is less than the new interval start time. It means they are not overlapping, there is a gap. So this less than condition is helpful. If they become equal, then they actually overlap and we have to merge them. So first we cater for less than condition and we figure out what are all the intervals which are not touching 4, 9. So those intervals we directly take into our result list because they are not touching 4, 9 and they are not overlapping 4, 9. So let's say if there are n number of intervals before 4, so we have to check each interval's end time and check whether it is less than the new interval start time. If it is less than the new interval start time, we know that they belong to this region. So after placing all the elements of region 1, we come to region 2. Now here what we check is, let's say if we take this example. So here if this interval has to belong in region 2, what we do is we take its start time and we check whether it is less than or equal to the new interval's end time. Now here we are checking for this condition, less than or equal to. So let's say phi is less than 9. So it means this interval belongs to region 2 because we have already excluded the region 1 intervals. And if any of the intervals is left, if this condition satisfies that phi is less than 9 or equal to 9, then this region, even if it expands beyond 4, 9, it will still overlap with 4, 9. And why we are taking this equal condition is because, let's say instead of 8, 10 we have 9, 12. So 9 is the start time, and if 9 is equal to new interval's end time, so still it is overlapping with this interval and we have to merge them. So it still belongs to region 2. So this is the main condition. For region 1, all the intervals end time should be less than new interval start time. So they will completely belong into this area and they will be non-overlapping. In this region they will overlap. So we have to simply check the interval start time and we have to check it is less than equal to the new interval's end time. If that is the condition, they still overlap and we have to merge them. So here if you see 4, 9 overlaps 8, 10 because 8 is the start time and it lies before 9 because 8 is less than equal to 9. So therefore when we will insert this interval, it will affect 5, 7 and 8, 10, and we know the formula that how to merge the two intervals together, which we saw in our previous slide. So after we add all these elements into the list, whatever elements are remaining, these are out of the boundaries of this 4, 9, which is the new interval which we want to insert. So we can directly add them into the list. They won't get affected by the insertion of this new interval. So after merging 5, 7 with 4, 9 and 8, 10 with 4, 9, it will become something like this. So our overall answer becomes 1, 3, 4, 10 and 11, 12. So the algorithm is something like this. We have to skip and add intervals that come before the new interval to the result list. So all the intervals of region 1 which are coming just before the new interval, we have to simply add onto the list. We have to merge all the intervals that overlap with the new interval. So this interval and this interval, they are overlapping with this new interval. So we have to merge it with this new interval. We have to add that merged interval into the result. So this is the interval which gets merged. We add this into the result. And finally we insert the remaining intervals to the result. So these are the remaining intervals. There can be many intervals like this. We have to just insert them to the result because they are non-overlapping and mutually exclusive. So this region covers this part, this region covers the overlapping part, and this region covers all the remaining elements. So all these regions will be captured by a simple while loop in the algorithm. So let's move ahead and see the algorithm. So this is the algorithm. So this while loop is for the region 1, where we simply skip the elements which just come before the new interval. This while loop is covering the intervals which are getting overlapped with the new interval, and this while loop is just adding the remaining intervals. So let's see the demonstration of this algorithm step by step. We'll call the insert method. We'll pass the list of intervals and a new interval which we want to insert, which is 2, 6. So let's say we have list of interval as 0, 1, 3, 5, 6, 7, 9, 10, and we need to insert 2, 6. So if we plot all these intervals on the time axis, it would look something like this: 0, 1, 3, 5, 6, 7, 9, 10. We need to insert 2, 6, which is from time 2 to 6. Moving ahead. So here we are just simply checking for the base cases, that if list is null or empty, we simply return the list. So currently list is not empty and it is not equal to null. So for the new interval, you can think that it's a valid interval. As we have to return the list of mutually exclusive intervals, we will create a result list which is currently empty. Now as we need to traverse each and every element of this intervals list, we'll create an integer I starting from 0 index. So first we are picking 0, 1. Now in this while loop we are checking that whether 0, 1, when this 2, 6 will be inserted into the list of intervals, will this get affected or not. So first we check whether I is less than intervals.size. We are simply checking whether value of I is less than interval.size, which is 4. Because as we are traversing each interval one by one, there would be a time that I will completely traverse all the elements. So we need to break from the while loop at that moment. So currently I is less than intervals.size. The other condition we check is we get this interval. So we do intervals.get I. So we get 0, 1. And as we discussed, we will check its end time with the new interval start time. And we check whether this interval's end time is less than new interval start time. Because if it is less than new interval start time, it means they are not overlapping. There is a gap between. So intervals.get I is this interval. If we do dot end, we get 1. We check whether 1 is less than new intervals.start. So new interval.start is 2. So 1 is less than 2. So it means this condition comes out to be true, which signifies that 0, 1 doesn't overlap with 2, 6. And we can simply skip this element and add it to the result list, because this won't get affected by insertion of this new interval. So 0, becomes part of the result. Now we will increment I. I will come to the index 1. So I is less than intervals.size, which is 4. Intervals.get I, which is 1, which is 3, 5. Now we are at 3, 5. We check whether this interval's end is less than new intervals.start. So here this interval dot end, which is 5. We check whether it is less than new intervals.start, which is 2. So this condition comes out to be false, which suggests that all the intervals which were just coming before new interval have already been part of the result. And once we reach on this interval, this condition comes out to be false, which actually states that 3, 5 will either lie in the area of new interval or beyond that, but it won't lie here in the region 1, because this condition came out to be false. So ideally this while loop will terminate, which signifies that all the intervals which were coming before new interval have been added to the result list, and we can move ahead with the another while loop. I is less than intervals.size. Now here we actually check for the second region, that whether 3, 5 is overlapping with 2, 6 or not. And we already discussed how we can do that is intervals.getI, which is this interval. We simply check its start time, which is 3. We check whether it is less than or equal to new intervals.end. So 3 is less than equal to new intervals.end, which is 6. So which is true. So it means these two intervals are overlapping, which is being proved by this condition. And so the condition in while loop comes out to be true. So first we will get this interval 3, 5. We assign it to current like this. Moving ahead. Now as we need to merge 2, 6 with 3, 5. So we know the formula that if we merge two intervals, let's say A and B, and let's say result interval is C, so it becomes C start becomes min of A dot start, B dot start, and C's end will become max of A dot end and B dot end. So here these two are the same conditions, and here C is our new interval only. We are simply merging 3, 5 into the new interval only. So new interval start will become the minimum of current start, which is this, and new interval start, which is 2. So minimum of 3, 2 will give 2. So new interval dot start will become 2, which is already 2. So this won't get changed. Now new interval end will become max of A dot end and B dot end. So current dot end and new interval dot end, we take max of it. So current dot end is 5 and new intervals end is 6. So if we take max of it, we get 6, which is assigned to new intervals dot end. So new intervals end doesn't get changed because it is already 6. So it means we have merged these two intervals and the resulting interval is same 2, 6. Because this new interval completely overlapped the current interval. Moving ahead. Now we are done with this interval also. So we'll increment I. I reaches to 6, 7. So here I is less than intervals dot size. Now here if we do intervals dot get I, we get 6, 7. So friends, here you can see that why this less than equal to is important. This 6, 7 is starting where this new interval is ending. So it means they are still overlapping because the interval start, which is 6, is actually equal to new intervals end, which is also 6. So therefore they are overlapping and we have to merge these two intervals as well. We can't exclude 6, 7 because it is just overlapping with 2, 6. So this condition is important. So the overall condition in while loop comes out to be true. We do intervals dot get I. The interval 6, 7 will be assigned to current like this. And we have to merge these two intervals now. So we'll use the same formula. The new interval dot start will become the minimum of current dot start, which is 6, and new interval dot start, which is 2. So minimum will give 2. So new interval dot start will become 2, which is already at 2. Now new intervals end will become the max of current dot end and new interval dot end. So max of current dot end, which is 7, and new interval dot end, which is 6. So it will give 7. So here is the one critical step, that new interval dot end will become 7 now, because after merging these two elements, the new interval will expand to 7 like this, that we have merged these two intervals. Moving ahead, we will increment I. I becomes 9, 10. I is still less than intervals dot size because value of I is, this is 0, 1, 2, 3. 3 is less than 4. Intervals dot get I, which is 3, will give 9, 10. And here you can see this 9, 10 is actually belonging to the third region. So therefore its start, if we compare it with new intervals dot end, so 9 is less than equal to new intervals dot end, which is 7. So this condition comes out to be false. It means 9, 10 is the remaining element and it doesn't overlaps with 2, 7. So we can directly add this 9, 10 and all the elements after that via this while loop. So this condition comes out to be false. So here you can see that before adding 9, 10 into the result list, we have to also insert 2, 7, which is our merged interval, into the result, which is actually merging 2, 6, which was our new interval, with 3, 5 and 6, 7. So after this 3 intervals merge, we get 2, 7. So this is one important step. We have to add this new interval into the result. So it will become like this. And now using this while loop, we will add the remaining interval into the result. So I is still less than intervals dot size. And as this condition reached this while loop, we are sure that all the remaining elements will be non-overlapping with this new interval. So we can directly add 9, 10 to the result. We do result.add and we pass in intervals.get I, which is 9, 10. So it looks something like this. And then we increment I. So I goes beyond the boundaries of this interval list. And now this while loop condition comes out to be false because value of I is 4 and interval.size is also 4. 4 is not less than 4. So this condition comes out to be false. And at the end we simply return the result, which is 0, 1, 2, 7 and 9, 10. 0, 1 doesn't overlap with this new interval and 9, 10 also doesn't overlap with this new interval. 3, 5 and 6, 7 were merged with 2, 6 and became 2, 7. So this was the answer. So friends, this was all about the algorithm. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.
Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss about the trie data structure. We will discuss about what is a trie and what are its real life applications. So friends, what is a trie? So here you can see the word trie actually came from the word retrieval. So the main purpose of this data structure was to retrieve the stored information very fast. So basically in real life application we actually store the collection of strings inside the trie, and whenever we want to get that string we can retrieve that string very fast. Below you can see the symbolic representation of a trie data structure. So here you can see that green circles are nothing but the trie nodes, and multiple trie nodes actually form a trie. And also you can see the topmost node is actually empty, which is being pointed by the root. So root actually points to an empty trie node, and from the root the other words originate. So here you can see, let's suppose if we store these 4 words into a trie data structure, then here we actually start from the root, which is an empty trie node. And let's say for an example, as we want to store a word dog, then we simply create 3 trie nodes, storing one alphabet into it, and the trie node pointing to others in sequence. So friends, here you can see that from root we pointed to node D, then from D we pointed to node O, from O to G. So friends, after storing G, we know that dog is in the trie. So we mark the last node in yellow color, stating that this is the end of the word. For example, if we take hat, then from root we point to H, from H we point to A, and from A we point to T. Now as T is the end of the word, we usually mark it in the yellow color. Moving ahead, Friends, if we talk about the applications of a try data structure, then here you can see the one application would be the autocomplete of the words. So friends, you must have searched something on the Google search engine. So there, as soon as you type something, the search engine suggests the complete word to you. So this autocomplete feature is basically implemented with the help of tries. Moving ahead, the other application would be the search contacts in phone. So friends, in your smartphone, whenever you want to search any particular contact, you just type the initial letters of the person name and the application automatically suggests the name of the persons. So this application is also implemented with the help of try data structure. Also friend, one more application would be the spell checking. So here you can see that many editors such as Word, Pages implement this spell check. So here what happens, whenever user types any wrong spelling, the application auto suggests the correct spelling. So here you can see the spelling is wrong. Therefore the application is suggesting the correct spelling so that user can select from one of these options and correct the spelling. So friends, this was the introduction to the try and also its applications. In our upcoming tutorial, we will discuss more on how to implement a try, the try node, and other methods which try supports. Thanks, have a nice day. Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in our previous tutorial we actually discussed about the try data structure and also about its usage in real life applications. So in this tutorial we will actually see how we can represent a try node in Java. So friends, what is a try node? So friends, in our previous tutorial we actually discussed that the try data structure most of the time store the collection of strings. So here a try node basically represents a single alphabet of the word. So here you can see, if we take an example of dog, so this green circle having the word as D is nothing but a try node. And let's say in order to store a word dog which has 3 alphabet, we actually need 3 try nodes, which is 1 for each alphabet. So here you can see the topmost try node is empty, which is being referred by root, and all the words which we want to insert into the try originate after that. So here let's take an example of word head, and let's say we want to store the head into this try data structure. So from the root we need to create 3 try nodes storing 3 alphabets such as H, A and T. So here you can see we have created 3 try nodes. From root there is a link to H, from H there is a link to A, and from A there is a link to T. And as T is the end of the word, therefore we are marking it in the yellow color. So friend, let's see about the representation of a try node in try. So a try node class in try consists of 2 data members. So here you can see a try node has 2 data members. So the first data member is nothing but an array of try node, which are nothing but the children of that particular try node. So here it's an array which refers to other try nodes in try, and also they are called as the child nodes of a particular try node. So friends, here you can see in the most of the applications we actually store the English words. Therefore the size of the array is usually taken as 26 because there are 26 alphabets in English language. So here if we take an example of this try node, there here you can see that there is one link to D and there is one link to H, and similarly it refers to the other letters of English alphabets, and that referring is done through an array which actually refers to other try nodes. And let's say if we are on any particular try node and it refers to other try nodes, then those are nothing but the children of that try node. So here the try node array is nothing but the first data member which a try node holds. So if we talk about the second data member, so it is nothing but a boolean value which signifies that a word has ended or not. So here you can see In this symbolic representation of try, we know that dog is a complete word. So here you can see from D it goes to O, and from O it goes to G. Now we need to pass some information to this node so that we can come to know that this word is in the try and it is the end of the word. So usually in the symbolic representation we mark this node in the yellow color, stating that it is an end of the word. But in Java we actually create a boolean value. So this value is set as true when a word is inserted completely. So friends, we will discuss more about these two properties in upcoming tutorials so that we can understand more about the representation of a try node in try. So friends, let's see the demonstration of a try node. So friends, if we take an example of hat, so we can see how it gets represented into Java, because here you can see the symbolic representation and here you will see the actual representation. So at the top there is a root which is empty. So in Java we represented something like that. A try node root points to an empty try node which has an array of size 26, because we have this 26 alphabets from A to Z. And when we actually initialize a try, root points to an empty try node. So here you can see the default value of is word is false. And also you can see the size of array is 26. And each index points to a different try node. But here when we initialize this root, they all point to null value. Now let's suppose we want to insert H. So in order to insert H, we need to create a try node. And from H, we need to refer that. So here it looks something like this. That we have created one try node, and from H we are simply pointing to this try node. So this represents that there is a children to the root whose value is H, and its default value is false because this is not the end of the word. And then we actually insert A. So here you can see that A points to null. So then we create a try node and we simply provide a link from A to this try node, stating that there is a children which points to A. And finally, let's say we insert T. So it would look something like this. That initially T was pointing to null, but then we created a try node and we simply provided a value of this try node into this index. So T points to this try node. And friends, here you can see, as this is the end of the word, we simply mark the boolean value to be true. So friends, here you can see if you are storing the English words, then each try node will actually point to the other 26 try nodes so that they can store a particular word. So here we actually saw that root, which is an empty node, it points to H, H points to A, and A points to T. And also when all the other values of this array points to null, because there are no more words inserted here. So here you can see that all other links points to null. And also friends, here you can see that this is an array. So 0th index points to A, 1st index points to B, 2nd index points to C, and similarly 25th index points to Z. So how this mapping is done, we'll discuss later. So for now you can keep an information that a particular try node has an array which refers to other try nodes and whose size is basically 26 if we are taking the English words. And it also has other property which tells that whether a particular word has ended here or not. So friends, in our upcoming tutorial, we'll actually discuss more about these try nodes and how this linking is done and how this mapping is done of English alphabet to the index of an array. Till then, have a nice day. Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in our previous tutorial, we actually discussed about the representation of a try node in Java. So in this tutorial, we'll actually see how we can implement a try in Java. Friends, in our previous lecture we saw about the representation of a try node in try. That a try node has two data members. One is the try node array, which actually points to the other try nodes, and which are also called as child nodes of that particular try node. And we also discussed that if you are taking the English words, then the size of this array is 26 because the English language contains 26 alphabets. Also friends, the second data member is nothing but a boolean value which indicates the end of the word. So we set this value as true when we know that word is inserted completely. So we will discuss about these two data members in depth in our upcoming lectures. So friends, let's see the implementation of the try class. So friends, here try will be implemented using the try node class, which we actually discussed in our previous tutorial. You can also see that root try node is at the top of the try, which has empty value, and it has a try node array which actually refers to other try nodes. So here you can see if you are working with English alphabets, then there are 26 links, and these links actually point to other try nodes, signifying that there is a letter into a try, or they actually point to null. So friends, in the try class we actually create an instance variable of try node and we give it a name as root, and whenever we initialize this try class we simply create an empty try node, and then using that root try node we actually insert the other try nodes, signifying that there are letters into this try. Moving ahead, friends, now here we will discuss about the character and the index mapping, that how it is done. So friends, as here you can see that it is an array of try node. An array has indexes. So in order to store these English alphabets, we usually take the values of the index and we map it to the alphabets. So here into this array we are not actually storing these values, we are actually using the indexes and we are figuring out the alphabets. So here you can see A points to 0th index, B point to 1st index, C point to 2nd index, and similarly the rest of the alphabets. So how this mapping is done, let's see its demonstration through a code. So here you can see a char in Java is nothing but a 16-bit value which starts from 0 and goes till 65,536. So here we are creating a char value which points to A, and let's say if we typecast it to integer value, then it prints 97. So this 97 is nothing but the ASCII value of this character A. And let's say next step, from A we minus the char value A, it prints 0. Similarly, let's say we define another value H, and if we subtract the char value A from H, it prints 7, because from A, H is 7 steps ahead. And similarly, if we define a value Z, and on the console if we print Z minus the char value A, it prints 25, which signifies that Z is 25 values away from A. So friends, here you can see that we can actually map the character with an index value by using a formula that whatever the letter we pass, and if we subtract the value A, we will actually get the index value. So for example, if we pass A and if we minus A from it, we get 0. If we pass H and if we minus A, we get value 7. If we pass Z and if we subtract A, then we will get the value 25. So friends, in try, as we are referring to this array, we are implicitly mapping the index value to character. We are not actually storing these characters, but any particular index value, we are simply mapping it to a character. So friends, this implicit character to index mapping we will be using in our upcoming tutorials when we will actually insert a word into a try and when we actually search for a particular word in try. Also friends, in our previous tutorial we actually saw this demonstration. So let's look it one more time to make it more clear. So here you can see the root trinode is empty, and whatever the values we will be storing, we will be actually storing into the children's of the root. We won't be storing any value inside this root, because this root is also type of trinode which refers to other trinodes through this array, which are nothing but the child of this root. So let's say we want to insert h. So what we do is we simply traverse to the h index. We see that its value is null. So then we create a trinode like this, and then we'll simply refer its value into this index. Moving ahead, let's say we want to store a. So as soon as we have inserted a value h, and after that we have to insert a, so we use this link to traverse to this trinode, and then we go to a and we see that it's pointing to null. So then we create a trinode, and whatever value it has, we simply put it into this index. And similarly, after a, we go to t. So from this trinode, after inserting a, we simply traverse to this trinode. We go to the index which maps to t, and we see that it has null value. So we'll simply create one trinode, and whatever the value this object will hold into the memory, we'll simply store it into this index. Because here a particular trinode actually refers to other trinodes. So here this trinode is actually referring to this trinode from the index whose character value is t. Also friends, t is the end of the word, which is marked here as in yellow. So what we do is we simply set the boolean value of isWord to be true, which signifies that we have completely inserted the word hat into this try. So friends, in this tutorial we actually saw the implementation of a try, that it is made up of a try node. Now let's go to Eclipse and implement a try. Hello friends, in our previous tutorial we actually discussed about how to implement a try. We also discussed that how a try node is represented into a try. So in this tutorial we actually code the basic implementation of a try data structure. So here I have created one class by name try, having a main method. So let's start our implementation. So friends, in our previous tutorial we discussed that a try is implemented by a try node class. So first we'll create a inner class and we'll give the name to it as try node. Also friends, we discussed that a try node has two data members. One is try node array, which are nothing but children of this try node. The other data member is a boolean value, which signifies that this try node is nothing but end of the word. So we'll give it a name as isWord. We'll also provide a constructor to this try node, and inside this constructor we will initialize this try node array with a size as 26, because here we are storing English words. So these words are from A to Z. Also the value of isWord is by default false. So we set its value to be true when this try node is actually an end of the word. Also friend, we discussed that a try contains an instance variable whose type is try node, which is nothing but the root of the try data structure. So this try node, which is root, will point to other try node through this try node array. We'll also provide it a constructor So whenever we initialize a try class, we simply create the instance of try node and we'll assign it to root. So here root is empty. So here whenever we initialize a try class, root points to the try node which is empty, and after that we insert a particular word character by character which this root points. So friends, this is how we actually implement a try using this try node class. Also friends, in our upcoming tutorial we will see that how we can insert a particular word into this try. We'll also discuss that how we can search for a particular value, that whether it's there in this try or not. So friends, in our upcoming tutorial we'll actually see how we can insert a word into this try, and we'll also see that how we can search for a particular word into this try. So friends, I hope you like this video. Thanks, have a nice day. Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss how to insert a word in try. So friends, let's see a demonstration of how to insert a word in a try. Friends, in our previous tutorial we discussed that whenever we initialize a try class, root points to an empty try node, because in the constructor of the try we create a new try node and we simply assign it to the root. Now for example, let's say we want to insert a word as cat. So here you can see the word cat has three characters C, A and T, and as we are using the English alphabets, we will initialize this try node array with a size of 26, where index 0 will correspond to A, index 1 will be corresponding to B, and index 2 will be corresponding to C, and similarly index 25 will correspond to Z. Friends, we also know that each character in this word will be represented by a try node. So using this root, so first we will insert C from the root. So here what we do, we go to index 2 which maps to character C, and we will see that whether try node at index 2 is null or not. So currently as root is empty, the try node at index 2 is null. Therefore in order to insert the character C, first we will create a try node, and after creating this try node we will simply refer it from the index 2 which maps to C. Also friends, once we insert this try node, using this link we simply traverse to this position, and after reaching to this try node, now we will insert A. So what we do is we simply go to the index 0 which maps to A, and we'll see that whether it's null or not. So currently you can see that it points to null. So in order to insert A, we'll again create a try node, and after creating the try node, we'll simply refer to this try node from index 0 which maps to A. Also friends, once we have inserted this try node, using this link we will simply traverse to this try node, and then we will insert the character T. So when we reach to this try node, we simply traverse to an index which maps to T, and we'll see that whether it's null or not. So here you can see it points to null. So in order to insert T, we'll first create a new try node, and then we will simply refer to this try node from the index which maps to T. Also friends, once we insert this try node, using this link we'll simply traverse to this try node, and after we reach to this try node, we see that there are no more characters left to be inserted. So we also know that this is the end of the word. So in order to mark cat as the end of the word, what we do, to this try node we simply assign the value as true. So this value signifies that when you reach to this try node, this makes end of the word. and it also signifies that cat is in the try. Friend, let us take one more example. We'll insert a word sun. So when we call the insert method, we'll start from the root, and as we want to insert s, we simply reach to index which maps to s, and we'll see that whether it's equal to null or not. So here you can see it points to null. Therefore, in order to insert the character s, we'll first create a try node, and we'll simply refer to this try node through this link from the index which maps to s. And after we insert this try node, we simply traverse to this try node through this link. And once we reach to this link, we'll now insert the character O. So here we go to index which maps to O, and we'll see whether it points to null or not. So here you can see it points to null. So in order to insert O, we'll again create a try node, and we'll simply refer to this try node through this link from index which maps to O, and then we'll simply traverse to this try node. And after we reach to this try node, we'll now insert n. So we simply traverse to an index which maps to n, and we'll see whether it's equal to null or not. So here you can see it points to null. Therefore, in order to insert n, we'll again create a try node, and after we create a try node, we'll simply refer it through this link from index which maps to n. And also friends, here you can see now this word is inserted completely. So using this link, when we reach to this try node, we'll now simply mark this boolean value to be true, which signifies that this is the end of the word. Moving ahead. Now friends, let's suppose we want to insert a word so. So here you can see we have already inserted sun, and the word so is prefixed to sun. So let's see how we'll insert so into this try. So we'll start from the root. We go to index which maps to s, and we'll see whether it points to null or not. So here you can see this time it's not pointing to null, and it is pointing to a try node, which signifies that there is a character s into this try. So we'll not create a new try node, and we'll simply traverse to this try node, and then we'll insert o. So here we'll reach to index which maps to o, and we'll see that whether it points to null or not. So here you can see that this index doesn't point to null, and it points to a try node, which signifies that there is a character o into this try. So what we'll do, we'll simply traverse to this try node now using this link. And once we reach to this try node, we see there are no more characters left to be inserted. So in order to mark this word so that it is present into this try, what we'll do, we'll simply assign a value true, which will signify that this is the end of the word and the word so is present into this try. So friends, this boolean value is very important, which let us know that whether the particular word is present into this try or not. Also friends, if we see the symbolic representation of this try, then it looks something like this, that root is empty, and from root there are three words, C-A-T, T is the end of the word, and sun, S-O-N, where N is the end of the word, and also so, where O is the end of the word. So basically this try has three words. Moving ahead. Friends, whenever we insert into a try, there are few use cases which we will look one by one. So the first use case is, let's say we have an empty try and now we are inserting a completely new word. So when we say an empty try, it means root is pointing to an empty try node. And let's say we insert a word as cat. So from root, we will first insert C. So it would look something like this. Then we'll traverse to C. And now we'll insert A. So it would look something like this. And then we'll traverse to A. And finally we'll insert T. So it looks something like this. And then we will traverse to T. And we know that now we have inserted this word completely. Therefore, we will mark T as the end of the word by making it in yellow color. So this was the use case 1. Now friend, the second use case is when we want to insert a word into this try, and this try contains already many words, but the word which we want to insert has no prefix to this word. So the new word which we are inserting is completely altogether new to all the words inside this try. So here let's suppose we want to insert sun. So here you can see that sun doesn't have any prefix to cat. So this is an altogether completely new word into this existing try. So we'll see how we can insert sun into this try. So we'll start from the root, and first we will insert s. So it would look something like this, that there is now another branch which takes in a word s from the root. Because friends, we also discussed that root has a trinode array which points to all the English alphabets. So in this trinode array, from the index which maps to C, there is a word, and from the index S we will start inserting our new word. So after we insert S, we will simply traverse to S, and then we will insert U. So it would look something like this, and after we insert U, we simply traverse to U to insert N. So it would look something like this, and once we insert N, we will simply traverse to this node. And here we also know that we have inserted this word completely, therefore we'll mark this node as the end of the word by making it in yellow color. Friend, use case 3 is insertion with word which is having a common prefix. So here you can see in our try there is already one word there, and let's say we want to insert a word there. So here you can see both these words have common prefix. So the letters T, H, E is also present here, T, H, E. So these three letters are common to these both words. So let's see how we can insert there into this try. So here we will start from the root, and we will see that whether T is present or not. So here you can see T is already present. So we will simply traverse to T, and once we reach to T, we see whether H is present or not. So H is already present, so we will simply traverse to H. After that we will see that whether E is present or not. So here E is present, so we will simply traverse to E. And now we will see that whether I is present or not. So here you can see I is not present. So here from E there will be another branch coming out. We'll create a new trinode I, and we'll simply link to this new trinode from E. So it would look something like this, that from E there is a link to a character I, and once we insert I, we'll simply traverse to I, and we'll finally insert R. So we'll check whether R is present or not. So here you can see R is not present, so we'll create a new trinode and we'll insert R, and finally we see here that it is the end of the word. So we'll simply mark R as the end of the word. Also friends, one final use case would be that insertion with word already present into the try. So here let's suppose our try consists of a word daddy. So it has 5 nodes which points to D, A, D, D, Y. And let's suppose we want to insert a word dad. So we know that dad is already present into this try, but we need to perform some work to make sure that dad is inserted into this try. So what we do is, we start from the root, we see whether D is present or not. So D is present, so we'll simply traverse to D. We check whether A is present or not. So A is present, so we'll simply traverse to A. We check whether D is present or not. So D is present, so we'll simply traverse to D. And as we know that we have inserted this word completely, so one last thing we do is we simply mark D as the end of the word by making the boolean value is word to be true. So friends, in this tutorial we actually saw the demonstration of how we can insert a word into a try through all the possible use cases. In our next tutorial, we'll actually see the code to insert a word into a try. I hope you like this video. Thanks, have a nice day. Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss how to insert a word in try. Friends, in our previous tutorial we actually saw a demo of how to insert a word in try by seeing the different use cases. So friends, in this tutorial we'll actually see the working of this algorithm step by step. So friends, below you can see the code to insert a word into a try. So let's see its demonstration step by step. So friends, whenever we initialize a try, we know that root points to an empty try node, because in the constructor we simply create a new try node and we'll simply assign it to root. So root will point to an empty try node. Now let's say we want to insert a word cat. So here string word will point to cat. So here we are simply seeing the string word in the form of character array, where C is at index 0, A at 1 and T at 2. So we'll see how we can insert cat into this try character by character. Also friends, in our previous tutorials we discussed that we always start from the root when we are inserting any new word. So in the step 1, what we'll do, we'll simply create a temporary node current, and whatever the node root points, we'll simply assign it to current. So it would look something like this, that current points to a node which root refers. Moving ahead, friends, now we will provide a for loop, because we need to iterate each and every character of this word and we have to insert into this try. So we'll start from the 0th index and we'll iterate this for loop till index 2. So the condition we place in the for loop is I should be less than word.length. So here word.length will be nothing but 3. So as we are starting from 0, we need to traverse till 2. Moving ahead. So in the for loop, what we'll do, we'll first take the character at index 0. So we'll simply call the char@, method of the string and we will take the character at index 0, because currently the value of I is 0. So the char C will point to character C. Also friends, in our previous tutorial we discussed that how we are mapping this index with an actual character, and we saw that if we are subtracting a from any particular character, we'll get the index value. So here the value stored in C is C, and when we'll subtract a from it, we get the index value. So here index becomes 2. So in the try node array, index 2 maps to character C. So using this current try node, we'll see in the children array, which is nothing but the array of try node, and we'll see the value at index 2. We'll check whether value at index 2 is null or not. So here you can see currently value at index 2, which maps to C, is null. Therefore the condition in if block comes out to be true, which means that C is not present into this try, and now we will insert C into this try. So the first step we do is we simply create a new try node and we'll simply assign it to a temporary try node. Also friends, as we have created this new try node, we have to link the try node at index 2, which maps to C, to this try node. So what we do is we simply assign a value of node to current.children at index 2, which maps to C. So it would look something like this, that now there is a link established from root to this try node from the index 2, which maps to C. Moving ahead. And also friends, in our previous tutorial we also discussed that as soon as we insert a try node, we simply traverse to that particular node. So here we'll simply assign the value of node to current. So now current will point to this try node. Moving ahead. So after incrementing value of I becomes 1. So the character at index 1 is A. So value of C becomes A. We will evaluate the value of index by subtracting A from the value stored in char C, which is nothing but A. So when we'll do A minus A, we get the value as 0, which makes sense because index 0 will map to a character A. Moving ahead, now as current is pointing to this try node, we will check into its children array that at index 0 whether its value is null or not. So currently you can see the value at try node, which is at index 0, points to null. Therefore condition in if block comes out to be true. So in order to insert A, we'll first create a new try node and we'll simply assign it to a temporary node. And in order to insert this try node in try, what we'll do, we'll simply assign the value of node, which is this try node, to current.children at index 0. So here it would look something like this, that now there would be a link from index 0 to this try node. Then we'll simply traverse to this try node by assigning value of node to current. So now current will point to this try node. Moving ahead, now after incrementing value of I by 1, it becomes 2. So now we will insert the value at index 2, which is t, into this try. So value of char C will become t. Then we will evaluate the index of the character t. So we'll simply subtract a from t. So it will give index value as 19. So in the if block we'll again check that value at index 19 is equal to null or not. So here you can see the value at index 19 of this try node array, which maps to t, is null. Therefore condition in if block comes out to be true. Now in order to insert t, we'll first create a new try node and we'll simply assign it to a temporary node. Moving ahead, and now we'll assign the value of node to this try node array at index 19, which maps to t. So it would look something like this. The try node at index 19 will now point to a newly created try node. And finally we'll simply traverse current to this newly created try node by assigning the value of node to current. So it would look something like this, that current will now point to this newly created try node. Now after incrementing the value of I by 1, I becomes 3. So the condition in for loop comes out to be false because 3 is not less than 3. So here we simply take an exit from this for loop. And also friends, in our previous tutorial we discussed that the last step we do is we simply mark the boolean value is word to be true, stating that this is the end of the word. So we'll simply assign the value true to current.isWord. So it becomes true. Moving ahead. Now friend, let's suppose we want to insert a string sun. So we'll again call the insert method by passing in word as sun. So it would look something like this. So as we are inserting a new word, we'll start from the root. So we'll create a temporary node current which will start from the root. And then we'll simply iterate each and every character of this word using this for loop. So in the first step we'll insert s. So C will have value as s. We will evaluate its index position by subtracting a from s. So index will become 18. Then we'll provide a if block and we'll check that into this try node array at index 18, what's the value, whether it's pointing to null or not. So here you can see currently it is pointing to null. So the condition in if block comes out to be true. So in order to insert s, we'll first create a new try node and we'll assign it to a temporary try node. And as we are inserting this new try node into the try, we'll simply assign the value of node to this try node array at index 18, which maps to s. So it would look something like this, that the try node at index 18, which maps to s, now points to this newly created try node. Moving ahead, so after this assignment, we'll simply traverse current to this newly created try node by assigning the value of node to current. So it would look something like this, that current will now point to this newly created try node. So after incrementing the value of I by 1, I becomes 1. So now we'll insert O. So value of char C will become O. We will evaluate its index position by subtracting A from O. So it would give index as 14. Now as current is pointing to this node, so we will check that value of try node array at index 14, which maps to O, whether it's null or not. So currently you can see this value is pointing to null. Therefore the condition in if block comes out to be true. Now in order to insert O into this try, first we'll create a new try node and we'll assign it to a temporary try node. And as we want to insert this new try node into try, we'll simply assign the value of node to this try node array at index 14, which maps to O. So it would look something like this. Moving ahead, then we'll simply traverse current to this newly created try node by assigning the value of node to current. Now after incrementing I by 1, I becomes 2. So now we'll insert the value n. So the value of char C will become n. We will evaluate its index by subtracting A from n. So it would give index as 13. So in the if block, we'll simply check that value of this children array at index 13, which maps to n, is null or not. So currently you can see this value points to null. So the condition in if block comes out to be true. So in order to insert n into this try, we'll first create a new try node and we'll assign it to a temporary node. And then we'll simply assign this newly created node to the index 13 of this try node array, which maps to n. So it would look something like this. And then we'll simply move current to this newly created try node by assigning the value of node to current. So it would look something like this. So after incrementing the value of I becomes 3. So the condition in for loop comes out to be false. And then we will exit from this for loop. So friends, as we have inserted the word sun completely into this try, the last step we do is we simply assign the value true to current.isWord, stating that this is the end of the word. So it becomes true. Now friend, let's suppose we want to insert a word cab. So here you can see that we have already inserted word cat, and cab has a prefix CA, which maps to CA of cat. So we'll see how we can insert cab into this try. So we'll call the insert method by passing in word as cab. So word will have the value as cab. We'll start from the root by creating a temporary try node by name current, and we'll assign a value of root to it. So it would look something like this. And then we'll provide a for loop which will iterate over each and every element of the word. So we'll start from C. We'll evaluate its index position by subtracting A from C. So index become 2. So into this children array, and we will see that whether value at index 2 which maps to C is equal to null or not. So here you can see the value is not null because it is pointing to a try node. Therefore the condition in if block comes out to be false, which tells us that C is already there into this try. So the else part will be executed. So in the else part we'll simply traverse current to a try node which this try node array holds at index 2 which maps to C. So it would look something like this. Moving ahead. Now after incrementing I by 1, I becomes 1. So now we will insert A. We will evaluate its index position by subtracting A from A, which gives index as 0. Then in the if block we will check that what's the value of children array at index 0. So here you can see that it is not equal to null and it is pointing to a try node. Therefore the condition in if block comes out to be false and the else block will be executed. And in the else block, whatever the value this try node array at index 0 is referring will simply traverse current to that try node. So it would look something like this, that current will now point to this try node. Now after incrementing I by 1, I becomes 2. So now we will insert B. Then we will evaluate index position of B by simply subtracting A from B. So it would give index as 1. And now we'll provide an if block and we'll check the value of this try node array at index 1 which maps to B, that whether it's null or not. So here you can see that it is pointing to null. So the condition in if block comes out to be true. Now in order to insert B, we'll first create a new try node and we'll assign its value to node. And then as we have to insert this try node into the try, we'll simply assign the value of node to this try node array at index 1 which maps to B. So it would look something like this. And then we'll simply traverse current to this newly created try node. So after incrementing I by 1, I becomes 3. So the condition in for loop comes out to be false because 3 is not less than 3. So this for loop will exit. And in the last step we'll simply assign the value of true to current.isWord, which states that this is the end of the word. Moving ahead. So friends, now let's cover the last use case by inserting a value so. So here you can see we have already inserted a word sun and the new word which we are inserting is so. So is already there into this try. But we need to provide some additional info to this try so that it can come to know that so is actually a word. So we'll simply call insert method again by providing a word as so. We will start from the root by creating a temporary try node by name current. We'll provide a for loop which will iterate over each and every value of this word. So first we'll insert S. We'll first evaluate its index position by subtracting A from S. So index become 18. Now we'll provide an if block and we'll check the value of this trinode array at index 18, which maps to C. So here you can see that value is not equal to null. So the condition in if block comes out to be false. So the else block will be executed. And in the else block, whatever the node this children array at index 18 is pointing will simply traverse current to that node. So it would look something like this. Moving ahead, after incrementing the value of I by 1, it becomes 1. So now we'll insert O. We will evaluate index of O by subtracting A from O. So index is 14. Now we'll again provide an if block and we'll check the value in this trinode array at index 14. So here you can see the value is not pointing to null, it is pointing to a trinode. Therefore the condition in if block comes out to be false and the else block will be executed. So in the else block, whatever the value this trinode array at index 14 is pointing will simply traverse current to that trinode. So it would look something like this. Now after incrementing I by 1, I becomes 2. So the condition in for loop comes out to be false because 2 is not less than 2. So the for loop exits. And here is the most important part, that as current is pointing to this trinode and we have inserted this word completely into this trie, we will mark the isword property of this trinode to be true, stating that this is the end of the word. So by assigning the value true to this trinode, we are telling trie that the word so is in the trie. So at the later point of time, whenever we perform a search over in this trie, this boolean value will help us return a value true or false, that whether a particular word is present into a trie or not, which we will be seeing in our upcoming tutorials. So friends, in this tutorial we actually saw the demonstration of how to insert a word into a trie step by step. Now let's go to Eclipse and see the working of this code. Hello friends, in our previous tutorial we actually discussed how to insert a word in a trie and we saw the demonstration of the algorithm step by step. And also in our previous tutorial we created one class by name trie and we implemented trie with the help of trinode class. So in this tutorial we'll actually code a method which will insert a word into a trie. So here I already created one method as insert which takes in a word and whose return type is void. So we need to insert this word into the trie. So let's write the code for it. So in the first step we simply check that whether word is equal to null or not, and also we'll check that word is empty or not, because if word is equal to null or empty, then we'll simply throw illegal argument exception saying invalid input. So friends, these are the basic edge cases. And also friends, in our previous tutorial we discussed that we will be storing the English words into the trie. So we have taken the size of this trinode array to be 26. So here we will be dealing with lowercase letters. So we'll convert the word to lowercase. And also friends, before calling insert method, we actually initialize this try class. So root points to an empty try node. So whenever we insert any word, we basically start from the root. So we'll create a temporary try node and we'll assign a value of root to it. Now we'll provide a for loop which will iterate over this word character by character. So we'll start this traversing from 0 to a value less than word dot length. And inside this for loop, we will insert this word character by character. So we'll first fetch the character at the value I by calling the char method of the string. After getting the character value, we will evaluate its index position by subtracting char a from the value which C holds. So this will give us back the index position of this try node array, that where we want to insert this particular character. So after getting the index position, we'll provide an if block, and inside this if block, we'll provide a condition that try node array to a try node which current points, and at its index value which we just evaluated, we'll check whether it's equal to null or not. So if this value is null, therefore we know that this character is not inserted into try. So in order to insert this character into try, we'll first create a new try node and we will assign its value to a temporary node. And after creating this new try node, we will assign its value to the try node array at the index which we just calculated. And after inserting this try node into a try, we'll simply traverse current to this newly created try node by assigning the value of node to current. Also friend, if the value is not equal to null, then we'll simply provide an else block, and in this else block, we'll simply traverse current to a value this try node array holds at the index. So friends, after inserting this word character by character, after the for loop, we'll simply assign the value of is word to be true, stating that this is the end of the word. So friend, this is the code to insert a word into a try. So in order to call this insert method, in the main method, we'll first create the instance of try. So when we will create the instance of try, into the try constructor, the root will be initialized to an empty try node. And then we'll simply call the insert method by passing in few values, say cat, cab, sun, and so. So these are the values which we actually discussed in our previous tutorial. So at last, I will simply print values inserted successfully. If I run this code now, You see it printed values inserted successfully. Also friends, in our upcoming tutorials, when we'll actually perform the search, we can actually test the working of this insert method, that whether these words are inserted properly or not. So friend, in this tutorial we actually discussed how to insert a word into a try. I hope you like this video. Thanks, have a nice day.
Hello everyone. So in this section of course, we will be discussing about dynamic programming, and we'll see that how we can solve the problems related to dynamic programming. So in this lecture, we'll simply see that what is dynamic programming with a simple introduction. So friends, what is dynamic programming? So if you visited the website Quora, there was a question asked on how you can explain what is dynamic programming in a simple manner. And to that question, a guy named Jonathan Paulson gave an amazing reply. So what analogy is demonstrated? So let's say we write something this on a sheet of paper, and we ask that what's that equal to? So your answer would be, you will simply count each one as 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 6, 7, 8. So you simply reply 8. Now let's say if we write 1 plus to the left of it, and we ask what about that? So you will be quickly replying 9. So initially you took some time to just add all those numbers, but when we simply added plus 1 to the left of it, you straight away replied 9. So how would you know it was 9 so fast? So our basic answer would be that we simply added one more, and we didn't need to recount everything again, because we remembered this result, which is equal to 8, and we simply added plus 1, which became 9. So friends, here you can see that dynamic programming is just a fancy way to say remembering stuff to save time later. So here what we do is, let's say we calculated these values, and when we added plus 1, we didn't need to count everything again, and we knew that all these values were added to 8, and we simply added plus 1 and we gave the answer as 9. And let's say if we do 2 plus to it, then we wouldn't have counted everything again, we would have straight away replied 11, because 9 plus 2 gave us 11. So friends, here dynamic programming also works the same. Let's say when we solve any small problem, so what we do is we simply store that result, and when we encounter that same problem again, we simply take that stored result instead of recalculating the values in the problem. So friends, this is how dynamic programming works. Let's say we are given a problem to solve. So what we do is we simply break that problem into smaller problems, we solve those problems, and we store the result of those problems. So while building up the solution to the large problem, if that smaller problem comes again, we don't recalculate it. We simply use the value which we already computed. So what it does is, it simply saves our time, and the problem takes less time to compute what the exact value is. So friends, when we discuss dynamic programming in the world of algorithms, it is basically a technique in which a complex problem is solved by first breaking it into smaller subproblems, second solving those subproblems and simply storing their results, and third reuse those stored results if subproblem occurs or overlaps again. So what it means, that we are simply avoiding solving that subproblem again, and finally using solutions to smaller subproblems to build up the solution for the complex problem. So friends, as we saw an example in our previous slide, that when we counted all the ones we came to know that they are equal to 8. So what we did was, we simply remembered that all these ones were equal to 8. And when we added plus 1, we straight away came to an answer that now it's equal to 9. So here also we break the problem into smaller sub-problems and we simply store their results. So that when those sub-problems comes again, we simply use that stored results so that our time is saved and we are not recomputing those values. And finally, using these steps, we build a solution to the complex problem. So friend, if we use dynamic programming, then we can solve a complex problem very fast by simply breaking down into smaller sub-problems, remembering the result of those sub-problems, and while building up the solution to complex problem, if those sub-problems are coming again, then we simply use those stored values instead of recalculating those sub-problems again, and finally coming to a solution for the complex problem. So friend, this is how we use the dynamic programming as a tool to optimize an algorithm. So friends, in our next lecture, we'll take a problem. We will solve it without dynamic programming. We'll see the problem associated with it, and then we'll introduce dynamic programming and we'll see that how fast it makes the algorithm. Hope you liked the lecture. Thanks, have a nice day. Hello everyone. So friends, in our previous lecture, we discussed about what is dynamic programming. So in this lecture, we will discuss more about dynamic programming and its relationship with recursion. We will see how recursion and dynamic programming go hand in hand. So here if you see, we mostly use dynamic programming to provide an optimization over recursion. So here let's say we use recursion to solve any problem. So usually it happens that when we solve a recursive problem, we tend to make the code inefficient, which means using recursion we can solve the problem, but what it happens is the problem is solved, but it tends to take more time. So in our previous lecture, we discussed that how dynamic programming usually help us to solve a complex problem by breaking it down into smaller sub-problems and then solving those sub-problems. And while solving those sub-problems, what we do is we simply store the result of those sub-problems, and whenever that sub-problem comes again into picture, we usually extract the stored result and we reuse rather than computing it again and again. So similarly, when we solve any recursive problem, what we do is we simply break it down to smaller sub-problems and we solve those sub-problems and we store those results. So whenever that sub-problem comes back into picture, we usually use the stored result of that sub-problem and we avoid recalculating the solution to that sub-problem. So by doing that, a recursive problem gets optimized. So if we see, the basic definition of dynamic programming is basically taking recursion plus memorization. So here we tend to solve a problem recursively, and when we solve the sub-problem, we usually memorize those solutions. And later point of time, if that sub-problem comes again back into picture, we use the memorization solution rather than again calculating those sub-problems. So friends, in order to explain what is the problem with using recursion directly and what's the advantage of bringing in dynamic programming with recursive solutions, we'll see an example. So we'll take the example of Fibonacci series. So what is Fibonacci series? So as per the definition, it is a series of numbers in which first two numbers are 0 and 1. After that, each coming number is the sum of the two preceding numbers. So if we go by this definition, then this is the formula which comes out. So here first two numbers are 0 and 1. So here you can see the Fibonacci of 0 is 0 and Fibonacci of 1 is 1, which means that first two numbers are 0 and 1. After that, each coming number is sum of the two preceding numbers. So let's say I want to calculate the nth Fibonacci number. So in order to calculate the nth Fibonacci number, what I can do is I can simply do the sum of the n-1th Fibonacci number and n-2th Fibonacci number. So which means that we are simply doing the sum of the two preceding numbers and getting the current number. So here you can see this is the Fibonacci series of first few numbers, where the first two numbers are 0 and 1, which is this. So let's say we want to calculate what's the Fibonacci number 2. So the Fibonacci number 2 is the Fibonacci number 1 plus the Fibonacci number 0. So here you can see the Fibonacci number 1 is 1 and Fibonacci number 0 is 0. So we do 0 plus 1, we get the number 1. If you want to calculate Fibonacci number 3, we simply take the two preceding numbers, which is 1 and 1. So when we do 1 plus 1, we get 2. And similarly, 1 plus 2 will give 3. 2 plus 3 will give 5. 3 plus 5 will give 8. 5 plus 8 will give 13. And 8 plus 13 will give 21. So this is how the series goes. If you want to calculate any Fibonacci number, we simply take the preceding two numbers, we do the sum of it and we get the number. So this is the basic formula to calculate the Fibonacci number. So friends, in our next lecture, we'll take this example of Fibonacci series and we'll see that how plain recursion in calculating the Fibonacci number is less optimized, and then we'll see that how we can bring dynamic programming more optimized. I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in our previous lecture, we discussed that how recursion and dynamic programming go hand in hand. And we also discussed that dynamic programming provides an optimization to recursion problems. And we also discussed about the Fibonacci series. And we saw that Fibonacci series is nothing but a series where first two numbers are 0 and 1. And after that each number is the sum of two preceding numbers. And we saw that we can calculate the Fibonacci number using this formula. So in this lecture we'll take the example of Fibonacci series and we'll see that how recursion is less optimized when solving the problem of the Fibonacci number. And then we'll see that how we can use dynamic programming to make this recursion problem highly optimized. So friends, in order to calculate the nth Fibonacci number, this is the basic algorithm which uses the recursion. So here you can see that we are using this formula to calculate the nth Fibonacci number. So you can see that when value of n is 0, we are simply returning 0. When the value of n is 1, we are returning 1. And in order to calculate the nth Fibonacci number, we are recursively calling this fifth function with the value of n-1 and n-2, and we are simply doing the sum of it to get the value of nth Fibonacci number. So here you can see that we are calling this method recursively by passing n-1, and whatever is written from it we are storing in an integer variable left, and then we are calling recursively the fifth function with the value n-2, and we are simply storing it in the integer value right, and finally we are doing the sum of it because we know that we need to do the sum of the two preceding numbers. So which is these two numbers. We are doing left plus right and we are simply returning the result. So this is the plain recursion without using any dynamic programming. So we'll see step by step how this algorithm goes. So let's say we want to calculate the fifth Fibonacci number. So then you can see that the fifth function will be called where n will be equal to 5. So we have called fib of 5. Then we move ahead n is equal to 5. Therefore the condition if block comes out to be false. We move ahead. N is not equal to 1. Therefore the condition if block comes out to be false. So we move ahead. And here you can see now we are again calling the fifth function with the value as n minus 1, which is nothing but 5 minus 1, 4. And we are going to call this fifth function recursively. So it would look something like this, that the fifth function will be called again with a value of n as 4, like this. And then we'll move ahead. N is not equal to 0, so we move ahead. N is not equal to 1, so we simply move ahead. And then we again call the fifth function with the value as n minus 1, which is 4 minus 1. So it would look something like this. The fifth function will be called with the value as 3, like this. We move ahead. The condition in if block comes out to be false because n is not equal to 0. Similarly, n is not equal to 1. So we move ahead. And here we again call the fifth function with the value as 3 minus 1, which is 2. So it would look something like this. The fifth function will be called with the value as 2. N is not equal to 0, so we simply move ahead. N is not equal to 1, so we move ahead. Now we are again calling the fifth function recursively with the value as 2 minus 1, which is 1. So it would look something like this. The fifth function will be called again with the value as 1, like this. So n is not equal to 0, so we simply move ahead. But now you can see that n is equal to 1, which is this. So we have encountered a base case where we want to return 1 now. So here fib of 1 is actually 1. So 1 will be returned from this fib of 1 to fib of 2. So it would look something like this. As we have left the fib of 2 at this point, we'll start executing from this point, where now left will get the value as 1 because we have returned 1. And now we'll move ahead. So here you can see that n is 2, and when we do n minus 2 and call the fifth function again, so it would look something like this, that it will call fib of 0. So it would look something like this. Now n is equal to 0. So now we'll simply return 0 from here. So it would look something like this, that 0 will be returned to fib of 2. And as we have left fib of 2 here, we are again coming back to this point. And finally we'll return left plus right, which is 1 plus 0, which comes out to be 1. So from fib of 2, we'll simply return 1. And as we have left fib of 3 at this point, we'll start executing now from this point. Here n is 3. We'll again call the fib of 3 minus 2, which is 1. So now fib of 1 will be called again. It would look something like this. N is not equal to 0. N is equal to 1. So we'll return 1 from here. And as we have left fib of 3 from this line, we'll start executing from this line. And we'll simply return left plus right, which is 1 plus 1. So from fib of 3, we are simply returning 2 to fib of 4. So we know that we had left fib of 4 at this point. So we'll start executing from this line. And then we'll call again this fib function recursively with a value as 4 minus 2, which is 2. So now fib function will be called with the value as 2. So it would look something like this. So n is not equal to 0. So we'll simply move ahead. N is not equal to 1. So we'll simply move ahead. And then from fib of 2, we are again calling the fib function recursively, because in order to calculate the fib of 2, we need to do the sum of two preceding numbers, which is fib of 1 and fib of 0. So first we are calling the fib of 1, because 2 minus 1 is 1. So it would look something like this. The fib will be called with the n as 1, and it would look something like this. So we will now again calculate fib of 1. We know that n is not equal to 0. So we'll simply move ahead. And here we know that n is equal to 1, because we are calculating fib of 1. So the condition in if block comes out to be true, and we are simply returning 1. So 1 will be returned to fib of 2, and we had left fib of 2 from the left side. So 1 will be stored in left, and then we'll simply move ahead. And then we'll go to its right by calling fib of n minus 2. So fib of 2 minus 2 is 0. So we'll simply call fib of 0 again. So it would look something like this, that now we are going to its right. So here we know that n is equal to 0. So we'll simply return 0 from its right. So we'll go back to fib of 2. And as we are returning it from the right, we start our execution from this point, where n is equal to 2 now. So finally we'll simply return left plus right, which is 1 plus 0. So fib of 2 will be returning 1 to fib of 4 from its right. So as we are returning it from the right, we'll start executing from this point, that we had left fib of 4 from the right side. So right will be having the value as 1, which we have returned it from fib of 2. And finally we'll return left plus right, which is 2 plus 1 from the fib of 4, which is 3. So this 3 will return to fib of 5, which we had left from the left side. So we'll start our execution from this point, where n is 5 now. And now we'll go to its right by again calling fib of n minus 2, which is 5 minus 2, which is 3. So fib of 3 will be called again. N is not equal to 0. N is not equal to 1. Now we'll go to its left, because in order to calculate fib of 3, we need to calculate fib of 2 and fib of 1. So we'll call fib of n minus 1, which is 3 minus 1, 2. So it would look something like this. N is not equal to 0. N is not equal to 1. And in order to calculate fib of 2, we'll first call fib again recursively by passing 2 minus 1, which is 1. So it would look something like this. n is not equal to 0. Now here n is equal to 1. So we'll simply return 1 from fib of 1 to fib of 2 like this. And as we have left fib of 2 from its left, we'll start our execution from this point. And we'll simply store 1 to the left, because this is what is returned from fib of n minus 1. And now we'll simply go to its right by calling fib of n minus 2, which is 2 minus 2, which is fib of 0. So it would look something like this, that fib of 0 will be called again. And here n is equal to 0, so we'll simply return 0. So as we are returning it from the right side, we'll start our execution from this point, because 0 will be stored in right. And finally, from fib of 2, we simply return left plus right, which is 1 plus 0. So 1 will be returned from fib of 2. And as we have left fib of 3 from its left, we'll start our execution from this point. And 1 will be stored in the left. Then we'll go to its right again by calling fib of n minus 2, which is 3 minus 2, which is 1. So fib of 1 will be called again. N is not equal to 0. N is equal to 1. So we'll simply return 1. So 1 will be returned to fib of 3. And as we are returning it from the right, we'll start our execution from this point, where 1 will be stored in right. And finally from the fib of 3, we'll return left plus right, which is 1 plus 1, which is equal to 2. So 2 will be returned from the fib of 3 to fib of 5. And as we have left fib of 5 from its right, we'll start our execution from the right, where 2 will be stored in right. And finally we'll simply return left plus right from the fib of 5, which is 3 plus 2, which equals to 5. So friends, the fifth Fibonacci number has a value of 5, which we have returned finally from fib of 5. So friends, here you can see that we use plain recursion to calculate the fifth Fibonacci number. So this solves our problem, but here you can see that it is very less efficient code. As you can see that we are calculating fib of 5, fib of 4, fib of 3, fib of 2, fib of 1 and fib of 0. But here you can see the boxes in blue color are recalculated again. So for example, here you can see that fib of 3 we calculated the value as 2, and here we again calculated the value of Fibonacci 3 as 2. So we went inside again this tree which you see here, and similarly you can see that fib of 2 we calculated here, then we calculated here, and then we calculated here. And similarly fib of 1 we calculated here, here, here and here. And same as Fibonacci 0, we calculated it here, here, here. So here you can see the boxes in green were the actual calculation which we wanted to calculate. But as we were using this recursion, we need to again recalculate everything here again in the blue boxes. So this makes this algorithm very less efficient. So what dynamic programming says is, when we were computing Fibonacci of 3, Fibonacci 2, 1, 0, what if we stored those values somewhere, and later point of time when we wanted to recalculate Fibonacci 3, 2, 1, 0, we could have used those values directly without going into again recalculating those values. So as per the dynamic programming definition, a complex problem is solved by making it into smaller sub-problems. We store those sub-problem results somewhere, and when we get those problems again, like here, 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 instead of recalculating those things again and again, we can simply use the stored result and we can solve these problems very fast. So here you can see that dynamic programming basically provides an optimization to the recursion, and as we saw in the definition, that it is basically an optimization over recursion. Plus dynamic programming is nothing but recursion plus memorization. So here we use recursion, but somewhere we memorize the solutions and we store it somewhere, so that when those sub-problems comes again into picture, we usually use the stored solutions rather than recalculating them again and again. So using this technique, dynamic programming provides an optimization over recursion. So friend, in this lecture we saw that how plain recursion can be a problem in solving a complex problem. So friends, in the upcoming lecture, we'll see the demonstration of how we can use dynamic programming to use recursion with memorization, and we'll see that how we can solve the problems such as Fibonacci series very fast. I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in our previous lecture, we saw an example to calculate the nth Fibonacci number, and we saw that how we can solve the problem using recursion, and we also saw that when we use recursion in calculating the nth Fibonacci number, the problem was solved, but the solution was very less efficient. So friends, in this lecture we will discuss that how we can identify that a particular problem comes under dynamic programming. So usually dynamic programming problem has few characteristics. So one of the characteristics is optimal substructure. So what do we mean by optimal substructure? So here you can see that a given problem has optimal substructure property if optimal solution of the given problem can be obtained by using the optimal solution of its sub-problems. So which means we are given a complex problem and we want to solve that problem, and if that problem can be solved by breaking it down into smaller sub-problems and using the solution of those sub-problems and obtaining the solution to the complex problem, gives the problem a property known as optimal substructure. So in our previous lecture, we saw that how we can calculate the nth Fibonacci number, and we also saw that how we can solve the problem of nth Fibonacci number by using the formula as, if you want to calculate the nth Fibonacci number, you need to find the sum of its preceding Fibonacci numbers, which is fib of n-1 and fib of n-2. So here you can see the complex problem has been broken down into smaller sub-problems, which again gets broken down into more smaller sub-problems, which we saw in our last lecture. Therefore, as an example, we can say that if you want to calculate the nth Fibonacci number, we can calculate by breaking it down into smaller sub-problems. Thus, this problem has optimal substructure. So in our last lecture, we saw that in order to calculate the nth Fibonacci number, we can use the recursion and we can solve this problem. So while using recursion, we saw that if you want to calculate, let's say, the fifth Fibonacci number, so here in order to calculate the fifth Fibonacci number, we break this problem into two sub-problems by first calculating the fourth Fibonacci number and the third Fibonacci number. So we further broke this problem into sub-problems and similarly it goes on like this. So finally, when we reach to a point that a problem cannot be divided further, so we usually encounter the base cases, which is n is equal to 0 and n is equal to 1. And then using the result of those base cases, we solve the sub problems. Then we use the solution to solve the bigger sub problem, and doing this, we finally solve our main problem. So here you can see that this complex problem has a property of optimal substructure, where a complex problem can be solved by breaking it out into smaller sub problems and using its solutions to solve the main problem. So this one property, optimal substructure, helps us to identify that whether a problem can be a dynamic programming problem or not. So friends, in our next lecture we will see that there is one more property. Combined with this property makes a problem a dynamic programming problem. So we'll discuss that property in our next lecture. I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in our previous lecture we discussed that how to identify a particular problem, that whether it is a dynamic programming problem or not. We saw that dynamic programming has few characteristics. So one of the characteristics which we discussed in our last lecture was optimal substructure. So in this lecture we will see that there is one more characteristic which basically help us to identify that whether a particular problem is a dynamic programming problem or not. So here the other characteristic is overlapping subproblems. So what is overlapping subproblems? So friend, let's suppose we are given a problem and we want to identify that whether the given problem has overlapping subproblems property or not. So we can simply identify the overlapping subproblems property by first taking the problem and breaking it down into smaller subproblems and solving those subproblems to get the solution of main problems. Now what this overlapping subproblems means? So let's say if our solution of a given problem is obtained by solving the same subproblems multiple times. So friends, few lectures back we saw that when we solved the nth Fibonacci number problem using recursion, there we saw that in order to solve the nth Fibonacci number, we first broke it down into smaller subproblems using recursion. And when we were building up the solution back by solving the smaller subproblems, we saw that those smaller subproblems were encountered multiple times. So here the example of calculating the nth Fibonacci number has few subproblems which are overlapping to each other. So here you can see that in one of our previous lecture we calculated the nth Fibonacci number using recursion, and here you can see that in order to solve the fifth Fibonacci number, we broke it down into smaller subproblems, something like this, by using these properties that nth Fibonacci number is equal to n minus 1th Fibonacci number plus n minus 2th Fibonacci number, which is nothing but taking the sum of previous two Fibonacci numbers. So friends, here you can see that when we solve this problem, so in this diagram you can see the boxes which are in blue color are basically the smaller subproblems which have occurred multiple times. So for example, you can see that when we want to calculate the third Fibonacci number, we calculated second Fibonacci number, first Fibonacci number, and again to get the value of second Fibonacci number, we broke it down into smaller subproblems by calculating the fib of 1 and fib of 0. If we see the tree of fib of 3, this much, you can see that we have recalculated this tree here again. And also if you see the tree of fib of 2, which is this much portion. We have recalculated it here and here. And similarly, fib of 1, we have recalculated it here, here and here. And same goes with fib of 0. We have calculated it here, here, here. So friends, here you can see that when we solve this problem by breaking it down into smaller sub-problems, we encountered that this problem has multiple overlapping sub-problems. Here this same problem overlapped with this sub-problem overlapped with this and this. Thus the problem to calculate the nth Fibonacci number has overlapping sub-problems. And also friends, you can see that it also has optimal substructure where we are breaking it down into smaller sub-problems and solving those sub-problems to get the solution to the main problem. So friend, a problem is considered to be a dynamic programming problem when it follows the two properties: the optimal substructure, which we discussed in our last lecture, and overlapping sub-problems, which we are discussing now. So friends, in our previous lecture we also discussed that this solution is very less optimized because we are recalculating the values of the sub-problems multiple times. So for example, let's say we calculated fib of 3, which has value 2. Now what if I store this value somewhere, and let's say when I encountered fib of 3 again, instead of going to this deep tree, I can just return 2. So I don't have to calculate this tree again. Similarly with fib of 2, if I store the value as 1, I can avoid recalculating this subtree and this subtree. Thus you can see that if I calculate the values in green box once, I can store those values and simply I can reuse whenever these values are required again. Therefore it's a perfect example of demonstrating that nth Fibonacci number is a dynamic programming problem. So friends, in our next lecture we'll see that how we can store these values somewhere and can reuse them again whenever the same sub-problems occurs multiple times. So friends, I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in our previous lecture we discussed about the two main characteristics of a dynamic programming problem, which was optimal substructure property and overlapping subproblems property. So friends, till now we saw that how we can solve a problem using recursion. So in this lecture and in upcoming lecture we'll see that how we can solve a problem using dynamic programming. So friends, there are two approaches to solve a dynamic programming problem. The first approach is bottom-up approach. So what do we mean by it? In bottom-up approach, we try to solve smaller subproblems first, use their solution to build on and arrive at the solution to bigger subproblems. So which simply means, so let's say if you want to solve a complex problem, so instead of solving the complex problem at once, what we do is we start with the smaller subproblems. We try to solve those subproblems. We use those subproblem solution to arrive at a solution to the bigger subproblems. And this way we try to solve the bigger subproblems and finally reach to the solution of our main problem. So the bottom-up approach is also called the tabulation method, because in this approach when we solve the smaller subproblems, we usually store the result of those smaller subproblems into a table, and when those smaller subproblems are encountered again, then we simply use the values from the table to arrive the solutions to the bigger subproblems, and this way solving the chain of subproblems we reach to the solution of the main problem. Therefore, the solution is built in a tabular form by using the solutions of smaller subproblems iteratively and generating solutions to bigger subproblems. So friends, in our previous lecture we saw that when we used recursion and when we solved the nth Fibonacci number problem, we saw that it was less efficient code because we were recalculating the subproblems again and again. So instead of recalculating the subproblems again and again, what we do is we store the results of those subproblems in a table, and when those subproblems are encountered again, we simply use the values of those smaller subproblems from the table itself without going to solve those subproblems again and again. So friends, now let's look at the demonstration of bottom-up approach, that how we can use the tabulation method to memorize the solutions of the subproblems and reuse them later when those subproblems are encountered again. So here you can see that in this example we are simply calculating the nth Fibonacci number, and this time instead of using recursion we are using the bottom-up approach, which is nothing but solving it via one of the methods of dynamic programming. So let's say we want to calculate the fifth Fibonacci number. So here when we call this function fib, the value of n will be 5. So in the first step what we do is we simply create a table which is nothing but an array to store the result of the smaller subproblems. So when we want to use the result of those subproblems again, we can simply refer this table, pick up that value and simply reuse. So friends, here we will simply create a table of length n plus 1. We will see why we are taking the length as n plus 1. So it would look something like this, that there will be an array by name table having 6 elements from 0 to 5, and we are using n plus 1 because we know that array starts from 0, and if you want to calculate the fifth Fibonacci number, the value of fifth Fibonacci number will be stored at the fifth index of the array. So therefore we are using n plus 1. Moving ahead. So friends, as we know that Fibonacci series starts with 0 and 1. So here you can see we are simply assigning the value as 0 and 1 to the 0th index and the first index. So we are assigning 0 to the 0th index, and then we are assigning 1 to the first index. Moving ahead. So friends, here you can see that we want to calculate the fifth Fibonacci number, which is this, but we are starting from the bottom by using these base cases. Therefore this approach is also called as bottom-up approach, because we build our solution by traversing from the bottom and we move up and finally we reach to our solution. So friends, here you can see that we have calculated the value at 0th index and at the first index. So now what we do is we provide a for loop. We start from the second index, and this for loop will go till the value of I is less than equal to 5. So here you can see I becomes 2, and as I is equal to 2, here we can see that I is less than equal to 5. Therefore the condition in for loop comes out to be true and the for loop executes. Also friends, we know that how we can calculate the Fibonacci number. We simply do the sum of its two preceding numbers. So here what we are simply doing, we have already stored the result of 0th index and the first index, and when we want to calculate the second Fibonacci number, we simply do the addition of the first preceding number, which is I minus 1, and the second preceding number, which is I minus 2. So this is nothing but we are doing the sum of its two preceding numbers, because in this table we are actually storing the Fibonacci series. And when we want to calculate the second Fibonacci number, we simply do the addition of its two preceding numbers, which is 0 and 1. So here you can see the value stored at table I-1, which is 2 minus 1 index, has value 1, and the value stored at table I-2, which is 2 minus 2, has the value 0. So we'll simply add 1 plus 0 and store the value 1 at the second index here. So these are the two preceding numbers which we will add and store at this position. So now the value at second index becomes 1. Moving ahead, now we'll increment I, so I becomes 3. And now we want to calculate the value at the third index. So we'll simply do the sum of its two preceding numbers with I-1 and I-2. So I-1 gives the second index value and I-2 gives the first index value. We'll do its sum, which is 2, and we'll store 2 at the third index. So value 2 is nothing but the third Fibonacci number. Moving ahead, now when we increment I by 1, I becomes 4. And now we want to calculate the value of the fourth Fibonacci number, which is stored at fourth index. And this value can be obtained by doing the sum of its two preceding numbers, which is at index 2 and 3, which can be obtained by taking the value of the table I-1 plus I-2. So I-1 gives the value at third index, I-2 gives the value at 4 minus 2, which is the second index. So we'll do its sum. 1 plus 2 becomes 3. We store 3 at the fourth index. Moving ahead, now we'll increment I by 1, so I becomes 5. And then we'll simply calculate the fifth Fibonacci number by doing the sum of its two preceding numbers, which is nothing but I-1, which is 5 minus 1 equal to 4, the fourth index, and I-2, which is 5 minus 2, which is 3, and that is nothing but value stored at third index. So we'll do the sum of these two values, which is 2 plus 3 equal to 5, and we'll store the 5 at the fifth index. And now we'll increment I again, so I becomes 6, but here you can see that 6 is not less than equal to 5. Therefore the condition in for loop comes out to be false and for loop terminates. So friends, we simply return the value stored at fifth index, which is nothing but our fifth Fibonacci number, which is 5. So friends, here you can see that in our previous lecture we used recursion to solve the nth Fibonacci number problem, and we saw the solution was very less efficient because we recalculated the values of the sub problems again and again. So here what we did, we simply created a table to store the results of the sub problems, and when we wanted to use the values of the sub problems again, we simply referred this table, used those solution and build up upon the solution to the main problem. So here we started from the bottom, which is from the 0th index and the first index, and as we knew that the first two number of Fibonacci series are 0 and 1, we simply used those two values to come up with the second Fibonacci number. Then we used the first Fibonacci number and the second Fibonacci number. We did its sum. We got the value of the third Fibonacci number. And similarly, we got the value of fifth Fibonacci number. So friends, here you can see that using this tabulation method, we are storing the results of the sub-problems, and we are not recalculating the values of those sub-problems. We are simply referring to this array. We are taking out the values and we are simply using to build up upon the solution to the main problem. So this is a bottom-up approach to solve the problem of calculating the nth Fibonacci numbers. So friends, now let's go to Eclipse and see the demonstration of this code. I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in this lecture, we'll see how we can code a program to find the nth Fibonacci number using dynamic programming. And in this lecture, we'll use the bottom-up approach. So friends, in our previous lecture, we saw the algorithm of how to find the nth Fibonacci number using the bottom-up approach. We saw its animation. And here in Eclipse, we'll actually code the algorithm. And using this main method, we'll see it's working. So here we'll create one method as public, which will return us back the nth Fibonacci number. So int, we'll give the method name as fib, which will take the value of n for which we want to find the Fibonacci number. So friends, for the positive values of n, we need to return the nth Fibonacci number from this method. And as we are discussing the bottom-up approach using dynamic programming, we know that this approach is nothing but a tabulation approach, where we create the table and store the results of the sub-problems. And when those sub-problems comes again into picture, instead of recalculating them, we simply reuse the values stored in the table. So here we'll create an array. We'll give it a name as table. And the size of the array would be n plus 1. Because as array is indexed from 0 and we are using this table to store the individual Fibonacci number. So in order to get the nth Fibonacci number, we need to create a table which can store n plus 1 items. So that it will start from 0 to n. And at the nth index, we will have our nth Fibonacci number. Also friends, what we discussed in our previous lectures, that the first two numbers of the Fibonacci series are nothing but 0 and 1. So table at the 0th index will have value as 0 and table at the first index will have value as 1. And also friends, we discussed that in Fibonacci series, if you want to know the current number, you just need to do the sum of its two previous numbers. So here we have this first two numbers. If we do sum of these two numbers, we'll get the second number. And similarly, using this approach, we can come to know that what is the nth number. So we are simply storing the Fibonacci numbers in this table array. So we have used the 0th index and 1st index. So now we'll start from the second index. We are starting from the second index. And as here you can see, the table has size of n plus 1. So we'll provide a boolean condition here that if I is less than equal to n, just iterate this for loop. We'll do I plus plus. So friends, here you can see the advantage of creating a table array. What we can do is simply Let's say if we want to calculate the ith Fibonacci number, we simply do the sum of its two previous numbers. And whatever the value is computed from this equation, we simply store it into the table at ith index. So thus this table helps us in computing the nth Fibonacci number from the bottom, which is from the 0th index to the nth index. So we have this first two values as index 0 and 1. The second value is computed by adding this value and this value, which is I minus 1 and I minus 2, and storing it into the second index. And similarly the third index will be calculated by adding the value at second index and the first index. So this loop keeps on going ahead and ahead, taking previous two values, doing their sum and storing it into the current ith position. And finally when this loop terminates, the final value will be stored in the table at the nth index, which we also saw in our previous lecture using the animation. So we'll simply return that value. So here first we'll create the object of Fibonacci number class. We'll provide a sysout to print the nth Fibonacci number. Let's say we want to print the 6th Fibonacci number. We simply call the method fib and we'll pass the value as 6. And now we'll simply run the program. So here you can see the 6th Fibonacci number is 8. So which is something like this. That series starts from 0, 1 and then the rest of the values are calculated by using the sum of its two previous numbers. So 0 plus 1 gives 1, 1 plus 1 gives 2, 2 plus 1 gives 3, 3 plus 2 gives 5 and 3 plus 5 gives 8. So the 6th Fibonacci number which comes out is 8. So friends, this was the demonstration of code to find the nth Fibonacci number using dynamic programming with a tabulation method, which is nothing but bottom-up approach. I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in this lecture we will discuss about the top-down approach. So in our previous lecture we saw that how we can solve a problem using dynamic programming with a bottom-up approach. And in this lecture we'll see that how we can solve a problem using top-down approach. So what is top-down approach? So this method is also called as memoization. So what it means is that in this method we break the large problem into multiple sub-problems. Each of the sub-problems are solved and solutions are remembered. So by remembering the solutions, we treat it as a memorization and the term given to it as memoization, which means that something we are remembering to reuse it later. So how does it work is, if the sub-problem is solved already, we simply reuse the answer. So here you can see that we are solving the sub-problems and its solutions are remembered. So later point of time, if that sub-problem comes again into picture, we simply reuse the remembered answer. Or else what we do is we simply solve the subproblem and store the result, which simply means that we are remembering the solution somewhere. Thus it memorizes the solution of the subproblem to avoid the recomputing the value if subproblem is encountered again. So friends, in our previous lecture we also saw that when we are doing recursion, we can solve the problems by breaking it down into multiple subproblems. And if those subproblems are encountered again, then instead of recalculating it again, we simply store the solution of that subproblem, and when those subproblems are encountered again, we simply use those solutions rather than computing them again and again. Thus it brings the optimization to our recursion. So here we'll see a program to find the nth Fibonacci number using top-down approach. So here you can see this is the algorithm where we need to find the nth Fibonacci number, and here we are also passing an integer array which will simply help us in memorizing the solutions of the subproblems, and we will frequently check this integer array to see if those subproblems are solved already or not. So if those subproblems are not solved, we proceed ahead, we solve those problems and we store it into this integer array. And if the subproblems are solved already, we simply reuse the solution. So this memo array helps us in remembering the solutions so that we can reuse those solutions if the same subproblem is encountered again. Thus it provides the optimizations to our recursive solutions. So friend, as this is the recursive solutions, we'll also see the demonstration using the call stack. So let's say we want to calculate the fifth Fibonacci number. So we'll simply pass an empty array with the size is 5 plus 1, which is 6, because we know that the indexes of array are starting from 0, and this memo table will store our Fibonacci numbers from 1 to 5. So the value stored at the fifth index will be our answer. So therefore we are creating an array of size 6. So in the first step it would look something like this, that we have an array of size 6 having the default value is 0, and on the call stack you will see the fib method has started its execution with the value of n as 5 and with the integer array shown here having all the values as 0. So friends, here you can see that as we are using the top-down approach, we are starting from the fifth index, which is the topmost index, and then we are going to the bottom. In the bottom-up approach, we started from the 0th index and we went till the 5th index, but here we are starting from 5th index and we are going to the bottom. So here we are simply checking if the value at 5th index is 0 or not. So here you can see the value at 5th index is 0, which in terms of this problem, it is not solved. So the condition in if block comes out to be true, and we need to calculate this value. So first we check whether the n is less than 2 or not. So here you can see the value of n is 5, which is not less than 2. So the condition in if block comes out to be false, and the else part gets executed. So here we also know that in order to calculate the fifth Fibonacci number, we need to do the sum of its two previous numbers, which is the number stored at third index and the fourth index. So in order to do that, we simply call the fib function again, passing in the memo array and the value is n minus 1, because we need to calculate this value and then do the sum of these two values to get this value. So here you can see that now this fib function is called recursively, and we are leaving this fib function on the call stack at line number 6. So we'll simply add the line number 6 here, so that later we can come to know that from which point we need to restart this fib function. So we have left this function, and on the call stack there will be one more fib function, with this memo array and the value of n is 4 because we are passing n minus 1. So 5 minus 1 gives 4. So this function will be executed with n equal to 4. We check that whether value at 4th index is computed or not. So we know that it is equal to 0, therefore it's not computed. So then we go ahead and compute it. 4 is not less than 2. So the condition in if block comes out to be false. And now in the else block, if we want to compute the value at 4th index, we need to compute the value at 2nd and 3rd index, do their sum and get the value at 4th index. So friends, here you can see that first we will need to calculate the value at 3rd index. So we'll again call the fifth function, passing in the array and the value as n minus 1, which is 4 minus 1 equal to 3. And we also know that we have to leave this fifth function at line number 6. So we'll simply store the line number here. And then the fifth function will be called again. And on the call stack, you can see we have left this fifth function and we have started executing this fifth function with the value of n as 3. We check whether the value of 3 is computed or not. So here you can see the value of n is equal to 0, therefore it's not computed. We check whether n is less than 2 or not. So 3 is not less than 2. And here in order to calculate the value of the third Fibonacci number, we need to first calculate the values of its two preceding numbers. So we again call the fifth function, passing it the integer array and the value as 3 minus 1, which is 2. And we are leaving this function at line number 6. So the fifth function will be called again with the value of n as 2. So on the call stack there will be another fifth function with the value as 2. We will see the value at second index is computed or not. So here it is equal to 0, therefore it's not computed. We check whether 2 is less than 2 or not. So 2 is not less than 2. So we'll start executing the else part. And here also, in order to calculate the value at second index, we need to first calculate the value of its two preceding numbers, do their sum and get the value of second index. So first we'll go to the n minus 1 part, which is 2 minus 1, which is equal to 1. So here now fifth function will be called again. So we are leaving this fifth function at line number 6. So we'll store the line number here. And then fifth function will be called again with the value of n as 1. So on the call stack it would look something like this. We see that value at first index is computed or not. So here you can see it is equal to 0. Therefore it's not computed. And we proceed ahead. Now we check whether n is less than 2 or not. So here you can see that n is less than 2 because the value of n is 1. So friends, here you can see that why we have provided this if block. So we know that the Fibonacci series starts from 0 and 1. So we are simply checking that whether n is less than 2 or not. If it is less than 2, we are simply storing the value of n to the memo of n. So here value of n is 1. So at the first index, we are storing the value as 1. So it would look something like this. So 1 is stored at 1th position. So after this step, finally we return the value stored at first index. So friends, here you can see that why we are returning this value 1 here, because we called this fifth function from this fifth function and we left at line number 6. So at line number 6 we had to calculate the value of 1 and then we have to calculate the value of n minus 2 and then do the sum of these two values to get the value at second index. So therefore we have calculated the fib of n minus 1, which is 1. So we are simply returning the value 1 from this fib function to this fib function. So it would look something like this. This fib function will be removed from the call stack, and the call will go to this fib function, and we also know that we had left at line number 6. So we'll start executing from the line number 6. And whatever we return from this method will be stored in the left, which is nothing but 1. Moving ahead. Now here you can see that when we are executing this fib function, the value of n is 2. We have computed one of its previous value, which is n minus 1, and now we have to find the value n minus 2, so that we can do the sum of these two values and get the value at the second index. So therefore now we'll again call the fib function to calculate the n minus 2th value. So here you can see that now we are again calling fib function, and we are leaving this fib function in line number 7. So we'll simply update the line number 7, so that we can come to know the later that at which line we left this function. So we have updated the line number, and now this fib function will be called with the value as n minus 2, which is 2 minus 2, which is equal to 0. So it is called for fib of 0. And here we check if the value at 0th index is computed or not. So it is equal to 0, therefore it's not computed. We check whether n is less than 2 or not. So 0 is less than 2, therefore condition if block comes out to be true. And finally we'll store the value of n, which is 0, to this memo table at index 0. So here at index 0 we'll simply storing the value as 0, because we know that the Fibonacci series starts from 0 and 1. So if the value of n is less than 2, we simply store that value into its index. So now we'll simply return this value, because we need to get this value here. So this fib function will be removed from the call stack, and 0 will be returned from here. And we know that we had left at line number 7. So we'll start executing from the line number 7. And this fib function has returned a value 0. So we'll store that value in the right. So 0 will be stored at the right. So friend, now you can see that in order to calculate the second Fibonacci number, we need to do the sum of its two previous numbers. So we have got the sum of its two previous number as 1 and 0. We'll do the sum of it and we'll store at the second index. So 1 plus 0 is 1. So we'll simply store the value 1 here. And then from this fib function, we'll simply return the value stored at second index, because value of n is 2, which is nothing but 1. So 1 will be returned from this method, and this method will be removed from the call stack. And now we'll start executing this fib function, and we know that we had left at line number 6. So we'll start executing from the line number 6, and we also know that we had returned the value 1 from this fib function. So 1 will be stored in the left integer variable. Moving ahead, now we have calculated the n minus 1th value, which is this, and we need to calculate the n minus 2th value, which is this, in order to get the third Fibonacci number, because value of n is 3. So we have computed one value, we need to compute the other value. So here the fib function will be called again with the value as n minus 2, which is 3 minus 2, which is 1. And we know that we are leaving this fib function in line number 7. So we'll simply update the line number 7 here. So the fifth function will be called again with the value of n as 1. Here now we have to calculate the value of the first Fibonacci number. So now here you can see the advantage of using this memo table. We are checking that whether value at first index has been calculated or not. So this subproblem has been encountered again because we have already calculated the value at first index, which is 1. So by providing this simple check that whether memo of n is equal to 0 or not. So we have already calculated this value. So we don't have to recalculate it again here or here. So therefore storing this results of the subproblems gives us an optimization over the recursion here. So instead of calculating it again here, we are simply returning the value stored at the first index. So we are simply returning memo of 1, which is 1. So this fifth function will return the value as 1. And we know that we had left at line number 7. So we'll start executing from this line. And as the return value is 1, the value stored in right would be 1. And finally we can come to know the third Fibonacci number by simply doing the sum of its two preceding values, which is 1 and 1. And we'll simply store that value at the third index. So 1 plus 1 is 2. So we'll simply store the value 2 at the third index. We move ahead and we'll simply return the value 2 from this fifth function. So this method will be removed from the call stack and it will go to its previous fifth function, which we had left at line number 6. So we'll start executing from the line number 6. And we know that we had written the value of 2 from this fifth function. So it will store in the left. And now we'll simply calculate the fib of n minus 2 to get the value of the right part. So on the call stack, we are leaving this fifth function at line number 7. So we'll update the line number 7. This fifth function will be called again. And on the call stack, we will call fib with the value as 4 minus 2, which is 2. Moving ahead, we'll simply check in this table that whether this subproblem, which is fib of 2, has been solved or not. So we are simply checking this memo table and we are simply checking at the second index whether the value is 0 or not. So here you can see we have already solved this problem and stored its result. Therefore we don't have to recalculate it again. So we are simply returning the value stored at the second index, which is 1. And we are returning the value 1 from this fifth function to this fifth function. And as we know that we had left this fifth function in line number 7, we'll start executing from the line number 7. And then we'll simply store the value returned from this function, which is 1, into the right variable. Finally, we'll do sum of these two numbers and we'll store it in the fourth index, because in order to calculate the fourth Fibonacci number, we need to do the sum of its two preceding numbers, which is at index 2 and 3, stored in left and right. So 2 plus 1 gives 3. So we'll simply store 3 at the fourth index. And finally we'll return the value 3 from this fifth function to this fifth function. And we also know that we had left this fifth function in line number 6. So we'll start executing from the line number 6. We return the value 3 from this fifth function. We'll simply store it into the left integer variable 3. And now in order to calculate the fifth Fibonacci number, which is our actual main problem, we had calculated one of its preceding value, which is n-1 here. We just need to calculate n-2th value, this value, and then we can do the sum of its two values and get the solution to our main problem. So here we'll again call fifth function, passing in a value as n-2, which is 5 minus 2 equal to 3, and we are leaving this fifth function at line number 7 now. So we'll update the line number 7. So this fifth function will call with the n as 3. And friends, here you can see the advantage of this memo table, that we have already calculated the third Fibonacci number, because value stored at third index is not equal to 0. Therefore we don't have to recalculate it again and again using this code. So finally we'll return the value stored at the third index, which is 2. And we'll simply return from this method and go to its previous method. And we know that we had left at line number 7, so we'll start executing from the line number 7. And as 2 is returned from this fifth call, we'll simply store it into the right integer variable. And then as we want to calculate the fifth Fibonacci number, we got the fourth Fibonacci number and the third Fibonacci number stored in left and right. We'll do its sum and we'll store at the fifth index. So 3 plus 2 gives us 5. So 5 is stored at the fifth index. And finally, from this fifth function, we'll return the value stored at the fifth index, which is our actual answer. The fifth Fibonacci number has the value of 5. So we are simply returning the value 5. And this method will be removed from the call stack. And hence our problem is solved. So friends, here you can see that we started from the top, we moved to the bottom. Therefore it's top-down approach. And we also know that we have used this memo array, which helps us in memorizing the solutions of the sub problems, so that those sub problems, when encountered again, are not recalculated again. So we are simply storing those sub problems result here, and when those sub problems are encountered again, we don't have to compute it again. We simply take that value from this memo table and reuse it again. Therefore, using this memo table to our normal recursion, we are providing an optimization. And we also know that dynamic programming is nothing but the optimization to our recursive problems. So friend, in this lecture we saw the top-down approach of dynamic programming, that how we can use that approach and solve a complex recursive problems efficiently. Now let's go to Eclipse and see the demonstration of this algorithm. I hope you like this video. Thanks, have a nice day. Hello everyone. So friends, in our previous lecture, we saw the animation for the top-down approach, that how we can solve the problem related to finding the Fibonacci number using dynamic programming by top-down approach. So in this lecture, we'll code the algorithm to find the nth Fibonacci number using top-down approach. So here in Eclipse, you can see that few lectures back we saw the bottom-up approach, and this approach is also a method in dynamic programming. So in this lecture we'll see the top-down approach. So first we'll create a method which will return us back the nth Fibonacci number, which is an integer, and let's say the name of the method is fib. Now as we discussed in our last lecture, that to this fib function we pass in a memo array which help us in storing the solutions to the subproblems, and when those subproblems are encountered again, instead of recalculating it, we just go to this integer array into that particular index, we pick up that value and reuse it. Thus this integer array helps us in optimizing the recursion solutions. So this method also takes the value of n for which we want to find the Fibonacci number. So friends, in order to find the nth Fibonacci number, what we simply do is we simply first check that whether the memo of n is equal to 0 or not. So what it means that we are using this array to store the Fibonacci series, and as we want to calculate the nth Fibonacci number, we simply check that this array at index n is equal to 0 or not. So if it is equal to 0, we come to know that the nth Fibonacci number has to be calculated. So inside this if condition, we provide a if block where the condition is if n is less than 2, then what we do is we simply assign the value of n to the integer array at the index n. So why we do this? Because we know that the first two numbers of Fibonacci series are 0 and 1, and as the array starts from 0th index, so this value will be stored at 0th index and this will be stored at the first index. So we simply check whether n is less than 2 or not. So if value of n is 0, then 0 is stored at 0th index, and if the value of n is 1, then 1 is stored at the first index. And if n is not less than 2, then in the else part what we do is, so here we know that the Fibonacci series has property the current number is sum of its preceding two numbers. So based on these two properties, what we come to know that if we want to calculate the nth Fibonacci number, we need to know its two preceding numbers, which is n-1 and n-2. We do its sum and we get the current number. So here let's say current number which we want to calculate is nth number. So what we do is we first calculate the fib of n-1. So we call this fib function recursively, which we also discussed in our previous lecture. So whatever the value it returns, we store in the left. And then we again call the fib, passing in the memo array and pass in n-2. Because if you want to calculate the nth Fibonacci number, we need to know the n-1th Fibonacci number and n-2th Fibonacci number. And once we know these two values, we can do their sum, which is left plus right. And as we know left plus right, we simply store this value at the nth index, because we know that this integer array basically stores the Fibonacci numbers. And as we want to calculate the nth Fibonacci number, we simply store the left plus right at the index n. And finally, we return the answer, which is the value stored at the nth index. So friends, here you can see that this line is very much important because this line checks that whether the sub problem is solved again or not. So here what we do is, if the mem of n is equal to 0, we come to know that the value at nth index is not been solved. So what we do is we go into if block and we calculate the value of nth index and we simply store it here. And what if the mem of n is not equal to 0? Then we know that we have already solved this problem. So then we simply return the value stored at nth index. Also friends, in our previous lecture we saw the animation that how this line helps us in optimizing the recursion so that we don't have to solve the sub problems again and again. And as we start from the value of n and then we slowly go to the bottom by doing n-1, n-2 and then again recursively moving down. Therefore this approach is also known as top-down approach because we start from the top and then go to the bottom. And as we go to the bottom, we encounter these base cases where the first two values we store as 0 and 1. And after getting these two values, we build up upon the solution. And finally, we get the nth Fibonacci number. So friends, now let's see the demonstration of this code in the main method. So first we'll initialize the Fibonacci number class. And let's say we want to find the 6th Fibonacci number. So here the value of n would be 6. And as we are calling this fifth function, we need to pass an empty array whose size would be n plus 1, which is 7, because we want to store the Fibonacci numbers from 0 to 6. And finally we need to return the value at index 6. So as we are going from 0 to 6, we need to initialize the array of size 7. So we simply pass an empty array of size 6 plus 1. And if I run this code now, so we get the answer as 8, because here you can see that in the array it will be stored in this format. 0, 1 would be the starting values. Then we do the sum of these two values, we get this value. Then we do sum of 1 plus 1, we get 2. Then 2 plus 1, we get 3. 3 plus 2, we get 5. 5 plus 3, we get 8. So friend, this is how we can use dynamic programming to solve this problem, to find the nth Fibonacci number. And using this top-down approach, we have solved this problem very efficiently. And whatever the solution we get is highly optimized. So friends, I hope you like this video. And in case you have any problem, you can watch my previous lecture where we go through this code step by step using the animation. And in our next lecture, we see different problems associated with the dynamic programming. Thanks, have a nice day. Hello everyone. So in this video, we will be looking into a problem, maximum sum subarray. And we will be looking into a specific algorithm which was provided by Cadence to solve this problem. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here in this problem, we are given with an array with some random elements and it can have negative elements as well. We name it usually maximum subarray sum. So here in this problem, what we actually do is we try to find any subarray such that if we do the sum of the elements of that subarray and whichever is the maximum sum, we simply find that out. So for example, let's say if I take these two elements, so a subarray is actually a smaller piece of array of the bigger array and the elements are contiguous. So if we do sum of these two elements, we will get 7. So this is one such subarray. One property of subarray is that it should be contiguous. So for example, 2 we can't take 2, 4, 5, do their sum and find the maximum sum because 3 is missing. So a sub array is actually a smaller array which is contiguous. So here we saw that one of the sub array has sum to be 7. Now there can be multiple sub arrays. So we need to find the maximum sum of any particular sub array and we simply want to return that sum. So here you can see if we take this sub array 4, 3, minus 2 and 6, we will get 4 plus 3 minus 2 plus 6. So it will give us 11. So this is one such sum. So we try to find that whether this array has any other sub array whose sum is maximum or not. So here if you see, if we take these 3 elements 7 plus minus 1 plus 6, so it will give us 12. So it means we can discard this sum and this would be our answer. So 12 is the maximum sum of any sub array. So in order to find such sum, the brute force way would be that we try to create each and every sub array, we do their sum and we see which is the maximum sum. So usually this approach is not good. So there is one such algorithm which was provided by Cadence which actually traverses this array once and figures out what is the maximum sum subarray. So here how we actually solve this problem is we usually create two variables, current max and the best sum or maximum so far. Now what these two variables denote we'll see later, and this algorithm we try to traverse from left to right. So at the start we encounter 4. Now what we do here is, let's say if our array had only one element 4, so the maximum sum would have been 4 only, and we would have written from this array saying that 4 is the max sum. So here you can see we will be traversing this array one element at a time, and let's say at this index, for example, we will be storing two things, current max and the max so far. So what these two variables denote is that at index 3 what is the current max sum, and as we have traversed this array we would have encountered many sub arrays. So among those sub arrays, what's the max so far or what's the best sum. So these two things we keep track while traversing from left to right. Also when we traverse the elements one by one, at each element the element usually asks two questions, that should I become part of the current subarray which will give us the maximum sum, or should I start my new subarray. So here we'll look into the demonstration and what these two questions actually mean. So here if you see at the start we encounter 4 at index 0. So 4 will ask that should I become part of the current subarray. So here if you see current subarray is empty because there are no elements, as this is the first element only. Should I become part of the current subarray so that sum is maximum. So at the start both these questions, as there is only single element, both these questions correspond to the same thing. If 4 becomes part of the current subarray, it would be something like this. Or if 4 starts a new subarray, it would be something like this. So usually at the start, the current max is 4 and it has been formed by this subarray. And we simply take 4 as the max so far, being formed by this subarray. Now we'll go to the first index. So at this index 3 will decide should I become part of the current subarray. So here if you see current subarray is 4. So if it becomes part of the current subarray, so subarray will become 4, 3 and sum will become 7. Or it will decide that should I start a new subarray. So if it decides new subarray, sum will become 3. So among these two questions, 3 will see that it's better to become the part of the current subarray because we are getting a maximum sum among these two sums. So 3 will become part of the current subarray. So the subarray will go something like this. These two elements are there and the current max at this point would be 7, which is being formed by 4 and 3. So here you can see now this max so far, this 7 is greater than 4. So this max so far will be updated to 7, stating that it has been formed from the elements 4 and 3. Moving ahead, now we encounter minus 2. I'll just remove this. So minus 2 will think, should I become part of the current subarray? So if it becomes part of the current subarray, the sum would be 7 because 7 is the sum of the current subarray plus minus 2, which will give it a value as 5. Or it will decide, should I start a new subarray? So if it starts a new subarray, the sum will become minus 2 because we will be discarding this subarray if we are starting a new subarray from here. So minus 2 sees that okay, if I become part of the current subarray, the sum will be 5, and if I start my own, we get minus 2. So it's better to go with the current subarray and get the sum of 5. So here at this position, the sum will become 5. It has been formed by 4, 3 and minus 2. And this 5 is actually smaller than 7. So max so far will remain this only. It means that though we have taken up minus 2 into this subarray, but the sum is not actually greater than the maximum sum so far or the best sum. So the best sum will actually remain this. So let's say if we had only this 3 elements in the array, so the current max would have been 5 and our answer would have been 7, stating that we usually take 4 and 3 and we will get the max sum. We will discard minus 2 from the best sum. And also here one question arises, why we are taking minus 2 into the consideration here. Why we are actually adding minus 2? Because there could be a possibility, let's say the current number here is 6. So there could be possibility here number is 1000. If we don't take minus 2, then our current subarray will start from this because the subarray is contiguous, and if we are not taking any element, it means we are discarding the previous subarray. So the sum would have become 1000 if we have not included minus 2. And now if we include minus 2, so here you can see the sum came out to be 5, and let's suppose here would have been 1000. So we would have included 1000 also and got 1005. So which is much way better than 1000. Therefore we simply include minus 2 based on these two questions because we are not sure what comes after this minus 2. It could be any negative value or it could have been any maximum value. So it's better to include minus 2 into this subarray. So now our subarray reaches like this, that it has included everything 4, 3 and minus 2. I will remove this. So now we encounter 6. So here 6 will decide that okay, should I become part of the current subarray? So if it becomes part of the current subarray, so the sum will become 5 because the sum is 5 plus 6, which will give us 11. Or it decides that should I start a new subarray. So if it discards this previous subarray and starts a new subarray from here, so the sum will be 6 only. So the element 6 will decide, okay, I will go with the current subarray because this gives the maximum sum. So here the current max will become 11, which will be the addition of these 4 elements of the subarray. So now here you can see that this 11 actually beats 7. So max so far will take the maximum sum as 11 because it will figure out that okay, now I need to include 4, 3, minus 2 and 6 together because this is giving me a maximum sum. Moving ahead, I will remove this. So now 6 has become part of our subarray. Now we encounter minus 12. So minus 12 will decide should I become part of current subarray. So the current subarray is this. So 11 plus minus 12 will give us minus 1. Or it decides should I start my new subarray. So if it starts its new subarray, the sum would be minus 12. So minus 12 sees that okay, minus 1 is greater than minus 12. So it's better I should become part of the current subarray. So here, now our current max become minus 1 being formed like this. But this minus 1 is very much less than 11. So max so far will remain the same. Then let's suppose if our array would have ended here. So the answer would have been 11, which is being formed from the elements 4, 3, minus 2 and 6. So this is the significance of max so far. It keeps the track of the maximum sum of any subarray so far. So I'll just simply remove this. And here minus 12 comes with the current subarray. Now we encounter 7. So 7 will ask should I become part of the current subarray. So it sees the current subarray is this and its sum is minus 1. So minus 1 plus 7 will give us 6. Or it decides should I start my own new subarray. So if it starts its own new subarray, it has to discard this subarray. And if it starts a new subarray from here like this, so the sum will be 7. So this element thinks that okay, I should not go with the current subarray because it is giving a sum only 6. But if I start my own, it will be a maximum sum of 7. So here is the critical step where the current element decides that okay, I won't go with the current subarray, I will start my own subarray, which is a new subarray. So here we simply discard this subarray because current max will now be 7 and it will be formed by only digit 7. But this 7 is less than 11, so the max so far will remain the same. So now this subarray is actually discarded and a new subarray will start from 7. So now we encounter minus 1. So minus 1 decides that okay, should I become part of the current subarray? So 7 plus minus 1 will give 6. Or should I start my own subarray? So the sum will be minus 1. If it starts its own subarray, so it decides that okay, I will be part of the current subarray because it is giving me a maximum sum. So here, now our current max will become 6 because minus 1 has decided to go with the current subarray. 7 comma minus 1. Okay, but this 6 is less than 11, so our max so far will still remain the same. Moving ahead, so now our subarray has two elements, 7 and minus 1. So now the last element comes, which is 6. So 6 asks, should I become part of current subarray? So 6 plus this 6 will give sum as 12. Or should I start a new subarray? So if it starts a new subarray, the sum will be 6. So this 6 decides that okay, I will go with the current subarray because it is giving me a maximum sum if I compare these two values. So here, now current sum will become 12. 7 minus 1, 6. So this will be included like this. And now here you can see 12 is actually greater than the max sum so far. So max so far will see that okay, I need to now discard this because we have found one more subarray whose sum is actually maximum from the current max so far, which is 12 formed by 7 minus 1 and 6. And here there are no more elements left. So the answer would be our max so far, which is 12. So this will get written. So friends, in this video we saw that how we can solve the maximum sum subarray problem using cadence algorithm. In our next video, we will actually see the demonstration of the algorithm step by step, that how we can use the code and come up with this logic. We will see it via an animation in our upcoming video. I hope you must have liked this video, and in case if you are new to my channel, then please subscribe to my channel. Thanks, have a nice day. Hello everyone. So in our previous video, we discussed about the idea behind how the cadence algorithm work in finding the maximum sum subarray. So in our previous video, we actually discussed the idea behind the algorithm. We saw that how current max and max so far, or the best sum, help us in determining the maximum sum subarray in this given array. And we also saw that we traverse the array, and on each element, the element decides that should it be part of the current subarray or should it start a new subarray. So now let's see the demonstration of this algorithm step by step. So here you can see that we have been provided with an algorithm, which is the cadence algorithm. So usually the method name is max subarray sum. It takes in an integer array and finds us a maximum sum for any subarray in this array. So let's see the demonstration of this algorithm step by step. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So at the start, let's say we provide an array as what we discussed in our previous example. So usually at the start, the first element is simply taken as max so far and the current max. So max so far is 4, this value, and current max also becomes 4. Now the algorithm basically starts with second element. So here I starts from 1 and goes till array.length. So here array.length is 8. So I will travel from 1 to 7 because 7 is less than 8. Now on this point, 3 has two choices. Either it should become the part of the current subarray. So the current subarray is this. or it should start its new subarray. So as we discussed in our previous slide, what we do is we take current max and we add the value stored at the index of I and we assign it to the current max. So here we are simply taking the current element value and we are adding it with the current max and assigning it to the current max. So it means 3 decided to go with the 4. It means 4 plus 3 will give us 7. So 7 is assigned to the current max. So current max becomes 7. Now why we directly assigned it? Because in the next step this current max is actually compared with the element's value. So this is our second question, that should I start my new subarray. Here this part was where element decides to go with the current subarray, and in this if block there is our second question, that should I start my new subarray. So if current max is less than the value of the current element, then we simply assign this value to the current max. So here 7 is compared with 3 because array of I is 3. So whichever is the bigger value is simply assigned to the current max. So 7 is the bigger value among these two values. So current max remains the same. So friends, here you can see that when element decides to be a part of current subarray, we simply add it to the current max, and here we are simply assigning it to the current max because in the next step we will reassign it if current max is less than the current element's value, which means that 3 has decided to create its own subarray. So this is actually our question 1 and this is actually question 2. So whichever wins, that value is assigned to the current max, and if this condition comes out to be false, then we do nothing with the current max because we have already assigned current max plus array of I to current max, which is 4 plus 3 equal to 7 to current max. So now this value is included in the subarray. So the current max is 7, being formed from the subarray 4, 3, which is these two elements. And now we'll simply compare this sum, current max sum, with the maximum sum so far. So if max so far is less than current max, we simply assign the current max value to the max so far, because current max actually beats the maximum sum so far. So here max so far is 4 and current max is 7. So this condition comes out to be true and max so far becomes 7. So here this is current max and this is max so far. So at the start it was 4, then it became 7, taking in 4, 3. Moving ahead, now we'll increment I by 1. So I points to the second index. Now this minus 2 has two questions, that should I become part of the current subarray. So we simply take their sum, current max plus array of I. It means we are including array of I. So here it will become 7, which is the current max, plus minus 2. So 7, which will give us 5. So current max will become 5. And then this element simply asks that, okay, can I start my own subarray? So this check actually decides that if current max, which is 5, so if it is less than array of I value, which is minus 2, so array of I value is simply assigned to current max. So currently, so this condition comes out to be false because 5 is greater than minus 2. Then we simply check whether max so far is less than current max or not. So why we are doing this check is, we are simply keeping the track of the maximum sum so far. So if at any step current max becomes greater than max so far, it means we have found the maximum sum so far.
So we simply assign current max to max so far. So as of now, max so far is 7 and current max is 5. Therefore this condition comes out to be false because 7 is not less than 5. So here the current max will become 5, taking in 4, 3 and minus 2, and max so far will remain same. So now we'll increment I, and here you can see this element has been included in the current max subarray. So friends, here you can see, as we know that each element asks two questions whether it should become part of the current subarray by simply adding its value to the current max, or they decide to create their own subarray. So this piece of code decides that. So you can also think this piece of code as something like current max equals. We can also write something as math.max, and the two values would be current max plus array of I or array of I. So whichever is the maximum value, we simply assign to the current max. So this is question 1 and this is question 2. That should I become part of the current subarray? If that is maximum, that value is assigned to the current max. Or if element decides to create its own subarray, so it's simply its value is assigned to the current max. So either we can do this or we can do this. That first we directly assign current max plus array of I value to current max, and then with this if block we reassign the array of I value to current max if the value at ith index is actually greater than the current max. So it means this value is greater than current max plus array of I. So this value will be assigned, or else we have already assigned this value to current max here. So now value at ith index is 6. So we simply assign phi plus 6, which is 11, to current max. So current max becomes 11. And then we simply decide that whether current max, which is 11, is less than the value 6 or not. So if it is less than 6, then we simply reassign current max to the array value at ith index. So this condition comes out to be false because 11 is greater than 6. So here 11 is our current max. We have taken these 4 values. Now we'll simply compare that whether the maximum sum so far is less than current max or not. So here you can see 7 is less than 11. It means we have found a new max so far. So we simply update current max to max so far. So it becomes 11, 4, 3, minus 2 and 6. So it means we have found a subarray of max sum as 11 having these 4 elements. So now we'll continue with the rest of the elements. We'll increment I. So I will now point to the 4th index. So here array of I is minus 12. So here we are simply adding current max, which is 11. It will give us minus 1. So current max will become minus 1. And then this element will decide that can I start my own subarray. So it will compare its value, which is this part, with the current max, which is minus 1. So minus 1 is greater than minus 12. So this condition comes out to be false. And the current max, which is minus 1, is actually less than max so far.
So this if condition also will come out to be false. So max so far will remain 11, which makes sense because a subarray whose maximum sum is 11 is being formed from these 4 elements. So here we simply write 11 only, 4, 3, minus 2 and 6. Moving ahead. So here minus 12 has been included in the current subarray. I will now point to index 5. Current max will become minus 1 plus 7, which is 6. So this is the part when array of I decides to go with the current max, and then it checks, okay, can I start my own subarray, because my own value is 7, but if I go with the current subarray, the current max is 6. So therefore it decides that it's better I create my own subarray, because if I create my own subarray, I will give a sum of 7, and if I go with the current subarray, the sum will be 6. So therefore this condition decides that the current max is 6 and it is actually less than 7. So the current max will become 7 by simply assigning array of I to current max, which signifies that 7 has decided to go and create its own new subarray. So current max becomes 7. So now this subarray will be removed. And from here a new subarray will start. And here we'll simply denote 7 by taking in only 7. And this current max doesn't beats the max so far. So this condition comes out to be false. Now we'll go to the next element, which is minus 1. So here minus 1 will be added to the current max. It will give 6. So current max will become 6 now. And now this minus 1 will see that if I become part of the current subarray, which is this, I am getting sum as 6. If I start my own subarray, I will get sum as minus 1 because this is the only element. So it sees that okay, it's better to go with the current subarray. So this condition comes out to be false because current max, which is 6, is actually greater than minus 1. So here now our current max is 6, taking in 7 and minus 1 together. Now this 6 doesn't beats the 11, so it remains the same. Now we'll increment I. So now I will point to the 7th index, and here this current subarray has included minus 1 with it. Now we'll simply add the value 6, which is this value, with the current max. So 6 plus 6 is 12. So current max will become 12. And this 6 also checks that if I start a new subarray from here, what's the sum? So this is the only element, so sum is 6. So it doesn't beats the actual current max. So this 6 decides to go with the current subarray by adding itself to the current max. So this condition comes out to be false because current max is 12 and it is greater than 6. So now this element is included in the current subarray. So the current max is 12, taking in 7, minus 1 and 6. And here you can see
that this current max 12 actually beats the max so far. So this condition comes out to be true because max so far is less than current max. So it means we simply update the max so far, which is 12. So this value is assigned to the max so far, stating that this sum was made from this subarray. It becomes 12. We'll increment I. So this for loop will exit because now value of I is 8 and 8 is not less than array.length. It is equal to array.length. So it means we have traversed this array completely, and at the last we will simply return 12 because this is the maximum sum so far created by a subarray, this 7, -1 and 6. So this 12 is returned. So friends, here we saw that there was one subarray 4, 3, -2 and 6, which actually gave the sum as 11. So this subarray was max so far for most of the time, and at the end this subarray, whose total sum came out to be 12, became the max so far. So 7, -1 and 6, which gave the sum as 12, was the maximum subarray sum, which we finally returned from this method. So friend, this is how the cadence algorithm works. So here one more question arises, that why we are actually taking in the negative values in the current max like we did here. We included -2 and the current max became 5 from 7, because here you can see that current max value is 5 after including -2. If this value would have been, let's say, 1000, so in the next iteration, if we have included 1000, we would have got 1005 because we will be adding 5 to 1000. But if we would have discarded this value, so from this part a new subarray would have been started, which only would have given 1000. So we are not sure what next element is coming up. So therefore we have included -2 because this value is less than this value. So therefore we have included -2 also because we are not sure what is coming up. There could be a very large maximum value which would have raised this sum to 1005. And if we would have discarded -2, so this subarray would have been ended here and a new subarray would have started here, which only could have given a sum as 1000. I hope you must have liked this video, and in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw that how cadence algorithm help us in finding the maximum sum of a subarray in a given array. We saw the demonstration of the algorithm step by step. Now in this video we will actually code the algorithm and will test its working in the main method. So if you want to understand the algorithm more, you watch the previous videos to this where the algorithm is being explained in a very detailed manner. So let's see the code of the cadence algorithm. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here we will be creating one method as public static. We'll give it a name as max subarray sum. So this method will take in an array and will return the maximum sum of any subarray. So its return type is integer. So here code wise this algorithm is simple, but to actually understand the concept behind it is very much complex, and you can watch my previous videos to it.
to understand more. So in this algorithm, we simply create two variables. One is current max, and we simply assign the first value to it, which is the value stored at 0th index, and the other variable is max so far. We also assign it a value of what the first element is holding. So here we are assuming that array has at least one element. So the algorithm basically starts from second element, from I equal to 1, and I goes from 1 to array dot length. So in our previous video we discussed that when we are encountering the current element, this current element basically asks two questions: that should I be part of the current subarray, which is the current max, or should I start my own subarray? So these two questions basically decides what will be the value of current max. So at the start, we simply assign array of I to current max. So this is the question 1, where the element becomes part of current subarray. So here we have taken the sum of current max and the value of the array at ith index. So this satisfied question 1 and we simply assign it to current max. So in the next step, we can't directly go with the current max value with this sum. This element will also ask a question that can I start my own subarray by taking my own value. So here we simply compare current max with array of I. So if array of I is greater than this current max, so it means that this element has started its own subarray because this value has been assigned to current max. So here this is the question 2, where element decides to start its own subarray. So after evaluating the current max, what we do is we compare it with max so far. So if this current max beats our max so far, so we simply assign current max to max so far. So friends, you can watch my previous video to understand more about this logic, that usually at each iteration we ask these two questions, and based on these two questions current max value is decided, and if this current max value is greater than max so far, so we simply assign current max to max so far, and at the end we simply return max so far, because after this while loop will terminate, whatever the value max so far is holding, it decides the maximum sum of any subarray in this array. So now let's test its working in the main method. So this is the array which we discussed in our previous video as well in the slide. Here we'll simply call max subarray sum method. We pass in the array, and if I run the main method, so here you can see it return the maximum sum as 12, so which is being formed by this subarray 7, minus 1 and 6. If we add all of these three values, we'll get sum as 12. So friend, this was all about the cadence algorithm. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon
so that you never miss any update. Thanks, have a nice day.
Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss the famous two-sum problem in Java. So here the problem is something like we are given an array of integers and we need to return the indices of the two numbers such that they add up to a specific target. So if we take an example, then let's say we have this array of integers 2, 11, 5, 10, 7, 8, and let's say we are given a target as 9. So we need to return the indices of two numbers such that they add up to this target. So here the problem states that we need to find two such numbers into this complete array which will add up to the target. So if we take the above example, then the solution would be the element at 0th position is 2 and the element at 4th position, which is 7. So they add up to the target. So we need to return the indices of it. So we need to return 0 and 4. So 0 is the index position for the number 2 and 4 is the index position for the number 7. So let's move ahead and see the demo of the algorithm. So friends, let's say we are given the array of integers and we are denoting it with the variable name as numbers. So here the array elements are 2, 11, 5, 10, 7, 8, which we saw in the previous slide, and below are the index position of it. And if you see, the below is the algorithm for finding two such numbers which add to make a specific target. Now let's say we are given a target as 9 and we want to find two such numbers which add to make the number as 9. So we know that 2 and 7 make up to 9. So in order to find those two numbers, below is the algorithm for it. So let's quickly see the demo of it. So as we need to return the indices of it, we will store it in the integer array of having two elements. So we need to return the indices of two such numbers. So we'll store it into the result array. So it would be something like this. So first we'll create a hash map. We'll see what the significance of this hash map is. So here we are encountering a for loop which traverses the complete array. So in the first iteration, I value is 0 and numbers.length is 6 because we have the 6 integers as 2, 11, 5, 10, 7, 8. So we'll traverse this array from 0th index to 5th index. And currently for the first iteration, I points to 0. So I would be pointing to the 0th index of the numbers array. So friends, the basic idea behind this algorithm is like we will traverse each element one by one and we'll store the element into hash map with its index value. So that on traversing this complete array, we'll take a particular number, we'll subtract it from this target and we'll find that whether this contains in the map or not. So instead of adding these two numbers and making it to a target, we'll just subtract that particular number from the target and we'll look up into this hash map and we'll see whether that particular number is there or not. So let's see how it works. So here if you see, we have this target as 9 and we have this number at ith position, which is number at ith position is 2. So what we'll do, we'll just check whether our map contains 9 minus 2, which is 7, into this hash map or not. So currently the map.contains key will comes out to be false because the hash map is empty, and if you do a reverse of it, then this condition in if statement comes out to be true. Therefore what we'll do, we'll just put the number at ith position along with its index. So moving ahead, now I becomes 1, and if you see, the I points to the index at first position, and also 1 is less than 6. Therefore this for loop will be executed. So now we'll again check whether target, which is 9, and we'll subtract the number at ith position. So if we subtract 11 from 9, we'll get -2, and we'll check whether -2 is a key in this hash map or not. So currently -2 is not a key into this hash map, therefore this condition map.contains key comes out to be false, and if you make a reverse of it, then the if condition comes out to be true. Therefore the if statement will be executed, and we'll simply put the number at ith position along with its index value. So we'll put 11 and 1. So 11 is the number at ith position and value is the index position, which is 1. So basically friends, we are putting these numbers so that we can have a quick lookup into this hash map, and we can come to know that whether there is a number whose addition with this current number will make the target as 9. So moving ahead, so now I becomes 2 and it will point to the second index of the array. So we'll again check whether target, which is 9 minus number at ith position. So number at ith position is 5. So we'll check whether 9 minus 5, which is 4, is present in this hash map or not. So number 4 is not present in the hash map. Therefore this condition map.contains key comes out to be false, and if we do the reverse of it, it comes out to be true. So the if condition comes out to be true, and we'll simply put the number at the ith position along with the index value in the hash map. So we'll store 5 with 2. So 5 is the number at the ith position, which is 2, and 2 is the index value. Moving ahead, now I becomes 3. So I will point at the third index, and we'll again check whether map contains target minus number at ith position. So target is 9 and number at ith position is 10. So we'll check whether 9 minus 10, which is -1, is there in the hash map or not. So currently it's not there. So map.contains key comes out to be false, and if we do the reverse of it, it comes out to be true. So if block gets executed, and we'll simply put the number at ith position and the index value in the hash map. So we are storing 10 along with its index value. Moving ahead, so now I becomes 4, and here it points to the fourth index. Now friends, we'll again check whether map.contains key target minus number at ith position. So target is 9 and number at ith position is 7. So we'll just check whether 9 minus 7, which is 2, present in the hash map or not. So if you see, when we do 9 minus 7, it comes out to be 2, and 2 is present in the hash map. So it means that the first number is 7 and the other number is 2. So when we do 2 plus 7, we'll get 9. So it's like a fast lookup into the hash map. So currently 9 minus 7, which is 2, is present in the hash map. Therefore the map.contains key comes out to be true, and if we do a reverse of it, it comes out to be false. So it means we have found our two numbers which will add up to make a specific target. And now as we want to return the indices of those two values, so first indices would be the current value of I, because 7 is one of the number. So we'll store the index value and the result array at the first position. Moving ahead, and we need to store the index of the number 2. So what we'll do, we'll just do a map.get target minus number at ith position. So we are simply doing 9 minus number at ith position, which is 7. So 9 minus 7, which comes out to be 2, and we are passing the key as 2, and we are getting the value out of it from the hash map. So it comes out to be 0, and we are storing it into the result array. So these are the two indices which we found which is 0 and 4, and finally we'll just return the result. So friends, this was the one of the way by which we can find the two numbers whose sum makes up to a specific target value. And suppose if you don't find any number, then we can simply either return a result array having the indices at 0 0, or we can throw an exception like illegal argument exception. So friends, this was the demo of the algorithm. Now let's go to Eclipse and see the working code. So friends, let's code the algorithm what we saw in the slide. So here I have just created one class by name toSum, and it has one method, the main method. So let's say I give the method name as public static toSum. So the return type is the integer array because it will return back as the indices of the two numbers, and the method takes in an integer array which is the numbers array, and it also takes an integer by name target. So in this method, first we'll create a result array. So this result array will store the indices of the two numbers, and then we'll create a hash map which will store the integers as key value pair. So map, so we can simply give the name as map new hash map. We'll just import it. Now we'll create the for loop. So we'll iterate the complete array from 0 to numbers.length. So this will basically iterate each and every element in the numbers array. So in the for loop, our first condition would be if map dot contains key, and here we'll provide target minus numbers at ith position. So we'll just check whether the map contains the target minus number at ith position key, and if it doesn't contain, then we'll simply put map dot put the numbers at ith position with its index value, and in the else, now the else part will come when we have found the two numbers. So we'll just populate the result array. Say at 1 we'll put the index, and at 0th position we'll put map dot get target minus numbers at ith position, and finally we'll just return the result. And if suppose we haven't found the two numbers, then we can either throw an exception. We can throw an exception, say illegal argument exception. The string is two numbers not found. So friend, this is the code for finding the two numbers which add up to make a specific target. Now let's see it's working in this main method. So here first we'll create the numbers array. So I will populate the values I had given in the slide: 2, 11, 5, 10, 7, init. Now as and result array will be returned, therefore created an integer array variable by name result, and I will just call toSum method by providing the numbers array, and let's say we give target as 9, and let's say we print both the indices. So the two indices are result 0 plus result at one position. So friends, let's run this Java code. So friends, you see the two indices are 0 and 4. So at 0 we'll find a number having the value as 2, and at index 4 we have found 7. So if we add 2 and 7, we get the value as 9. So friend, this was a tutorial about toSum problem. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.
Hello everyone. So in this video we will be discussing about the toSum problem in Java. So in one of our previous video we have actually seen the solution to toSum problem where we used a hash map. So in this video we will be looking into yet another approach to solve the toSum problem. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here if you see, we are given an array of integers, let's say having different values 2, 11, 5, 10, 7, 8. Now the integers in this array are not repeated, and we are also given a target, let's say 9. So in this problem we have to write a function where this array and this target will be given, and we want to return a pair of numbers such that they add up to a specific target, which is 9. So here if you see, 2 plus 7 will give the value as 9, which is equal to our target. So we need to simply return 2 and 7 in a form of integer array. So let's move ahead and see the demonstration of this algorithm step by step. So here's the algorithm which we will be using to find the pair of numbers which is equal to our target. So the method name is toSum. It is taking in an array and a target, and it is returning an integer array. So at the first step, we usually call toSum method by passing in the array, and the target is 9. So this method will start its execution. This is the array having values as 11, 2, 0, 10, 7 and 6. So these are 6 elements from index 0 to 5, and the target we are providing it as 9. So we want to find a pair of number such that if we sum them we get the value 9. Moving ahead, so here if you see, as these numbers are in random order, so in order to find the pair 2 and 7 which will be resulting to our target, we have to compare each element of this array to another element, but doing so will be the time consuming algorithm. So what we do in the first step is we try to sort this array. We will see its significance later. So after we sort this array, here you can see the elements are arranged in ascending order 0, 2, 6, 7, 10, 11. Moving ahead, now we'll see the significance that why we sorted this array. So in order to solve this problem, what we actually do is we actually take two pointers. One is the left pointer and one is the right pointer. So the left pointer usually points to index 0 and the right pointer usually points to the last index of this array. So here if you see, we will be creating a variable left. We'll assign a value 0 to it. So this 0 signifies the index. So it would look something like this, that left is pointing to index 0. Moving ahead, we will create a right variable. We'll assign the value as array.length -1. So if you see array.length value is 6 and if we do -1 we'll get 5. So right will point to 5th index. Moving ahead, now what we do is, as we want to return the pair, so we create a result array which will only take 2 values. So this is the result array. So by default the values will be 0 0 because we are taking the integer array. Moving ahead, now here we actually did two things. First, we sorted the array in ascending order, then we created 2 pointers left and right. Now what we do is, we provide a while loop, and inside this while loop we provide a condition as left should be less than right. So here if you see, left is at 0th index and right is at 5th index, so left is less than right. Now using these 2 pointers, what we do is, we try to find out the pair. So first number will be denoted by left and second number will be denoted by right. So these 2 pointers will help us in pointing both the pairs. So the condition is left should be less than right in the while loop. So at the start, this while loop will execute because left is less than right. Now at the first step, what we do is, we take the value associated with the left pointer and with the right pointer, and as we want to find the pair sum, we usually do their sum. So here if you see, we do 11 plus 0 which will give us 11. So sum will be 11. Now what we do is, we try to compare our sum with target to simply check that whether sum is equal to target or not. So here if you see, target is 9 and our sum is 11. So 11 is not equal to 9. It means this is not a valid sum. So basically when we do this comparison, there are 3 possibilities. Sum is equal to target, sum is less than target, or sum is greater than target. So sum is not equal to target, so the else part will be executed. And now here we will be checking whether sum is less than target or not. So here if you see, sum is 11 and target is 9. So 11 is not less than target. Now why we have provided this condition is because, so here if you see that when we sorted this array in ascending order, now the advantage will come into picture at these 2 steps. So if 11 is not equal to 9, which means sum is not equal to target, so there are 2 possibilities, either sum is less than target or sum is greater than target. So here currently 11 is greater than target, and as we have this array in sorted form in ascending order, we know that we need to reduce this sum by 2 or whatever value so that it is equal to 9. So we have 2 choices, either we traverse left this side or we go right this side. So here you can see, if we go left this side, we will get a value greater than 0, and if we go in this direction to right, we will get a value which is lesser than 11, and we want to reduce this sum. So here we can't go in this direction by moving left to this position, because in the next iteration when we will do sum, we will get 11 plus 2 which will give us 13. 2 and 11 will give us 13, and 13 is way more far than 9. So we have only one choice to make, that we reduce the sum by moving right into this direction. So here these are the 2 checks which we perform. So sum less than target, so this condition comes out to be false because sum value is 11 and target is 9. So the else part will be executed, where you will see the significance that why we are doing right minus minus, because we need to shift right to this position, which means from 5th index we need to move to 4th index. So we'll simply decrement value of right. So it would look something like this. Right becomes 4 and now it will point to the 4th index. I'll simply remove this. Now again our execution point will reach here. We will check whether left is less than right or not. So left is less than right. So the while loop will execute. We will again calculate the sum by taking in the values at left and at right pointers. So now our values would be 0 plus 10. So these are the values. It will give us a value of 10. So sum will become 10 now. We will compare sum to the target. So here we can see that sum is not equal to target. So the else part will be executed. We will again check whether sum is less than target or not. So here you can see 10 is greater than 9. So therefore this if condition will come out to be false, because we can't move left to right, because if we move left to right then we'll get a value which will be more than 9, which is like 10 plus 2, which will give us 12, which will make us more far from the target. So what we do is we simply shift right by decrementing it by one position, because we know that as the array is sorted, if we move right to this position we will get a number lesser than 10. So the else part will be executed. Now right will point to 3, which is the 3rd index. We'll again check in the while loop whether left is less than right or not. So left is less than right. We'll again do the sum. So this time it would be 0 plus 7, which will give us value 7. So sum becomes 7. We compare sum with the target. So sum is not equal to target. Now again our else block will be executed. So here you can see now that sum is actually less than target. So initially sum was actually greater than target, so we moved right pointer in this direction because we wanted to decrease the actual sum, but now sum is actually less than target. So what we need to do is, if we move right again to this point, so when this while loop will execute again, we will get 6 plus 0, which is like we are going to a more lesser value than target. So if sum is less than target, we need to increase the sum so that we reach the target. So the only way we can increase the sum is by moving left to this point, because we know that here its value is 0 and this array is in ascending order. So whatever value we'll get after that will be greater than 0. So this condition is for that. So else if part will be executed and we'll simply increment left by one position. So left becomes 1. Now it will point to the first index. Moving ahead, we will check whether left is less than right or not. So left is less than right. We will take their sum at their respective indexes. So it will be 2 plus 7, which is 9. So sum will become 9. So friends, here you can see now sum is equal to target. So it means we have reached to a point where we can simply return this pair, because we have found a pair whose sum is equal to our target. So this if block will be executed because this condition came out to be true. So in the if part, what we do is, one value is 2. So we'll simply assign the value stored at left pointer to the 0th index of the result. So this 2 will come here, and then we'll simply assign the value stored as right pointer to the first index of result. So here 7 will come to the first index. So we have found our pair, which is, if we do the sum of 2 plus 7, we will get 9, which is the value equal to our target. So at the last step, we will simply return the result integer array. So friends, here you saw the significance that why we sorted the array. Because if the array is not sorted, then we need to compare each element with every other element. So this would have given us a time complexity of O of n square, which is not a good time complexity. So we actually sorted the array so that we know that the first element is the smallest and the last element is the largest. So when we do the sorting, we usually go to n log n time complexity, and then using this while loop, we simply do one iteration and we find the pair using this 2 pointers. Because as the numbers are sorted, left starts from here and right starts from here. And then we simply take these values stored at right and the left pointer, we do their sum and we try to compare it with our target. So if the sum is less than target, what we do is we simply shift left by one position. We simply moved right to this direction by incrementing or decrementing respective variables. So friends, I hope you have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw an animation that how we can solve the two-sum problem in Java. Now in this video, we will actually code the algorithm and we will test its working in main method. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here you can see that I have created one class as arrayUtil. And in one of our previous video, we saw the two-sum problem. In that video, we discussed one of the solution to solve the two-sum problem. We basically took the help of a hash map and we solved the problem. Now in this video, we will see one more way to solve this problem. So let's suppose I create one method here as public static two-sum 2, because we are discussing the second approach here. So this method will take in an array where we will be provided with different numbers, and those numbers will be unique, and we will be also provided with a target, and usually there will be one such pair which will be equal to the target. So we need to find that pair, and after finding that pair, we will simply return it in the form of an array of length 2. So in our previous video, we discussed that how we can solve this problem. We took the help of sorting and two-pointer approach. So the first step we do is we sort the array. So using arrays.sort, we will pass in the array. So we'll get the sorted array. So here you can see this arrays class in Java has a sort method where if we provide the array, we get the sorted array in ascending order. So here you can use your own sorting algorithm, or we can use the sorting algorithm provided by Java. Now after sorting this array, what we'll do is we create two pointers. One is the left pointer, which starts from 0th index of this array, and one is the right index, which usually start from the end of the array. So if we want to know the last index of an array, what we can do is we'll simply call array.length. So this will give us complete length, and if we do -1, we'll get that particular index, because array starts from 0 index and goes to array.length -1 index. Now after creating these two pointers, as we want to return the pair of numbers whose sum is equal to target, we will create an array. We'll name it as result, and this array will be of size 2 because it will take two numbers. Now after creating this array, we have these two variables left and right. Now these two variables will help us in finding that pair of numbers whose sum is equal to the target. Now here we will provide a while loop, and as left starting from 0th index and right is starting from the last index, this while loop will go on till left is less than right. If left becomes right, then we'll simply break from this while loop. So in the while loop, what we'll do is we'll first calculate the sum of the values stored in the left and the right index. So we'll do array of left plus array of right. Now in our previous video, we discussed that after calculating the sum, we try to compare it with the target. So there are basically three possibilities. So the first possibility is if sum is equal to target, it means we have found our target, and we'll simply store both the values array of left and array of right into this result, and we'll simply return the result. So here what we'll do is result at the 0th index, we'll simply store array of left, and at the first index we'll store array of right, because these two are the numbers when we did the sum of it became equal to our target. So we are storing both these values into the result array, and here we are simply returning result. Now this is the first condition when sum is equal to target. There could be two more conditions. That sum could be less than target or sum could be greater than target. So friends, here is the significance that why we actually sorted the array. If our sum is less than the target, then what we do is we need to increase our sum in the next iteration. So here we simply increment left by one position. So let's say if I take this example here, let's say the sorted array comes out to be 0, 2, 6, 7, 10, 11. So here you can see left will be pointing to 0 and right would be pointing to 11. So if we do sum of it, we will get value is 11, and let's say our target we want is 9. So here we know that 0 plus 11, which is our sum, is greater than target. So what we do is we need to reduce the sum. So we have two possibilities. Either we traverse left towards the second value, or we can traverse right towards the second last value. So here currently sum is 11, but if we traverse left to the second position, in the next iteration our sum will become 2 plus 11, which will give us 13. So we are going way more far than the target. So here our only possibility is we move right to the second last position, because in the next iteration if we do the sum, we will get 10 plus 0, which would be 10. So 10 is pretty much close to the target. So these are the if else provided for that. So if sum is less than target, then we need to increase the sum so that it matches target, and the only way to increase the sum is by incrementing left. so that left can go to the higher values. And if sum is greater than target, then we need to reduce the sum. So for that, what we need to do is we need to decrement right, because as the array is sorted, if right is pointing here, let's say to 11, if it goes to the second last position, we will get a value which is lesser than 11. So here we'll do right minus minus. So after this while loop will terminate, what we can do is we can simply return a dummy integer array, or we can throw an exception like we did here, the two numbers not found. So now let's test its working in the main method. So let's suppose we are provided with this array, and here what we do is we simply call toSum, we pass in the array, and let's say we pass in the target as 9, and we'll simply print the array. So if I run the main method now, so here you can see it returned two values, 2 and 7. So if we do 2 plus 7, we will get our target as 9. So friend, this was all about solving toSum problem using the sorting and two pointer technique. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel. Thanks, have a nice day. Hello everyone. So in this video, we will be discussing is subsequence problem in Java. So first we will see what is a subsequence. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So usually a subsequence of a string is actually a new string which is formed from the original string only. And how it is formed? By deleting some or no characters. And only thing to keep in mind is we should not change the order of the remaining characters. So what it means, now let's see via example. Let's suppose we are given with the original string A, B, C, D, E, and we are given a sequence A, C, E. Now we have to find whether A, C, E is a subsequence of A, B, C, D, E or not. So here you can see if we delete B and D and we don't change the order of the remaining elements, we actually get A, C and E. So therefore A, C, E is a subsequence of A, B, C, D, E. If we look into A, E, C, so it is not a subsequence of A, B, C, D, E. So here A, E, C is present in A, B, C, D, E, but if we remove B and D, the remaining characters doesn't form A, E, C. It actually forms A, C and E. So the only thing we need to keep in mind is the order of the elements shouldn't get changed. So here C is actually coming before E, but here E is coming before C. So therefore the order of the element has changed. So therefore A, E, C is not a subsequence of A, B, C, D, E. Now if suppose we were given a string as A, B, C, D, E. So here you can see by deleting some or no characters. So if we were given this string also is a subsequence of A, B, C, D, E. Because we are not removing any characters and we will be getting the same string back. So this is a subsequence of A, B, C, D, E. So one other way to look into subsequences, we simply see in this direction in both the string and we see whether those characters come into this order only or not. So here first we encounter A and here we see we have got A. So we move ahead
Now we see C. So here is B. So we simply move ahead. We encounter C. So we simply move ahead. We see E and here we see D. So we simply discard it and we move ahead. And at the last we find E. So therefore ACE is a subsequence of ABCDE. Now here we see A. So we move ahead, we go to E, we go to B. So these two are not equal, so we discard it. We go here, we see E and C, we discard this, we go here, we find D and E, we discard this, we come here, we find E. So E and E matches. So now we move here, but here you can see complete string is exhausted and there are no more elements. Therefore, we come to a conclusion that AEC is not a subsequence of ABCDE. So we will be applying this similar algorithm to solve this problem. So here you can see this is the algorithm where we will be provided with the original string and a sequence. We need to simply find out whether this sequence is actually a subsequence of this string or not. So let's see the demonstration of this algorithm step by step. So we'll call this subsequence method by passing in two strings. One is the original string and other is the sequence. And here you can see the return type of this method is boolean. So we will either return true or false. So at the first step, ABCD is our string and the sequence is ACE. So we are figuring out whether ACE is subsequence of ABCDE or not. So this is our original string and this is the sequence. So here you can see that we have represented a string in a form of a character array. So in Java, string class has this method character at, where we pass in an index and we get a particular character present at particular index. So if we pass 1, we will get the character as B. So we can use this method to simply get a particular character at a particular index. We can also use toChar array method, which actually gives us the character array, and then we can perform our logic on this character array. But here I will be simply using this char method and we will see the string in a form of a character array. Moving ahead. Now what we discussed in our previous slide, that we simply look into this direction in both the string. So for that we create two pointers I and j. So I will simply traverse into the original string and j will traverse into the sequence. Now we want to simply check whether ACE is present in this particular order into ABCDE or not. So for that we have provided a while loop where the condition is this while loop will continue till I is less than string's length. So here string length is 5 and j should be less than sequence length. So here I will be traveling from 0 to 4 and j will be traveling from 0 to 2 because the length of the sequence is 3. So this is the condition we need to keep in mind. So why we have provided this condition is I should be less than string dot length is. So if I goes beyond the length of the string, then we need to break from this while loop because there are no more characters left to be compared. And similarly with the j, if j travels beyond the sequence, then it simply signifies that we have found our sequence and we should simply break from this while loop. Because this original string can have n number of elements, and as we have found our sequence, we should break from this while loop because we don't want to go further into the string. So at the start, I is less than 5 and j is less than 3. So this condition comes out to be true. The first step what we do is, we simply compare the character at ith index with a character of the sequence at jth index. So it means we are simply comparing this character with this character. So j is pointing to sequence, and j is also referring to the index 0. So this character is compared with this character. Now if they are equal, so currently a is equal to a. So this condition comes out to be true. Now what it signifies is, one of the sequence character has matched. So now we can safely move j to the next index. So we do j++. So j becomes 1. Moving ahead, and after that we do I++ because now our second character should match with the rest of the string, which is this, because this is already being matched. So we do I++. So I points to index 1. Moving ahead, I is less than 5 as 1 is less than 5 and 1 is less than 3 because j is pointing to 1. So both condition comes out to be true. We again check whether character at ith index of string is it equal to the char at jth index of the sequence. So it simply means we are comparing B with C. Now here you can see B is not equal to C. Therefore this condition comes out to be false. Now as this condition comes out to be false, we don't increment j because there could be a possibility C might come later in the string. So therefore condition in this if block comes out to be false. And we only increment I. So we don't touch j, we only increment I. So I becomes 2. So I'll just remove everything. Now we again check whether I is less than 5. So this condition comes out to be true. And we also check whether j is less than 3 because sequence.length is 3. So both this condition comes out to be true. We compare the respective characters at ith and jth index. So here we are comparing C with C because I and j are pointing to these two indexes. So here you can see C is equal to C. So this condition comes out to be true. It means our second character actually matched with the character in the original string. So we'll simply increment now j by 1 because we have matched our character, and now we simply move to the next character. So j becomes 2 and we'll increment I because this character is already matched. So I becomes 3. Now here 3 is less than 5 and 2 is less than 3. So both condition comes out to be true. We compare the characters at these respective indexes. So it means we are comparing now D with E. So here you can see D is not equal to E. Therefore this condition comes out to be false and we don't increment j. And here as we discussed why we don't increment j, because later in the string there could be E coming up. So here you can see E is here, but if here the character would have been different, so there could be a chance that E might have come later. So we don't increment j, we only increment I.
So I becomes 4. So I'll just remove this. So 4 is less than 5. This condition is true. And 2 is less than 3. So this condition is also true. We'll compare E and E, which is this character with this character. So this comes out to be true. So we'll increment J because our character is matched. So J becomes 3. It means now J has crossed the limits of sequence. Moving ahead, we'll increment I. So I becomes 5. It means I has also crossed the limit of the string. So now here you can see value of I is 5 and 5 is not less than 5. So this condition comes out to be false. So the overall condition comes out to be false. So this while loop will exit. So friends, here at the last step, this condition is pretty much important because if value of J is actually equal to the sequence length, it means J has traversed this sequence complete and we have found our element. So currently J value is 3 and sequence length is 3. So 3 is actually equal to 3. Therefore, we will return true because J is equal to sequence.length and this expression returns true as 3 is equal to 3. Because when J will equal to the length of the sequence, it means it has traversed A, C and E completely. So here we are returning true. So now we'll see one more example. Let's say we call ABCDE with the sequence AEC. So we'll go over this example quickly. I is 0 and J is also 0. Here string length is 5 and sequence length is 3. Both the condition comes out to be true because I is less than 5 and J is less than 3. We compare the characters at the respective indexes of their respective strings. So we are comparing A with A, which is true. So we'll increment J. J becomes 1 and we'll increment I. So I will become 1. Both this condition is true because I is less than 5 and J is less than 3. We'll compare B with E by this expression. So B is not equal to E. So this condition comes out to be false. We won't increment J because there could be a possibility E might lie somewhere after B. So we'll only increment I. I becomes 2. Both the condition comes out to be true. I is less than 5 and J is less than 3. We'll compare C with E now. So this condition comes out to be false. We'll increment I. I becomes 3. I is less than 5 and J is less than 3. We'll compare D with E. So they are not equal. So we'll simply again increment I. I becomes 4. I is less than 5. J is less than 3. Now we'll compare E with E. So they are actually equal. So it means the if block condition came out to be true. So we'll increment J. So J becomes 2. And we'll increment I. So I becomes 5. So this is the important moment that I has become 5. It means I has crossed the boundaries of this string. So here
value of I is 5 and string length is 5. So therefore this condition comes out to be false. So this while loop will exit. So friends, here you can see now value of j is 2 and sequence length is 3. So this condition is very much important to figure out whether all the characters of the sequence were traversed or not. So here you can see j is 2 and 2 is not equal to 3. Therefore AEC is not a subsequence of ABCDE. So we'll simply return false. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel. Thanks, have a nice day. Hello everyone. So in our previous video, we discussed the problem of is subsequence, where we were given two strings. One was the original string, another was a sequence, and we need to find out that whether that sequence is actually a subsequence of that original string or not. So before going through this video, you watch that animation so that you get an idea that how we can find out that whether a sequence is a subsequence of any other string. So in this video, we will actually code the algorithm and will test its working in the main method. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here you can see that I have created one class as string util, and inside that class we will be creating our method public static. We'll give it a name as is subsequence. Now this method will take two strings. One is the original string, another is the sequence. So we need to find out whether this sequence is actually a subsequence of this string or not. So the return type would be a boolean. So in our previous video where we saw the animation, we actually used the two pointer technique where we created two pointers I and j. So I usually traverse the string and j traverse the sequence, and usually we traverse both from left to right, and we simply try to compare the character present at that particular index, which is being denoted by I and j, into their respective strings. So we provide a while loop, and inside this while loop we provide the condition as this while loop will go on till I is less than string's length and j is less than sequence length. Because as we are traversing this two pointers from start to finish, if any of the pointer crosses the limit of their respective strings, we simply break from this while loop. So inside this while loop, we simply compare the character at I and jth index of their respective strings. So here we do if char at I is it equal to sequence.char at j. So if they are equal, so here let's say if we take the string as A, B, C, D, E, and let's say we take the sequence as A, C and E. So here you can see that j starts from 0 and I starts from 0. So we are simply comparing the first element. If they are equal, it means we have found one of the character of the sequence into the original string. So we simply increment j
by 1, because now we try to compare the next element into the original string, and after this if block we always increment I by 1 position because we have matched this character with this character. Now C and E will be compared with the rest of the string. So in the next iteration you will see that B is compared with the C via this condition. So this condition comes out to be false because B is not equal to C. So we don't increment J, we only increment I because there could be a possibility that C might come later in the string because we are trying to find out the subsequence here. So we always increment I irrespective whether we have found our element or not, because if we have found our element here then we increment I because we have to compare the rest of the sequence with the rest of the original string, and if we don't find the matching character which is here where we are comparing B with C, so this condition comes out to be false. So we try to only increment I because there could be a possibility that next character should match with the sequence character at jth index. So this loop goes on, and at the end what happens, either this condition comes out to be false or this condition comes out to be false, or both condition comes out to be false. So this while loop will terminate. So after this while loop will terminate, we simply return is j is equal to sequence.length or not. So why we are doing this is because let's say if this condition comes out to be false, it means j is equal to sequence.length, which signifies that if j is equal to sequence.length, we have found our subsequence. We have found that this sequence is actually a subsequence of this string because we have traversed each and every element and we have found them to be true, and at the last increment of j it will actually reach to the sequence.length. So if j is equal to sequence.length, it means this sequence is actually a subsequence of our original string. And let's say friend, if we provide A, E, C, so this A would have matched with this A, this E would have matched to this E, and after that J would have remained to C because our original string would have been exhausted here, as I would have become equal to string.length. So at that moment of time this condition would have come out to be false, which says that AEC is not a subsequence of ABCDE. So friend, this is the algorithm which help us in determining that whether any sequence is a subsequence of the original string or not. So now let's test its working in the main method. Here we will simply print is subsequence. Let's say we pass the string as A, B, C, D, E, and we pass A, C and E. If I run the main method now, you will see it came out to be true. Now let's say if I run it with A, E and C, so it came out to be false. So why? Because AEC, though it's present in ABCDE, but the order of elements which constitutes the property of subsequence is not matched. Here you can see C is coming before E, but here E is coming before C. Therefore this cannot be the subsequence of this string because the order matters in the subsequence. So friends, I hope you liked this video, and in case if you are new to my channel, then please subscribe to my channel. Thanks, have a nice day. Hello everyone. So in this video we will be discussing first non-repeating character problem. So this is a very famous interview question which is being asked by many companies. So we'll see what this problem is and we will see the demonstration of this algorithm step by step. So here you can see that we are given a string S which only has lowercase letters. Now we need to return the index of first non-repeating character. First non-repeating we mean is the unique character which occurs first, and if it doesn't occurs or doesn't exist, we can return -1. So we need to return the index. Let's see with an example. Suppose the string provided is code for code. So here you can see the answer is 4th index. The first non-repeating character is F and is found at index 4. So let's see how. We actually traverse the string from left to right because we need to find the first non-repeating character. So here you can see, if you see C occurs here as well. So this is not a unique character. We check O is here and here at 3 places. So O is also not unique. We see D is here and here. So D is also not the unique character or first unique character. E is here also. So E is not the first unique character. Now we see F. So here you can see F is not present in the rest of the string. So F is the first non-repeating or unique character in this string. And the index is, let's say 0, 1, 2, 3, 4. So 4 is the answer. Now let's suppose we are provided with string as A, B, B. So here you can see A occurs twice and B is also occurring twice. So it doesn't have any non-repeating character. So we simply return -1. Now let's see the algorithm for it and its demonstration step by step. So here you can see this is the algorithm to solve first non-repeating character problem. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here, let's say we call this method first non-repeating character. We pass the string as race cars. So here the string is race cars, something like this. So friends, the basic idea behind this algorithm is we actually take the help of a hashing data structure, which is a hash map, which basically has key and value. So here key is unique, which is our character, and the value is a integer, which will actually hold the count of the character occurring in the string. And why we are taking a hash map is because if you see somewhere here we are doing get. Now this get operation, when we pass any character, will return us the count for that particular character, and this happens in O of 1 time. If we don't use hash map, then the algorithm will take multiple for loops and will increase the time complexity. So therefore, to get the character count very fast, we use this hashing data structure, which is our hash map. So we'll see its significance when we see the algorithm step by step. So first we will create a map having key and value of type character and integer. So here I am simply demonstrating it as key value pair, but internally this map uses a hash function to store this key value pair such that the retrieval becomes faster. You can watch my videos on hashing data structure and hash map, but here I will be simply demonstrating it with the values. So here we have this string race cars. Now what we do is, as we need to find out a single character which is first non-repeating, we first take this string, we call toCharArray method on it, and this will return us a character array. So this method is present in a string class. So it would look something like this, that we have got our character array, where this array at each index holds one character like this. Moving ahead, now what we do is, we iterate over each and every character one by one, and we put the character into the map, and we put it such a way that if that character is not present, we put 1, and if the character is present, we take that value first and we add 1 to it. So we'll see how this line works, but here you can see that we are putting the character because key is the character, and as the integer what we are doing is we are calling hashmaps method get or default. So when we do map.get or default, if this character is already present, then its corresponding value is returned, and we simply add 1 to it and we put it back into the map. And if the character is not present, then we return a default value. So it's like get or default. So for the default value, here you can see we provide 0, which signifies that the particular character, if it is not present in the map, it means just return the count as 0. And why we are doing +1 and putting it back into the map, you will get more when we will see the working of this for loop. So here, this for loop will iterate each character one by one. So it will start with R. Here we will put R, and here you can see the map is empty. It doesn't have R. So the default value of 0 is returned. And when 0 is returned, we do +1 to it. So it becomes 1 and we put it into the map. So here it would look something like this. We put R as our key and value as 1. So this 1 signifies that character R occurred one time as we are traversing from left to right. So at this moment R has occurred one time. So therefore we are returning this 0 because we are adding 1 to it. So if R again comes up, we will do map.get or default. We will get actually 1 because R is already present as a key. So we add 1 to it, which means the count of R is 2. We extracted 1 and we added 1 to it. So the count became 2, and if the value is not present, we add 1 to the 0 and put it back into the map. Moving ahead, now it will pick the second character, which is A. It checks whether A is present or not. So A is not present in the map. So it simply returns the default value 0. We add 1 to it and we put A as a key and value as 1. So it goes like this. It takes C now, and similarly it puts C as a key and 1 as a value because C is also not present in the map. So get or default will return 0 as a default value. Now it takes the fourth character, which is E. We put E also as 1 because the count is still 1. Now it takes C. So here you can see when we will do map.get or default, now this time 0 won't be returned because C is already present and with a value as 1. So this 1 will be returned, and we'll simply do +1 and we put C with value as 2. So this complete expression gives us 2 for C. So here it becomes 2, and which makes sense because till this point we have encountered C 2 times. So we are simply storing the frequency of the character in the value field. Moving ahead, now it will pick A. A is also present, so it will take this value, it will add 1 to it and it will insert it back. So it will become 2. It will pick R. So R also becomes 2. And at the end it picks S. So here S is not present. So therefore the default value 0 will be returned. We do +1 and we put S with 1. So now this for loop will end. So friends, here you can see this is the character frequency map. So why we have done this is to simply count the number of occurrence of a particular character. So here you can see R occurred 2 times here and here. A occurred 2 times here and here. C one here and one here, and E and S occurred only once, here and here. So now the next for loop will help us in deciding which is the first non-repeating character. So here we will again iterate the char array from 0 index to the end. So initially I is 0 and I is less than chars dot length, which is 8. So chars dot length is 8. So we pick the first character, we provide the index 0. So R will be picked. And now we'll simply call map.get and we pass the character. So when we do map.get, we will get its corresponding value because we are passing in the key, and this map will return us back the value associated with this key, and that too in O of 1 time, which is very fast. So that's why we were using hash map. So here when we do map.get R, we will get the value as 2. So here you can see 2 is not equal to 1. It means R cannot be our first non-repeating character because it has value 2. So we move ahead with the next character. I becomes 1. 1 is less than 8. We take the next character, which is A, as index 1 because value of I is 1. We do map.get A. So we pass in the key as A and we get value as 2. It means A cannot be our first non-repeating character. We move ahead. I becomes 2. 2 is less than 8. We pick C now. We do map.get C. We get the value as 2. 2 is not equal to 1. So therefore C can't be our first non-repeating character because it has value 2. It means it has occurred 2 times. We'll increment I to 3. We'll pick now E. Now here you can see when we do map.get E, we get a value as 1. So 1 is equal to 1. It means this condition comes out to be true, and which signifies that we have found our first non-repeating character. Because we were traversing this for loop from this end, and whichever value we found to be 1, we simply return its index. So here whatever the value I will have, we'll simply return it back. So the answer would be 3. So now let's see this example one more time with values AB, AB. So we'll quickly go over it. String is AB, AB. We create a hash map like this. We convert this AB, AB into character array by calling toChar array. So it comes out to be like this. Now we'll iterate each and every character and we put its frequency as a value in this hash map. So we start with A. We check whether A is present or not by this. It is not present, so we return the default value as 0. Whatever value is returned, we add 1 to it and we put A into the hash map. So the value would be 1, signifies that A has occurred 1 time. We go with the B, and similarly B will have 1 because B is not present in the map. We take A and we see A is already present, so we get this value out. We add 1 to it and we put it back. So 1 plus 1 will give 2 and we put 2 back into the hash map. We take the last character B. We see B is also present, so we do 1 plus 1 and add it back. So occurrence of B is also 2. Now this for loop will end. So here you can see, looking into the hash map, A occurred 2 times, here and here. B occurred 2 times, here and here. So here we can see that in this string, no character has appeared once. So this for loop will help us in figuring that out. We will start with I equal to 0 index. We go till chars.length. So chars.length is 4. 0 is less than 4. We take first element, which is A. So we do map.get A. We pass the A. We get value as 2. So here we can see that 2 is not equal to 1. So this condition comes out to be false. We increment I. I becomes 1. 1 is less than 4. We take the first index character, which is B. I'll remove this. We do map.get B. We pass the key B. We get value as 2. So here 2 is not equal to 1. So this condition comes out to be false. I becomes 2. 2 is less than 4. Now we take the second index value, which is A. We do map.get A. It returns 2. 2 is not equal to 1. This condition comes out to be false. And similarly, we do for the last character. We take B. We do map.get B. It will return 2. 2 is not equal to 1. So this condition comes out to be false. So here now I will become 4. And 4 is not less than 4. So this for loop will end. And once this for loop will end, if we haven't written anything from this condition, at the end we know that there are no characters in this string which are unique. So we simply return -1. So friends, here we saw 2 examples. In one we found the first non-repeating character, and in other we didn't found any non-repeating character. So if I go to the previous slide, so here you can see that when we did race cars, we actually saw that E and S both had a count 1, but here E occurred before S. So therefore this E was the first non-repeating character, not S. So this is one thing we need to keep in mind, that we need to find first non-repeating character. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw the detailed demonstration of the algorithm to find first non-repeating character in a string, where we were given a string in lowercase letters and we wanted to find the index of the first non-repeating character in it. So in case if you want to understand more, you can watch my previous video. So in this video we will actually code the algorithm and will test its working in the main method. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here in string util class, I will be creating the method as public static. We'll give the method name as first non-repeating character. So this method will take a string and it will return the index, which is of integer type, for the first non-repeating character. So friends, here in order to find the first non-repeating character, we first iterate this string completely and we figure out the character frequency, that how many times a particular character has occurred. So for that we are using the map whose key is character and value is integer, which is the count of that particular character, that how many times it has occurred. So we can give it a name as character frequency map, new hash map. Now we want to iterate each and every character of the string one by one. So for that, we take the string and we convert it into character array by calling toCharArray method. Then we provide a for loop. So here we will iterate one character in each iteration. Now here what we do is, as we want to count the character frequency, that how many times it has occurred, what we do is we do character frequency map dot put. We put the character as key, and the value we put is, we first check that whether this character is present in the map or not. So we do it by method get or default. We pass the key to it. If that character is present, the value corresponding to it will be returned, and if that character is not present, so we can return a default value because the method is get or default. So we need to pass the default value to it, which is, let's say if the character is not present, we want it should return 0. So here you can see default value is 0. And what we need to do is, let's say if the string has a character A which is not present. So here we have encountered A. So we need to put the count as 1 because A has occurred once. So we'll do +1 to it. And let's say next time, for example, let's say our string has something like ABA. So for this map will have A as a key and value as 1. Now when this A will again occur, so this get or default will return the previous value which is 1, and we will add 1 to it. So now map will have A as a key and value as 2 because A occurred 2 times. So this we do for each and every character. And after doing that, we provide another for loop. And we iterate this char array once again. And now as we want to find the first non-repeating character, and we are starting from 0th index, so whichever character value in this character frequency map will have 1, it means when we had traversed this character array completely, that particular element was the one which had only occurrence 1 and which was the first non-repeating character. So here what we do is, we take the char from the ith index, we provide a if check. If the character frequency map we do get, we pass the character, and if the value returned is 1, it means this is our character which is first and non-repeating. So we simply return its corresponding index which is I. And if we don't find any such character whose frequency is 1, then at the end we simply return -1. So now let's test it's working in the main method. Here we will call first non-repeating character. Let's say we pass the string what we saw in our previous video, race cars. So here you can see it should return 0, 1, 2, 3 because E is the first non-repeating character. Why? Because R, A and C have occurred 2 times in this string. So if I run this, so here you can see it returned 3. And let's say if we put a string which doesn't have any unique character, so here A has occurred 3 times, B has also occurred 3 times. If I run it, it should return -1. and let's say we provide a value here as E. So now we have E as a character which has occurred only once, and it's the first non-repeating character. So if I do run it, we will get its index as 6 because 0, 1, 2, 3, 4, 5, 6. So E is at 6th index. Now let's say if I do in between I do F. So now F is our first non-repeating character because E comes later. So now it should return 3. So it comes out to be 3. So 0, 1, 2 and 3. So friend, this was all about the algorithm to find the first non-repeating character in a string. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video, we will be discussing a problem that how we can remove vowels from a string. So here we are given with a string and we need to remove the vowels from that string and return that string. And the string only contains the lowercase letters. So if we talk about vowels, then there are 5 vowels: A, E, I, O, U. So let's suppose we are given with this string, what is your name? So the output would be this A, I, O, U, A and E. This will be removed because those are vowels, and this string will be written like this. So now let's see the demonstration of the algorithm step by step, that how we can remove the vowels from a string. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here you can see that this is the algorithm to remove vowels from a string. So now let's see the demonstration of this algorithm step by step with an example. So we'll call remove vowels method. We'll pass the string as ice cream. So here string would be ice cream. So here you can see that it has vowels like I, E, E and A. So here in order to remove the vowels from this string, we take each character and we see whether it's a vowel or not. So for that, first we create a set which we denote as vowels, and this set will only have the characters. So this is a set of A, E, I, O, U. And why we are taking it as a set? Because here you can see that we are using for loop. We are iterating over each character of this string and we are checking whether this particular character is present in this vowel set or not. So this contains method is very fast and it has an average time complexity of O of 1, which is nearly constant. So therefore we are using set. In order to know more about set and hashing data structure, you can watch my series on hashing. So after creating the vowel set, we will be creating an instance of string builder. Now why we are taking string builder is because when we will be removing the vowels from this string, we will be creating a lot of intermediate strings. So to avoid that, we are basically using string builder. So string builder class is provided by Java, which actually deals with the operations performed over the string and which help us in generating a string without giving a performance hit. Moving ahead, now this string has a method toChar array in Java. So when we call this method, we will get a character array. So this ice cream will be separated out in a form of a character array. So it would look something like this. That this is the character array going from index 0 to 8 because it is taking ice cream one single character at a time.
So now we'll traverse each and every character one by one using this for loop. So this for loop tells that iterate over each character present in the char array. So when this for loop will start, ch, which is the character, it will point to the first character, which is I. So ch is I. So we take this character and we search into our vowel set that whether it contains ch or not. So here you can see vowel set has character I. So it means this is a vowel and we don't want to include this into our final string. So what we do is, here you can see the condition as vowels.contains will come out to be true, and if we negate that, it will become false. So this condition comes out to be false, and we will simply skip I because it is a vowel. So now we'll go to the second character, which is at index 1. So ch will become C. We check whether C is present in the vowels set or not. So vowels.contains will return false because C is not present, and if we negate that, this will become true. It means C is not vowel, so we need to include this C into our final string. So this condition comes out to be true. So string builder has a method append where we will simply append the character C. So it would look something like this, that C comes into the string builder. Moving ahead, we will go to the third character, which is E. Now E is a vowel, so vowels.contains E will come out to be true, and this condition after negating becomes false. So therefore we will skip E because E is a vowel. Moving ahead, now the fourth character is actually an empty string or a blank character. So ch will point to this empty thing or space. So this condition vowels.contains will come out to be false, and if we negate that, it will come out to be true because this is not a vowel. So we will include this. So we'll simply append the space. Moving ahead, the fifth character is C. So we will simply include this because C is not a vowel. So C gets appended. Now sixth character is R. So vowels.contains R comes out to be false because R is not a vowel. If we negate this, overall condition comes out to be true. It means R is not a vowel and we need to include this. So we'll simply append R. The seventh character is E. So E is a vowel. So vowels.contains will return true. And if we negate it, this condition will become false. So we'll simply skip E because E is a vowel. Now we will take the eighth character, which is A. A is a vowel, so we need to skip it. And at the last, we will take M. So M is not a vowel, so this condition is false and overall condition after negating becomes true. So we need to include M because M is not a vowel. So we have included M, and after M there is no more character left. So this for loop will terminate. So here you can see at the end
whatever we collected into our string builder. If we do toString, we will get a string like this, and we'll simply return it from the remove vowels method. So friends, in this video we saw the algorithm to remove vowels from a string. We took the help of the set and string builder to remove the vowels and return the final string without these vowels. I hope you must have liked this video, and in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in our previous video, we saw an animation and we discussed the problem that how we can remove the vowels from a string. So in this video, we will be actually coding the algorithm and will test its working in the main method. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here we have created one class as string util, and inside that class I will be creating one method as public static. We'll give it a name as remove vowels. This method will take a string and this method will return back us a string without vowels. So the input is a string with vowels. What we get in return is a string without vowels. So here basic idea behind this algorithm is we iterate over this string character by character and we figure out that which character is vowel and which character is not. So how can we figure that out? First we will create a set of vowels using set.off method. Now this method will simply take the characters. So we can provide the vowels as A, E, I, O, U. Also here this string will only contain the lowercase letters. So we have only provided the lowercase vowels. Now after creating the set of vowels, what we can do is we will create string builder class. So this string builder class will help us in creating the string which we want to return, and this string builder class is performance efficient. It has many utility methods by which we can manipulate the string. Now in order to iterate the input string character by character, what we can do is we will call toCharArray method. Now this method basically return us a character array. So after getting the character array, we will provide a for loop where we will simply iterate over each character one by one. So what we do is we provide a if condition. If vowels contains the character, so if vowel contains the character, it means this character is actually a vowel and we don't want to include it. But if it is not a vowel, then we need to include that character into our final string. So here what we do is we do the negation of it. So if character is present into this set, this will return true, and if we negate it, we are simply skipping the vowel. And let's suppose character is something like C, B, J, K. For example, when we will call vowels.contains this, let's say C, so it will return false. This condition will come out to be false, and if we negate it, it becomes true, which means that if there is C, then we need to include that into our string. So we'll simply append the character to our string builder class. So basically when we will encounter any vowel, this part will be skipped because vowels.contains will return true,
and if we negate it, this condition comes out to be false and this part is skipped. So after doing this for each and every character, at the end we'll simply return sb.toString. So this string builder will simply append only the characters which are not vowels, and at the end when we will call toString, it will convert everything into the string and it will return. So this is the algorithm. Now let's test its working. Here we'll call remove vowels, and let's say we provide string as ice cream, and if I run it, so here you can see all the vowels are removed. I, E, E and A. Everything is removed and rest of the string is returned. Also friends, why we are using this set is because when we do contents on a set, this is a very faster operation. The average time complexity of this operation is O of 1. So basically it signifies that in O of n time, we can simply find out the vowels from the string and remove it. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss that how we can reverse an integer in Java. So here let's suppose we are given an integer x. Now we need to return x with its digits reversed. So if you see an example here, let's say if we are given with the integer as 1, 2, 3, 4. So our output should be 4, 3, 2, 1. We are simply reversing the digits of this integer. Similarly, if we are given an integer which is negative 1, 2, 3, 4. So it should return negative 4, 3, 2, 1. So the sign should be there with only digits being reversed. And let's say if we see example 3, here we are given an integer which is nothing but integer.max value, which is 214748367. Now when we reverse this integer, we get 746384741. So here you can see that this is the integer's max value, and if we reverse it, this value may overflow the integer range. So we need to encounter this use case as well, that when we are reversing the max or the min value or any value of the integer which on its reversal may overflow, we need to encounter that use case as well. So let's move ahead and see the demonstration of the algorithm step by step. So here you can see that we are given with a method as reverse, and we are passing in the number which we want to reverse. So this method return type is long. Now why we have kept the return type as long is because there may be a chance that let's suppose this int value is maximum or any number which on its reversal may overflow the integer's maximum range or minimum range. So therefore, in order to fit that particular range, we are taking a long value which will be returned from this method. So here this long is basically handling our overflow case, because when we cross the integer's range, the data type which can handle that overflow range would be the long. So now let's see the demonstration of this algorithm step by step. Let's say we want to reverse a negative number 1, 2, 3, 4. So here the number will be minus 1, 2, 3, 4. So here you can see the first thing we do is we simply check that whether this number is negative or not. So if we provide this condition, then whether number is less than 0 or not. So if number is less than 0, the is negative will have value as true. Currently number is less than 0. So the value of is negative will be true by this condition.
And why we are evaluating whether number is less than 0 or not? Because when we are reversing the digits, we need to take its absolute value without the sign. We'll see this later. So for time being, we just evaluate whether number is less than 0 or not. If it is less than 0, then we simply multiply it with -1 to make it a positive number. So now number will become 1, 2, 3, 4. So here -1, 2, 3, 4 into -1 will give 1, 2, 3, 4. This minus minus becomes positive. Moving ahead. Now in order to store the reverse, we are taking in a long value. And why we are taking it as a long value is because this integer value number, if we reverse the digits of it, there may be a chance that this number may overflow the maximum or minimum range of the integer. So therefore, in order to accommodate this overflow condition, we are taking it as long, because any value which crosses integer's max or min range can be fit into the long variable. So at the start, reverse is 0. We will create the last digit integer value. So this integer value will hold only one single digit, which would be the last digit, which we will see later here. So friends, in order to reverse this integer value, these are the three main critical steps we need to perform in a while loop. This is one of the approach to reverse the integer value. Now there can be one more approach. We can simply take the string value of this number, convert it into the character array, and then we simply reverse the characters in that particular array. So that could be one case, but here we are taking the help of modulus operator and the division operator, because this modulus operator is very important when dealing with numbers. So here we will discuss what actually this modulus operator does and division operator does. So currently number is greater than 0. So this while loop will execute till number is greater than 0. When number will be equal to 0 or less than 0, then this while loop will terminate. So friends, here you can see that in order to reverse this number 1, 2, 3, 4, it should become 4, 3, 2, 1. So what we need to do is, we need to first take the last digit, bring to this position, then second last digit, bring to this position, third last to this position, and fourth last to the last position. So these are the things we need to do. So how we can extract the single digits from this number is, we can take the help of modulus operator. So here you can see, let's say we want to divide 12 by 10. So 10 is the divisor, 12 is the dividend. And in normal mathematics, when we divide 12 by 10, we get quotient as 1 and the remainder as 2. So here, this remainder is nothing but the result of the modulus operator, which you see here. And this 1 is nothing but the result of the division which we do here. So using the simple mathematics, we will evaluate the reverse of this number. And also friends, here you can see that in order to get 4, when we divide any number by 10, whatever the remainder we get, that would be our last digit. So here if we divide 1, 2, 3, 4, let's say if I do 1, 2, 3, 4, and let's say I divide it by 10. So 1, 2, 'So here you can see that this is our quotient and this is our remainder. So when we have divided 1, 2, 3, 4 by 10, we get the remainder as 4, which is nothing but our last digit. And the quotient would be the remaining digits just before the last digit. So this is the crux of the algorithm, that when we divide any number by 10, the remainder will give the last digit and the quotient will give the remaining digits. So here, when we take the remainder of the number, which is 1, 2, 3, 4, the last digit will have value as 4, because this is our remainder here. Moving ahead. Now friends, as we have extracted the last digit, this would be our first digit when we do the reversal. So here if I reverse 1, 2, 3, 4, we get 4, 3, 2, 1. So this would be our first digit now. So in order to make it first digit, what we do is, whatever the value reverse will hold, we will simply multiply it by 10 and we will add the value stored in the last digit. We will see the importance of this part later. So currently reverse is 0. So 0 into 10 will give 0. And when we will add 4 to it, we get reverse as 4. So reverse will become 4. This part will be clear in the next iteration. Moving ahead. Now as we have extracted one digit, we need the rest of the digits now. And how we can get the rest of the digit is the quotient of this division. So when we will do number divided by 10, we get the quotient as 1, 2, 3. So the new number will become 1, 2, 3. Moving ahead. So number is greater than 0. 1, 2, 3 is greater than 0. So this condition comes out to be true. Now we need this last digit. So what we need to do is, we need the remainder. So when we will divide 1, 2, 3 by 10, because this is our new number, so here we'll get 10, 1. So here you can see, when we divide 1, 2, 3 by 10, we get remainder as 3 and the quotient as 12. So this is a similar approach. When we divide any number by 10, the last digit is our remainder and the remaining digit is our quotient. So now last digit will become 3, because we need 3 to simply append it here somehow. Moving ahead. So friends, now as we have got 3 as last digit and we need to append it here, we can't directly add this 3 to the reverse. What we do is, whatever the value reverse will hold, if suppose this is 4 and if I multiply it by 10, we will get 40, and then if I add the last digit, which is 3, we will get 43, which is the stuff we want. If we reverse 1, 2, 3, 4, we should get 4, 3, 2, 1. So 4 and 3 should be next to each other. So this is the important step here, that when we are multiplying the reverse by 10, we are simply shifting the digit by one place and we are adding the last digit to it, so that both these numbers are next to each other. So this is the important step. So here now reverse will become 43, what we discussed here. And as we are done with the digit 3, we need the remaining digits. So the remaining digits we get by number divided by 10, which will give us the quotient. So number will become 12. The number is still greater than 0. So this condition comes out to be true. Now we will take the last digit. And how we can get the last digit is, we divide the number by 10 So this is our remainder and this is our quotient. So our last digit is 2 because number modulus 10 will give us the remainder as 2. So 2 will be assigned to the last digit. And now how we can append 2 just after 3 is we need to create one space here. And how we can create the spaces? We simply multiply it by 10, we get 430. And then we simply add 2 to it, which is our last digit, we get 432. So this is the step which help us in appending the last digit to the reverse. So after this line gets executed, reverse will become 432 with this multiplication and addition. Moving ahead, we are done with 2 and now we simply need 1. So our new number will become the new quotient by number divided by 10. So we'll get the new number as 1. Number is still greater than 0. So this condition comes out to be true. Now we need the last digit, but here you can see 1 is the only digit left. So here when we will divide 1 by 10, we get remainder as 1 and quotient as 0 because 1 is not divisible by 10. So 1 will be our remainder and quotient will be 0. So now last digit will become 1. This. And here how we can append this last digit to 432 is 432 into 10. It will give us 4320. We will do plus 1. We get 4321. So this is our last digit. So by these two operations, the reverse will become 4321. And now we'll simply assign number divided by 10 value to number. So here you can see when 1 got divided by 10, the quotient was 0, which is the result of our division. So 0 will be assigned to the number. So number became 0. So now here you can see this while loop will terminate because number is equal to 0 and not greater than 0. So this while loop will terminate. And here is the important step, that why we are providing this condition is because we have used up all the digits of our original number and we have reversed it. So therefore this condition is very important, that number should be greater than 0, because when number will be equal to 0, it means there is no value left in the number to be reversed. And at the last we simply check whether our original number was negative or not. So our original number here was negative. So if it is negative, then this condition will be executed. We will simply multiply reverse by minus 1. So 4321 into minus 1 will give minus 4321. So minus 4321 will be returned from this reverse method. And if is negative would have been false, then we would have simply returned the reverse. So friends, this is how we actually reverse an integer value. There are 3 steps to remember. First, we need to evaluate whether the number is less than 0 or not. The second is we need to take this data type as long, because when we reverse a bigger integer value, there may be a chance that its reversal may overflow the integer value. So if we take integer here, then this reverse will only hold the garbage value, which we don't want. So in order to accommodate the large overflow integer value, we will store it in the long, because long can accommodate that value. The other thing is this simple mathematics here, which is very important. When we divide any number by any value, whatever is the remainder, if we want to achieve the remainder directly, we can use the modulus operator, which is here. And if we want to access the quotient, we can simply take the value of the division here. And using these 3 steps, we have actually performed the reversal of this integer. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.
Hello everyone. So in this video we are going to discuss a lead code problem, remove element.
So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update.
So in this problem we are given an integer array and we are also given with a integer value. Now our task is to remove all the occurrences of that value from the integer array and that too in place. So what do we mean by in places? Let's say if we take this example and this is our input array and this is the value given to us, which is 3. Now our task is to remove all the occurrences of this value from this array, that too in place. So it means that we have to modify the given array in such a way that we have to remove all the occurrences of this value. We can't use additional data structure or an additional array for this removal. Whatever operation we need to do, we have to perform in the given array itself. And in this problem, after removal of all the occurrences of the value, it is okay that order of the elements may change. So for example, in the second array, when the value is 2, you can see after removing the 2, we are getting 0, 1, 4, 0, 3. Now here we can also return something like 4, 1, 0, 0, 3. So the order of the elements may get changed, but our task is to just remove all the occurrences of the given value. And finally we have to return an integer value, which is a count of the elements which are not equal to the given value. So here in the first example you can see the array is 3, 2, 2, 3 and the given value is 3. So after removing 3, we are only left with 2, 2. So the output would be 2 because there are 2 values, 1 and 2. Similarly here, let's say we are given with this array and the value is 2. So after removal of all the occurrences of 2, we get 1, 2, 3, 4, 5. So our output should be 5. Now here we have to do 2 tasks. First is we need to return the count of the values which are not equal to val, so which is our k. And the second task is we have to actually perform this removal in place in the given array. So we have to remove all occurrences of val in array and that too in place. So we have to perform these 2 tasks. Now if we look into the problem, this is the problem on lead code. We have to do these 2 tasks. So whatever the array is given to us, we have to modify the same array and we have to return the total number of elements which are not equal to this value. So for example, in the first test case, if the val is 3 and the array is 3, 2, 2, 3, so we know that after removing 3, the number of elements which are not equal to val is 2, 1 and 2. So here if I directly return, let's say 2, so this test case should get passed, but if I run the code, so here you can see that we have returned 2, which is our output, but we haven't modified the array in place. So the lead code editor will also check the given array that we have removed all the occurrences of the given value from the given array. Now let's see how we can approach the solution of this problem. So for example, let's suppose we are given with this array 0, 1, 2, 2, 3, 0, 4, 2. Our task is to remove all occurrences of 2. The output should be 5 because the total number of elements which are not equal to 2 are 5. 1, 2, 3, 4, 5. And the remaining element is shown blank because the test case doesn't look beyond our output, which is 5. So here how we can approach this problem is we can use 2 pointers, let's say I and j. So let's suppose if this is our array and we have to remove all the occurrences of 2. So this is our val. Now here two pointers will move throughout this array in such a way that one is slow pointer and another is fast pointer. So let's say they both start at 0th index, and here let's suppose j is our fast pointer and I is slow pointer. So j will travel each and every element throughout this array. So it's just for iteration. And here I will move slowly, and its main purpose is to actually remove all the occurrences of the given value. So once it removes the occurrences of the given val, it will then move ahead slowly. So here it helps to remove the element. So here what do we do is, as j is iterating over complete array, we simply compare the value at jth index with the value we want to remove, and I is actually helping us to remove that value. So here, if the value at jth index is not equal to 2, it means we have found an element which we need to keep in the array. So we simply take that value and assign it to the ith index, and then we actually increment I. So let's see why an example. So currently the value at jth index is 0. It is not equal to 2. So 0 is not equal to 2. So it means that we have found a value which we need to keep in this array, and we know that I will help us in keeping that value in the array. So at the start we will assign 0 to the ith index, so this value stays here, and we increment I to the next index. So I comes here, and j is actually traversing the array, so it will also get incremented. Now we again check that value at jth index 1, whether it is equal to 2 or not. So 1 is not equal to 2. So we assign the 1 to ith index. It means the same value is assigned to this index, and we move ahead. So I moves to this index, and j also moves to the second index. Now here the value at jth index is 2, and 2 is actually equal to 2. So here we know that we have to remove this occurrence. So I will actually point to the same index because its task is to actually remove this element. So when the value at jth index is equal to our value which we want to remove, we don't move the ith index, we only move the jth index, because I is actually helping us to remove this value. So here I stays at the same place and j moves. So j comes here. Now again here the value at jth index is 2, and 2 is equal to 2, and we have to remove this occurrence via taking help of ith pointer. So here I stays at the same place and j moves. So j comes to the fourth index. Now value at jth index is 3, and 3 is not equal to 2. So it means we have to move this value here so that this occurrence can be removed. So when we move 3 here, it would look something like this, that 2 is gone and 3 comes here. And after the assignment, I will move to its next index, because its task is to remove all the occurrences of the given value, and j usually moves ahead. So it goes to 5th index. Now here the jth index value is 0, and 0 is not equal to 2. So therefore we will assign this value at the ith index like this, and here now value will become 0, and now both the pointers will move ahead. Now here value at jth index is 4. So here 4 is not equal to 2. So therefore we will assign this value at the ith index. So it would look something like this. So 3 will be gone, and here it will be 4, and both the pointers will move ahead. So I will come here and j will come here. So now the value at jth index is 2, and 2 is equal to 2. So we do nothing here, we simply increment j. So now j has traversed complete array, and here you can see the ith index will be our answer, because this is the last place where we need to remove an element, but we didn't find any more elements. So after removal of 2, our output came out to be 5. So if we put the index at 0, 1, 2, 3, 4 and 5. So this 5 is nothing but a value which is pointed by the ith index, and this would be our answer, because till this point all the occurrences have been removed, and after that there were no more elements to be removed. So therefore we have achieved two tasks. One is we are returning the output as 5 and another is we have modified the array in place and we have removed all the occurrences of 2. So in this problem the basic idea is we are using these two pointers I and j. The purpose of j is to simply traverse the array, compare the value at jth index with the value we want to remove, and the purpose of I is to actually remove the element via assignment when we actually find a value at jth index not equal to the value which we want to remove. Now let's move ahead and see the demonstration of this algorithm step by step. So friends, before we start, in case if you're new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here this is the code, and let's say we are given with this array which we discussed in our previous slide. We are calling remove element method, passing in this array and the value as 2, for which we want to remove all the occurrences in this array. So we have nums array and the val as 2. Now we are creating these two pointers I and j. So here I starts from 0. And as we know that the purpose of j is to simply traverse the array and compare the value at jth index with the actual value we want to remove. So we are using a simple for loop here. So j starts from 0. So at the start j is 0 and nums.length is 8 because we have 8 elements 1, 2, 3, 4, 5, 6, 7, 8 and 0 is less than 8. So this for loop will execute, and as we already discussed, we have to simply provide one if check that whether value at jth index, whether it is equal to val or not. So currently value at jth index is 0 and 0 is not equal to 2. So therefore this condition comes out to be true. It means that we have found a value which is not equal to 2 and which we need to keep in the array. So the way we keep in the array is via ith pointer. So we simply assign nums of j to nums of I. So nums of j is 0 is assigned to nums of I, which is at 0th index. So this value is assigned to the same index like this. And the actual purpose of I is to actually remove the elements and keep only those elements which are not equal to 2. So after putting a value which is not equal to our given value, we move I to the next index like this. We will increment j. J comes to index 1 and 1 is less than 8. So this for loop will execute. We again compare the value at jth index with the given value. So the value at jth index is 1 and 1 is not equal to 2. So therefore we have again found a value which is not equal to the value which we want to remove. So the condition in if block comes out to be true. And we simply assign value at jth index to value at ith index. So 1 is assigned to the same index because I and j are pointing to the same index. And after putting a value which is not equal to 2, we simply increment I. We increment j. So value of j is 2 and 2 is less than nums.length which is 8. So this for loop will execute. We again compare the value at jth index with the given value. So here 2 is actually equal to 2. So the condition in if block comes out to be false. Whenever we are encountering a value which we want to keep in the array, at that time we are doing this assignment, and as soon as we are finding a value at the jth index equal to the value which we want to remove, we do nothing and we simply increment j. So I will actually remain at this position because in the future there could be a values which we want to migrate to this index because we want to remove this 2. So let's say in future there is 3, 0, 4. So 3 should come here and this 2 should get removed. So this I should stay at the same place. So now value of j is 3. 3 is less than 8. So this for loop will execute. Now value at jth index again is 2 and 2 is equal to 2. So therefore the condition in if block comes out to be false and we do nothing. We again increment j. Value of j becomes 4. 4 is less than 8. So this for loop will execute. Now the value at jth index is 3. So here 3 is not equal to 2. So it means we have found a value which is not equal to the given val and we need to keep this value in the array.
and this index is not the right place for the value 3. So therefore this I will actually help us in shifting of this 3 from here to here via this assignment. So the condition if block comes out to be true. We assign the value at jth index, which is 3, to ith index. So now this 2 will go away and this 3 will come here like this. And after placing 3 at its correct spot, now it's time to move I to the next index, because in the future there could be more values which can come here. So we simply increment I. Value of I becomes 3. We increment j. J becomes 5. 5 is less than 8. So this for loop will execute. Now value at jth index is 0. And 0 is not equal to 2. So this condition comes out to be true. So it means we have to shift this 0 to its correct position, which is being denoted by I. So here we simply assign value at jth index to value at ith index. So 0 comes here with this assignment. And after placing 0 at its correct spot, we will simply increment I. We will increment j. J becomes 6. 6 is less than 8. So this for loop will execute. So value at jth index is 4. 4 is not equal to 2. So therefore this condition comes out to be true. And we simply shift this value 4 at index I. So 4 comes here via this assignment. And then we simply increment I because we have placed 4 at its correct spot. We increment j. J becomes 7. 7 is less than 8. So this for loop will execute. So now here value at jth index is 2. 2 is actually equal to 2. So therefore the condition in if block comes out to be false. So we do nothing. And we simply increment j. So value of j becomes 8. And 8 is not less than 8. So therefore this for loop will terminate. And at the end we'll simply return the value which is being held by I, which is 5. Because this was the last place where we couldn't remove the occurrence. And before that we have removed all the occurrence. And as the array starts from 0th index, we have to return a value which is the total number of elements which are not equal to our given val. So here we had 0, 1, 3, 0, 4 which were not equal to 2. And if we count them, we have 1, 2, 3, 4, 5. So whatever value I holds, that will be our answer. So we simply return 5. And we have also modified the array in place by removing all the occurrences of our given value, which is 2. So friends, this was all about the remove element problem. I hope you must have liked this video. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss a lead code problem. Remove duplicates from sorted array. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So in this problem we are given with an integer array and the array is sorted in non-decreasing order. So as an input we are given with an integer array and the integer array is sorted in ascending order. Now as the array is sorted in ascending order, there may be duplicates. Now our task is to remove the duplicates and that too in place. So by in place we mean that we cannot use additional array or any other data structure. We have to modify the same array and we have to remove the duplicate such that each element appears only once. So for example, let's say we have this input array 1, 1, 2. So the array is sorted and here we have one duplicate which is 1. So we have to remove this duplicate such that only one occurrence of an element occurs, such that the element appears only once. So after removal of the duplicates, we get two numbers 1 and 2 and this 1 is removed. So our output is 2 and the array is modified like this 1, 2 and whatever elements are left over, those are ignored. And one more thing we need to keep in mind is the relative order of the elements should be kept the same. So we have to modify the input array in such a way that let's say we have 1, 1 and 2 So at the start there should be 1 and after that 2 should come. It should not be like this 2, 1 because we have to maintain the relative order of the elements. So let's say if we are taking the second example. Now if we remove the duplicates from this sorted array, so here we have 2, 0, so 1 is removed because the element should appear only once. After 0, if we see the relative order, the next number is 1 and we have 3 ones. So we have to remove this 2 ones and we need to keep only one occurrence of 1. And after that we have 2 2s, so we have to remove 1 2 and we have to keep only 1 2. Then we have 2 3s, so we have to remove 1 3 and at the end we have 4. So 4 is itself unique. So after the removal of duplicates, if we count the unique elements, so we get 1, 2, 3, 4 and 5 elements. So our output is 5 and we have to modify the array in place. So at the start 0 comes, then 1 comes, then 2, then 3 and then 4. So the relative order is maintained and the rest of the elements are just ignored. So let's move ahead and see how we can solve this problem. So suppose we are given with this array 0 0 1 1 1 2 2 3 3 4. Now our task is to remove the duplicates and keep only one occurrences of the element. So let's say our array is 0 0 1 1 1 2 2 3 3 4. So here first property is the array is sorted in ascending order. So it means whatever duplicates we have, they are very adjacent to each other. So second property is duplicates are adjacent to each other. Now how we will solve this problem is we will take two pointers I and j. So here j will traverse each and every element of this array. So therefore it's a fast pointer and I will move slowly. So it's a slow pointer. Now the purpose of j is to basically iterate the array and compare the duplicates. And the purpose of I is to actually remove the duplicates. So as soon as I removes the duplicates from this array, it will move slowly one step at a time and j will simply traverse the array once. So here both the pointers will start from first index I and j. So I start from first index because the 0th index already contains a unique element and the next unique element should come here. So I starts from here and its main purpose is to remove the duplicates. And after removal of duplicates, it simply moves ahead. Now similarly j starts from first index because it actually compares current element with previous element so that it can figure out that these two numbers are duplicates. So what it does is we simply compare value at jth index with value at j minus 1 index. So therefore we have to start from the first index. So as soon as j moves ahead, we simply compare the current element with its previous element to figure out whether they are duplicates or not. So at the start, value at jth index is 0 and j minus 1th index is also 0. So here 0 is equal to 0. Therefore this condition comes out to be false. So whenever this condition comes out to be false, we actually do nothing and we simply traverse j to its next index. So j will come to the second index. Now value at jth index is 1 and j minus 1th index is 0. So 1 is not equal to 0. So this condition comes out to be true. So whenever this condition comes out to be true, it means that we have found a unique element because the element just before that is different from this. So whenever this condition comes out to be true, it simply means that when we compared these two elements, they were not equal. So the current integer is actually a unique integer which we need to keep in the array. So what we do is when this condition comes out to be true, we simply assign value at jth index to value at ith index, because the purpose of I is to actually remove the duplicates, and we know that 0 is a duplicate here. So we simply assign value at jth index to value at ith index. So after this assignment, 1 comes here. After this assignment, we know that the next unique element should come here. So we simply traverse I ahead. So I comes here and j will move to the third index. So purpose of j is to simply traverse the array one element at a time and compare the current integer with its previous integer. So now value at jth index is 1 and value at j minus 1th index is also 1. So they are equal. So this condition comes out to be false, and we know that once this condition comes out to be false, we do nothing and we move simply j one step ahead. Because we didn't find any other unique element, so that we can replace it with ith index, we simply move j one step ahead. Now again value at jth index is 1 and value at j minus 1th index is also 1. So it means this condition comes out to be false and we do nothing, we simply traverse j one step ahead. Now here value at jth index is 2 and value at j minus 1th index is 1. So 2 is not equal to 1. So therefore this condition comes out to be true. So when this condition comes out to be true, we know that we have found a unique element which we need to keep in the array. And we know that we are using this ith pointer to simply put this value in the array. So once this condition comes out to be true, we perform this step. So value at jth index, we simply assign it to value at ith index. So this 2 comes here and this one which is duplicate gets removed. So 2 comes here. And after this assignment we do I++, because the next unique element will come here. So I comes here and j traverse ahead. Now value at jth index is 2 and value at j minus 1th index is also 2. So this condition comes out to be false. So therefore we do nothing and we simply traverse j ahead. Now here value at jth index is 3 and value at j minus 1th index is 2. So 3 is not equal to 2. It means we have found one more element which is unique and which we need to keep in the array. Once this condition comes out to be true, the correct place for this 3 is we simply assign the value at jth index to value at ith index. So this 3 comes here. So this one goes away and 3 comes here. And after this assignment we simply increment I, because the next unique element should come here. So I moves here and j moves here. Now the value at jth index is 3 and j minus 1th index is also 3. So therefore this condition comes out to be false. So we do nothing, we simply traverse j to the next index. J comes here. Now value at jth index is 4 and value at j minus 1th index is 3. So 4 is not equal to 3. So this condition comes out to be true. It means we have found one more unique element which we need to keep in the array. So we simply assign this value to nums of I. So this 4 will come here and this 1 will go away. And after this assignment we move I one step ahead and j also one step ahead. So now j is actually traversed till the end of the array and we know that we have removed all the duplicates till this point. And if we count the number of elements, we have 1, 2, 3, 4, 5. So our output would be 5. And here, as this is an array, so this is 0 index, first, second, third, fourth, and this is fifth. So we simply return the value which is stored in I, which is 5. And rest of the elements can be ignored. So this array can be ignored. Our task was to remove all the duplicates such that each element appears only once. So now let's move ahead and see the demonstration of this algorithm step by step. So friends, before we start, in case if you're new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So yeah, this is the code, and let's say we are given with this array which is sorted in ascending order, and our task is to remove the duplicates. Now as the array is sorted, the duplicates will be adjacent to each other. So when we call this method, the first thing we do is we create these two pointers I and j, where j is our fast pointer. It traverses the array from index 1 to index 7, and I will start from 1 because this 0 is already at its correct place and unique. So we don't touch the 0th index and we start from the first index. So we start j also from the index 1, and why we are starting from j equal to 1 is we simply compare the current and the previous element. So we start from index 1 and j will travel till nums.length. So nums.length is 8. So 1 is less than 8. So this condition comes out to be true and the for loop will execute. Now in the for loop what we do is we simply compare the two adjacent values, which is the value at jth index and the value at j minus 1th index, and we check whether they are duplicates or not. So currently value at j's index is 0 and j minus 1th index is also 0. So therefore this condition comes out to be false because both the values are equal. So when both the values are equal, it means we have found a duplicate and we do nothing. We simply increment j. J becomes 2. 2 is less than 8. So the for loop will execute. Value at j minus 1th index is 0 and value at jth index is 1. So 0 is not equal to 1. So this condition comes out to be true. It means we have found one unique element which we need to keep in the array. Because the adjacent elements are different, it means this value is the first integer which is unique. So we need to keep this value in the array. So the if block will execute, and we know that index I will actually help us in placing this value at its proper position. So we simply assign nums of j to nums of I. So 1 comes here. And we know that next unique element should come here. So we simply increment I. So I becomes 2. We increment j. So j becomes 3. 3 is less than 8. We compare these two values now. And 1 is not equal to 2. So therefore this condition comes out to be true. It means we have found one more element which is 2, which is unique in this array and which we need to actually keep in the array. So the condition in if block comes out to be true, and we assign this value to nums of I because I is actually holding that place where we can only insert a unique element. So via this assignment 2 comes here, and next unique element should come here. So we simply increment I. I becomes 3. We increment j. J becomes 4. 4 is less than 8. So this for loop will execute. So now we are comparing these two values. So condition in if block comes out to be false and we do nothing. We increment j. J becomes 5. 5 is less than 8. So the for loop will execute. And now we are comparing these two elements. So the condition in if block comes out to be false. We simply increment j. J becomes 6. And 6 is less than 8. So this for loop will execute. And now we are comparing these two elements. So 2 is not equal to 4. So this condition comes out to be true. And we have found one more element which is 4, which is unique and which we need to keep in the array. So the if block will execute. And how we will keep this value 4 in the arrays? We simply assign value at j's index to value at ith index. So this 4 will come here. And we know that the next unique element should come here. So we simply increment I becomes 4. We simply increment j becomes 7. 7 is less than 8. So this for loop will execute. Now we will compare these two elements. So here both the elements are equal. It means we haven't found any unique element. So the condition in if block comes out to be false. We increment j. So j becomes 8 and 8 is not less than 8. It means we have traversed all the elements of this array. So this for loop will terminate. And here you can see whatever the value I is holding, that will be our answer. So if we count the unique elements, we have 1, 2, 3, 4. And here we can see as the array starts from 0th index. So whatever the value I is holding, which is 4, will give the total number of elements which are unique in this array, which is 4. So we simply return 4 from this method. So that is our answer. And we have also modified the array in place. So friend, this was all about remove duplicates from sorted array. I hope you must have liked this video. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss a very famous interview problem, which is threesome problem. So in this problem we are given an array of distinct integers. Now our task is to print all such triplets such that they add up to a specific target, and the triplet should be ordered in ascending order. So let's say we are given an array of integers. Now these are actually distinct integers 2, 4, 3, 7, 1, 8, 9, 0. We need to print all such triplets such that they add up to a specific target. So we have been provided with the array and a target value. The triplet should be ordered in ascending order. So we need to find 3 numbers such a way that when we add them, we get a target of 6, and that too number should be in ascending order. So for example, 0 plus 2 plus 4 will give 6, and here 0, 2 and 4 are in ascending order. 1 plus 2 plus 3 will also give us 6. 1, 2, 3 are in ascending order. So we need to find all such triplets which sum up to a specific target and they are ordered in ascending order. So let's see the demonstration of this algorithm step by step. So here this is the algorithm where method name is threesome. We are given an array and a target. Let's say we are given with an array having 6 elements 2, 4, 3, 7, 1, 0 and a target, let's say 6. So when we call threesome method, we pass the array and the target as 6. So friends, basic idea behind this algorithm is, first we sort the array. Second, we use 3 pointers. So when we sort the array, we can print the triplets in ascending order. So that is one of the use case. And the second use case is, when we sort the array, we can use 3 pointers which can provide us 3 numbers which add up to a specific target, and that too with a optimized time complexity. So here the 3 pointers we use are I, J and K, which we will be seeing later here. So these 3 pointers will give us 3 different numbers from the array. We will take up their sum and print it on the console if sum is equal to target. So let's see the demonstration of this algorithm step by step. So in the first step we are actually sorting the array in ascending order. So 2, 4, 3, 7, 1, 0 will be sorted and it will become 0, 1, 2, 3, 4, 7. Moving ahead. Now as we discussed that we will be using 3 pointers.
I, j and k. So for I it will start from 0 and it will go to array.length -2. So we will see why we are taking -2 later. But it will start from 0 and it will go to index 3, which is array.length 6 - 2 4. So here less than means that it will go till 3. We will see later that why we are taking array.length -2. So currently I will start from 0. It means it will be pointing to the 0th index of the array. Now as we need to find the 3 numbers which are distinct, so the j pointer will start from I plus 1. So here whenever this for loop will start with any value of I, j will start from a value just ahead of it. So value of j will start from 1. And we will take the k pointer. We will start it from array.length -1. It means the third pointer will start from the last index, which is array.length 6 - 1, which is 5. So k will start from 5. We will see its significance that why we are starting it from array.length -1. Moving ahead. So friends, as we have now pointed I, j and k to 3 different indexes, we will try to find out the sum of these 3 numbers and then we will figure out whether they are equal to the target or not. So this for loop will actually help us in traversing I, and this while loop will help us in traversing j and k. So as we want to find the 3 distinct numbers, we have provided a while loop and the condition is j should be less than k. So here j and k will traverse through this array. J will traverse in this direction and k will traverse in this direction, covering up the elements. So this while loop will go till j is less than k, because if j will be equal to k, both j and k will point to the same number, which we don't want. So j should be less than k. In the first step, what we are doing is we are calculating the sum of array at ith index, at jth index and at the kth index, because we need to find out the triplets. So I, j and k will provide us that triplet. So when we do sum of 0, 1 and 7, we get 8. So sum will become 8. Now we simply check whether sum is actually equal to our target or not. So our target is 6 and sum we want is 8. So this condition comes out to be false. So here, as I is fixed at 0th index, we have sorted the array in ascending order. It means whatever value will come after 1 will be greater than 1 and whatever value will come before 7 will be lesser than 7, because the array is sorted. Now when we compared sum with target, we found out that sum is actually greater than target. Sum value is 8 and it is greater than target. So somehow we need to reduce the value of sum in the next iteration so that it matches the target. So what we do is we provide these 2 conditions. We check whether sum, if it is not equal to target, we check whether it is less than target or it is greater than target. So currently if sum is greater than target, it means we need to reduce the sum. So here array is sorted, I is fixed. The only option we have is to move j this direction or k this direction. If we move I this direction, in the next iteration when we will do sum, the sum will become 0 plus 2 plus 7, which will give us 9, which is actually more than the current sum and which we don't want. So let's say if we move k this direction, so k will come here, and if we do sum in the next iteration, we will get 0 plus 1 plus 4, which will be equal to 5, which is actually reducing the sum to get it more closer to 6. So here, as the array is sorted, when sum is greater than the target, we actually move k to this direction so that in the next iteration the sum will become closer to 6, which is our target. And if sum is less than target, then we move j to this direction, because that will only increase the sum and then it will match our target. So currently sum is greater than target, so this condition also comes out to be false. So the only option we have is, when sum is greater than target, we move k to this direction, because in the next iteration it will help us in minimizing this sum. So here the condition is, if sum is greater than target, move k left. If sum is less than target, move j to right. So currently sum is greater than target, so we will move k left. So k will become 4. We are simply moving it one position here. J is still less than k, so this condition comes out to be true. We will evaluate sum again. 0 plus 1 plus 4 will give sum as 5. So sum will become 5. We compare whether sum is equal to target or not. So sum is not equal to target, so this condition comes out to be false. And as the condition has come out to be false, we provide these two conditions. We check whether sum is less than target or sum is greater than target. If sum is less than target, then we move j to right, because if we move j to right, we will get a value higher than the current value of array at jth index. And when we will do sum in the next iteration, we will get 0 plus 2 plus 4, which will be equal to 6. So here, when we need to reduce the sum, we move k to this direction. When we need to increase the sum so that it matches the target, we move j to this direction. So currently sum is less than target. We need to increase the sum, so we do j plus plus. J becomes 2. So j comes here. J is less than k. Now we'll again evaluate the sum. So 0 plus 2 plus 4 will give sum as 6. So sum will become 6. So here you can see, when we provide this condition, that whether sum is equal to target or not, so this condition comes out to be true. It means we have found one of the triplet, which is 0, 2 and 4, whose sum is equal to the target. So we are simply printing the value at ith index, jth index and kth index on the console. So it will print 0, 2, 4, 0, 2, 4. And as I is fixed, j value is used up, k value is used up. So here what we do is, we increment j and we decrement k, because 0, 2, 4 is already being found. If we only increment j, it will come to this position. So 0 plus 3 plus 4 will never give us a sum of 6, because 0, 2, 4 has already given us the sum of 6. And as these are the distinct integers, here value cannot be 2. It can be only greater than 2. So therefore, if we increment j, we also decrement k, because we will never find any such pair. If it would have been duplicated values and here would have been 2, then we have incremented only j. So we would have found another triplet 0, 2 and 4. But here, as these are the distinct integers, Therefore, when we increment j, we will never find any such other triplet whose sum will be equal to target. So 0 plus 3 plus 4 will give us sum as 7. So therefore, to keep k at this position is also useless. So we decrement k also. So first we'll increment j becomes 3, and then we decrement k. Now here you can see j is actually equal to k. So therefore, this while loop will terminate because we need to find a triplet which is unique. So j and k cannot be pointing to the same number and bringing up the sum. So this while loop will terminate. So the call will reach here. Now we will simply increment I by one position by I plus plus. So I will become 1. Now we have seen all such pairs which can form a triplet with the value as 0, and we have used up index 0. So when we will start I from 1, we will not go behind the value of I because that we have already seen. So the new j value will be I plus 1, which is 2, and k we will take as array.length minus 1, which is the last index. J is less than k. We will take sum of these three values, value at ith index, jth index and kth index. We will do their sum. So 1 plus 2 will give 3, 3 plus 7 will give 10. So sum will become 10. It is not equal to target. Sum is not less than target, so this condition also will come out to be false. Sum is greater than target. An array is sorted, so if we move k to left, we will get a smaller number, so that in the next iteration, this sum will be reduced and can match to the target, because currently sum is greater than target. We need to reduce this sum. Currently the value is 7, which is being used up in forming the sum. If we shift k this side, we will get a lesser value. So in the next iteration, our sum will be more closer to target. So therefore we are decrementing k. So k becomes 4. J is less than k. We again do the sum. So 1 plus 2 will give 3. 3 plus 4 will give 7. So sum will become 7. So here you can see why we moved k to this direction is, in this iteration, we actually reduced the sum from 10 to 7. Sum is still not equal to target. Sum is not less than target. So we need to reduce sum further down. So we simply do k minus minus. So k will become 3. J is less than k. J value is 2 and k value is 3. So j is less than k. Now we will do sum of these three values, 1 plus 2 plus 3, which will give us sum as 6. So sum is equal to target. It means we have found one more triplet. So we will print it on the console. 1, 2, 3. 1, 2, 3. And then we simply increment j and decrement k. So j will become 3 and k will become 2, like this. Now this while loop will terminate because j is actually greater than k. We will increment I again. I will become 2. We have used up these elements. So our jth pointer will become I plus 1, which will start from third index, and k will start from the last index. J is less than k. we will take the sum of these three indices at their respective array positions. 2 plus 3 plus 7 will give sum as 12. Sum is not equal to target. Sum is not less than target. It is actually greater than target. So we need to reduce the sum. And when we reduce the sum, we simply decrement k. K will become 4. J is less than k. The new sum will be 2 plus 3, 5 plus 4 will give 9. So sum is reduced, but still it is greater than target. So sum is not equal to target. Sum is not less than target. It is actually greater than target. So we again decrement k. So k will become 3. So here you can see j and k are now pointing to the third index. So therefore this while loop will terminate because j is actually equal to k. Because we need to find triplets which are unique. So all these pointers should point to a different values of the array. We will increment I. I becomes 3. We have used this position. So here you can see if we calculate array dot length, we will get 6. If we do -2, we will get 4. So I is still less than 4 because it is pointing to third index. And here you can see that why we have provided this condition is because we need to give space for the other two pointers as well. One can occupy this position, other can occupy this position. If I would have traveled all the way across the array, say for example, if I would have reached here, so j would have started from here and k would have also started from here, which we don't want because we want j should be less than k. So at least we need to give space for two elements. So therefore we are taking it as I should be less than array.length -2. We are doing -2 because one slot will be taken by j and other slot can be taken up by k properly. So this condition is still true that I is less than array.length -2. So j will start from fourth index, k will start from the last index, j is less than k. We will do the sum. 3 plus 4 plus 7 will give 14. Sum is not equal to target. Sum is not less than target. If we want to reduce the sum, we have to decrement k to reach here. So k will become 4. And as we have decremented k, j and k are pointing to the same index. So therefore this while loop will terminate. And again when we will increment I will become 4. So 4 is not less than array.length -2. 6 minus 2 is array.length -2, which is 4. 4 is not less than 4. So therefore this for loop will terminate. And once this for loop will terminate, our method will also get terminated. And whatever we have got as a triplet, we have printed on the console, which is 0, 2, 4, 1, 2, 3, which are the three numbers which add up to a target of 6 and they are in ascending order. So friends, this was all about the three-sum problem where we use the technique of sorting and three pointers to figure out which are those triplets which add up to a target. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss a problem, product of array except self. So let's see what this problem is and how to solve this. So in this problem we are given an array of integers. We need to return an array result such that value at index I is actually equal to the product of all elements of array except the element at index I. So in the result array, let's say at any index I, we need to store the product of all the elements of the given array, leaving the element at that respective index. So when we are doing the product, the values are given in such a way that product fits in the 32-bit integer. One constraint is the algorithm should run in O of n time and without using the division operator. So let's understand the problem with an example. Let's say we are given an array having 4 elements 1, 2, 3, 4. Now in the result array, we need to store the product of all the elements of array in such a way that, let's say if we are on index 1. So this is 0 index, this is 1, this is 2 and this is 3. So let's say at index 1 we have value 2. So in the result array, we need to store at index 1 product of all the numbers in this array excluding 2. So for example, at index 0 we have 1. So we can directly do the product of rest of the elements. 2 into 3, 6. 6 into 4 is 24. So we can directly place 24 here. We haven't included 1 into the product. Now for index 1, at index 1, we are storing the product of rest of the elements excluding 2. So 1 into 3 is 3, 3 into 4 is 12. So we are storing 12 here. For index 2, we will exclude 3. We will take the product of rest of the elements, which is 4 into 2, 8, 8 into 1, 8. So we are storing 8 here. For the last index, we will exclude 4 and we will take the product of rest of the elements. 1 into 2 is 2, 2 into 3 is 6. So we are storing 6 here. So in this problem, in the result array, at any particular index, let's say this index, we are storing the product of rest of the elements excluding the element at that particular index. So friends, we don't have to use the division operator, or else the problem would have been very simple. We could have multiplied all the numbers. So for example, if we take the product of all the numbers, we will get 24. Now let's say if we want to fill for the index 1 excluding 2, so we would have directly divided it by 2. It would have given 12 and we would have placed 12 here. So we don't have to use the division operator. And secondly, we need to solve this problem in O of n time. So here you can see if we use 2 for loops, the nested for loops, the time complexity will be O of n square. So the first for loop will traverse the element one by one and the inner for loop will travel rest of the elements, take their product and store it at the respective index of the outer for loop iterator. So the time complexity would have been O of n square. So we need to solve this problem in O of n time. So now let's see the algorithm and the demonstration of that algorithm step by step. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Now here we will call find product method. We will pass this array having 4 elements 1, 2, 3, 4. So friends, how we will solve this problem in O of n time is, we will traverse this array 2 times, one in this direction and other in this direction, and let's say this is our result array. So when we will traverse in this direction, let's say if we take the example of index 2, this element. Now at this index, we need to exclude 3 and store the product of rest of the elements. But here you can see at index 2, we are doing the product of these 2 elements, which is on the left side, and all the elements on the right side, and excluding 3. So when we will traverse the array from the left side, in the result array we will store the product of the left part of the array, and when we will traverse from the right side, we will include the elements of the right part of this index. So when we will traverse from the left, we will do the product of the left part, store it here, and when we will traverse from the right side, we will take this value, whatever value is stored here, we will do their product and we will place it here. So in the left part, we are doing 1 into 2, we will place 2 here, and when we are traveling from the right, we will take the value 4 multiplied with 2 and store 8 here. So this we will do for all the elements at the respective indexes, and finally we will get the result array. So first we are traveling from the left direction. So at the start we are creating a temporary variable, assigning it a value of 1. We will see its significance later. So temp is equal to 1. We will create the result array. Like this. And as total length of array is 4, we will initialize the result array with array.length, which is 4. Now we will start the for loop from index 0 and go till the end of the array. So at the start I will be equal to 0, which is pointing to the 0 index. Now as we discussed, when we are traveling in left direction, we will store the product of the left side elements. So currently for index 0 there are no elements in the left side, and here we have created a temporary variable, assigned it a value 1. So we will directly store 1 here, which is the value stored in temp, because there are no elements in the left part of index 0, and we also know that anything multiplied by 1 will give the same result. So therefore we are initializing temp with 1. So here we will get value as 1. Moving ahead. Now for the next index, let's say for 2, we need to take the product of the left part. So here as we are assigning temp directly to the result at a particular index, here what we are doing is we are taking the product of temp with the previous value, and then we are storing it in the result array. So for the next iteration, we have to take product of the left part. Currently here we have only one element, which is 1. So we are multiplying temp with the value stored at index I, which is index 0. So temp becomes 1, because 1 into 1 gives 1. You will understand more about this step when we move ahead. So now we'll increment I becomes 1. Now as temp is storing the product of the previous elements, we will directly take the value of temp and store it in the result array at ith index. So 1 will be stored here, because value of temp is 1. So friends, the next iteration I will reach here. So for index 2, we need the product of left side. We need product of 1 and 2. So temp already has product of this part. Here we will multiply it with array of I, which is we will multiply it with 2, and we will get the product of these 2 elements. And that product we can safely store here, because when we are traversing from the left side, for this particular index, we will only store the product of these 2 elements. And currently, as we have already stored the value of temp into result I, which is 1 here, If we multiply temp with current element, we will get the overall product of these two elements. So the new value of temp will be 2 into 1, which will give us 2. We will increment I becomes 2. And we know that temp already has the product of its two previous values, which is 1 into 2. So we will first directly store 1 into 2, which is 2, at index 2 of the result array. So this step does that. So 2 comes here. Now when we will move to the next element, we need to include 3 also in the product. Because for index 3, which is this index, we need to take the product of these 3 elements. We already know the product of these 2 elements, which is stored in the temp. If we multiply it with 3, which is the current element at index I, we will get the product of 3 elements previous to third index. So therefore we are multiplying temp with the current index value of array, which is 3 here. So 3 into 2 will give 6. So temp becomes 6, which makes sense because 1 into 2 into 3 will give 6, which we can use directly in the next iteration. So we will increment I becomes 3. So in the result array at third index, we will first directly store the value of temp, which is 6. So here you can see for third index, the product of its previous values is 6. 1 into 2 into 3 is 6, and we are storing 6 here. And as we are traveling from the left side, we are only looking in the elements which are on the left part of the particular index. So as there are no more elements left, this product makes no sense. So temp into array of I, 4 into 6 will give 24. So temp will become 24, but it is of no use because there are no elements going further. So we'll increment I will become 4, and this for loop will terminate because 4 is not less than array.length, which is 4. So when we had traversed from the left side in this direction, we stored the product of the left part. So now we'll again initialize temp with 1. So temp becomes 1. And now we will traverse from the right side. So here I is starting from array.length, which is 4, minus 1, which will give us 3. Which means we are starting from the third index. And this loop will go till I is greater than or equal to 0. So friends, we also discussed that let's say if we want to fill for index 2, we need product of these two elements, and whatever the product will come, which is 2 here, we will multiply it with the right side elements, which is 4 here. So 2 into 4 will give 8, and we will store 8 here. So in the result array, we are already having the product of the left part of each index. Now we simply need to take the value of the right part, do their product, and whichever value is stored here, we simply need to multiply it with that value. So now that thing we will do when we are traversing from the right side. So at the result array at ith index, so currently we are at the third index. Whatever value is stored is actually stored of the product of its previous numbers. And as index 3 has no elements to its right, we will simply multiply whatever value is stored here into temp, which is 1, and store it back into the result array. So for index 3, at result of I, we will take 6, which is this value. We will multiply it with temp, which is 1, which will give us 6, and we will assign 6 back to index 3 at the result array. So it will remain 6. So here we are doing the same steps. For index 2, we need product of its elements which are on its right side. So temp value is 1. We will multiply it with 4 and we will get the product of its right side elements. So temp becomes 4. We will decrement I. So I will come at index 2. Now at this index, you will understand the algorithm more. What we are trying to achieve is, in the result array, for index 2, we need to store the product of the elements excluding index 2, which is 3. So 1 into 2, which is on the left part, excluding 3 and taking in remaining element which is on the right part. So 1 into 2 will give 2, 2 into 4 which will give us 8. So we need to store 8 here. Now in the result array we are already having the product of the left part which is 2 here. We need to simply multiply this 2 with the product of its right part. So currently it's 4 which is stored in the temp. So result of I, which is 2, multiplied by 4 which is temp. So value stored at result of I multiplied by temp will give the actual product of all the elements excluding this index, because temp is already having product of its numbers on the right side. So 2 into 4 will give 8 and we will assign 8 back to the result array at index I. So 8 will come here. Now we will multiply 3 with temp, which will give us 12, and we'll assign 12 to temp. So why we are doing it? Because in the next iteration, so when we will decrement I will come to index 1. Now for this index, we already have the product of its left element here in the result array. We need the product of its right part. Previous value of temp was 4 and we multiplied it with 3, which gave us value as 12. So temp is currently having value 12, which is the product of all the elements on the right side. So for filling the value of index 1, we need product of the left side, which is 1, which we already calculated. We will exclude this element and we need the product of the right side, which is already stored in the temp. So value at result array, the ith index, which is 1, will give product of the left part. Temp will give product of the right part. When we will multiply them, we will get 1 into 12, which is 12. So 1 into 12, which is temp, will give 12. So 12 will come here. And for the 0th index, we need product of the right part. So temp already has product of 3 and 4, which is 12. We will multiply it with the 2, which is the array element at index I. So temp will become 24. We will decrement I. So I will come at index 0. Now at index 0, we need to simply put the product of all the elements on the right side, their product with product of the elements on the left side. So left side doesn't have any value because we have value as 1 here. We will take value 1, multiply it with value of temp, which is 24, and we will assign it back to the result array. So here it will come 24. And then we will evaluate temp again, which actually is of no use because we have already filled all the positions here. So the new value of temp will be temp, which is 24, into array of I, which is 1, which will give 24. So now we'll decrement I, and this for loop will terminate because value of I will become -1, and -1 is not greater than or equal to 0. So this for loop will terminate, and at the end we will simply return the resultant array. So friends, the basic idea behind solving this problem is we need to do two traversal. One is from the left side and one is from the right side. When we are traversing from the left side, we will only see the elements which are on the left part of any particular index. We will do their product and we will store that value in the result array, and that will be done from the left part. Now when we are traversing from the right part, let's say for index 2, when we had completed from the left part, we had product of these two elements. So in the result array, the value would have been 2 because 1 into 2 will give 2. When we are traversing from the right side, we need product of the right part. So currently, as there is only one element, which is 4, we will take 4 multiplied with 2, which will give us 8, and we will store 8 back here. And this we will do for all the elements. So it's very simple. For any index I, this is left part, this is right part. We are excluding the current element, left into right, and whatever we get value, we'll store back it here in the result array. So we are excluding this part, we are taking left part, we are taking right part product, we are doing their product and storing back at the respective index. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss sliding window maximum problem. So let's move ahead and see what this problem is and how to solve this. So in this problem we are given an array of integers and we are given a sliding window of size k. So it means we are given with this array and a value k, which is the size of sliding window. Now this sliding window is moving from very left of the array to very right. So this sliding window is starting from 0th index, having a size of 3, and it is moving from left to right. And as it is moving from left to right, we can only see that many numbers. So at the start we can see only 44, 77, 33. So it means we can only see k numbers of the array at a time. And this sliding window is moving into this direction by 1 position. So first we will see 44, 77, 33. Then we will see 77, 33, 44. Then we will see 33, 44, 88. And at the last we will see 44, 88 and 11. So for this array with the sliding window of size 3, what we need to find is for every window which we saw. So we need to find max among these 3, and then sliding window will move ahead. So then it will see these 3 elements, and then we have to find the maximum among these 3. So which is 77 again. So similarly till the end we need to find the maximum in the sliding window. So this is the output for this array having the sliding window of size 3. Now how this output came? Here you can see in the first sliding window 44, 77, 33. The max value among these 3 elements is 77. So for this sliding window the max is 77. Then this sliding window will move ahead. So 44 will go out and this 44 will come in. So now among these 3 elements 77, 33, 44, 77 is max. So in this sliding window the max would be 77. Similarly sliding window will move ahead. Now we have 33, 44 and 88. So among these 3 elements 88 is max. And at the end the sliding window will reach to the end of the array. So among these three elements 44, 88 and 11, the max is 88. Now let's move on and see that how we can solve this problem. Suppose friends, we are given with this array and we need to find the max in the sliding window. So here, in order to solve this problem, there are various solutions. So one such solution is to find the next greater element of each and every element in this array. So the problem of next greater element we already discussed in one of our previous video. You can watch that video to understand more about this algorithm. In this video, I will be demonstrating the next greater element problem as well. So here actually what we do is, for each and every element you see here, we find its first next greater element towards the right. So if you see for 44, if we look in this side, we just see the first next greater element to 44. So currently 77 is greater than 44, so it becomes the first next greater element of 44, like this. Then we look at 77. If we look in this direction, 33 is less than 77, 44 is less than 77, 88 is greater than 77, and it is first next greater element towards right of 77. So here 88 becomes the first next greater element to 77. Similarly for 33, if we look in this direction, 44 and 88 both are greater than 33, but the first next greater is 44. So the answer will be 44. For 44 it will be 88. For 88, here we have only 11. So therefore there is no element in the right of 88 which is greater than 88. So in our previous video we discussed that we simply return -1 because there are no elements greater than 88 towards its right. And similarly with 11, as it is the last element, there are no elements after that. So for 11 also our answer becomes -1. So in that video, this was our output and our answer. So we will use the same algorithm here, but there will be a slight difference. So here you can see below I have written the next greater element of each and every value of this array. So in our previous video, in the next greater element array, we actually returned this as our output. But now instead of this as our output, first we will evaluate the indexes of these elements and we actually store the indexes in the next greater element array. So for example, for 77, if you see, has index 1. So instead of storing 77, we will store 1, like this. So these are the indexes of this next greater elements. So for example, for 77, our answer was 88. So if you see, 88 is at index 4. So we are storing 4 here. I'll remove this. Here if you see, for 33, its next greater is 44, which lies at index 3. So we are storing index 3. For 44, the next greater is 88, which lies at index 4. So we are storing 4 here. And for 88, there is no greater element towards its right. So therefore, as we are storing indexes here if you see, the last index is 5th index. So we are storing a greater value to 5, which signifies that we have gone out of the boundaries of this array. So we are simply storing 6. So this 6 is nothing but array.length, which signifies that for 88 there was no greater element towards its right, and for 11 as well. So we are storing 6, 6, and the value we are taking as -1 and -1. Here we need to store an index which is out of the boundaries of this array so that we can justify that for 88 there is no greater element towards its right, and for 11 there is no greater element towards its right. So we are storing the index as array.length. So here you can see if we are on at index 0, for example, we see there is a value 44. Now if we go to the index 0 of next greater element array, we see there is a value 1. This value is only for demo purposes I have written here, but actually we will be playing with this value and this value. So at 0th index we have 44 and we need to find its next greater element. So what we do is we simply go to this array, we see there is a value 1 and we know that this is actually an index. So what we do is we simply go to the original array at index 1 and whatever value here it is, we simply say that this value 77 is next greater to 44. So it goes like this. From here first we go here and then we go here to find the next greater. Now similarly, if you want to find that what's the next greater to 33, we simply go to index 2. We see there is a value 3. So we go back to index 3 and we find 44. And we know that 44 is next greater to 33. So friends, our problem is to find the maximum in the sliding window. So how this next greater element array is helping us in finding that is, let's say for example, this is our sliding window. Here we have taken k as 3 and let's say after evaluating the maximum of the sliding window reached here. And now let's say we want to find the max among these 3 elements. And we actually know that it is 88. So here what we do is, the step 1 is, from where our sliding window is starting, we take that element. So currently it is 33. We take 33 and assume that it is the max in this sliding window. And here you can see it is at index 2. But we know that 33 is not the max in this sliding window. So what we do is, this is our assumption. In the second step what we do is, we simply go to the next greater element array at index 2 and we see there is an index 3. Which means that if we go to index 3, we will find an element which is greater than 33. So here what we do is, if you see, the window is starting from index 2 and the value of k we are taking as 3 for example. So we know that this window will go till 2 plus 3 minus 1, which is till 4th index, this index. So we are taking 3 elements because value of k is 3 from index 2 to 4. So starting is 2, this is our k, and if we do minus 1 we'll reach the last index. So when we find 3 here, we first check whether this index is in the range of the sliding window or not. So here you can see 3 actually lies in the range of sliding window. So this point suggests that there is an element greater than 33 and it lies in this sliding window, which is 44. So therefore this 33, which was our assumption, is wrong. And now what we do is, we simply go to this element 44 and assume that now it is our maximum. So we reach here at the 44, but still we are not sure that 44 is max or not. So what we do is, we simply go to the index 3, which is of 44, in the next greater element array. Here we find a value as 4, which is the index 4. And we also see that 4 is actually in the boundaries of the sliding window, which suggests that at index 4 there is a next greater element to 44 and this element is also in the range of the sliding window. So our assumption that 44 was max is also wrong. So now what we do is, we simply now go to 88 here and we assume that now 88 is our max. But now what we do is, we simply go to the index 4 here and we see we have value as 6. And then what we do is, we take this 6 and before going to the 6th index, which is out of this array, what we first check is whether this 6 is in the boundaries of this sliding window or not. So the maximum range of the sliding window is 4 and we know that the next greater element to 88 is at index 6, which is out of the boundaries of the sliding window. It means let's set index 6 here, we have one element 100, like this. So here for 88 we know that if we go to the index 6 we will find 100. But this 100 is not lying in this sliding window and we need to find the maximum in the sliding window. So we know that for 88 its next greater is 100, but it is lying at index 6. It is not in this sliding window. So it means we are 100% sure that 88 is max in this sliding window. So therefore we use this algorithm and we can come to know that 88 is max in this sliding window. So this approach we do for every sliding window. like this. And what we do is we take the first element, we assume it's the max in this sliding window. But to confirm that, we take this index, we go to the next greater array at index 2, we pick the index of the next greater to 33, which is this index, and the element is 44. And as the index is 3, we check whether this index 3 is actually in the range of the sliding window. Here it is from 2 to 4, and 3 actually lies between 2 to 4. So therefore, we know that 33 cannot be our max in this sliding window, because there is one more element in this sliding window which is greater than 33, which is 44. And similarly with 44, we found that its next greater is 88, and this 88 is also lying in this sliding window range. So then we came to 88, and for 88 we found that its next greater is at index 6. Here index 6 is out of the range of this array. But let's suppose even if the index had any value, let's say 100. But we know that we have to find the max in this sliding window, and the next greater to 88 is 100, which is out of this window. So therefore our answer would be 88 for this window. So friends, here is the importance that why we are actually storing the indexes instead of actual values. Because this window of size k is actually dealing with the indexes, and we need to find the index of the element's next greater. So therefore, instead of storing the actual values in this array, which we also saw in the previous video, we are actually storing the indexes now. The algorithm is very much similar, but the only difference is instead of these numbers of next greater, we are actually storing their indexes. So let's move ahead and see the demonstration of the algorithm step by step. So friends, before we start, in case if you want to master algorithms and data structures, you can subscribe to my channel and click the bell icon so that you never miss any update. So here we will call the max sliding window method by passing in the array. So this is our array, and the sliding window size is 3. So value of k is 3. So here the return type of this method is list, because we need to return the max of sliding windows among this array, which we will store and we will return. So here at step 1, what we are doing is we are simply calling next greater element method. We are passing in the array. So this algorithm we have already discussed in our previous video. I will also demonstrate one more time, because the only difference is we are storing the indexes in this array, not the actual values. So when this method will be called, this is our array. So at step 1 we will create the result array. Now this result array will store the next greater elements. So now as we need to find the next greater elements of this array, what we do is we take the help of stack. So first we create a stack. So stack is LIFO data structure, which means the element inserted last will be the first to be removed. So we will use this property and we will figure out the next greater element of all these elements. So now we will provide a for loop where this I will start from the last index, which is array.length -1, and I will go till it is equal to 0. It means it will travel in this direction and it will reach till index 0, and I will help us in placing the next greater element of each and every index. So we are starting from the last index because it will make our job easy to find the next greater element towards right. So first we are actually finding the next greater element of 11. So as 11 is the last index and we know that there is no next greater element to 11. So here we are providing this if block. We will discuss this later, which says that we first check whether stack is empty or not. So currently stack is empty. It means this condition comes out to be false. And actually this stack will hold the next greater elements in the stack for the remaining array. So as 11 is the last element, we know that stack must be empty because there are no greater elements towards its right. So we first check whether stack is empty or not. So if stack is empty, we simply put array.length into the result of I. Why we are putting array.length is because array.length is 6 and 6 suggests an index which is not in this array, which also suggests that for 11 there is no next greater elements towards its right. And we will also see that how this index will help us in later in the algorithm when we will find the max in the sliding window. So after the if else block, now this 11 can be a next greater element for the remaining array. So for example, instead of 88, let's say if the value would have been 9. So for 9, 11 would be the next greater element because 9 is less than 11 and 11 is the only element towards its right which is greater than 9. So therefore we will push index 5. It means we are pushing 11 on the stack like this. So I will also write the values beside the index. We are actually storing the index in the stack because we need to get a result in the form of indexes, and you can assume that we are actually storing the values like 11. Moving ahead, we will decrement I. Now stack is not empty. So the first thing we do is we provide a while loop. Now inside this while loop, what we are doing, we are first checking whether stack is empty or not. So stack is not empty. So this much condition is true. This condition is very important. Here what we are doing is, we are first taking stack.peak value. So if you see, stack.peak is 5. And if I do array of 5, and then I do whether it is less than equal to array of 4. It means we are comparing whether 11 is less than equal to 88 or not. So this condition comes out to be true. So the while loop will execute, and what it will do is, this 88 will simply pop 11 out of the stack because we had placed 11 in the stack thinking that there could be a lesser value here for which 11 could become the next greater element. But as soon as we figured 88, this 88 will discard this 11 because for the remaining array, even if we have any value here, its next greater element will reach till 88 and it won't go beyond because 88 is already greater than 11 and 11 cannot be the next greater element of any of the element in the remaining array. Let's say if we had 9 here for example. So for 9 also the next greater would become 88. Let's say if we had 10 here. So for 10 also it would be 88. And let's say if we had 11. So for 11 also it would be 88. But there would be no such value here for which 11 can become the next greater element because we have found one element which is already greater than 11. So therefore the job of a greater value here is to remove the smaller values out of the stack because now they won't contribute in the next greater element. So first we pop 5 out of the stack. So now stack becomes empty. So this while loop will terminate. We check whether stack is empty or not, and we know that if stack is empty, it means for this value 88, we didn't find any element which is greater than 88 because stack is empty. 88 will pop out the smaller elements and will stop till there are elements which are greater than 88. And those elements will lie for sure in the stack. But if stack is empty after this while loop, then for 88 there is no greater element towards its right. So we simply put array.length which we had placed for 11, which suggests that for 88 also there are no greater element towards its right. Moving ahead. So now 88 can become the next greater element for remaining array till here. So we'll push the index of 88 here, which is 4, which corresponds to 88. We'll decrement I. I comes at index 3. And now we are figuring out the next greater element to 44. Stack is not empty. So this condition comes out to be true. In the while loop, stack is not empty and first we will take the stack.peak which is 4. So array of 4, we will compare whether it is less than equal to array of I which is 3. So here we are simply comparing whether 88 is less than equal to 44 or not. So this condition comes out to be false, which suggests that 44 cannot pop 88 out of the stack because 44 is less than 88, and we can't pop 88 out of the stack because 88 can become the next greater element of the remaining array. So here, for example, for 77, its next greater is 88 only. So therefore, if a value is smaller, it cannot pop this element out of the stack, and if value is greater, it can pop the element out of the stack. So this condition we need to keep in mind. So 44 cannot pop this element out of the stack because this condition came out to be false. And now we simply check whether stack is empty or not. So stack is not empty. So the else part will be executed. As stack is not empty, which suggests that there would be some element in the stack which is greater than 44, because 44 could not pop that element out of the stack, and that element will be for sure greater than 44. So at the result of I, we store stack.peak, which is the index, or indirectly we are storing 88. So we are storing index here 4, and then we will put value of I, which is 3, on the stack like this, because this 44 can become the next greater element for the remaining array. So for example, for 33, 88 is also next greater element, 44 is also next greater element, but 44 is the first next greater element to 33. Therefore, we can't discard 44, we have to put it on the stack like this. We'll decrement I comes to index 2, stack is not empty. In the while loop, stack is not empty, and if we do stack.peak, we will get 3. So array of 3, we are checking whether it is less than equal to array of I, which is 2. So we are simply checking whether 44 is less than equal to 33 or not. So this condition comes out to be false, which makes sense because 33 cannot pop 44 out of the stack because 44 is next greater to 33, and which is at the peak of the stack. So therefore this while loop will terminate. Stack is not empty, so this condition comes out to be false. In the else part, whatever is at the peak, that will become the next greater to 33. So here we are storing stack.peak, which is 3, which suggests that we are storing a value 3, which is the third index value, which is 44. This. And then we will push 2 on the stack like this. So let's say if we had 11 here. So for 11, 33 would have become the next greater element. So therefore we can't discard 33. We have to push it on the stack. So 2 comes here, which is the index of 33. We'll decrement I. Stack is not empty. So friend, now here one critical step comes. Stack is not empty. In the while loop, we are checking array of 2, whether it is less than array of 1 or not. So we are checking whether 33 is less than 77 or not, which is true. And we have already discussed here that if we find any value which is greater than the peak value of the stack, this value will simply pop the element out of the stack. Because if we see the remaining elements in this direction, let's say if we had more elements here, 33 cannot become the next greater element for the remaining array, because for the remaining array 77 can become the probable next greater element, but 33 cannot, because 33 is less than 77 and we need to find the next greater element. So let's say if we had 2 here, or let's say 33 here, so for 33 also the next greater would become 77, and for no value here 33 can become the next greater, because so for example if we had 87, so for 87 the next greater, if it is not 77 then it will be 88, but we are 100% sure it won't be 33 because 33 is already lesser than 77. So therefore this condition comes out to be true, and 77 will pop 33 out of the stack, because now we can safely discard this value. It will play no role in finding the next greater element. 2 is popped out of the stack. Stack is still not empty. And here if you see this condition, we are checking array and passing stack.peak, which is 3. We are checking whether it is less than array of 1 or not. It means we are now checking 44 is less than 77 or not. So this condition comes out to be true. It means 77 has rights to pop 44 also out of the stack, because 44 also will not be contributing in the next greater element, because we have found already one value which is greater than 33 and 44. So first we have popped out 33. Now we are popping out 44, which is at index 3. So 3 will be popped out like this. Stack is still not empty. So now here array of stack.peak, which is 4. We are checking whether it is less than array of I. So we are simply checking whether 88 is less than 77 or not. So this condition comes out to be false, because 77 cannot pop 88 out of the stack, because 88 can become a probable next greater for the remaining elements in the array. And in fact for 77, 88 is the next greater element. So therefore 77 will not be able to pop 88 out of the stack. So this while loop will terminate, because this condition comes out to be false. Stack is not empty. So in the result array, we are simply putting stack.peak. So if stack.peak is not empty, and whatever is at the top will become the next greater element for the current value, which is 77. So we are storing 4 here, which suggests that if you go to index 4, you will find 88, which is the next greater to 77. And similarly we will push 1 on the stack, which is we are pushing 77 on the stack. Like this. We'll decrement I comes to 0th index. Stack is not empty. This condition also comes out to be false, because 44 cannot pop 77 out of the stack, because it is lesser than 77. So this while loop will terminate. Stack is not empty. So for 44, the next greater element would be whatever the element is on the peak of the stack, which is index 1 value 77. So we put stack.peak at the result array at ith index like this, and we push 0 on the stack. And if we decrement I, it goes beyond the boundaries of this array. So therefore this for loop will terminate, because I should be greater than or equal to 0. So then we will simply return the result, which is actually storing the indexes of next greater elements. So this NGE array will have the indexes, and I have just written the values for these indexes below that. So 44 is at 0th index. If we go to 0th index of next greater element array, you will find 1, which is the index. So if we go to index 1, you will find 77. So I have written 77 directly here, so that you can just relate that at 4 we have 88 like this. At 3 we have 44 like this. So now as we need to collect the max in sliding window, we create a list by name result like this. So this is a list of integers. And here you can see that now we will start the for loop from I equal to 0 from here. And this for loop will go till array.length minus k. Why it is going till it is less than equal to array.length minus k is, if you see array.length, which is 6, if we do minus k, which is 3 in our case, so it will give 3. So it suggests that I will go till index 3, because now in this for loop we are actually calculating the max in the sliding window, and the last window will start from when I will be equal to 3, because the value of k is 3. So this window will go till this index from 3 to 5, and beyond that this condition will come out to be false, and we will break from this for loop. So I will travel till index 3, because the last window will be this window,
which will actually cover the last window, which is the last 3 elements of this array, and beyond that we don't have to go. So I will travel till it is equal to 3. So when I is equal to 0, we are looking at the first window, which will be from 0 to k minus 1, which is 0 plus 3 minus 1, which is 2. So it will grow from 0 to 2. So this is the first window of size 3. And now our target is to find the max in this window with the help of this next greater element array. So as we have already discussed, what we do is, in the first step, the element which is the beginning of this window, we assume that it is the max in the sliding window. So we are creating an integer value j, which is our assumption that it always starts from the first element of this window. So we are assuming 44 is max in this sliding window, which is being denoted by j. So j is also pointing to 0th index like this, because value of I is starting of this window from 0. So j is also starting from 0th index. And now, as we discussed, that we need to confirm this assumption. So what we do is, we are providing this while loop, and the condition in this while loop is, for 44, which is at index 0, we simply go to this index, we see there is 1. So we take this 1 out, and then we are checking whether this lie in the range of this sliding window or not. So here if you see, if I do I plus k, 0 plus 3, so this value will give 3, 1 is less than 3. So it suggests that for 44, which is at index 0, if we go to the next greater element array at index 0, we are finding a value 1, which suggests that for 44, its next greater element lies at index 1, which is value 77. And this 77 is actually, if you see, it is in the range of our sliding window. It means our assumption that 44 is max in this sliding window is false, because the next greater element to 44 is 77, and this 77 is also in this sliding window. So therefore now j will simply travel to index 1, because now our next assumption is 77 is the max in this sliding window. So here we are doing that thing only. 1 is less than 3, so this condition comes out to be true. It means the next greater element for j, which is 44, is 77, which is at index 1, and this 1 is lying in this sliding window. So j will simply travel to that index, which is the next greater element array of j, which is 1. So it means j will directly shift to 1, suggesting that now our assumption is 77 is max in this sliding window. So after this assignment, j comes here, and our assumption that 44 is max in this sliding window comes out to be false. And now our new assumption is 77 is max in this sliding window. But as this is a while loop, we have to confirm that. So now we are again checking that next greater element array of j, which is 1, which is 77, which is our assumption. We are going to this index. We are finding a value 4. So now what we are doing, this is giving us a value 4. So we are checking whether 4 is in this sliding window range or not. And how we can figure out whether 4 lies in this sliding window is, we know that sliding window starts from I. So if we do 0 plus 3, it will give 3, and we have to do less than that, so it will go till second index, which is the first 3 elements from 0 to 2. But here 4, which we evaluated from this part, that 77, if we go to this index, next greater element array of j is 4. So this 4 is, we are checking whether it is less than 3 or not. So this condition comes out to be false, which actually proves that 77 is max in this sliding window, because the next greater element to 77 is 88, which is at index 4, which is actually beyond the boundaries of this window, which proves that whatever element comes after the 77 in the sliding window will be lesser than 77. So therefore now this while loop will terminate, because this condition comes out to be false,
and we have found the first max in the sliding window, where window is starting from 0 and going till index 2. So in the result, we have to store 77, and 77 lies at array of j. So here you can see our assumption was correct here. So 77 becomes our first max in the sliding window. Moving ahead, now we'll increment I. So I will come here at index 1. Now which suggests that our sliding window will shift by one position ahead. So we are done with this value, and sliding window will shift by one position ahead like this, I plus k minus 1. So 1 plus 3 will give 4, minus 1 will give index 3. So it will take 3 values, index 1, index 2 and index 3, because the size of this sliding window is k, which is 3. And now we'll apply the same logic. We assume that the first value of this sliding window is maximum, and j will point to that value. So I and j at the start are pointing to index 1, which is 77. So our assumption is 77 is max in this sliding window. Now to confirm that, what we do is next greater element array of j. J is pointing to 1, so it means we are going to this index now. And here we are finding a value as 4, which means that at index 4 we have 88, which is the next greater element of 77. And here you can see 88 is next greater to 77, but 88 is not in the sliding window range. It is just outside the sliding window range. Therefore, we are 100% sure that whatever the elements are here, which is 33 and 44, they will be 100% sure lesser than 77, which means for this window 77 will become our max, because the next greater element to 77 is 88, which is at index 4, and it is lying outside the boundaries of this sliding window. So this condition, this part will give 4. We check whether it is less than I plus k, which is 1 plus 3, which is 4. So 4 is not less than 4. So this condition comes out to be false. It means that our assumption at the start only, that 77 is max in this sliding window, comes out to be true. So in the result list, we will simply add the value at jth index. So array of j is 77. So it becomes like this. So we'll increment I. I comes to index 2. So our sliding window will shift ahead from 2 plus 3 minus 1, which is from 2 to 4th index. And now our task is to find the max in this sliding window. So now you will understand more about the problem in this step. We assume that 33 is our max in this sliding window, which is being pointed by I. So j starts from I, which is 33. So this is our assumption. So now we will confirm this assumption based on this while loop. What we do is j is pointing to index 2, I is pointing to index 2, and we are assuming that 33 is max in this sliding window. So what we do is we just check that at index 2 in the next greater element array, which index lies. So we find 3. And if we go to index 3, you will find 44, which is actually lying in this sliding window. So it means the next greater element to 33 is 44, and it is also lying in this sliding window. Therefore our assumption that 33 is max in this sliding window comes out to be false. And this condition comes out to be true because next greater element of array of j, which gives us value 3, we are checking whether this 3 is actually lying in the sliding window or not via this comparison. So we are checking whether it is less than I, which is 2 plus 3. So we are checking whether 3 is less than 5 or not. So this condition comes out to be true, which suggests that the next greater element to 33, which lies at index 3, is actually in the boundaries of this sliding window. So this condition comes out to be true, and in the while loop j simply shifts to 44 because our new assumption is 44 is max in this sliding window. So I remains here and j comes here. Like this. And now again we need to confirm whether 44 is max in this sliding window or not. So what we do is, j is pointing to third index. So we simply go to the third index. We find a value 4. We check whether the value at index 4, which is 88. Does 88 lie in this sliding window or not? So here if you see, 88 is lying in this sliding window. But this condition is actually helping us figure that out. 4 should be less than value of I is 2. 2 plus 3. 4 should be less than 5. So this condition comes out to be true. It suggests that the next greater element to 44, which is at index 4 here, is also part of this sliding window. So the condition in while loop comes out to be true. And our assumption that 44 is max comes out to be false. So now j will simply shift to 88 via this assignment. And now once again we need to confirm whether 88 is max in this sliding window or not. If we go to this index, you will see the value is 6, which suggests that for 88 there are no greater element towards its right because the last index is 5. And therefore we were storing array.length here, which suggests that there are no elements greater than 88. So here this condition 6 should be less than 5 comes out to be false. So this while loop will terminate. And we will simply add 88 into the result list. Like this. So for the third window, 88 becomes the max. We'll increment I. And I is actually equal to array.length minus k, which is 3. So this loop will run one more time because the sliding window will shift by one position. And now it will cover all the elements of the array. We assume 44 is max. So j is pointing to 44. We go to this index. We see the next greater to 44 is lying at index 4, which is 88 here. So we are simply checking whether 44 is max in this sliding window or not. So this will give us value 4. We are checking whether it is less than I plus k, which is 3 plus 3. 4 is less than 6. So this condition comes out to be true because 88 is next greater to 44 and it is lying in this range. So therefore j simply shift to 88 now via this assignment. Like this. And now we'll again confirm whether 88 is max in this sliding window or not. So we go to this index, we find 6, we check whether it is less than I plus k, which is 3 plus 3. So this condition comes out to be false. It suggests that the next greater element to 88 is beyond the boundaries of this array and our sliding window is still the last index. So our answer is 88. So this while loop will terminate. And to the result list, we will add array of j, which is 88. So 88 comes here. So we'll increment I. So I will come here. But here you can see this condition comes out to be false because there is no more window left of size 3. So therefore the for loop will terminate. And at the end, we will return our result list storing the max in the sliding window, which is 77, 77, 88, 88. So the first 77 is from here to here, which is this value. The second 77 is from here to here. The 88 is from this window to this window. And the last 88 is for last window, which is from here to here. So friends, this was all about the sliding window maximum problem. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video, we are going to discuss a problem, maximum sum subarray of size k. Now let's move ahead and see what this problem is and how to solve this. So here in this problem, we are given an array of integers like this, and we are given a value of k which is an integer value. Now this k value, you can treat it as a sliding window of size k. Now this sliding window is moving from very left of the array to very right, and it is moving 1 position in this direction. So at the start, if the value of k is 3, it means the sliding window is taking in first 3 elements, and these 3 elements also form a subarray of size k. Now our task is to find maximum sum of any contiguous subarray of size k. Now contiguous means that the elements should be next to each other, and we need to take a subarray of size k only. We need to evaluate their sum, and whichever subarray has the maximum sum, we need to return that sum. So let's say if we are given with this input array and sliding window is of size k, which is 3. So our output would be 16. Now how this 16 came is, let's say our first contiguous subarray of size k is from 0 index to second index. So it is 0, 1, 2, 3, 4 and 5. From 0 to 2 we have a window of size k. This is our subarray and the elements are contiguous to each other. Now if we take the sum of these 3 elements, we will get a value 12. Now after that what we do is, we move the sliding window to right by 1 position. So 2 goes out of the sliding window and 5 comes into the sliding window. So now our 3 elements are this, 7, 3 and 5. If we do the sum of these 3 elements, we get the sum as 15. Then we move the sliding window ahead by 1 position. So 7 goes out of the sliding window and 8 comes into the sliding window. So now this is our sliding window. If we do sum of these 3 elements, we get sum as 16. And at the end, the sliding window moves by 1 position and reaches to the end of the array, and this is our sliding window. If we do sum of the 3 elements, the sum is 14. So here you can see we had 6 elements, and if our sliding window is of size 3, we saw there were 4 subarrays of size 3, from 0 to 2, from 1 to 3, from 2 to 4 and from 3 to 5, and their sums are 12, 15, 16 and 14. So among these 4 sums, 16 is the max. So our answer should be 16. It means we are telling that we have found one subarray having 3 elements 3, 5 and 8. If we do their sum, we get a maximum sum of 16. And here window size is whatever the value of k. So friends, now let's move ahead and see that how we can solve this problem. So let's suppose we take this array and value of k is 3. It means the sliding window size is 3, and it also means that at a time we can only see 3 elements in the array. And for those 3 elements we do their sum, and we keep on doing their sum for all the sliding windows, and whichever sum is the maximum, we simply return that sum. Now here you can see one way to solve this problem is, let's say we take a for loop, and inside that we take another for loop. So the outer for loop, let's say it's point to 0 index, and the inner for loop will take 3 elements because value of k is 3. So it takes 2, 7 and 3 and do their sum. So let's say j goes from 0 to 2 and do their sum. So we get a value as 12. Now after evaluating the first window, I will simply travel to this index, and j will take the next 3 elements. So this and this. If we do their sum, we get 15. And similarly it keeps on going till I reaches here for the last window and do the sum. And as we are evaluating the sum for each window like this, we compare that which is the maximum sum, and at the end we simply return that sum. So for 3, 5 and 8, this window, the sum would be maximum, which is 16. So if we solve the algorithm using 2 for loops, this problem is very easy to solve. So this solution is roughly time complexity of O into n into k. because we are traversing the array and each time we are taking k elements. So the time complexity is O of nk. So this time complexity is not efficient. We need to solve this problem in better time complexity, let's say of O of n. So if I remove everything, so here with this approach, I was here and then we picked 3 elements, did their sum, and then we moved I here and we then picked the 3 elements. So here if you see that for the first sliding window, 7 and 3 were part of the sum. For next sliding window, this sliding window, 7 and 3 were part of the sum again, and only 5 was included and 2 was excluded. So we did the sum again for these 2 elements, and similarly for the second window, we took the sum of 7, 3 and 5 like this. But when we went to the third window, we again took the sum of 3, 5. So this much part, we are doing the sum again in the for loop. So this is actually increasing our time complexity. Now how to solve this problem in a better time complexity is, here you can see what we do is, as we need to take the sub array and it should be of size k. So for the first window, we take the sum directly. We simply add 2, 7 and 3 and we get sum as 12. So this is our first window where we do the sum directly. Now what happens is, we shift the window to right by 1 position because we need to take now the next sub array from index 1 to 3. So when we do this shifting, what happens is, the window in blue becomes our new window and the window in yellow was our old window. But here you can see, in both this window, 7 and 3 were included in the sum. So let's say if we do 2 plus 7 plus 3, we get 12. And then we shift the window ahead, we do 7 plus 3 plus 5 and we get sum as 15. So here you can see with this nested for loops, we were evaluating this sum again, which was in the middle of both the windows. Now if we stop calculating this sum again and again, we will get a better time complexity. Here you can see when window was here, we did a normal sum because we need at least k size window. So at the start we are doing the sum normally, 2 plus 7 plus 3. We got 12. Now when this window shifted ahead for the next sum, here you can see 2 goes out of the window. So if you see the blue window, 2 went out of the window and 5 comes into the window. So 5 comes into the blue area and 2 went out of the blue area because our current window is from index 1 to 3 of size k. Now here you can see we know the sum of first 3 elements, which is 12. Now as we are moving window ahead, 2 goes out of the window. We know that sum is 12 and if we do minus 2, our sum will be 10, which is the sum of these 2 elements. And if we add only 5 to it, we get 15, which is the sum of our next 3 elements, which is in the blue area. So using this property will reduce the time complexity of the algorithm. So now what we do is, we simply perform 3 steps. First, we take sum of first k elements, which is 2 plus 7 plus 3. So let's say it gives value as 12. Now as we are shifting the window to the next element so that we can evaluate the next window sum, what we do is, we don't have to recalculate 7 plus 3 plus 5. What we can do is, we already know 7 plus 3 is already in the sum, in the 12. We just subtract the element going out of the sliding window. So the element which is going out of the sliding window is 2. So we are subtracting 2 to get the sum of the remaining elements in the previous window, which is 7 plus 3, which is 10. And the third step is, as 5 is getting into the window, here we simply add the new element coming in the sliding window. So we are simply adding 5, which is our new element, to 10 to get 15. So if you see 7 plus 3 plus 5 will give 15, which is the sum of our next window which starts from 1 to 3, and similarly this window goes on like this. One element goes out of the window and new element comes into the window. So the element which is going out of the window we simply subtract from the sum, and the new element which is coming into the window we simply add that. We also compare 12 with 15, then with 16, then with 14, and at the end we will figure out that 16 is the maximum sum in the sub array of size k. So this would be our answer. And also friends, here you can see the value of k is 3, which is very small. So here you can see these are only 2 elements coming. Let's say value is k is 100. So if one element goes out of the stack, we don't have to calculate the 99 elements sum again and again. We can simply subtract one element and add another element, and we will get the sum of the next 100 elements. So this makes our algorithm efficient. Now let's move ahead and see the demonstration of this algorithm step by step. So before we start, if you want to master data structures and algorithm, then you can subscribe to my channel and click the bell icon so that you never miss any update. So here is the algorithm. The method name is max subarray sum, which takes in the array and a value k, which is the size of our window. So this is our array and value of k is 3. It means we are taking a sliding window of size 3. As we want to evaluate the maximum sum in a subarray of size k, we create an integer variable max sum because we need to return an integer value from this method. So here at the end we will return the max sum. So we initialize a variable max sum with 0. Then we create a variable window sum. So as we want to take the sum of sliding window of size k, so let's say this is a sliding window of size k. So for these 3 elements, whatever their sum will be, we store in the window sum. And similarly for the next window sum, we store in the window sum. So we create a variable window sum having value 0 at the start. Now we create an integer value start, which will start from the 0 index. So this value is basically an index value like this, that the initial value is 0 for start variable. We will see its significance later, that why we have created this start. And now we provide a for loop, and inside this for loop we will do the window sum. We'll compare the window sum of different windows of size k, and whichever is the maximum sum we simply evaluate here. So what we do is we take an integer variable end, we initialize it with 0, and this end will go till array.length. So array.length will be 6. So end will go till the last index, which is 5th index. So here end will start from the 0 index. So in our previous slide we discussed the 3 steps. The first step is we simply take the sum of first k elements. Because the first window is of size k, so at the start we need to include the first k elements so that we can get a sum. So here you can see the first window of size k will go from index 0 to 2. So it means for this window we will straight away calculate the sum, because we need to return the maximum sum of a subarray of size k. So we need at least k elements to evaluate the sum and then compare with the next windows. So this if condition, if you see here, will help us achieving that. So value of end, which is 0, is less than 6. So this condition comes out to be true. Now to our window sum, as we need to evaluate the sum of first 3 elements, this will get stored in the window sum because this is our first window. So what we do is, to window sum we add array of end, which is the first element, which is 2. So here initially the value of window sum is 0, plus we are doing array of end, which is 2. We are adding the first element and assigning it to window sum. So window sum will become 2 like this. And here you can see that we need to evaluate the sum of first k elements. So this condition, if AND is greater than or equal to k minus 1, it means we are saying k minus 1 is 2 because value of k is 3. If AND is equal to 2 or greater than 2, then this if condition will come out to be true. So at the start, value of AND is 0. So 0 is not greater than 2 or equal to 2. So it means this if condition comes out to be false and this if block won't get executed. So here you can see if AND comes to index 2 here. At that moment 2 will be, this condition will come out to be true. So it means when AND has reached here, we have evaluated the sum of first k elements already. Here we added the first element, then we will add 7 and then we will add 3. So at that moment AND will be at index 2. And when AND will reach here, then only our main algorithm will run. And then it will keep on running for every window. We will see that later. So currently this condition comes out to be false because 0 is not greater than equal to 2. We will increment AND. So AND comes to index 1. We take window sum 2. We add array of AND which is 7 and we will assign it back to window sum. So window sum will become 9. Now this is the sum of first two elements. We need at least first k elements to start comparing for the maximum sum. So this condition 1 is greater than equal to 2 still comes out to be false. We will increment AND. AND comes to index 2. We take window sum which is 9. We simply add 3 to it. So it becomes 12. Like this. And now here you can see that our first sliding window is from index 0 to 2. It means we have taken the sum of first k elements which is 2 plus 7 plus 3 which is 12. And now here you can see AND is at index 2. So value of AND is 2. And it is greater than or equal to k minus 1 which is 3 minus 1 which is 2. So this condition comes out to be true. So now if block gets executed. So here as we have calculated the sum of first k elements, it means we know the sum of first sliding window of size k which is 12. At the start max sum is 0. So now what we do is we simply compare max sum and window sum, and which is the maximum between these two we simply assign to max sum. So here what we are doing is, as we have calculated the sum of first k element which is the first window, initially max sum is 0. So you can think of this condition is like we are doing if window sum is greater than max sum, then to max sum we are assigning window sum like this. So currently max sum is 0, window sum is 12. So window sum is greater than max sum. So this tells us that we need to discard this max sum and our new max sum will become 12. So max sum value will become 12 like this. So as we discussed in our previous slide, that after evaluating the sum of first k elements, this sliding window will shift ahead to get the sum of next k elements. So 2 will go out of the window and 5 will come into the window. So we also know that the second step we discussed that we need to subtract the element which goes out of the window. So here we are doing the same, and here you can see this start is actually helping us to know which is that first element of that window. We know that start we initialize with the 0 and end move till the index 2. So if you see, our window is from start to end having 3 elements. Now when this window will shift ahead, at whichever value start is pointing, that will go out of the sliding window, which means 2 will go out of the sliding window. So what we are doing is, we are not recalculating the sum now. So here, now what we are doing is, we are simply subtracting the element which is going out of the sliding window. So we are taking the window sum and we are simply subtracting the element which is at start index, which is 2. So our window sum will become 12 minus 2, which is 10. Like this. And this window sum will have the sum of these two elements. So for the next window, we don't have to calculate this window sum again. We can simply reuse that. So now as 2 went out of the sliding window, so for the next sliding window, it will start from index 1. So we simply increment start. So start comes at index 1. We'll increment end. End comes to index 3, which suggests that now our new window will be from start to end. Like this, which means these 3 elements. And we know that when we shifted this window here, 2 went out of the window and 5 came into the window. So here you can see 5 came into the window. So our third step was we add the element which comes in. So we are simply adding 5 to our previous evaluated window sum, which is 10. So it becomes 15. It means with just one sum, we now have the sum of these 3 elements. We didn't evaluate 7 plus 3 again. We just added 5 to our previous calculated sum, which give us 15. This condition comes out to be true because value of end is 3. 3 is greater than equal to 2. And here you can see our window sum is 15, max sum is 12. We simply compare these two values, and if window sum value is greater than max sum, we simply assign that value to max sum. So here we are taking these two values, which is 12 and 15, and whichever is the max among these two, we are assigning it to max sum, because we need to return the maximum sum of a sub array of size k. So we just evaluated the sum of second sub array of size k, and we simply compared it with the max sum. So we got 15 from this sub array. So our max sum will become 15 from this statement, like this. And now after we did the sum of this sliding window from here to here, we know that now this sliding window will move ahead and 7 will go out of the sliding window, which is the element to which start is pointing. So this will go out of the window, and we know that we need to subtract the element which goes out of the sliding window, so that for the next sliding window we can evaluate the sum easily. So window sum is 15, we do minus 7, so it will give 8. And once 7 will go out of the sliding window, we know that now next sliding window will start from index 2, so we do start plus plus. So start will come at index 2. We will increment end. End comes to index 4, which means now our window will start from index 2 to 4, like this. Now here 7 was excluded from the sliding window and 8 was included in the sliding window, because this sliding window shifted by one position. So 3 and 5 remained there and 8 was included. We know that we need to add that value which comes in. So here we are doing the same thing. We are adding the value 8 into the previous calculated sum. So 8 plus 8 will give 16. This condition is true because 4 is greater than equal to 2. The max sum is 15 and this window has a sum of 16. 8 plus 5 plus 3 will give 16. We know that we have found one window whose sum is 16, which is greater than the previous max sum. So whichever value is greater among these two values, we simply assign to max sum. So max sum will become 16 now. We are done with this window. So now for the next window, 3 will go out of the sliding window and 1 will come into the sliding window. So if 3 is going out of the sliding window, we are taking the sum, which is 16, and we simply subtract 3. So it becomes 13. And as our new sliding window will start from index 3, we simply do start plus plus. So start comes at index 3. We'll increment end. End comes to index 5. It means now our sliding window is from index 3 to 5. This is our last sliding window. And 1 was added to this sliding window. So we simply do window sum, which is 13 plus 1, which gives 14. We assign this 14 back to window sum. So window sum will become 14. This condition is true because value of end, which is 5, is greater than equal to 2. Now our max sum is 16 and window sum is 14. So here you can see the max sum is 16, window sum is 14. So we already have a maximum value in max sum. So max sum will remain to the 16 only because 14 is less than max sum. And now for the next sliding window, we simply remove 5 from the sum. So it becomes 9. We do start plus plus because next window will start from index 4. But here you can see if we do end plus plus, so end will go out of the boundaries of this array, which also suggests that there is no window left of size k now. So therefore this for loop will terminate. And here you can see at the end we are returning the max sum as 16. So which is our answer? So which came from this sub array of size k, 3 plus 5 8, 8 plus 8 16. So friends, here you can see we used only one for loop and we evaluated the maximum sum of a sub array of size k. We need to keep these 3 steps in mind, that at the start we do the sum of first k elements, and then based on this condition we do our rest of the steps, that one element goes out of the window and one element comes into the window. So the element which goes out of the window, which is array of start, we subtract from the window sum, and in the next iteration of for loop, which is our next window, we simply add the element which just comes into the sliding window. And therefore this property helps us in evaluating the sum in a very efficient way. We don't have to recalculate the sum of every k elements. So friends, this was all about the problem. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video, we are going to discuss a problem, longest substring without repeating characters. So let's move ahead and see what this problem is and how to solve this. So in this problem, we are given a string like this. Our task is to find the length of longest substring without repeating characters. So first of all, let's understand what is a substring. So let's suppose if we are given a string like this, test. So here a substring is a part of the string in which we will take out the sequence of characters, and those sequence of characters should be contiguous. It means they should be next to each other. So the property a substring has is, first, it should lie within the string. So it lies within the string. Second, the sequence of characters which we are taking, those should be contiguous, which means they should be next to each other. So for example, if we want to find that how many substrings are there in this string, so if we start from t, one substring would be t, other would be te, tes, test. Here you can see this substring should be within the string and it should be contiguous. It means they should lie next to each other. So we can't take a substring like tt, one t here and another t here. We need to take a part of a string which is contiguous. So if we start from E, it would be E, ES, EST. If we take it from S, it would be S, ST. And if we take the last T, it would be like this. So if the length of the string is, let's say, n, so the total number of substring would be n into n plus 1 by 2. So here n is 4. So if we put 4 here, we will get 4 into 4 plus 1 by 2, which is 4 into 5 by 2, which is 10. So here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to keep in mind a substring should lie within the string and the part of the string that we are taking, it should be contiguous. So our task is to find the length of the longest substring in such a way that character should not be repeated. So if we take this example, here ABC has length 3, but as soon as A comes, we get a repeating character. So we discard this A, and if we take BCA, the length is 3, because after that we have found one B, and B is repeating in BCA. So we discard this B now. We start from C. So C, A and B, length is 3. We can't move ahead because we have found a repeating character C. So we discard this C, and then we find A, B, C, and again we find a B. So length remains 3. So after we find this B, we can discard this A and B together because they won't contribute to the longest substring now. So C and B will take 2 characters, and then we find a repeating character. So we discard this C and B, and at the end we will find one B. So the length of the longest substring without repeating character is 3. It can be found from ABC, BCA, CAB, ABC. That's it, because after that we are getting a substring of length 2 like BC, CB, and at the end we are getting only one B. Similarly, in this example we have a string BBBB. So the longest substring without repeating character would be 1 because all the characters are repeating. Here PW becomes 2 because we have found one W here which is repeating. So we'll discard this P and W. Then we'll go here and then we will find one W. So this length is 3, and as soon as we find W, we discard this W, and then we start our substring from K. We will find KEW, which is length 3. So the length of the longest substring without repeating character is 3. So let's move ahead and see the demonstration of this algorithm step by step. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here is the algorithm to find the length of the longest substring without repeating characters. So method name is length of longest substring. It takes in a string S and returns the length of the longest substring without repeating characters. So let's say when we call this method by passing this string, so S will become like this, PWWKEW. So if we see this string internally, it will be a character array like this. So friends, the basic idea behind this algorithm is we create a hash map like this, where key is the character and value is the integer. So here, as we need to find the length of the longest substring without repeating characters, what we are doing is we will store the character along with its index into this map, so that when we encounter a repeating character, we simply look up into this hash map and we simply figure out that when that repeating character last occurred, so that we can start our new substring search from an index just after that. So you will understand more later in the algorithm. As we want to return the length of the longest substring without repeating characters, we will be storing it in the max length. So at the start, max length will be 0, like this. So as we want to identify the length of the longest substring without repeating characters, we will process each character one by one from left to right. So let's say if we take these 2 characters, P and W, so the length of this substring is 2. So in this algorithm, we will take the help of 2 variables, start and end. So this start and end will be actually referring to the indexes. So let's say for PW, let's say start is here and end is here. So if you see closely, start and end basically forms a window like this, which has some characters. So this window is starting with this start variable and ending with this end variable, and those are pointing to the indexes. So if we want to know the length of this substring, we can use the formula as end minus start plus 1. As these are pointing to the indexes, it would be 1 minus 0 plus 1. So we'll get the answer as 2, which is the length of this substring. So you can treat this as a window from start to end. Why we are using this 2 pointer is we need to identify the length of the longest substring without repeating characters. So we need to put start at a point from where we are evaluating the length of the longest substring, and we will move end in this direction so that as soon as we encounter a repeating character, we stop end there itself, and using start and end we can figure out the length of that particular substring with this formula. So we will understand more when we proceed ahead. So as we haven't processed any of the node, so start will point to 0 index like this, and as we discussed, we will move end into this direction and starts from 0 because now we are processing this first character, and end will go till the last index, which is 5. So in the string class we have a method char at, where if we pass any index, it will return back the character at that particular index. So if we call s.char at 0, because end is at 0 index, we will get a value as p, which we will be storing in the right char like this. So here we are asking the string to return the character at this index, which is 0 index, which is p, and that p we are storing in the right char like this. So as end is moving in this direction, we have denoted it by a right char. So now the first thing we do is we simply find whether right char is present in our hash map or not. So we provide this if condition map.contains key, where we pass the right char, and if the map contains that key, it will return true. We will understand more about this part later. So currently map.contains key will return false because this key is not present in the hash map. So here for the first char we know that it's a substring and it doesn't have any repeating character, and we also know that in the hash map we put the char along with its index. So we are putting char along with its index, so it would look something like this, p, and we are putting value as 0, which is end. So here you can see currently our window is here, where start and end are pointing to only single character, and our max length is 0 because we haven't processed any character. So with this formula we will identify the number of characters in this window. So end minus start plus 1. So it would be 0 minus 0 plus 1. So the length of the substring is 1. We are comparing it with max length, that whichever is the max we will directly store in the max length, because at the end we have to return the max length. So for this small substring the max length will become 1 because here it is 0 and this gives value as 1. So whichever is the max we are storing in the max length. So we will increment end. So why we are incrementing end? Because with the combination of p and w we can get a substring which is of length 2 and it doesn't have a repeating character. So therefore start will remain at index 0 only, and we will move only end in this direction. So first we will get the character at index 1 now. So right char will become w like this. We will check whether w is present in this map or not. So this condition comes out to be false, and we will simply put w along with its index in the hash map. So it would look something like this. Now here max length is 1, and if we use this formula 1 minus 0 plus 1, it will give the value as 2. So here you can see that we have a window of length 2, which is a substring pw, which doesn't have repeating character. So this will give value as 2. So now our max length will change. It will become 2. We'll increment end. So end will come to index 2. So first we will identify the character at index 2, which is w. So right char will become w. So friends, here you can see that our hash map actually contains W. So when we will call map.contains key, we'll pass the character as W. It will return a value true. So this if condition comes out to be true because we have W already in the hash map. It means we have found a repeating character and we can't include this W into this substring. So here now what we do is, till this point we have found the length of the longest substring as 2, which is PW. But as soon as we encounter W, we can't include this W here because we will have a repeating character. So we need to move this start after W so that we can discard one of the W. And how we can do that is, as W is present in this hash map at index 1, we will first get that index. It will be 1. So this index will be returned. And we have to just start after this index. So we will add +1. And currently start is at 0 index. So we will take the max of start and this value. So 2 is greater than 0. So now our start will go to the index 2. Like this. Which suggests that we have found W here. So the next longest substring will include another W. So we need to discard this W and start just after that. So therefore we are looking up into the hash map to see when this W occurred last. And then we start finding a new substring from an index just after that, which is 1 plus 1 because W was found at index 1. So start comes here. So it means we can simply discard these two characters and start finding the length of the longest substring from index 2 now. So as we are starting from index 2, because start is pointing to index 2, we will put W along with its index in the hash map. So this value will be overridden to 2. And for this single substring, we know that max length is 2, which we already found as PW. So 2 and minus start plus 1. So 2 minus 2 plus 1 will give 1. So 1. So the length of the longest substring without repeating characters till this point will remain 2. We will increment end. End comes to index 3. At index 3 we have a character K. So right char will become K. K is not present in this hash map. So this condition comes out to be false. So we will simply put K with index 3 into our hash map like this. The max length is 2. End is at index 3 and start is at index 2. So 3 minus 2 plus 1. It will give 2. So the max length will still remain 2 because this part is 2. And math.max will return a maximum value between these two. So 2 will be assigned to max length like this. We'll increment end. End becomes 4. The character at 4th index is E. So right char will become E. E is not present in this hash map. So this condition comes out to be false. So we will put E into this hash map along with its index like this. So here you can see max length is 2 and minus 2 plus 1. It will give 3. So this part will give 3. So here you can see we have found one substring WKE without repeating characters which has a length of 3. So therefore now our max length will change because math.max will return a value 3 when it's compared with 2. So max length will become 3, which suggests that we have found one substring of length 3 without repeating characters. We'll increment end. End becomes 5. The character at 5th index is W. So right char will become W. So friends, here you can see that W is present in this hash map. So this condition comes out to be true. And here what we are doing is, with this map.get right char, we are just figuring out that when this W occurred last in this character array, so this hash map will bring us that index that W occurred at index 2. So which suggests that whatever the substring we found till this point, we can't include W, because if we include W, that will be a repeating character. So in order to include W for the rest of the string, we have to discard this W. So for that we need to know the index. So when we identify that index, we simply shift start to a character ahead than what we find from this map.getWriteChar. So here it gives 2. So we simply just shift by one position by adding +1. Start was at 2. So math.max among 2 and 3 will give value as 3. So start will now come to index 3 like this, which suggests that our new substring should start from this index. So now we simply put W into the hash map along with its index. So the index value will be updated here. It will become 5. And here you can see max length is 3. End minus start +1. So 5 minus 3 plus 1 will give 3. So this comes out to be 3, which suggests that one more substring is KEW, which is longest and without any repeating character. But among these two lengths, both are same, so the max length will still remain 3 only. So now we'll increment end. So end goes beyond the boundaries of this char array. So this for loop will terminate because end should go till it is less than s.length. So at the end we will simply return a value 3. So friend, let's suppose here if we had a value like a. So this for loop would have run one more time. So here this a is not in this hash map. So we simply put a here like this a with the index 6. And here our max length would have changed. Initially it was 3. End minus start, so 6 minus 3 plus 1 would have given 4. So this would have become 4 and our answer would have become 4, which would suggest that the longest substring without repeating character is KEWA. So friend, this was all about this problem. We can solve this problem by keeping a sliding window of variable size which has a range from start to end, and whatever the characters are between start to end, those number of characters will give the length of that particular window, and we can use this hash map to figure out the repeating characters so that we can start our new window from a different index by making a lookup into the hash map for the character which just got repeated. So friends, one important thing to discuss is that why we are using math.max and we are taking whichever is the max from the start and from this statement. So in order to understand this, let's suppose we are given with this string pwwp. So the example which we took was like this. So in our previous example till this point, everything remains the same. The w we placed last in the hash map at index 2, and after that we went to k. So instead of k, now we are going to p. So we will see what the difference is. So when we will increment end will come to index 3. So here instead of k, now we are taking the right char as p by this. And here you can see that map actually contains p at index 0. So this condition comes out to be true. So friends, here you can see that if we only provide this condition, if we do map.getWriteChar, we'll get value as 0, and if we add +1 to it, we'll get 1. So we can't discard this p and start from index 1, because then our substring will have wwp, and here currently the max length is 2. So when we will do end minus start +1, so end is 3 and this start will come here, so -1 + 1, so our answer will be 3. So at the end we will return max length as 3, so which is wrong, because here we are playing with the indexes and this algorithm doesn't know that we have encountered a w here, and this is a substring with a repeated character. So one thing to keep in mind is, if our start is at index 2 and we have found one character which is at index 3, and when we look up this character in the hash map, if that character comes beyond our start, which is the current case at 0, so this P last occurred at index 0, so we don't have to consider this P or this index because currently we are processing this substring from start to end, and this P has occurred in this region. So therefore if we do map.get right char, we get index 0. If we add +1, we get this index 1, but our start is already at index 2 here. So therefore we are doing this math.max because we have to assign the maximum value between these two statements to start. So if start is already ahead of this statement, then we don't shift start back, we keep the start at that point only. So this is the one important thing to consider for this algorithm. Now after this statement, start remains at index 2 and we simply put 3 here, and here the max length is 2. If we do end minus start plus 1, we will get 3 minus 2 plus 1, which is equal to 2. So this is the length of that substring. So when we will do math.max, our answer will be still 2, because here you can see the longest substring without repeating character is 2, this or this. So therefore this is the important condition to keep in mind. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day. Hello everyone. So in this video we are going to discuss a problem, symmetric tree. So let's move ahead and see what this problem is and how to solve this. So in this problem we are given with a root of a binary tree like this, which actually holds this complete tree. Now our task is to check that whether this binary tree is mirror of itself, which means we need to check whether this binary tree is symmetric around its center or not. So let's suppose we are given with this binary tree and we need to check whether it's a symmetric tree or not. So for this binary tree, if we draw a line like this, so this line is nothing but a line of symmetry. So around this line, if a binary tree is a mirror image of itself, then we consider that binary tree as a symmetric binary tree. So usually when we talk about symmetrical images, let's say if I take a rectangle, and if I want to find out whether it's a symmetrical image or not, what we can do is, we can create a line of symmetry, and if we rotate the image like this, around this line of symmetry, let's say denote this as A, B, C and D. So if we rotate this image around this line of symmetry, you will see that A will come over B and C will come over D. So if that is the case, then this shape is a symmetrical shape. So if any shape is rotated around its line of symmetry, if the left part superimposes the right part, then that shape is a symmetrical shape. So here you can see for this binary tree, the line of symmetry goes from the root, and we have to determine whether this binary tree is a mirror of itself. That is, we need to check whether it's symmetric around its center. So this is the center. So if we rotate this binary tree, you will see that after the rotation, 2 will come over this 2, this 4 will come over this 4, and this 3 will come over this 3. So we can come to know that this binary tree is symmetric around its center because 1 will remain there itself. And if we take this example, here you can see that 2 will superimpose 2, but as we are rotating this binary tree around the line of symmetry, when this 2 will superimpose this 2, this 3 will come like this. It will not superimpose this 3. So therefore this is not a symmetric binary tree, because as we are folding this binary tree around this line of symmetry, when this 2 will superimpose this 2, this child at right will come towards the left of it, and so this 3 is not superimposing this 3. So therefore we can consider that it's not a symmetrical shape. Also, one thing to note here is the symmetrical shape is actually equidistant from the line of symmetry. So this 2 and this 2 both are at a equal distance from the line of symmetry. This 4 and this 4 both are equidistant from the line of symmetry, and similarly this 3 and this 3. But here you can see this 2 and this 2 are equidistant from the line of symmetry. This node 3 and this node 3 are not equidistant from the line of symmetry. Therefore, it's not a symmetric binary tree. So friends, the basic idea behind this algorithm is, if I remove this, so let's say if we are on root and this root has only one tree node like this. So therefore, we can directly consider that it's a symmetric binary tree, because we need to find whether the binary tree is symmetric around its center. So this is the center. If this root is null, then also we'll return true, that it's a symmetric binary tree. So here now if binary tree is given like this, so after the root, if we are going on the left, so we will reach to this node, and if we look into the mirror, then this left should be equal to this right, so that we can come to know that till this point the image is symmetric. Now when we reach here and here, if we are going towards left, then in the mirror it would look like we are going like this, towards right. So we land here, we compare these values, and we know that till this point also the tree is symmetric. Now if we go towards right, so in the mirror it would look like we are going towards left, and we reach to node 4 and we compare its values. So those are same. So 2 is equal to 2, 3 is equal to 3, and 4 is equal to 4. And after that there are no more nodes. So we can consider that this is a symmetric binary tree. So here let's say if we are going towards left, then in the mirror we are going towards right. So we reach here, we compare those values, they are equal. So now here we have a null value. If we are going towards left, then in the mirror image we are going towards the right. So here we have reached to the null value, but here we have reached to a actual node having value as 3. So when we will compare them, they won't be equal. So we can directly come to know that this is not a symmetric binary tree. So one property to remember is, if we have mirror here, and if we are going towards left, then in the mirror image you are going towards right. And if we are going towards right, then in the mirror image we are going towards left. So similar technique we will apply over the binary tree to figure out whether it's a symmetric or not. So now let's move ahead and see the demonstration of this algorithm step by step. So let's say if we are given with this binary tree and we need to check whether it is symmetric or not. So when we will call this method is symmetric by passing in the root, it would look like this, that root is pointing to this binary tree, and this method will return a boolean value stating that this binary tree is symmetric or not. So here the first thing we check that whether root is equal to null or not. So if root is equal to null, then we can directly return true, because there is no binary tree and there is no node. So the binary tree is actually symmetric around its center. So we are returning true. So this condition comes out to be false because root is pointing to a node having value as 1. So friends, we will use stack data structure to figure out whether this binary tree is symmetric or not. So here we will initialize a stack like this. So stack is a LIFO data structure where the element inserted last will be the first to be removed, and we will use this property to figure out whether the binary tree is symmetric or not. So we will see that later. So here you can see if root is not equal to null, it means there is one node. Till this point the tree is symmetric, and let's say if I draw the line of symmetry like this. So we know one of the property of this line of symmetry is, let's say on this side, if we are going towards right, then in the mirror image it would look like that we are going in this direction. And similarly, if we are going in this direction, then in the mirror image it would look like we are going in this direction. So therefore in the stack what we are doing is, we are pushing root.right, which is 2. So it means if we look into its mirror image, then we need to put this 2 into the stack as well. Because we know that on this side if we are going towards right, it means on this side we are going in this direction. So therefore we need to compare this 2 with this 2. So if we are going towards right on this side of mirror, then we are going towards left on this side of mirror. So we are putting both the 2's into the stack so that we can pop them out in pair and compare them. So this thing we will do in the while loop. We will check whether stack is empty or not. So currently stack is not empty. So the condition in while loop comes out to be true. So here this 2. So here first we place the right one. So this is the right one and this is the left one. So we will create two nodes n1 and n2. We will pop the nodes from the stack and assign it to n1 and n2. So first we'll pop 2 out, which is on the left side, and assign it to n1. Then we will pop the right one and assign it to n2. So after getting n1 and n2, we need to compare these two nodes now. So the first thing we are checking is whether n1 and n2 both are null at the same time or not. So if both n1 and n2 are null simultaneously, then we will continue with the while loop. So let's say this is our line of symmetry, and let's say this is our node 1 and this is our node 2. So here both of them are null. It means the symmetric property holds true for both of this node. So we will simply continue. But here you can see n1 is pointing to 2, n2 is pointing to 2. So both of this condition comes out to be false. And then this condition is very important because it will directly return false, that whether the tree is symmetric or not. So here we check that whether n1 is equal to null and n2 is equal to null. So if both of the conditions are true, that n1 is null and n2 is null, so we can continue. So if this condition comes out to be false, which suggests that there could be a chance that either n1 or n2 can be null. So if n1 is null, we directly return false. Because here we have already checked whether n1 and n2 both are null simultaneously or not. So if this condition came out to be false, we are simply checking first that if n1 is equal to null, then we can directly return false. Or if n2 is equal to null, we can directly return false. Because these two cannot be null simultaneously based on this condition. Or if their values are not equal. So currently n1 is not equal to null, n2 is not equal to null. n1.val, which is 2, is actually equal to n2.val. So this condition also comes out to be false, which proves that till this point the tree is symmetric and this 2 and this 2 are actually equidistant from the line of symmetry. So we simply move ahead. And now what we do is, as we are on n1 and we are done checking these two nodes n1 and n2, now what we do is, if we want to proceed ahead in the binary tree to figure out the rest of the elements are symmetric or not, we know that if we are going towards left from this 2 to 3, then in the mirror image it would look like we are going towards right. And if we are going towards right, then in the mirror image it would look like we are going towards left. So these two nodes are symmetric. So now we have to compare n1's left with n2's right and n1's right with n2's left. And if those are equal, then we keep on doing this thing till the complete binary tree is empty. So here in the stack what we are doing is, we are pushing n1's left, which is 3. So this is the first node, like this. And as we need to put them in pairs so that we can pop them out and compare, with n1's left we need to put n2's right. like this. So n2's right is 3. So this is second. And then we will put n1's right, which is null. And along with we will push n2's left, which is the mirror image of n1's right. So null will come like this. This is the fourth push. Stack is not empty. So now we will pop in pairs and we will compare them. So when we will do stack.pop, fourth node null will be popped out, which is n2's left, which is 4. So n1 will point to n2's left like this. And then we will pop one more element, which is 3, which is n1's right. So n2 will point to n1's right like this. So here you can see that now we are actually comparing the mirror images nodes, comparing n1 and n2, which are actually symmetric nodes across this line of symmetry. So if n1 is null and n2 is null, then we will simply continue. So currently n1 is null and n2 is null. So which proves that till this point the tree is symmetric. So we will continue. Stack is still not empty. We will pop the node, which is n2's right. So now n1 will point to n2's right, which is this node. And then we will pop one more node, which is n1's left. So n2 will point to n1's left. And now we'll simply compare them. So here you can see that we are using the stack data structure, which is popping the elements in pairs. And we have pushed in such a way that this is the line of symmetry, that if you are pushing any node in the left side, then in the mirror image we have to push the right side node so that we can compare them and come to know that whether they are symmetric or not. So n1 is not equal to null and n2 is also not equal to null. Here you can see n1 is not equal to null or n2 is also not equal to null. n1.val is 3, n2.val is 3. So 3 not equal to 3 comes out to be false because 3 is equal to 3. So this condition comes out to be false. So it means that till this point the tree is symmetric. And now what we do is we perform the same steps on this node and this node. So first we will push n1's left. So n1's left like this. So if we are pushing n1's left, we are going to the left. So on this side we have to take its corresponding node on the right side like this. So we are putting n2's right, which is also null. Then we will push n1's right, which is this null. And correspondingly we have to push n2's left like this. Stack is not empty. We will pop this null value, which is n2's left, and assign it to n1. So n1 will come to n2's left like this. We will pop this null, which is n1's right. So n2 will come to previous n1's right here. So here you can see n1 is equal to null and n2 is equal to null at the same time. So therefore we will simply continue. Stack is still not empty. So now we will pop both the nulls. So first we will pop n2's right. So n1 will point to previous n2's right, which is this. And we will pop this null also, which is n1's left. So previous n1 was here, its left is this. So n2 will point to previous n1's left. n1 is null and n2 is null simultaneously. So therefore this condition comes out to be true. So we'll simply continue. Which suggests that this null and this null is symmetric, this null and this null is symmetric. Stack is empty. It means there are no more nodes in the binary tree to be traversed. So we'll simply return true, stating that across this line of symmetry, this binary tree is symmetric. So friend, let's suppose we are given with this binary tree now. This is the line of symmetry and we need to check whether this binary tree is symmetric or not. So we will perform the same steps till this while loop. Root is not equal to null. We will create a stack. Root is not equal to null, so we will push roots right on this side along with roots left, which is a mirror image of this node in this side. So 2 will come and this 2 will come. Stack is not empty. We will pop 2 from the stack and assign to n1 like this. We will pop another 2 and assign it to n2 like this. n1 is not equal to null and n2 is also not equal to null. So this condition comes out to be false. n1 is not equal to null, n2 is not equal to null. n1.val, which is 2, is equal to n2.val. So this condition also comes out to be false. And then we will simply push n1's left, which is null. So till this point the tree is symmetric, and for this node and this node we have to check whether its child are symmetric or not. So if we are putting the left part on the stack, then on this side we are actually pushing n2's right, which is 3, and then we are pushing n1's right, which is 3, and its corresponding n2's left, like this. Stack is not empty. We will pop null n2's left. So n1 will come to n2's left here. We will pop this 3, which is n1's right. So n2 will go to n1's right, like this. So n1 is equal to null and n2 is not equal to null. So one of them is null but other is not null. So we can't continue. So this condition comes out to be false. Now here you can see, as we need to compare these two nodes and they should be equal, this condition proves that n1 and n2 both are not null, but there could be a chance that n1 is null or n2 is null. So if any of the node came out to be null, we can directly return false, because instead of null we actually need a node 3 here so that this binary tree can be symmetric till this point. But as it's a null value here, so this condition comes out to be true, and as it's a OR operator here, we can directly return false. So from here only we will return false, stating that this is not a symmetric binary tree. So friend, this was all about the symmetric binary tree. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.